Step into the world of Google Cloud Cybersecurity and become a digital defender against evolving cyber threats. This certificate program from Google Cloud combines expert-led instruction with hands-on Google Cloud Labs, equipping you to analyze vulnerabilities, build robust defenses, and safeguard critical systems. This complete course can be watched alongside the Google Cloud Skills Boost platform, where you will find interactive labs and hands-on practice environments. You get 35 credits free per month for labs, but for faster completion, you can pay for unlimited access. At the end, you can earn a certificate. And thanks to Google for providing a grant to make this course possible.
Picture this. You've got a startup that's just gaining traction. So you want to organize a database of customers and streamline some of your processes with updated programs. It wasn't too long ago that you'd have to keep all of your data and programs you want to run on premises, where your data is physically stored on site in a room full of massive computers. Thankfully, in the 1960s, some innovative engineers thought, hey, what if we shared computing power across a bunch of different businesses so they didn't all have to manage their own systems? The engineer's idea was a success then and continues to evolve today. Consider how far we've come. Today, instead of needing to find a physical space, staff, and surveillance, you can access the resources you need by connecting to a remote data center through the cloud. These remote data centers store awesome amounts of information, as well as hardware and software applications and networking equipment. Way more than those engineers dreamt. The cloud makes it all possible. I know, all this cloud stuff sounds fantastic. And it is. It's also extremely at risk of attack. Cybercriminals know that the cloud holds a ton of valuable data. That data is coming from users and industries all around the world. Cybercriminals also know the cloud is a complex, shared environment, so securing the cloud can be challenging. Cloud security is a vital and highly valued profession. It's also an exciting one, because as a cloud security team builds robust security, cybercriminals continue to attack. The content in this program will equip you with the knowledge and skills required of entry-level roles in the field of cloud cybersecurity. And career resources, including resume and interview prep, will help you prepare to apply for jobs in the field. My name is Megan, and I'm a security engineer at Google. I'll be your instructor for the first course of this certificate program. I'm on the security reviews team under Information Security Engineering. My team evaluates all of our product and feature launches to make sure they're secure before making them available to the public. I usually describe my job as ethical hacking. My background is in computer science, but I learned a lot about security in different ways. I took introductory security classes in school and learned about networking, disaster recovery, and offensive security through internships. Outside of school, I learned most of my hacking knowledge through online resources, cybersecurity certificates, like this one, and capture the flag challenges. A unique thing about me is that I'm disabled. I have a chronic illness that sometimes makes it difficult to work when I'm having a flare-up. I was worried about starting my first full-time job, but my coworkers and managers have been nothing but supportive. The program is divided into courses based on different cloud cybersecurity processes. The course topics include Introduction to Cybersecurity and Cloud Computing, Proven Strategies for Risk Management in the Cloud, Identifying and Protecting Against Threats in the Cloud, and Detecting, Responding, and Recovering from Cloud Cybersecurity Attacks. Each topic builds on the content before it, so I encourage you to complete the courses in order. The final course is the capstone. It's a great opportunity to demonstrate the knowledge and skills you gain throughout your academic journey. As you work on your project, we've got videos and readings to teach you cloud cybersecurity concepts and skills. Then, interactive activities and labs will let you practice those concepts and skills. You can take the labs more than once, and lots of learners do. So if you hit some trouble spots, just keep at it. You'll also have quizzes to confirm your understanding and glossaries to help reinforce key terms. I'll be by your side throughout this first course, making sure you're getting the foundational knowledge you need. Then, you'll meet my teammate Preston.
Hello, I'm Preston, and I'm a security engineer here at Google. Together, we'll explore cloud risk management frameworks. In this course, you'll learn how to identify risks and implement security controls to mitigate them. You'll also understand compliance while managing data protection and privacy, and you'll compare and adopt frameworks. Next, Manny will take over.
Hey there, I'm Manny, and I'm a Google security engineer. I'm really excited to introduce you to identity, management, and access control principles in a cloud environment. We'll check out 3 of my favorite topics: threat and vulnerability management, cloud-native principles, and data protection measures. Next, in the course on cybersecurity attacks in cloud, you'll learn from Celine.
Hi, my name is Celine, and I'm a security engineer at Google. I'm excited to investigate how cloud cybersecurity professionals can detect, respond, and recover from cybersecurity attacks. Together, we'll dive into logging, security and alert monitoring, and mitigation techniques. Last up, you'll meet Lewis, when you put everything together that you've learned in a capstone project.
Hello, I'm Lewis, a Google security architect, and I'm going to help you prepare to wow potential employers. Together, we'll put everything you learned from courses 1 through 4 into action in a capstone project. You'll create impressive work examples to share with future employers.
We instructors are really happy you're here. So let's get started. Hey there. Welcome to the first stage of your cloud cybersecurity learning journey. In this course, you'll explore essential security principles in cloud computing. You'll get an overview of the security lifecycle and investigate Google Cloud tools like the Google Cloud Console and Cloud Shell. You'll gain insight into DevSecOps, which stands for Development, Security, and Operations. This methodology integrates security into the entire software development lifecycle. Along the way, you'll discover how you can translate many of the skills you already have into the cloud security field. These transferable skills include problem solving, analytical thinking, collaboration, and communication. One of my favorite things about this field is that as the cloud evolves, so do the ways in which its security can be compromised, which means I get to learn new things all the time. So let's get started. In this section of the program, you'll kick off with a general introduction to cloud computing and cloud infrastructure. Then you'll examine how virtualization, containers, and storage function in cloud computing. Next, you'll deepen your defenses in the cloud using security controls, identity and access management, and networking practices. You'll also discover how users and cloud service providers share security responsibilities in different cloud models, like infrastructure, software, and platform as a service. Then you'll check out automation in the security lifecycle. You'll learn about teams and workflows, along with automation's role in software pipelines and infrastructure as code. Plus, you'll explore the software supply chain and the importance of securing it. To wrap up, you'll explore the roles, responsibilities, skills, and tools of a cloud cybersecurity analyst. You'll experience Google's Cloud Shell and add lots of tech solutions to your cloud security toolbox. I'm here to help you every step of the way. And keep in mind, you set the pace. When you're ready, head on over to the next topic. When you're learning a special skill, it helps to understand the basics first. You wouldn't try to surf big waves without knowing how to swim. That's why we're going to take a dive into the foundational concepts of cloud computing first, so you can gain the knowledge you'll need to succeed in this program and ride some waves into your future career. You'll start off with an overview of cloud infrastructure. Then you'll consider key strategies when migrating to the cloud. Next, you'll check out components of cloud computing and learn about how it improves on the traditional on-premises approach. Then you'll be introduced to containers and their applications in the cloud. You'll discover how containers help users deploy more agile and portable software packages. You'll also review cloud storage options for different data types. When you're ready, let's begin.
My name is Ben, and I'm the Senior Vice President of Learning and Sustainability at Google. I'd always been interested in learning because for me, my mother was a school teacher, and I felt that learning is really what enables people to reach a different point than they otherwise would. I know it enabled me to go to a place I could not have dreamt of being were it not for the education I got. And I think that's incredibly important for people to have access to that kind of opportunity. And growing up in India, I did have access to a good school. I did not come from a wealthy family, but I had access to a good school. And I saw the difference it made in my life. And I think today, with the help of technology, we can hopefully bring more of that opportunity to more people in the world. The cloud is really important because it's a trajectory of where computation is going. If you think about all of the major products that you use, almost all of them are now based in some online cloud data center. And they have access to all these amazing computing resources, and they enable you to these services to really provide amazing things for their users. So studying cloud technologies enables you to participate in that whole economy of jobs and of opportunities that consist of building these powerful facilities in the cloud that are being used by people around the world. One of the really interesting ways in which education is evolving is allowing people to build and learn individual skills through various skilling courses. Many aspects of education are not available to everybody everywhere, unfortunately. But it's possible to build the basic skills that one could get that one needs from an education more piecemeal today. And I think the approach of skilling can allow people to build up the pieces of the education that they really need in the way that they have access to, in a way that they have time for, in a way that they have the resources for. The initial parts of learning anything are learning the basics and the fundamentals. Whether it is a sport or a physical skill like carpentry or whatever, the first steps are learning the basics. So persevere with it, and it'll get really interesting. I've been working with computers for, what is it now, over 35 years, and it is still fascinating every day.
Thanks to the cloud, we can now interact with data pretty much anywhere and at any time. Whether it's checking the weather to see if I need a sweater, or streaming my favorite podcast. It may seem like magic, but storing all that data and keeping it organized takes infrastructure. Of course, data existed and needed to be stored before the cloud. So let's check out where we started before learning where we're going. Before the cloud, organizations kept their data in large physical infrastructures, usually on-premises. On-premises, or on-prem as we say in the industry, describes information technology infrastructure that's physically located in an organization's own data center or office. This means the organization manages their own servers, networks, and storage to run and store data. Now the cloud uses these physical structures to run. All of the information it holds is hosted by a cloud service provider, also known as a CSP. And these providers store cloud resources in data centers. A data center is a physical building that stores servers, computer systems, and associated components, creating a centralized location for vast amounts of data. The servers within data centers provide computing power to the cloud. Cables connect the machines, which then link up to other data centers in the area. This is called a zone. A zone is the collective number of data centers in an area. A zone may contain one data center or multiple data centers. And a region is a group of zones. Google Cloud has many regions across the globe, and it's always growing. Google Cloud refers to the grouping of zones and regions as failure domains. A failure domain is a resource that can fail without impacting the availability of data. Failure domains can include zones and regions where data is replicated to improve resiliency. Resiliency is the ability to prepare for, respond to, and recover from disruptions. Having data across failure domains is one way that cloud service providers safeguard user data. Let's use an example. Let's say you're a cloud cybersecurity professional, and your organization uses cloud resources in a zone on the coast of Australia. You're in the middle of work one day when there's a power outage to the data center in your zone. It's all okay though. Your work is safe because you've selected services from your CSP that replicate your resources across other failure domains. The practice of having multiple copies of data in different locations to avoid a single point of failure is referred to as redundancy. Redundancy ensures your data is available when you need it. All right, now you know where data is kept in the cloud, but how is data stored? And more importantly, how fast can you access the stored data? With such an incredible amount of information being generated every single second, quick access is essential. This concept is called latency. Latency is the time it takes for data to travel from one location to another. This can be from a user's device to a cloud server or between cloud servers. For example, when you're on a website, the lower the latency, the faster the web page loads. And research shows that 53% of users will leave web pages that don't load within 3 seconds. I am definitely in that 53%, for the record. So, CSPs strive to provide low latency to users. Latency, redundancy, and the cloud's underlying infrastructure have the potential to significantly improve an organization's commitment to their users. In fact, these benefits contribute to an organization's digital transformation journey. Digital transformation is when an organization modernizes their applications, services, and customer relationships by using new technologies. The cloud's ability to scale and globally replicate data enables an organization to provide a better user experience to not only their employees, but also their customers. As a cloud security professional, it will be really important to understand how cloud infrastructure works. With your knowledge of these core cloud concepts, your cloud learning journey is underway. No latency here. The cloud delivers infrastructure in a few varieties called deployment models. Let's take a deep dive into the different options users have for tapping into the power of cloud computing. The deployment model is an important consideration for cloud infrastructure. There are three main options: public, private, and hybrid. First up is public cloud, which is a cloud model that delivers computing, storage, and network resources through the internet, allowing users to share on-demand resources based on their specific business needs and operational goals. So the CSP's infrastructure and resources are shared in a multi-tenant environment with other users. A multi-tenant environment is an environment in which cloud infrastructure and resources are shared among users. You never know who your data center neighbor might be. Even though you share resources, the other users can't access your data. Privacy matters. Next up is private cloud, which is a cloud model in which all cloud resources are dedicated to a single user or organization and are created, managed, and owned within on-premises data centers. In this cloud model, all cloud resources are dedicated to a single user or organization. They own the underlying infrastructure, typically in their own data center, but they use a CSP. Because the infrastructure and resources are dedicated to the single user, the private cloud is a single-tenant environment. A single-tenant environment is an environment in which cloud infrastructure and resources are dedicated to a single user. This model is especially useful for companies with compliance and/or regulatory considerations. Think of the private cloud as owning a business, and the public cloud as renting office space. An individual business is responsible for maintenance and repairs, but the business owner also has the flexibility to make renovations or structural changes, like adding a new kitchen. Similarly, using the private cloud means the business has both responsibility and control over the resources and infrastructure. On the other hand, when renting an office space, a business probably has to stick to the current floor plan and are unable to make structural changes. But the management company takes care of the upkeep and repairs, like the electrical, heat, and cooling. Your rent probably includes maintenance fees, but the business isn't responsible for the repairs. Much like the public cloud, users pay the CSP for both resource usage and maintenance. Okay, finally we have the hybrid cloud, which is a cloud model that combines public and private models, so organizations can enjoy both the cloud services and the control features of on-premises cloud models. Hybrid cloud allows users to add a public cloud provider to an existing on-premises infrastructure, which increases computing power without adding data center expenses. Because users choose where their applications sit and where computing happens, there are key security and compliance advantages too. A hybrid cloud is like having a storage unit. The business has the convenience and access of more space without needing to move or expand. With users consuming an increasing amount of cloud resources, the multi-cloud deployment model has emerged. Multi-cloud is the strategy of using more than one cloud service provider. For example, your organization might use Google's Gmail service for corporate email and another cloud service provider for storing its data. Whether your future employer is best suited to a public, private, hybrid, or even multi-cloud model, all offer innovative ways to advance and protect computing resources. All computer users, at one time or another, experience speed, performance, or storage problems. Maybe you bought a laptop, but it takes longer and longer to load because of limited space left on the hard drive. Or maybe your desktop computer has a lot of memory, but as it gets older, you can't add the app you want because the computer isn't compatible. Well, the cloud can help you with these and lots of other constraints related to storing your data, software, and hardware locally. And that's just what we're going to explore in this video. Specifically, we'll discuss 5 major cloud benefits. The first benefit of the cloud is faster time to market. With cloud computing, your organization won't waste time, energy, and money buying hardware, waiting for it to be installed and configured, and then inevitably diagnosing hardware problems. And the ability to quickly create infrastructure means getting new apps out to consumers much more quickly. The second benefit of cloud computing is scalability. In an on-premises environment, the number of storage devices varies with the demand for data. The cloud security team will need to add new devices in order to manage the growing data. When these devices are no longer needed, the team members have to find another use for the devices because they can't be returned to the supplier. But with the cloud, the resources automatically match the workload, often saving time, effort, and money. Now, just as time to market and scalability often lowers expenses, switching to the cloud itself can provide cost savings. When using an on-premises solution, a business is responsible for the costs of physical hardware, the staff managing the devices and data center, plus maintenance and service fees. This framework is called capital expenditure, or CapEx. The cloud follows an operational expenditure, or OpEx model. OpEx means you only pay for the resources you use. Pretty cool, huh? The CSP is responsible for all upfront costs of physical equipment and spaces, like servers, networking devices, and data centers. And because there are so many users, sharing cloud resources cuts the price tag for everyone. Okay, now there's the advantage of better collaboration. When using the cloud, companies don't need a direct connection to physical resources to access their data. With just an internet connection, they can access it from anywhere in the world. This enables globally distributed teams to collaborate easily and efficiently. Another prime advantage is the cloud's extensive security capabilities. And this, of course, is where cloud cybersecurity professionals really shine. They know how to ensure the confidentiality, integrity, and availability of cloud-based data, applications, and infrastructure. They work hard and think creatively to prevent unauthorized access or criminal exploitation. This keeps cloud assets safe and secure. Likewise, using the cloud helps avoid damage to business resources and information, and it prevents data loss because redundancy practices ensure information is replicated across failure domains. You might recall redundancy is the practice of distributing cloud resources across zones and regions. While there are lots of really great benefits to using the cloud, it isn't perfect. So it's important for cloud cybersecurity professionals to recognize the cloud's limitations. The reliance on a stable internet connection is of key importance. In some cases, a CSP's network connection might be compromised. This would cause users to experience longer wait times to access their cloud resources. The good news is that CSPs can mitigate this issue by having multiple connections to the internet for each cloud location. In a time when technology is developing at light speed, the cloud provides some key advantages that enable organizations to make the most of these incredible innovations. As a cloud security professional, you'll play a key role in helping your future employer advance its operations, quickly scale, adapt to market changes, minimize costs, and increase data security. These are just some of the ways you can bring a ton of value to any organization you serve. You might know that phrase, the only thing constant is change. This idea of change is directly relevant to cloud technology, especially its ability to constantly keep up with amazing technical advancements, surprising market shifts, ever-evolving consumer demands, changing organizational structure, and so much more. The pace of change is accelerating, so it's important to be able to adapt. This can be challenging, but it's also an opportunity to grow and learn, just like you're growing and learning through this training. By embracing change, you're in a better position to stay ahead of the curve and make the most of whatever may come your way. And what's coming your way in this video is an investigation into cloud computing and how it enables businesses to proactively respond to change. Let's start with a quick definition. Cloud computing refers to the practice of using on-demand computing resources as services hosted over the internet. For example, this enables users to reduce information technology, or IT, overhead while enjoying advantages like scalability, enhanced collaboration, responsiveness, and cost savings. In cloud computing, an instance is a server resource that runs workloads in the cloud. Instances are created or retired quickly to keep pace with the latest releases and updates. Now, a very important part of cloud computing is something called ephemerality. Ephemerality is the concept that things only exist for a short amount of time. In other words, change in the cloud is constant. Cloud security analysts use ephemerality on the job all the time. Take this example. Rather than spending time patching software on enduring physical servers, analysts create a new server image, which is a server in the cloud. Creating a new, healthy server means analysts can quickly launch a new instance. Ephemerality helps make the cloud more flexible because resources can easily adapt to change. The CSP enhances the performance of cloud assets, since assets can scale quickly using ephemerality. Ephemeral resources are a big plus in the security field because they are less likely to be targeted by attackers. Cybercriminals would need to quickly find and exploit a vulnerability before it's destroyed. Alright, now let's go over the three main categories of cloud computing resources: compute, storage, and networks. In the cloud, compute refers to computation performed by a physical computer in a remote environment. For example, memory, CPU, and storage are all compute components. Basically, compute is the brainpower behind running resources. All of these compute elements run on remote servers, so organizations don't need to worry about managing or providing physical equipment. Organizations can efficiently scale the volume of their data up and down. Let's take an example. Consider a clothing company that offers discounts to online purchases of winter jackets in the spring season. In the past, its website experienced lags and downtime because of the increased traffic. This frustrated customers and negatively affected sales. In response, this retailer opted to migrate to cloud computing. And next spring, the website's workload automatically scaled to meet increased demand. Customers appreciated browsing and checking out quickly, thanks to the cloud's low latency. Then, once the peak season was over, the company's compute resources scaled back to normal workload levels. Good for the customer, good for the business. Okay, next up is storage. Cloud data storage is a solution that enables organizations to keep, access, and maintain digital data on off-site cloud-based storage devices. So just like compute, the CSP uses a remote infrastructure when storing data. Finally, networks in the cloud run using software. Unlike traditional networks that require physical devices, software enables users to change their network designs without buying new hardware. And using a cloud network provides visibility into the communication between your incoming and outgoing network traffic. With cloud computing's compute, storage, and network capabilities, managing workloads is an efficient process. Better yet, from exciting new inventions to sudden disruption and everything in between, the cloud makes it possible to react to change with confidence. Now, I hope that you're also becoming more confident with your knowledge of the cloud. Welcome, Future Security Pro. Thanks for joining me for this video all about virtualization and virtual machines. Virtualization is the foundation of cloud computing. As a cloud security analyst, it's going to be super important for you to understand how it works. So let's dive in. Virtualization is a technology that creates a virtual version of physical infrastructure, such as servers, storage, and networks. This technology uses virtual machines, or VMs, to simulate a physical computer. VMs contain their own operating systems, like Windows and Linux, and use only a portion of the underlying computer's compute power. Virtualization uses hypervisors to manage the relationship between physical and virtual resources. A hypervisor is the abstraction layer that sits between the physical computer and the VM. Abstraction is what separates hardware from software. There are two types of hypervisors. Type 1, also known as bare metal. Type 1 is more common. It replaces the entire operating system of the underlying computer. Type 1 hypervisors interact with the operating system's components directly. Having this direct access makes Type 1 streamlined and secure. On the flip side, Type 2 hypervisors, also known as hosted, use the computer's existing operating system and runs as an application over the operating system. Type 2 hypervisors may be easier to install, but you need to take into consideration the extra overhead and security needs of the underlying operating system. So, hypervisors distribute resources across VMs and keep VMs separate so that each one simulates an individual computer. And the hypervisor ensures that information in one VM is not visible to others. In this way, an organization's development team can transform one physical computer into lots of virtual machines, instead of buying new hardware each time they need a server. If needed, a development team can also add CPU, memory, and storage space to the VM. Now, let's discuss the three advantages of VMs: portability, scalability, and testing environments. The first advantage, portability, makes VMs especially useful for hybrid cloud environments where application resources are shared between on-premises and cloud infrastructure. Because each one is an isolated entity, developers can relocate them throughout a network. The The second advantage, scalability, means that VMs can be scaled to provide additional or fewer resources if the development team's needs change over time. This is unlike physical servers, which have a fixed amount of hardware. The third advantage, testing environments, help developers test code without worrying about affecting existing infrastructure or users. Plus, VMs simplify testing because developers don't need to deploy complex production environments, and they can delete the testing environment machines afterward. As a core foundation of cloud technology, virtualization will be a big part of your future career in the cloud. You'll be a major asset to any employer because you understand the advantages virtualization offers and you can maximize its power. Think about how a package delivered to your door got there from its original location. It probably started off in a warehouse and then went inside a cargo container. There'll be many packages of different sizes inside each container. Next, the containers are loaded onto a transport vehicle, like a train car or ship. Multiply this by thousands of containers over the world. They're transported from one place to another, but this doesn't change the contents inside, like your package. Okay, so a container is a software package that holds only the components necessary to execute a particular application. Each container has a container image, which is a file with the code and dependencies that the container requires to run the application, like documents in a filing cabinet. The cabinet is the container. The folders in each drawer are container images, and those container images store the documents or information needed to perform a task. Developers use something called container registries to upload and download container images. This enables teams to share and deploy consistent images, and organizations use orchestration tools to help deploy, scale, manage, and monitor containers. Packaging software in a container uses less memory and fewer resources because the operating system itself is not included in the container. And bonus, they're isolated from the surrounding environment, which means they're pretty easy to deploy across cloud deployment models, like public, private, or hybrid clouds. You'll work with containers a whole lot throughout your career, so it's important to understand their key benefits, including portability, immutability, and responsibility separation. Let's kick off with portability. Containers enable users to run software quickly from one computing environment to another. This portability helps create cloud tools super efficiently. Unlike virtual machines that have an operating system, containers only house isolated software while using a common underlying operating system. This allows an individual container image to run in multiple locations without the need for a separate operating system. All of this contributes to their portability. Next up, immutability. Immutability means an object can't be changed after it's created and assigned a value. Just like the contents of those shipping containers don't change during transit, cloud containers also can't be modified during their lifetimes. If a container does require a change, users must create a new container image and redeploy it. This also allows developers to seamlessly replace outdated or insecure container images. Immutability makes containers more secure by ensuring consistency across multiple deployments, since there is no patching or updating that could cause configuration drifts. Lastly, containers separate the responsibilities among the developers and operations teams. Developers can devote their time to managing the container's code, and operations teams can concentrate on deploying and managing the container's applications. This frees people up to work on the projects where they can bring the most value. And there's nothing like knowing you're playing to your strengths. Guiding you through this lesson was a blast. I can hardly contain myself. Okay. But seriously, I'm confident that you'll bring all kinds of value to your future security team and organization, especially because you'll be able to clearly and confidently advise them about all things containers. There's all kinds of different storage out there for our important documents, data, and more, like hard drives, and even your smartphone. These devices are great for personal use, but what if you need to store assets for thousands of users? Well, enter cloud data storage. The cloud makes it possible for organizations to store truly massive amounts of data. And that's what we're going to explore in this video. Cloud data storage is a solution that enables organizations to keep, access, and maintain digital data on off-site cloud-based storage devices. A cloud service provider, or CSP, is responsible for ensuring the replication and availability of the data, and users can retrieve their data using the internet anytime from anywhere. Before cloud data storage, organizations kept data locally in on-premises computers or servers. As companies grew, more storage was needed to accommodate the increasing volume of data. Businesses started adding more servers, external hard drives, and larger storage systems to meet this increasing demand. But cloud data storage addresses lots of the challenges associated with traditional methods. Plus, users benefit from scalability, redundancy, cost savings, and security. Let's take a deeper dive here. First, storage using the cloud allows for scalability. When an organization needs to store more data, they can adjust their use of the cloud accordingly, without the need to buy, install, organize, and manage new physical devices. Another benefit is redundancy. Redundancy is the practice of distributing cloud resources across zones and regions. This means the CSP duplicates the user data across multiple failure domains, making sure the data is safe and always available. So, if a component fails, the redundant backup can take over, allowing the user to have access to the data. A third benefit is cost savings. With cloud data storage, users no longer have to buy and maintain their own devices. It's the CSP's responsibility to have the infrastructure to host and maintain the data. They also provide high levels of uptime, so that the data is available whenever the user needs it. Because users no longer pay upfront costs, the overall cost of the data storage goes down too. Plus, users only pay for storage resources they use. And because of the ability to scale, it's not necessary to pre-buy storage in case a company suddenly needs more storage capacity than expected. Cloud data storage also offers important security controls to check user authentication, access control, and data encryption. The scalable, redundant, cost-effective, and secure aspects of cloud data storage provide a more seamless experience when managing data. This has become a key solution for companies of all kinds. It's helpful for small businesses or entrepreneurs who might not have the resources to handle vast amounts of data. And of course, larger companies also leverage the cloud's ability to store and move massive amounts of data quickly and securely. Understanding cloud data storage is an essential foundation for your data security career. It offers a number of business benefits, and your know-how will help any employer make informed decisions about how to put cloud storage to excellent use. Deciding where to store something has everything to do with what's being stored. Here's an example. Let's say you just made some iced tea. You'd most likely put it inside a liquid container with a tight-fitting lid, not a flimsy paper takeout box. Or let's say you went to the store and bought a 12-pack of paper towels. You wouldn't keep them all on your kitchen counter. You'd probably put one roll in a dispenser, then store the rest in your pantry until you need them, right? There are lots of different ways to store and use data in the cloud. And just like the liquid iced tea and the bulky paper towels, there are many storage options available in the cloud. Let's cover the different types of data being stored. This is important to understand because each storage type contains a specific data type. First up is structured data, which is data organized in a certain format, like rows and columns. It's taken from its native form and transformed into a predefined format. A predefined format means that all submitted data are categorized into specific fields. The data is then stored in a database meant for storing structured data. This makes structured data easy to search. Examples of structured data include names, addresses, credit card numbers, and dates. Next, unstructured data is data that is not organized in any easily identifiable way. It's stored in its native form and appears in a variety of formats, including images, videos, and documents. These formats aren't structured at all. For example, think of a doc file. It can contain text, images, or even embedded photos and videos. These data types are unstructured because they can't fit in the tables and rows of a database, like with structured data. Luckily, there are specific types of storage to accommodate all types of data. Let's take a rundown of the three main storage types: file, object, and block. To start, let's examine file storage. File storage uses a hierarchy of files in folders. It keeps data in one place and organizes it in a simple, easy-to-understand way. File storage is ideal for smaller volumes of data that a few people might need access to, like files on a family computer. Each file starts at the home directory. Then users can navigate to what they need by following a logical path. File storage is the oldest and most widely used data storage system, but it has some limitations and can only handle so much. File storage is also commonly used in data repositories. Developers rely on repositories as a centralized place to store, download, and share data. All right, let's move on to object storage. Object storage holds unstructured data in something called a bucket. A bucket is a virtual container that holds objects. Each bucket is assigned a unique name. These buckets can be public, meaning that anyone can access the objects inside, or private, so only certain people have access. Using buckets is a great way to organize large amounts of unstructured data. When storing data in block storage format on the cloud, data is split into smaller blocks, each stored in different locations to maximize efficiency. Each block is given a unique ID, and when users ask to retrieve their data, the smaller blocks are connected together again based on these IDs. Block storage is flexible and efficient, as it can be accessed by any operating system and any virtual machine system. Great work learning all about data types and storage options. With this information, you now know how to use the cloud to properly store data. This brings you one step closer to protecting information in the cloud. Bye for now. Congratulations on completing the first section in your Introduction to Cloud Computing. In this section, you learned some essential cloud computing concepts, which you'll build on throughout your journey to becoming a cloud security professional. You started with an introduction to cloud infrastructure. This included understanding its distinctions from on-premises methods and key considerations of moving to the cloud. Then you explored what the cloud is made up of by learning the components of cloud computing. Next, you learned about containers in the cloud. You also explored several advantages that containers bring to organizations. This section wrapped up by discussing the different storage options that are available on the cloud, including file, block, and object. Thanks so much for being here with me, and keep up the amazing work. Hey there! Ready to explore security principles in the cloud? There's so many exciting things in store, and I can't wait to go on this journey with you. Together, we'll examine the different layers of security and explore how each layer applies to the cloud. We'll also go over different security measures used in cloud environments. First, we'll explore security controls used in cloud computing. Then we'll discuss how the defense-in-depth approach applies to securing cloud resources. Next, we'll go over security responsibilities you'll share with cloud service providers, CSPs. You'll also learn about the shared responsibility and shared fate models, and the considerations of sharing security with a CSP. Then you'll build on shared responsibility concepts by learning about different cloud service models. You'll also review how infrastructure, platform, and software as a service offer varying degrees of security responsibilities. After that, you'll examine how identity and access management helps you maintain control over your resources. You'll also be introduced to the principle of least privilege and separation of duties in identity and access management. Finally, we'll discuss networking in the cloud. This includes software-defined networking, virtual private clouds, and load balancing. You're about to learn some really cool ways to secure cloud environments using security principles. I'm excited to go on this adventure with you. When you're ready, let's get started. Just like you might help someone you care about cross a busy street, in the world of cybersecurity, different strategies are used to protect data and assets, especially sensitive ones. The more valuable an asset is, the more advanced the security protecting it should be. Today, you'll learn about a strategy that's used to protect critical assets, the defense-in-depth model. Using this model can help protect cloud resources. It can also improve an organization's ability to manage its defense of assets and data, which is an organization's security posture. Defense-in-depth is a layered approach to vulnerability management that reduces risk. Defense-in-depth uses multiple security controls to protect assets. Let's learn about some of the cloud security controls that can improve your defenses. As a cloud security analyst, there are several security controls you'll encounter in your day-to-day tasks. Security controls are safeguards that reduce security risks. Common types of controls used in the cloud include identity, protective, network, detective, responsive, and recovery. The first type of control we'll cover are identity controls. An identity control is a measure that helps authenticate a user before they access resources, like networks or storage. Identity controls are becoming a lot more common, so it's possible you've encountered them before. One of the most common examples of an identity control is when your email provider asks you to add another email or phone number to verify your identity. This is an example of an identity control known as multi-factor authentication, which adds an additional layer of security to the authentication process. Another type of security control is protective controls. A protective control is a measure that protects access to resources and shields against malicious attacks. Other examples of protective controls are installing antivirus software on individual VMs, web application firewalls, and organization and infrastructure as code policies. A network control, like a firewall, is a measure that helps protect access through network paths. Next, a detective control is a measure used to identify suspicious activity if it occurs. An example of a detective control is an intrusion detection system that monitors system activity and alerts analysts if there's a possible intruder. Google Cloud Security Command Center is an example of an intrusion detection system that can alert cloud security professionals of malicious activity. A responsive control is an application or tool that uses automation to respond to security events. For example, responsive controls could automatically notify you through email or other systems in response to a detected threat. Finally, after detecting and responding to threats, analysts use recovery controls. A recovery control is a measure that restores access and functionality in the event of failures. The most common example of a recovery control is where you can revert to a backup of a system you stored after an attack. The combination of these controls create a more robust defense strategy for your organization. Think of the controls working together like a security system for a community garden. Gotta keep those prize-winning tomatoes safe. Identity controls determine who is able to access the garden, and installing a fence around the garden's perimeter acts as a protective control. You protect access to the garden by only giving authorized people a key to the gate, like using network controls. Using a detective control, you install a camera to monitor suspicious activity. Then, if there's suspicious activity, you'll use a responsive control to receive an automatic text message. Last, using a recovery control, you can reestablish the security of the garden by mending any failures in the fence. Now that you're familiar with the different layers to secure assets, you can combine them to create a defense in-depth security strategy. By adding security controls in each layer, you can increase the overall security of your cloud resources, making this an effective strategy to reduce your vulnerabilities. The cloud offers many capabilities for securing resources. This gives security professionals the exciting opportunity to protect assets in a variety of ways. In this video, you'll learn about the shared responsibility model and how customers and cloud service providers, or CSPs, work together to protect the cloud and a business's assets. A customer is an organization or user who pays a cloud service provider to host and run their cloud resources. Before diving deeper into shared responsibility, let's examine the difference between on-premise and cloud responsibilities. In a traditional on-premises model, a business owns their own data center and servers. The business is responsible for securing their services against threats. However, if that business decides to use a CSP to run or store their resources in the cloud, then the CSP takes responsibility for some of the security of those assets. The amount of CSP involvement depends on several factors. Let's explore these responsibilities further. The shared responsibility model is the implicit and explicit agreement between the customer and the cloud service provider, or CSP, regarding the shared accountability for security controls. In the shared responsibility model, the CSP is like a gymnasium. The gym provides the building and equipment and ensures the equipment works properly. The customer is responsible for using the equipment safely and maintaining their own personal fitness goals. Before the customer starts using the gym, they sign a contract where they agree to use the equipment appropriately. Shared responsibility works in a similar way, where the customer and CSP agree on who is responsible for securing what resources. One way to think about shared responsibility is considering security of the cloud versus security in the cloud. Here are some common CSP responsibilities. The CSP must maintain physical infrastructure like servers and data centers. Additionally, CSPs need to ensure network and resource availability. These responsibilities provide the security of the cloud. The customer is responsible for configuring their services to meet their specific security and compliance requirements. The customer is also responsible for securing their data. Organizations have to consider the security requirements of the people using their apps and resources. In these cases, the focus is to secure data in the cloud. For example, imagine a customer uses a CSP's network and wants to incorporate network controls. The CSP provides the network and firewall service and is responsible for their maintenance and updates. The customer is responsible for configuring the firewall, monitoring traffic, and responding to incidents. CSPs usually provide each customer with a service level agreement, or SLA, that quantifies the availability of services. For example, a service may offer an SLA of 99.99%, where that service must be accessible and available for the user 99.99% of the time. In the network example, the SLA outlines the customer's terms for network controls, which eliminates guesswork for who is responsible for what. Although the customer and CSP are securing different aspects of the network, both parties work together to achieve better security. The customer's workload and level of service, meaning infrastructure, platform, or software as a service, dictates how much responsibility the CSP assumes. The more the CSP manages, the more they are accountable for security. Responsibility levels also vary by industry type and regulatory frameworks. Within these frameworks, the customer should know the security controls they're responsible for, what controls the CSP provides, and default inherited controls. Inherited security controls demonstrate security posture to auditors. The proper use of security controls is important, especially if a business must comply with specific regulations or other government and industry requirements. A business's location also impacts how they apply shared responsibility. Different countries may have different types of regulations and requirements for their data. In this video, you learned that implementing shared responsibility can come in many different forms. CSP customers have lots to consider, including the type of workload, industry, and location. Understanding how to manage these considerations will create a strong relationship with a CSP. The shared responsibility model has lots of benefits, but sharing security responsibilities also creates a new set of challenges. Learning to identify and navigate these challenges will improve your effectiveness as a cloud security professional. The first and most common challenge is misconfiguration. Misconfiguration is a leading cause of security breaches in the cloud space. Cloud technology is constantly evolving, and managing the frequency of updates and new integrations is difficult for a lot of organizations. Misconfigurations sometimes happen because of inadequate security during development. Insufficient security makes it easier for malicious actors to infiltrate systems and source code repositories. More importantly, misconfiguration can leave data exposed, which can result in major regulatory fines for an organization. As a cloud security professional, you can help a business avoid these types of security vulnerabilities by closely monitoring resource provisioning and incorporating automation and safe security policies. Another measure that you can use to prevent misconfiguration includes properly managing identity and access management, or IAM policies, and using the principle of least privilege. The principle of least privilege means that a security architecture grants the minimum authorizations needed for a principal to perform its function, which in turn reduces risks. Suppose you need to unlock a door in a building. The principle of least privilege means that you would have a key that only unlocks that door, rather than a key that unlocks every door in the building. Next, larger companies usually use a variety of services to host and manage their cloud resources. Companies must consider the different services CSPs offer and how these services relate to one another. Vulnerabilities in security may arise if the business and the CSP don't closely monitor services when sharing responsibility. Another shared responsibility challenge you might come across involves tracking how regulations change as your company and market grow. The company you work for might acquire other companies or expand its product line, both of which could change the security landscape, the controls needed, and the established service-level agreements with their CSP. Consider this scenario. A business acquires a small tech company based in a different country. The business must now assume responsibility for the tech company's data as a result of the acquisition. Companies within a given country have to consider and comply with other countries' guidelines. Finally, remember that security is an ongoing process. It's important for your security team to stay up to date with the latest threats and vulnerabilities that may harm the business. In this video, you learned about challenges organizations might face when they work in a shared responsibility model. A better understanding of shared responsibilities implications can help customers make informed decisions about their security practices. Let's pretend you've been assigned a school project with a partner. Naturally, you want to do well on the project, and you hope your partner does too, right? You want them to work just as hard as you so you can share the work fairly and get the best grade possible. Things work similarly in the world of cloud security. As organizations make the decision to migrate to the cloud, one of the factors they have to consider is the trust they have in their cloud service provider to secure their data and resources. This trust is one of the main reasons for the shared responsibility model with a CSP, which has recently been elevated to a model known as shared fate. The shared fate model emphasizes the CSP's involvement in the customer's entire security journey and offers resources to securely manage their environment at each stage. The shared fate model was created to respond to gaps in the shared responsibility model, with the CSP offering more extensive guidance in how to secure customers' cloud-based resources. This addresses the challenges that customers face when using the shared responsibility model. Some of these challenges include navigating changing regulations, determining how security controls overlap, and approaching security as an ongoing process. The primary purpose of the shared fate model is to increase the level of trust between the users of cloud services and the cloud service provider. In shared fate, the cloud service provider invests more time to develop resources to help the customer design, deploy, and operate their cloud environment. This means there's a stronger partnership between the customer and the cloud service provider. There are several ways the shared fate model can increase the level of trust with the customer. 3 examples we'll cover are security foundations for users, landing zones, and mitigating risk. Security foundations for users are used by Google Cloud. Google's security foundations are a list of best practices, or blueprints, for configuring and deploying Google services. They deploy and maintain secure solutions using infrastructure as code. The second way the shared fate model increases trust is with landing zones. A landing zone is a modular and scalable configuration that enables organizations to adopt Google Cloud for their business needs. Google offers guidance on configuring landing zones. For a user that's new to the cloud, using a landing zone provides a starting point for adding identity provisioning, a resource hierarchy, and network and security controls. Finally, the shared fate model focuses on mitigating risks with the Risk Protection Program. Part of the program includes Google's tool, Risk Manager. Risk Manager is a Google Cloud security tool that offers insight into your organization's technical risk posture. It lets you generate reports to evaluate risk across your organization. Throughout this video, you learned about how the shared fate model strengthens the relationship between customers and the CSP, and how it distinguishes itself from the shared responsibility model. Building trust and understanding common vulnerabilities are huge assets to security analysts. Imagine you work for a nonprofit organization. Your boss schedules a meeting to explain that the organization is migrating some resources to the cloud in an effort to save money. As the nonprofit security analyst, it's your job to decide which cloud service model is the best fit for your organization's security needs. To help you make that decision, let's examine some of the most widely used service models. Cloud computing has several service models available depending on the degree of service customers need. The 3 major models include Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, or SaaS. The type of workload determines the level of responsibility the CSP has over your organization's security and resources. The CSP has the least responsibility in the IaaS model. In IaaS, the CSP provides instant access to infrastructure services, ranging from compute, storage, and networking to virtualization. The customer manages all other services, like virtual machines, operating systems, data, and security. With IaaS, the customer doesn't have to worry about maintaining their own data center infrastructure. Next, in a PaaS model, the CSP supplies and manages the hardware and software resources needed to develop applications. Customers write the code and manage all the apps, data, and security, while the CSP is responsible for maintaining the software development platform. PaaS manages more resources than the IaaS model, so IT and development teams have less operational responsibilities. Lastly, the CSP has the most responsibility in a SaaS model, where customers only need to focus on securing their content and access policies. So customers pay for web applications accessed over a network connection. SaaS is widely used in cases where companies don't have the staff or resources to build their own applications. Google's Gmail offering is an example of a SaaS environment. Gmail users control the data on the email platform, while Google provides the software and the hardware. All of these models share one thing in common. The customer is always responsible for securing their data. There are several service models beyond IaaS, SaaS, and PaaS. For example, Functions as a Service, or FaaS, provides serverless computing to developers who want to run singular pieces of code. Serverless computing separates physical servers from development environments. Developers use this service when they don't want to manage backend infrastructure like servers or resources like containers. Identity as a Service, or IDaaS, is another cloud service model. IDaaS is commonly used for multi-factor authentication, single sign-on, and identity and access management. Implementing IDaaS is one measure to prevent threat actors from gaining unauthorized access to your data. Lastly, Firewall as a Service helps organizations create more secure networks. Firewall as a Service is useful for growing organizations that need firewalls to block unauthorized access. As the volume of employees and their connected devices increase, so does the need for firewalls to protect the organization's resources and network. Let's come back to the nonprofit scenario. Your overview of the cloud service models helps you make a decision about the best model for your organization. You narrow your search down to the IaaS, PaaS, and SaaS models because they all remove the need for maintaining your organization's infrastructure. PaaS is useful for your developers so they can focus more on writing code and less on the actual platform. And with SaaS, your organization only needs to secure your data and access policies. When you consider the strengths of each service model, you decide IaaS is the best fit for the nonprofit. Using the cloud's infrastructure means you'll spend less time managing physical resources, and you'll still maintain control over a lot of your services, like your operating systems and data. With the information you learned about cloud service models, you are better equipped to choose the best model to meet your organization's needs. Let's consider a scenario where you're a member of the cloud security team at a local university. The university is preparing to migrate their traditional on-premises infrastructure to the cloud. You're tasked with reporting how infrastructure as a service, IaaS, is beneficial to the university's needs. In this video, you'll discover what IaaS can offer you in the world of cloud computing. IaaS is a cloud computing model where the CSP provides on-demand access to computing resources such as servers, storage, networking, and virtualization. IaaS offers lots of benefits for organizations. First, IaaS is scalable, so customers can configure their resources to increase and decrease on demand depending on their needs. In the university example, IaaS's scalability improves resource allocation. For example, during peak times of the school year, like student enrollment or final exams, the college's IT infrastructure expands to accommodate the increased workload. When students leave campus during winter or summer break, the infrastructure scales back to adjust to the decreased workload. Second, in an IaaS model, the CSP pays for the underlying equipment and devices. The customer only pays for the resources they use. Continuing with the scenario, the university can use any savings that comes from adopting the cloud for other budgetary needs. Additionally, removing the need for physical servers and equipment opens more space for students. Third, adopting IaaS improves business productivity. With the CSP managing the physical infrastructure, IT teams can devote more time to managing infrastructure services and security. While the CSP secures the underlying infrastructure, the bulk of the security responsibilities belongs to the customer. Just to name a few, responsibilities include securing data, operations, and access and authentication. With this understanding of IaaS, you might wonder how exactly workloads are transferred to a cloud platform. One way to move your infrastructure from an on-premises environment to the cloud is by using the lift and shift migration model. Lift and shift is a migration model where workloads are moved to the cloud with little to no modifications. Because this model requires fewer modifications, it doesn't take long to migrate your workloads or for teams to adjust to using the cloud as a platform. Adopting IaaS is beneficial for organizations looking to migrate to the cloud while maintaining the most control over their workloads. After considering the advantages of IaaS and how to migrate your resources, you can provide the university's security team with a well-informed perspective. This type of knowledge can help you make confident, informed decisions in real workplace situations. Imagine you're on the cloud cybersecurity team of a small tech company. As the business grows, you investigate software as a service, SaaS, as an option to help manage your workloads. Let's review what SaaS offers to better understand what this service can do for the company. SaaS is a cloud-hosted application software accessed over the internet through a web browser or mobile app. The SaaS model is ideal for organizations who might not have the staff or expertise to manage infrastructure or build their own applications. Customer responsibilities include securing their data, and access policies. That's it. Gmail is an example of a SaaS product. Google manages the Gmail application and all of the underlying infrastructure. Gmail users manage their emails and login access. Most SaaS offerings operate using a subscription model. If more or less capacity is needed, customers can purchase a different tier that will adjust to the workload. For example, if Gmail users have large amounts of saved emails with attachments, they may want to upgrade to a tier with more storage. With the CSP managing and maintaining the infrastructure, operating systems, and storage, CSP customers have far less overhead. Overhead is the use of excessive hardware or personnel resources to accomplish a task. Organizations adopting SaaS only pay for using the software, so customers don't have to worry about paying for and maintaining the equipment and servers needed to support the workloads. One advantageous aspect of SaaS is the instant use of apps. Customers can access most SaaS applications online on a web browser, which eliminates the need to download software. So SaaS applications are globally available. For example, you can access software for work while traveling or retrieve photos from the cloud. The SaaS service model has much to offer, but there are also considerations organizations should take when using SaaS. One of the biggest things to consider is shadow IT. Shadow IT tends to occur when employees or teams use SaaS products without getting approval from IT teams first. This practice is a concern for IT staff because those products might be inadequately secured, leading to more vulnerabilities and security issues for the organization. To summarize what we covered in this video, SaaS is ideal for those searching for a solution that requires minimal maintenance and security responsibilities. Now that's downright practical. It's important to know who has access to what. In security, making sure the appropriate people can, or can't, access certain things is essential to maintaining strong security measures. In this video, we'll explore identity and access management, or IAM. Let's cover some key parts of IAM: roles, principles, and policies. Roles are a collection of permissions that can be applied to principles. Permissions determine the actions a principal can take, and principles represent either an end user or an application. Principles can take several forms, like a Google account for end users, or service accounts for workloads and applications. A service account is a non-human identity that is typically granted to virtual machines, applications, and services. They're granted IAM roles to perform certain actions. Principals are assigned a role that grants permissions, rules, policies, or constraints. Depending on these role assignments, principals are then granted access to their organization's applications and resources. So to recap, roles are a way to organize the permissions of each principal. Granting a role to a principal transfers all the role's permissions. For example, A person on your team might need to access a storage bucket. To get access to the bucket's content, they would first need to be granted the correct role. When granting roles, it's important to apply the least amount of privileges. Only grant a user or principal enough access to perform their job. Categorizing principals as end users or service accounts is helpful. But what if you work for a company with hundreds of users? Groups are a solution to combining principals. Organizations can use groups to combine users or service accounts together to more easily assign access controls for larger sets of accounts, instead of assigning individual access one by one. Next, we'll go over policies. Organizations can set allow or deny policies that attach roles or deny permissions to resources. An allow policy is a type of access a principal has and sets conditions on this access. A deny policy is a constraint that sets rules to prevent principals from carrying out certain actions. It's an IAM best practice to create an allow policy for groups instead of multiple individual accounts. For example, an engineering team might consist of 50 people. Instead of setting a policy for each individual person, it's more efficient to create a group for the team members, then use an allow policy to bind the group to a role that has the permissions needed to perform their job. In this video, you learned about several key parts of IAM. With an understanding of roles, principles, and policies, you'll be better equipped to secure your resources. Making sure the right people have the appropriate access permissions will allow you to keep data and assets secure. When you think of networking, you might think of making connections with others in your work industry or social interest group, like a book club. In cloud security, you might think of connecting to online resources. But there's so many more aspects. And because networking is a huge part of cybersecurity, lots of companies are turning to the cloud for networking services. In this video, we'll uncover how traditional networking concepts translate to the cloud. Traditional networking infrastructure uses hardware and devices, like routers and switches. Remember that a router is a network device that connects multiple networks together. A switch is a device that makes connections between specific devices on a network by sending and receiving data. With networking in the cloud, instead of configuring hardware routers and switches, as a cloud cybersecurity professional, you implement routers and switches using software. This process is called software-defined networking, or SDN. CSPs use SDN for cloud services, where the routers and switches are hosted in data centers. SDN virtualizes these network devices, meaning the networking components are abstracted from the physical devices powering the network. You can configure SDN through either their cloud provider's console or by using an application programming interface, or API. An API is a library function or system access point with well-defined syntax and code that communicates with other applications and third parties. So instead of buying a hardware router, you can define a router in the cloud by calling an API. The API then requests access to the router for the organization. SDN is useful because it reduces the amount of maintenance an organization needs to keep networks running. The CSP manages the physical devices, so you can focus on developing and securing their applications. SDN is also scalable. You can add or subtract networking resources on demand as you need them. SDN also incorporates network monitoring, which can be used to detect distributed threats like denial of service attacks and unauthorized network scans. This security capability makes SDN valuable for cloud security teams. Along with these advantages, the cloud uses load balancing to distribute traffic. Load balancing distributes user traffic across several cloud servers, where the load balancer moves traffic to the appropriate backend service, like the cloud resources running your application. Distributing traffic prevents one server from becoming overwhelmed with traffic, which leads to slow performance. Load balancers also help ensure high availability for your resources. There are two types of load balancers: application and network. Both load balancers operate at different layers of the Open Systems Interconnection, OSI, model. The OSI model is a standardized concept that describes the 7 layers computers use to communicate and send data over the network. Security professionals use this model to communicate and pinpoint security threats when they occur. Application load balancers use one IP address to run workloads. They operate on layer 7, or the application layer, for HTTP or HTTPS traffic. The application layer connects users to the internet using software applications. When you access a website during peak shopping seasons, the application load balancer is what gets you and hundreds of other users to the web page quickly. Network load balancers operate on layer 4 of the OSI model, the transport layer. This layer is responsible for the delivery and speed of data between devices. The network load balancer handles traffic from UDP and Transmission Control Protocol, or TCP. This means the load balancer takes information from a router and forwards it to the correct TCP or UDP server. You just learned a lot about networking in the cloud, including the parts and benefits of SDN and load balancing. Networking is a major component of cybersecurity and cloud computing, so this knowledge will help you along your cloud journey. And as a cloud security professional, it'll be important for you to understand how traditional networking concepts translate to the cloud. Imagine you're hungry. So you decide to go to your favorite restaurant. When you walk in, the restaurant is crowded with people, and all the tables are full. Thankfully, you made a reservation in advance, so your table is ready for you right away. Now, you don't have to wait or worry about someone else taking your table. Reserving a table at a busy restaurant is a lot like a virtual private cloud. A virtual private cloud, or VPC, is a private cloud hosted within a public cloud, enabling organizations to use the public cloud's resources while being completely isolated from other cloud users. So just like having your table ready at your favorite restaurant, using a VPC as a cloud security professional allows you to take advantage of public cloud resources while having your own private section. Sounds pretty ideal, right? VPCs form the backbone of a cloud provider's network and assures privacy for your cloud security team. In Google Cloud, VPCs are global resources, meaning they're not attached to any specific zone or region. The global nature of Google Cloud VPCs makes it easier to design highly available cloud environments. VPCs facilitate network segmentation, which is an architectural approach that divides a network into chunks called subnets. Segmentation is important for network security because it improves an organization's ability to closely control and monitor network traffic. Segmentation is beneficial to organizations because separating cloud resources that shouldn't communicate with each other into different subnets reduces the attack surface. Subnets also allow the cloud security team to pinpoint and isolate issues when they arise. Google Cloud VPCs offer several other security features, like firewall rules. Firewall rules determine who can access specific subnets based on IP addresses, helping enforce the principle of least privilege for employees. You can also access VPCs from other remote networks. Virtual private networks, or VPNs, facilitate encrypted connectivity between networks. In a traditional environment, employees use a VPN provided from the company's on-premises infrastructure to connect to remote assets. With a cloud VPN, you can connect from your on-premises infrastructure to the cloud. Using the cloud's infrastructure also means the VPN can be set up in minutes, rather than months. Cloud VPNs have revolutionized the ability to work from home and connect to your job's resources. Imagine you've landed your first job as a cloud security professional, and you've been assigned to work remotely. Cloud VPNs allow you to access the files, folders, and documents you need using only a web browser or applications. Several CSPs offer VPC services that directly connect on-premises networks to the cloud, using network circuits for faster connection speeds. For example, Google Cloud offers Cloud Interconnect, a service that connects your organization's network to Google's virtual private cloud. This service provides users with a highly available and low-latency solution for hybrid cloud environments. Virtual private clouds are a great advantage to cloud security teams working with CSPs. As a cloud security professional, you'll benefit from your resources being globally available, all within your own private slice of the cloud. With VPCs, your data always has a reserved place at the table. Congratulations on making it to the end of Security Principles in the Cloud. Along the way, you've learned many options to secure cloud environments using security principles. First, you explored how to use security controls in cloud computing. You also learned how a defense-in-depth approach helps to secure cloud resources. Then you discovered the different security responsibilities you and the CSP share. You learned about the shared responsibility and shared fate models, and the considerations you should make when sharing security with a CSP. You then built on shared responsibility concepts while exploring different cloud service models. You also learned how infrastructure, platform, and software as a service offer varying degrees of security responsibilities. Next, you reviewed how identity and access management helps leverage control over cloud resources. You also learned about the roles that the principle of least privilege and separation of duties play in identity and access management. Last, you discovered how networking concepts translate to the cloud. You learned about software-defined networking, virtual private clouds, and load balancing. Great work on your progress so far. You're doing a fantastic job. The world of cybersecurity is a rapidly changing field where you, in a cloud security role, have to quickly adapt to new types of attackers and threats as you encounter them. With these ever-changing threats, your approach to securing your assets and information has to change accordingly. Being able to adapt and quickly react is an exciting and necessary skill to practice as a security professional. In this video, you'll be introduced to the security lifecycle and its relationship to software development. Throughout this section, you'll dive into the security lifecycle as it relates to development, security, and operations. DevSecOps, software pipelines, the software supply chain, and infrastructure and policies as code. You'll begin by learning about DevSecOps, its history, and how it has altered the workflow of professionals in development, security, and operations. Then, you'll examine software pipelines more closely and learn how you can use them to leverage automation to ensure consistency across software development processes. You'll inspect continuous integration and continuous delivery, also known as CI/CD pipelines, and the security team's role in reducing development downtime and human errors along the way. Next, you'll discover the software supply chain and the components that are critical to secure. We'll dig into artifact threats and vulnerabilities and how to mitigate them. Finally, you'll review infrastructure and policies as code and practice applying infrastructure as code concepts in the workplace. You'll also be introduced to tools and processes that support automation in the cloud landscape. The security lifecycle is an exciting process, and we'll introduce you to lots of important strategies for following this lifecycle. Good luck!
My name is Dayo, and I'm a security engineer at Google. I work for a team called Enterprise Infrastructure Protection, and essentially what we focus on is implementing controls to enable Googlers do their work in a secure manner. I would say my journey or my background, it's a bit non-traditional. Growing up in Nigeria and the types of courses that I took and the types of resources that we had available to us, it's not cutting edge. And what I mean by that is we didn't have adequate opportunities to resources like laptops to be able to write code efficiently, right? We'll be in class and probably have like a group of 4, 5, 6 students on one computer learning how to write code, right? It's not the best way to learn. That really challenged me in a few ways where, one, I didn't really like writing code growing up. And two, I had to seek out other means to learn what I know now. Some of the other methods that I used to learn is just picking up on random YouTube videos or picking up books that I, out of my own personal time, just put in extra hours to learn what it is I'm trying to achieve. I obtained my bachelor's degree in Nigeria in computer science. And then right after my bachelor's, I landed my first real job in the industry as a network engineer. So I did things like configuring switches and routers, going to client sites to provide internet services for them. It got to a point where I felt like I needed to push myself a bit further by education. So I migrated to the United States to do my master's degree in cybersecurity, and that's where the journey in security started. Cloud is a very exciting space to be in right now. Cloud is now the new cool, right? Pretty much a lot of our resources, be it computing, storage, other things, all live in cloud, right? So the skills that you're learning from taking this certificate is really going to be beneficial to you and the company that you end up working with. As part of my continuous learning, One thing I'm actually learning about and studying right now is I'm taking a certificate in cloud security, specifically cloud cybersecurity. It's fast growing, and cloud, especially cybersecurity in cloud, is a skill that I want to get for myself. So I'm taking a certificate just like you are to arm myself with additional knowledge to be able to thrive in that space. Learning is what has brought me to where I am right now. Just looking back in my career over the years, I would say the main reason why I decided to keep pursuing my goals is through learning. I would say learning can definitely be life changing. Look at me, I'm an example of that. I work for Google in Silicon Valley.
Imagine a situation where you spend months on a cloud security team creating an app. The team finishes developing the code and sends the app to the operations team, who release it soon after. The app is well received by its users, who highly rate its security features. This situation might appear too good to be true, but with the introduction of DevSecOps, this scenario can be a reality. DevSecOps is a culture that consists of guidelines, best practices, and tools that development, operation, and security teams use to collaborate. DevSecOps has become an integral part of the software development lifecycle. The software development lifecycle is a process for developing, testing, and monitoring software. Security was not always a key component in the framework. DevSecOps actually began as just DevOps, but security was added as a component because of several problems in the original framework. To understand how the addition of security helps to resolve problems, you'll need to know the history of the framework and its impact in the tech workspace. The term DevOps consists of two terms: Dev, which refers to the development team, and Ops, which refers to the operations team. Prior to the popularization of this framework, each team was a separate entity. The Dev team built the given application or software, and the Ops team managed the infrastructure, deployed the finished product, and monitored the release. The DevOps team would perform security checks as the final step before deployment, leaving security as an afterthought instead of an integral part of the development process. This separate workflow caused several problems. Many teams reported to different leadership, resulting in members of those teams receiving varying direction and priorities. This separation resulted in separate and even competing objectives. Additionally, these teams usually worked in isolation, with little interaction between them. The combination of conflicting priorities and sparse communication resulted in software releases that contained a lot of issues. Across the industry, people working on different teams became frustrated with the disconnected workflow. In the early 2000s, professionals from both sides took to online forums and even met in person to resolve the issues in the industry. This collaboration helped to create and bring unity to the DevOps framework. Today, communication, collaboration, and shared responsibilities are the core of DevOps culture. Across teams, every person is accountable for their contributions in the development process. Fast feedback is a cornerstone of improved communication. Receiving timely feedback allows developers to implement revisions and quickly roll out updates to users. Improved collaboration means the ops team is more involved throughout the development process, enabling them to advocate for the end user's needs earlier in the cycle. Likewise, the dev team monitors the product through its release, instead of merely passing it off to the ops and moving on to the next project. This infinity loop is commonly used to illustrate the collaboration between development and operations. There is no end to the loop. The software is continuously monitored, tested, and released. While the improved collaboration within DevOps solved several of the issues that appeared throughout the development lifecycle, there was still one important gap: security. Going back to my earlier explanation, historically, the DevOps team would perform security checks at the last software development lifecycle stage. When working with security in the DevOps framework, security checks became very frequent with every update and release. But with saving security as a final check, the process slowed down, causing bottlenecks. DevOps practitioners realized they needed a solution to make security more of a streamlined process. DevSecOps emerged as the solution, where development, operations, and security teams collaborate at the very beginning and throughout the development process. With DevSecOps, security teams implement automated security tests from the start of the project, which means the operations team releases applications even faster. DevSecOps culture also reinforces the security concept of shifting left. To shift left means security checks and practices are implemented at the beginning and throughout each phase of the software development lifecycle. Using the same infinity loop illustration, you'll notice that the addition of security to dev and ops strengthens the entire cycle. Shifting left with security involves a variety of shifting left practices that might include code analysis, change and compliance management, threat modeling, and security training. Additionally, automated security testing is conducted throughout the software development lifecycle to monitor for threats and vulnerabilities. With your current understanding of DevSecOps, you now know one of the common workflows of software development. Additionally, you can apply a security mindset to improve the process among development, operations, and security teams. Now you know how to use the framework to build an app with your cloud security team and reel in those high user ratings. The adoption of DevSecOps in the tech workspace led to drastic improvements in the software development cycle. In this video, you'll dive deeper into software pipelines and learn more about their advantages. But first, let's learn more about the limitations of one of the traditional software development frameworks, the waterfall approach. In 1970, Dr. Winston Royce coined the term waterfall methodology as a way to develop software in a step-by-step order. With this methodology, developers move from one step to the next. Returning to previous steps can cause the developer to lose their progress or require them to repeat their previous work. A development team completes the waterfall workflow in 6 main steps. The first step is to establish project requirements. The second step is to design the software. In the third step, the team develops the software. The fourth step is to test the code. The fifth step is to release the project. Lastly, the sixth step is to conduct maintenance for any issues that arise post-deployment. Although the phases are clearly defined, this approach has several drawbacks. One drawback is that if the test step finds any issues that the development team need to address, then the waterfall process comes to a stop, and other teams on the project have to revisit their step, like design and develop steps. A second drawback is that when one team is blocked from continuing their step, then the project can't move forward as planned, and the team may not complete the project on time. One common solution to the issues in waterfall development is using a software pipeline. A software pipeline is a process that uses automation and tools to facilitate movement through each phase of the software development lifecycle. Unlike traditional development, software pipelines help developers release changes quickly. Developers can modify an application's code without disturbing other parts of the project. With DevSecOps methodology, teams can apply the software pipeline and work collaboratively to build, deploy, and secure apps. Teams use continuous monitoring to alert for any anomalies that may arise in the development process. While they may vary based on the organization's needs, generally, software pipelines include automated integration and testing, code validation, and reporting measures. Automation facilitates a consistent process and enables seamless security scans, forming a reliable way to strengthen security. Unlike the traditional waterfall method, software pipelines introduce testing throughout the lifecycle, rather than testing the deliverables in one large batch at the end. An organization can include a variety of tools to use throughout the development project. These tools can be used to enable modular testing, conduct security checks, and even compile and analyze code. In this video, you learned how software pipelines redefine traditional project workflow, like waterfall development, and support DevSecOps methodology. Adopting this approach is another step towards streamlining your organization's development and operations. Do you like making things simpler? Me too. Let's explore some ways that software pipelines solve a lot of the complications that arise from a traditional software development framework. In this video, you'll be introduced to the most commonly applied pipeline methodology, the continuous integration and continuous delivery, also known as CI/CD pipeline. CI/CD pipelines are a valuable approach to automating build, validation, and deployment processes. What does CI/CD mean? Simply put, CI/CD is a process DevSecOps teams use to create software and automate updates. The first phase, CI, is where developers continuously create and update code that's uploaded into a shared repository. For example, uploading the code automatically triggers a validation process, builds an image, and then stores the code in a repository. Automation is crucial. Everything from the build process to validation tests should be automated. Validation tests that detect broken code trigger an alert that flags developers' attention immediately. The second phase, CD, actually has two meanings. The first being continuous delivery. Continuous delivery standardizes the continuous release of software builds to a staging or testing environment. Changes to code are automatically tested for bugs and merged into a repository. Like with continuous integration, automated tests validate any code or build updates. Once the build is ready for deployment, manual approval is required to push the updates to a production environment. The second meaning of CD is continuous deployment. Unlike continuous delivery, continuous deployment automatically deploys builds into a production environment in real time. Manual approval is not required for the updated software to be pushed out to end users. Continuous deployment can be thought of as an extension of continuous delivery. Although the processes are different, it's helpful to know that you might hear these terms used interchangeably. The CI/CD pipeline has 4 key stages: source, build, test, and deploy. Continuous monitoring runs throughout each stage. Let's take a look at each stage. In the source stage, developers compile their code into a shared repository. Each developer works solely on the source code in this repository to ensure consistency. The team monitors for any deviation from the source code. In the build stage, developers implement edits to the source code in the shared repository. This triggers a build. Once the build is complete, it continues to the test stage. Automated security tests check the new build's integrity. If any bugs are found in the build's code, the pipeline stops the process until developers fix the problem. Last, the software deploys to the end users within minutes. The DevSecOps team continuously monitors user feedback to quickly implement new features or improvements to the software. Why is CI/CD an invaluable approach to software development? One key benefit is that it minimizes downtime and reduces interruptions caused by human error. With automation built into the process and the application of continuous deployment, there's no additional time waiting for manager approvals. The less a development team needs to manually touch the code, the less likely it is that unintentional errors will occur. Another important benefit of using a CI/CD pipeline is that it gets updates to apps and users faster. Users don't have to wait for new releases or for bugs to be fixed. Once the developer has committed changes to the code in the repository, the update is well on its way to automated deployment. Now that you have the basics down, let's consider security's role in the CI/CD methodology. When planning your pipeline, there are certain points where you can incorporate security checks throughout the development lifecycle. Next, let's cover some example places to add security checks during the first few phases. In the source stage, the source code is scanned, which triggers a build. In the build stage, the image is scanned for vulnerabilities and checked against policies. If the build passes this step, it continues to the image repository. Once in the repository, security measures can include applying IAM permissions to access the images, and incorporating regular scanning to identify vulnerabilities. The test stage detects any vulnerabilities and should trigger patching and redeployment. The image undergoes another cycle of vulnerability testing and checks the build's integrity before deployment. The image undergoes another cycle of vulnerability and integrity testing before it's released in the deploy stage. Another security measure includes only limiting service accounts access to deploy builds, rather than individual human users. Recall that a service account is a non-human identity that is typically granted to virtual machines, applications, and services. Automation is a key part to each CI/CD stage because it helps the stages work more quickly with fewer errors. In this video, we covered how to integrate security throughout the CI/CD pipeline in order to reduce downtime and use automation to reduce interruptions caused by human error. Isn't it nice when things go smoothly? Today, you'll learn how important it is for you, as a cloud security professional, to secure the software supply chain. The software supply chain includes the people, processes, and tools that play a part in software development. This includes code scripts, people and organizations, third-party dependencies, processes, and more. The software supply chain's components each have their own security vulnerabilities and can also be attacked. This results in faulty software that can harm your organization and its users. Let's cover the different vulnerabilities of the software supply chain and how threat actors might target it. The people involved in the supply chain are one of the vulnerabilities susceptible to attacks, including developers, security analysts, management, and any person with credentials to the source code repository or system. In fact, employees can be an organization's biggest vulnerability. Other vulnerabilities in the supply chain are an organization's processes and policies. This usually happens because of inadequate system access, insecure review cycles and feedback loops, software update rollouts, and even ineffective communication and approval practices. Technology and third-party dependencies also open up your supply chain to attacks. For example, you may unknowingly use dependencies like libraries, plugins, and containers that threat actors tampered with to gain access to your data. Threat actors search for people, process, and technology vulnerabilities in underprotected networks, infrastructure, and coding practices. For example, a hacker might access a business's system to change source code and even hide malware in an app. The business may then unknowingly release the app to the public, unaware that these malicious changes have been made. Attacks can occur at any stage of the software supply chain, so measures must be taken to ensure the security of resources and data. There are several ways to secure the supply chain to harden your security. Security hardening is the process of strengthening a system to reduce its vulnerabilities and attack surface. One way to protect your supply chain is to implement regular vulnerability checks throughout the CI/CD pipeline. If detected, your organization patches the vulnerability as a measure to strengthen security. Another method is to use a software bill of materials, or SBOM, to address security measures and compliance. An SBOM is a machine-readable list of each piece of software and its components involved in the supply chain. Possessing an SBOM also demonstrates to stakeholders that your project or organization not only applies security measures, but also follows compliance guidelines. Let's examine the following scenario, where a supply chain attack had significant consequences. A software company was recently vulnerable to an attack on many of their network devices. The company was unable to complete certain review cycles and feedback loops due to a shortage of resources and time to roll out their latest software update. Then, an attacker accessed the software company's system and discovered how to manipulate network traffic and credentials for malicious intent. This example demonstrates the critical need for a cloud security team to secure the software supply chain. Using secure CI/CD pipelines, incorporating security checks, and maintaining an SBOM are all ways to strengthen your organization's security and better protect your data and your customers' data. The software supply chain includes the people, processes, and technology involved in software development. As a cloud security professional, you may take on the exciting and important role of working on securing the different components of the software supply chain. In this video, you'll learn the moves of a popular framework that cloud security teams use and organizations use to strengthen their security. This type of security framework is called SALSA, which stands for Supply Chain Levels for Software Artifacts. Just as salsa dancing can be a great way to stay fit on the dance floor, I think you'll find that the SALSA framework is a great way for a business to keep its cloud security fit as well. SALSA improves security by outlining standards and controls that enhance the integrity of artifacts. So, what is an artifact? An artifact is a digital object, like a file or image, that is used in the software development lifecycle. SALSA uses guiding principles to make security recommendations. SALSA prioritizes placing trust in build platforms and code over the individuals who have access to them. SALSA does not assume a platform implements correct security measures. Instead, it requires documentation that proves builds are securely configured. SALSA's framework revolves around 3 trust boundaries: build integrity, source integrity, and dependencies. Build integrity involves verifying the software uses the correct original dependencies. For example, developers on a cloud security team should use unmodified source code and follow the workflow prescribed in their CI/CD pipeline. Source integrity tries to ensure the source code actually reflects the developer's goals and intent, and that any code modifications are easily traced and monitored. The dependencies boundary requires that any dependencies used in an artifact are examined using security checks. Now that we've learned about SALSA's trust boundaries, let's examine the SALSA levels that work together to harden an organization's security. Organizations can use SALSA's standards and recommended technical controls to reinforce security throughout the supply chain. To achieve a higher level of security, SALSA splits the security levels into tracks. Developers on a cloud security team complete each track separate from the others, making it easier to address specific security concerns. Each level of the build track focuses on establishing provenance. Provenance is a description of the processes and tools used to build an artifact. Think of SALSA's framework structure as a pyramid. L0, or the base level, indicates the artifact does not meet SALSA requirements. As a cloud security professional, you can implement the framework starting at the bottom of the pyramid and gradually moving up to more advanced levels after you've cleared the previous level. In L1, document provenance, organizations must meet minimum requirements for documenting the artifact's provenance. This might include documenting the artifact's dependencies and detailing how it was built. With documentation standards met, advancing to L2 requires using a hosted build platform for managing builds. Finally, L3 dictates that the build platform used must provide protection against tampering with the artifact's provenance. It's important to note that implementing the levels takes time, especially since a cloud security team must meet each level's requirements before advancing to the next. Depending on the size of the organization, it can take years to achieve the top level, L3. Additionally, SALSA's framework doesn't offer security recommendations for companies that intentionally create malicious software. Further, SALSA does not assess the integrity of a developer's coding practices. Completing these boundary checks and integrating each level's best practices makes artifacts more resilient, which reduces potential attacks in the software supply chain. Along with levels and boundaries, SALSA recommends incorporating technical controls, such as version control, vulnerability scanning, build verification, deployment policies, and artifact management. You can research these on your own if you're interested in learning more. In this video, you learned some great moves to apply SALSA's framework to secure the software supply chain. You learned how implementing guidelines at each of the levels gradually secures an organization's artifacts and build processes. You also learned how trust boundaries and controls reinforce these guidelines and best practices. All these SALSA guidelines will provide a great rhythm to keep an organization's security fit and in step. Implementing infrastructure in the cloud for the first time might seem like a large task for cloud security professionals and even organizations to take on. Luckily, there's a bright side. You have a lot of different tools and strategies you can use to help mitigate this challenge. One of those tools is infrastructure as code. So what is infrastructure as code? Infrastructure as code, or IAC, is the practice of automating and managing infrastructure using reusable scripts. It's another important tool in the DevSecOps toolkit and replaces the time-consuming and expensive manual provisioning of infrastructure. IAC's automation capabilities are important in cloud computing. The increase of infrastructure components, plus the need to easily scale resources, makes automation essential. Let's examine a scenario where IAC can address a situation that might occur in traditional IT infrastructure. There is a multinational plant supplier that ships plants across the globe. As different holidays approach, their mobile app and website traffic grows. Currently, they use traditional IT infrastructure to run their website and mobile app, but their IT department struggles to keep up with the increasing demand. Because of this, employees make uncoordinated changes to the system on a case-by-case basis to keep their resources running and their customers satisfied. The company also has a business objective to cut costs to account for the slow winter season. So how can the company solve its IT infrastructure problem and meet its business objective? Well, this is where IAC can help. To adopt IAC, organizations develop a configuration file that houses the source code that is used to build their infrastructure. Using code makes it easier to manage and distribute the infrastructure. One reason is because the code is stored in a shared repository, so teammates have visibility into what changes are made. IAC supports an immutable environment. Immutable means that outdated resources are torn down and replaced with an updated version, instead of merely patching the issue. The ability to quickly release improved infrastructure keeps IT and customers happy. As a cloud security professional, you can use the primary programming model to configure IAC called declarative. Using the declarative approach, you define the system's desired state from the start, including any resources and corresponding properties you might need. IAC tools first look at the current state of the infrastructure, and then make the appropriate changes to achieve the desired state for you, keeping a list of your system's objects and making your infrastructure easier to control. Adopting IAC provides lots of benefits. One benefit is that IAC lowers costs because of decreased time, effort, and complexity of using cloud resources. IAC saves costs by freeing developer time to focus on other projects. not to mention saving money by eliminating physical hardware and the space needed to store it. Using an IAC also means IT no longer needs to manually configure their infrastructure. Removing manual configuration can help to eliminate the risk of human error. Next, IAC encourages faster and more efficient development. The dev and ops teams deploy the same infrastructure throughout the software development lifecycle. This efficiency leads into the next benefit, which highlights IAC's usefulness in the DevSecOps workflow. It accelerates the speed of delivery using automation. Automation of the same infrastructure deployment ensures the dev and ops teams collaborate on the same source code, which helps keep the CI and CD pipeline running smoothly. This automation works to reinforce security by integrating security checks earlier in the development process. Another important benefit of IAC is it reduces configuration drift. Configuration drift is when a resource's configuration has altered from its original or expected state. Typically, drift happens because of unplanned changes to the configuration code, or even with unmonitored software or hardware updates. IAC reduces configuration drift by enforcing consistency through automation and using one configuration file as the single source of truth. Lastly, IAC increases accountability. Teams that share the same repository increase visibility into changes made to the configuration code, which allows for revisions as needed. As a cloud security professional, you'll work on IAC components to provide a seamless experience. Implementing security checks at the infrastructure layer ensures provisioned resources remain safe. One method of incorporating security is to automate scanning the infrastructure regularly. These scans are important for detecting configuration drift and policy violations. There are several tools available that aid in configuration management and orchestration. IAC's ability to automate scaling and security checks and enforce version control make it an invaluable cloud computing methodology. Transitioning from manual processes to automated ones can be daunting. However, remember that bright side. You have the IAC framework available to you. It's a huge asset in a cloud security professional's toolkit. Automation is a process that is becoming more relevant to the world of cloud security. Working in the cloud involves knowing how different components are automated. As a cloud security professional, it's important for you to use those components proficiently to ensure they are fully secured. In this video, you'll explore how automation concepts are used in policy as code. In a cloud security team, you'll have lots of considerations to take into account when developing software. Following policy and compliance conditions is an important task that is easily lost in the activity of building new applications. Traditionally, the cloud security team creates policies in environments where version control isn't possible. And without automation, testing policies uses up a lot of time and effort. Also, problems happen when organizations don't have a unified approach to implementing compliance security checks. These problems can include inconsistent scanning and manual application of security practices. To help prevent these problems, a security team implements policy as code. Policy as code, also known as PAC, is the use of code to define, manage, and automate policies, rules, and conditions using a high-level programming language. PAC enables developers to provision and manage their policies to meet organizational requirements. PAC also enforces best practices for compliance management. An advantage to using PAC is strengthening the security in the DevSecOps lifecycle. Automated vulnerability scanning provides developers with continuous feedback about security concerns and red flags that may lead to compliance errors. The security team can also code triggers that alert developers to take immediate action on incoming threats. The security team can automate these triggers, which removes the manual decisions of what policy to test and when to test that policy's integrity. Consider this example. You're designing an app for users in the United States that tracks the user's heartbeat. Users can choose to have the app send this data directly to their healthcare provider. Since the app interacts with sensitive health information, you must enforce policies that follow HIPAA guidelines. You choose to code these policies to determine misconfigurations, identify vulnerabilities, and automate versioning. Shortly after your team creates the triggers, you're notified of a security vulnerability and policy violation. This allows your team to take appropriate steps to resolve the issue. Now you're able to better maintain user security as they monitor their heartbeat. Your app also maintains necessary HIPAA compliance. Security is an important aspect of PAC, but there are a lot more advantages to code policies and rules. Organizations that adopt PAC enjoy several benefits. Earlier, you learned the ability to achieve version control is advantageous. First, developers can easily track code updates. And second, they can roll back revisions when needed. A third version control benefit is to improve visibility. With version control in place, project stakeholders can monitor the policy's progression and ensure that policies are appropriately incorporated. A fourth important benefit is to increase efficiency. Automating testing and removing manual policy enforcement enables developers to quickly share and scale coded policies. With greater efficiency comes the fifth benefit, which is to facilitate collaboration. Access to the shared policies as code encourages and simplifies collaboration amongst the engineering team and beyond. Centralizing rules and policies allows stakeholders to work seamlessly together. You've gained a deeper understanding of how impactful coded and automated policies can be. You also explored how PAC practices provide security to developers and end users. So take a deep breath and rest assured, you know how to use PAC in your next role in cloud security and keep the business fully secured. Security plays a very important role in the automation of software releases, infrastructure, and policy. This video introduces a new framework known as GitOps. GitOps is a framework that applies version control, collaboration, compliance, and CI/CD best practices to automate cloud infrastructure. GitOps uses Git, an open-source version control system to store configuration files. The first component of GitOps is that it uses infrastructure as code, or IAC, as a core process for automation. Developers store the infrastructure as source code in a Git repository. This repository serves as the single source of truth for all configuration files. This gives all involved stakeholders improved version control. In Git, the original source code is called the main branch, also known as the trunk branch. Think of a tree. As a cloud security professional, when you need to update the IAC, you make a pull or merge request. When you make a pull request, you're incorporating the committed files from a branch into the main trunk. Initiating a pull request includes a description of the request, details about the CI/CD pipeline, comments about the code, and the intended commits. A commit is the specific change made to a file. GitOps relies on CI/CD methodology to deliver the code commits. GitOps uses continuous integration as a method for submitting pull requests. Continuous delivery integrates security and IAC requirements throughout the software development process. GitOps supports the DevSecOps security mindset of shifting left. Cloud security analysts can incorporate security best practices like vulnerability scanning and IAC compliance checks from the beginning of development and throughout the CI/CD pipeline. There are several GitOps benefits. The first benefit is that GitOps improves efficiency and visibility throughout development. This benefit comes about when an organization can use a single tool to manage infrastructure and the application development lifecycle. Both infrastructure and application management are rooted in the same version control system. A second benefit is that this central management of application and infrastructure allows developers to easily manage services like container instances, microservices, and other infrastructure parts. GitOps principles make it an ideal model for organizations using container services. You learned how GitOps is a valuable tool for automation, version control, and configuration management. Recall how GitOps works like a tree, where you can create branches from the trunk to help streamline operations. This understanding of GitOps will help prepare you for the varied methodologies you'll encounter and use as a cloud security professional. You've come to the end of the security lifecycle. Throughout your journey, you've learned lots of concepts related to the influence of security and automation in the software development lifecycle. Great work! Along the way, you've learned how important it is to follow the security lifecycle as it relates to development, security, and operations. DevSecOps, software pipelines, the software supply chain, and infrastructure and policies as code. You started this course with an introduction to DevSecOps and how it transforms collaboration, communication, and security in the software development environment. Then, you learned about software pipelines and the role security plays in streamlining workflow. You were also introduced to security best practices when working with software pipelines. Next, you explored the software supply chain and its components, You learn about the possible vulnerabilities throughout the supply chain and how to develop strong security that mitigates threats. Lastly, you reviewed infrastructure and policies as code, and practiced applying infrastructure as code concepts in the workplace. You were also introduced to tools and processes that support automation in the cloud landscape. Congratulations on your progress so far. Keep going on your journey into the fascinating world of cloud security. Hi there, and welcome. I'm excited to explore the role of a cloud security analyst with you. Throughout your learning journey, you'll learn about the role, responsibilities, and skills of a cloud security analyst. First, you'll explore the analyst's role. Then you'll learn about different career paths and several job titles you'll encounter in your job search. Next, you'll receive an overview of the typical responsibilities of a cloud security analyst. You'll also review the wide range of exciting tasks analysts take on to defend their organization against cyber threats. Then you'll discover what it's like to be a part of the cloud security ecosystem. You'll also learn what it's like to work with different teams, communicate with stakeholders, and apply specific skills. Finally, you'll explore the different tools analysts use and get practical experience with one of Google's tools, Cloud Shell. You'll also learn how these tools are applied in the security industry. When you're ready, let's get started. Now is the perfect time to develop security skills. Cloud security is a growing field with a wide variety of exciting jobs opening up every day in almost every industry. In this video, you'll learn about some of the career paths you can pursue as a cloud security analyst. First, let's explore some of the fields a cloud security analyst can work in. The first field is information risk management, which is the process of identifying, assessing, and minimizing potential threats to information assets. Information risk management has a lot of career options for security analysts. It's used to develop strategies for securing cloud assets. Since an organization's cloud environment may include thousands of assets, it's important for risk managers to understand what their organization's environment includes, such as by using cloud asset inventory software. This allows them to conduct research into potential threats and put controls in place to make risks less likely. Information risk management could also be used to plan an organization's security budget. Each organization has a limited amount of resources to spend on security. Information risk management plays an important role in prioritizing which tools an organization spends its money on, and which assets the organization focuses on protecting. The higher value an asset has to the organization, the more money they should invest to protect it. Another field cloud security analysts can work in is cloud security posture management, or the process of monitoring and configuring cloud assets for security and compliance with best practices, regulations, and organization policy. Analysts use cloud security posture management tools, like Google Cloud Security Command Center, as centralized places to find and analyze information about what's going on in the cloud environment. Posture management involves using tooling to monitor cloud environments for misconfigurations and vulnerabilities. Using posture management strategies, cloud security analysts can also take steps to improve their organization's security posture. You might be wondering, what is security posture? Security posture is an organization's ability to manage its defense of critical assets and data and react to change. So, security posture management strategies often include regularly reviewing and updating security policies, ensuring that identity and access management services, or IAM policies, are configured correctly, and implementing and testing security controls. Cloud security analysts also review their organization's security posture regularly with cloud service providers to make sure technology features are up to date. Analysts document these reviews and use them to improve their cloud assets' security over time. As part of security posture management, analysts also communicate with non-technical audiences, including management and users. It's important for analysts to have great communication skills so they can explain technical concepts to those who may not have a technical background. Analysts are often responsible for educating their colleagues about security best practices. A third field cloud security analysts can work in is threat intelligence. Threat intelligence includes the collection, analysis, and evaluation of cyber threat information. Cyber threats include the techniques malicious actors use to damage cloud resources or gain unauthorized access to data, Several cybersecurity organizations around the world work together to document and categorize cyber threats. The information these organizations collect include details about known attack groups, the methods they use, which systems are vulnerable, and how to reduce the risk of being affected. Cloud security analysts use threat intelligence to stay ahead of potential attackers. By knowing which assets are most vulnerable to attacks, analysts can help direct resources and budget toward the areas that need it most. Threat intelligence also helps analysts respond to incidents. When a cyber attack, breach, or other incident occurs, cloud security analysts are responsible for minimizing the impact on the organization and supporting the recovery process. Now you know about some of the different specializations available to cloud security analysts. Consider your own interests and start to think about whether any of these might be a good fit for you. In this video, we'll explore some of the common responsibilities cloud security analysts may have in their role. This is a great opportunity to think about what aspects of cloud security are interesting to you. First, it's important that cloud security analysts are familiar with the core products that cloud service providers offer, including computing, storage, and networking. These products help analysts manage their responsibilities and complete the tasks they need for their roles. One of the many responsibilities cloud security analysts have is mapping security concepts to cloud products. Mapping allows analysts to identify potential attack vectors for their organization's cloud assets. By anticipating how attackers might try to harm the organization's assets, analysts can focus on strengthening the defenses that need it most. Analysts are also responsible for using tools to check for vulnerabilities in virtual machines, containers, and networks in the cloud. Cloud security analysts use these tools to track their organization's assets and check for misconfigured settings or other conditions that could make an attack more likely. Cloud security analysts also use tools to analyze threat detection and security compliance reports. Depending on the industry, an organization's cloud environment may be required to follow specific security standards or regulations. So, analysts are responsible for using cloud tools to maintain compliance and gather information about potential threats. Another responsibility cloud security analysts might have is communicating with their organization about the security of their cloud environment. To do this, analysts use information from cloud monitoring tools to prepare status reports for management and other security team members. Threat detection and analyzing compliance reports are just a few of the ways that security analysts monitor their organization's infrastructure for potential security incidents. For example, analysts use cloud logging tools to collect information about user actions, system activities, errors, and other security-related information. Analysts are also responsible for identifying unusual activity involving the organization's network, virtual machines, or containers. Another responsibility of cloud security analysts is responding to security incidents, like a malware infection or an attempt to gain unauthorized access to cloud storage. Responding to a security incident starts with identifying unusual behavior and determining whether it's an actual threat or just a false positive. If it's a threat, analysts work to contain it. This could include shutting down a virtual machine running harmful software. After an incident, analysts help the organization recover. Then, they document what went wrong, so the organization can be better prepared in the future. To continuously improve their organization's security posture, cloud security analysts are responsible for testing and evaluating new security products. This could include deciding which security products their organization chooses to use, and how those products are configured. Additionally, analysts regularly test security products to make sure they work properly. Finally, cloud security analysts are responsible for staying up to date with the security and technology industries. By understanding new cloud technologies, analysts can learn to secure them. Like new technologies, new cyber threats are always emerging and evolving. So cybersecurity organizations and cloud service providers use threat intelligence to document and share information about these threats. Several organizations also post blogs and reports that cloud security analysts can read to stay up to date on the latest developments. Now that you've got a better idea of what cloud security analysts do every day, you're even closer to finding the role that's right for you. Ready to learn about your future coworkers? Cloud security professionals have a lot of responsibility, but they don't do everything alone. In this video, we'll explore the wider cloud cybersecurity ecosystem and discuss some of the potential teammates you may work closely with as a cloud security professional. Let's get started. What is a cloud cybersecurity ecosystem? The cloud cybersecurity ecosystem includes the network of people, processes, and technologies that work together to keep the cloud secure. The cybersecurity ecosystem includes everyone, from large organizations to individual users. If you end up in a cloud security analyst role, you'll most likely be a part of your organization's Security Operations Center, or SOC, which detects and responds to cybersecurity incidents affecting the organization. Some of the professionals you may work with on a cloud security team include cloud security architects and cloud security engineers. You may also work with compliance team members. Let's learn more about each of those roles. A cloud security architect is a professional who designs and develops security controls and measures within an organization's cloud infrastructure. Cloud security architects develop these controls to ensure the confidentiality, integrity, and availability of their organization's information. They also consider the organization's specific goals and security requirements. A cloud security engineer is a professional who implements and manages secure cloud workloads and infrastructure. Cloud security engineers also configure access to cloud resources and put security controls in place to protect data and workloads. They support compliance with security best practices, regulations, and standards, and manage operations within the cloud environment. The compliance team is a team within an organization that ensures processes act in accordance with laws, regulations, and standards. Depending on the industry and location, one or more laws apply to most organizations storing customer data in the cloud. Security teams also work with compliance departments to make sure cloud assets align with legal requirements. In this video, you learned more about the cloud cybersecurity ecosystem and some of the professionals you may be working with. Working in such a vast space means collaborating and communicating with others to achieve success, which can be a very rewarding process. As a cloud security professional, you'll frequently be in charge of conveying important information to people who need it. These people, usually referred to as stakeholders, will need you to keep them updated. In this video, we'll discuss working with stakeholders as a cloud security professional. A stakeholder is a person or organization who can affect or be affected by a system. Stakeholders of an organization's cloud environment include anyone who might be affected by whether or not the cloud remains secure. For example, management and leadership, other departments, and end users of products can be stakeholders. Because cloud professionals help to create their organization's security policies, they also educate non-technical staff on how to keep cloud assets secure. So, cloud security professionals often need to discuss cloud security concepts with stakeholders. If a security incident, like an attack or data breach, happens, cloud security professionals may meet with leadership to explain the situation. They may also be involved in planning communication with users affected by an incident. Let's discuss some of the skills you'll need to communicate with stakeholders. As a cloud security professional, it's important to keep your technical communication skills current. You'll use these skills to communicate effectively with other security team members, as well as with stakeholders. Because you might sit in on meetings, discussions, and information gathering sessions with stakeholders, it's a good idea to hone your note-taking and listening skills, so you can capture details, requirements, and action items. Taking notes and listening will help you to gather accurate information, interpret security requirements, and accurately address stakeholders' concerns. Security professionals are also skilled in balancing the needs of different stakeholders. It's common for different departments within an organization to have diverse needs for cloud security. For example, the compliance department is more focused on having the legally required controls in place, whereas the product department is more focused on ease of use. Communicating with stakeholders is one of the most exciting parts of a cloud security analyst's job. You're that much closer to improving your communication skills, which will help you keep the cloud even more secure. Cloud security analysts have a lot of important responsibilities and usually work with a variety of people inside and outside of their organizations. To be successful in their role, there are many skills they'll need to develop. Learning these skills is like adding tools to a tool belt. The more tools you have, the more situations you'll be prepared to handle with ease. In this video, we'll explore cloud security analysts' role within the security ecosystem and within their specific organization. We'll also cover the skills you'll use to succeed in your responsibilities as a cloud security analyst. Let's review some of cloud security analysts' responsibilities within the security ecosystem. As a cloud security analyst, communicating cloud security concepts to a non-technical audience is a core responsibility. For example, you might help to train other departments in using the company's IT assets securely. As a cloud security analyst, you may also work with compliance teams to help develop cloud security policies for your organization. To do this, you'll need to understand and communicate industry security compliance standards to help make sure the organization aligns with all the laws and regulations that apply. By keeping your organization's cloud assets safe and in compliance, you'll help keep the cloud safer for everyone. Next, let's discuss some of the core skills you'll need in your role. Developing problem-solving and analytical thinking skills will be important to your work as a cloud security analyst. Issues can come up suddenly, so you and your team will need to work quickly to resolve them. Even if you're working on a new type of issue, being able to break it down into smaller parts makes it easier to understand the problem. This will help you identify the best solution. Being able to do this in different situations is a valuable skill that will serve you throughout your career. Attention to detail is an important skill for a cloud security analyst to have. The difference between normal and abnormal activity in cloud resources can be subtle. Cloud security analysts who pick up on details can catch and solve problems before they grow into serious issues. And that's a huge help to any organization. As a cloud security analyst, you'll be an important part of the cloud security team. You'll also work with other departments as needed. Because you'll be working with others, collaboration is an important skill you'll need to be successful in your role. Next, let's explore some of the technical skills cloud security analysts use on the job. As a cloud security analyst, you'll learn to define and configure security controls. Security controls are controls that safeguard cloud environments from threats and minimize the effects of harmful attacks. Security controls include antivirus software and firewalls. Another major part of a cloud security analyst's role is to conduct network analysis. Analysts configure and use security tools to closely monitor and log network activity in the cloud, then receive alerts when something appears out of place. Security analysts also use their skills to monitor and manage intrusion detection systems, or IDS, and intrusion protection systems, or IPS. Intrusion detection systems monitor your cloud system for threat actors trying to gain access, while intrusion protection systems proactively remove threats based on specific rules. Depending on the industry, an organization's cloud system may be audited for compliance or security by internal auditing teams or external regulatory bodies. Cloud security analysts prepare for audits by understanding the audit requirements, identifying weaknesses, and implementing necessary solutions. After an audit, they collaborate with audit teams to plan for improvement. As a cloud security analyst, there will be many opportunities to learn new skills and develop those you already have. And as you develop these skills, you'll be better prepared to handle the responsibilities that come with your role. There's no better feeling than knowing exactly what to do when a complex security problem arises. Cloud cybersecurity is a fast-paced, exciting field to work in. Cloud security professionals are always working to defend organizations from cyber attacks, and they get to use a variety of tools to help combat these threats. The amount of tools available to cloud security professionals continues to grow. In this video, we'll examine a variety of tools, including Linux, Terraform, reCAPTCHA, Wireshark, VirusTotal, and LucidChart. First, let's discuss Linux. Linux is a widely used open-source operating system. Linux uses a shell environment as the command line interpreter. The shell translates your commands so the computer can perform the instructed task. Lots of security tools run on Linux, so it's helpful for you to gain practical experience using it, so you can install and run these tools when needed. With Linux, you can verify the status of each application in your infrastructure, review networking traffic, and filter access to non-production IPs and ports. Next is Terraform. Terraform is commonly used in cloud security as an infrastructure as code tool. Terraform enables you to automate the provisioning of cloud resources. Security teams can use Terraform to consistently create health checks and security enforcement policies across their infrastructure. Using Terraform, you can create templates that are pre-approved and checked by the security team, so the engineers building infrastructure can repeat the same patterns safely every time they create new assets. Next is reCAPTCHA, a risk analysis engine that detects and helps prevent spam and malicious behavior from happening on websites. For example, imagine you manage an online store that lists customer reviews and comments for each product. reCAPTCHA scans the reviews to identify any reviews made by a bot, alerting you to questionable traffic. reCAPTCHA also helps prevent bots from spreading malicious information about your services or products. Additionally, this tool is capable of filtering spam and even detecting fake friend requests on social media. Then there's Wireshark. Wireshark is a packet analyzing tool that provides insight into your network. This insight allows you to quickly identify the root cause of issues and enables you to focus your investigation. With Wireshark, you can apply different kinds of filters to packet captures to identify suspicious activity like data exfiltration. This capability makes Wireshark a valuable tool for cloud security analysts. You can also use Wireshark in a specific interface and review all traffic passing through. This way, you recognize and separate normal packets from those that are a possible risk, then act to protect the infrastructure accordingly. Another important tool is VirusTotal. VirusTotal is a website that analyzes files and URLs for malicious content like viruses, worms, trojans, and more. Data retrieved from these websites is shared with the greater security community. Security professionals use VirusTotal as an investigative tool. For example, a security analyst might use VirusTotal to scan their organization's email messages for suspicious attachments. Next, LucidChart is a diagramming application that helps users communicate and collaborate across teams. Cloud security analysts use this tool to help document security processes using visuals. It can also be used to map out networks and data flow. Security teams also use LucidChart to help meet business requirements. For example, it's common to create diagrams that show how information flows through a system, so that you can identify and implement the appropriate protection measures. The security team can leverage LucidChart's diagramming features to set goals, meet requirements, and add milestones along the way. In this video, you explored various tools that cloud security professionals frequently use in the workplace. Using a combination of these tools can help strengthen your security posture and defend against cyber threats. When you use a cloud service provider, you can access your cloud resources in several different ways. You can use the provider's console or a command line interface, also known as a CLI, from within the console. In this video, we'll explore Google's Cloud Shell, an easily accessed CLI where you interact with your cloud environment. Cloud Shell offers you the ability to manage cloud resources with the command line. It provides a convenient way to enter commands or develop shell scripts that perform tasks in a user's cloud environment. Cloud Shell's environment is provided at no cost, but the shell itself is temporary and will shut down after a period of inactivity. After the shell is shut down, you won't be able to execute production actions or leave production files in the operative system disks. Cloud Shell is accessible through a web browser, so you can use it anywhere at any time. Utilities like tools and commands are pre-installed, so you can easily start experimenting with and managing your resources right away. Cloud Shell uses the Google Cloud CLI, also called the G-Cloud CLI, to build and manage resources. The G-Cloud CLI includes a suite of G-Cloud commands that perform tasks. These commands are nested into command groups that represent different Google products. For example, imagine you want to create a virtual machine on Google Cloud. To do this, you would use the product compute engine. The command group compute can be used in Cloud Shell to initiate the creation or manipulation of Google Cloud Compute Engine resources, like virtual machines. You can also use Cloud Shell to perform a variety of tasks. For example, you can develop and deploy applications. You can even create storage buckets, access databases, and view and edit files. You can also execute Terraform infrastructure as code scripts to build a test, QA, or production environment. As a cloud security analyst, you might use the Cloud Shell to create VPCs, or virtual private clouds, and view your networks in any given region. Remember, VPCs provide network capabilities to resources like virtual machines or containers. Let's explore how to create a VPC and subnet using Cloud Shell. First, go to cloud.google.com/cloud-console. Then, click the Activate Cloud Shell button in the top right corner of the page. The shell will open in a terminal window right on the web page. The first step to creating a VPC is to enter the following command: gcloud compute networks create labnet --subnet -mode equals custom. Let's examine each command. gcloud invokes the gcloud command line tool. Compute is part of a group command that allows you to create or manipulate compute engine resources. Networks is a subset of the compute command that specifies the compute engine network. Create is the action you're instructing the group to execute. And labnet is the name of the network you're creating. Next, you can create a custom subnet. Subnets in a given region must have unique names. Let's name it labnet-sub. The full command is gcloud compute networks subnets create labnet-sub --network equals labnet space /. Press enter. Then --range equals 10.10.0.0/28 space /. Press enter. Then --region equals US-east1. This command lists the region and IP range for your Cloud Shell session. Now let's view the networks we just created. We'll run gcloud compute networks list. Here, there are two networks listed. The network named default was created when the project was initiated. You can delete default networks for security purposes. The network named labnet was created by the gcloud command you entered earlier. Last, you can verify the subnets using the following command: gcloud compute networks subnets list --network equals labnet. The labnet subnet appears, confirming the VPC network was successfully created. Wow, you just explored how to create a VPC and subnet using Cloud Shell. That was a lot of information. If it felt like a challenge, that's okay. Working in this type of environment will get easier with time and practice. And I'll be here to encourage you along the way. Remember, Cloud Shell has many capabilities and is a valuable tool to develop your resources from anywhere, anytime. Congratulations on completing the introduction to cloud computing. You started by learning all about the cloud and its underlying infrastructure. You also learned about components of cloud computing like virtualization, containers, and storage. Then you explored security in the cloud and learned about security controls, shared responsibilities, identity and access management, and networking concepts in cloud computing. Next, you explored the security lifecycle and how it relates to DevSecOps, software pipelines, the software supply chain, and infrastructure and policies as code. Finally, you learned about the cloud security analyst's role and the responsibilities and skills common in the field. You also reviewed many of the tools analysts use on the job. You started to build a foundation of cloud security principles that you can continue to expand on in your future career as a cloud security analyst. Coming up, you have even more exciting discoveries to make. Get ready to continue on your cloud journey.
My name's Chris. I am a staffing lead working in people operations at Google. I'm essentially trying to make sure that we are helping to staff those organizations and helping to guide business strategy to ensure that we're hiring with an inclusive and a diverse lens. I've been in recruiting for about 17 years, 18 years. So yeah, it's been a lot of resumes. Personal branding is huge. It is, in a lot of ways, the new resume. One of the big ways to discover your personal brand or enhance your personal brand is to kind of surround yourself with like-minded individuals or individuals that are interested in the roles that you're ultimately trying to pursue. So joining groups of folks that might be involved in cybersecurity, if you're going for that type of a role specifically, they will help you not only keep, up to breast with the most, detailed information in the news, the new articles, the new releases, keep you current with those types of things. And technology moves very, very quickly. So it is good to have people around you that can kind of keep you up to speed there. Reaching out for coffee is an excellent way to get to know someone, get to know their environment, and honestly, to get to know nowadays a little bit about the work-life balance that's going on in the environment as well. Some do's when you're interviewing. Feel comfortable understanding the question, which means please feel comfortable asking qualifying or clarifying questions. Repeat and re-articulate that question to make sure that you're actually answering the thing that was asked of you. And at the end of it, ask if that answers the question to make sure that you've actually articulated your point clearly. So that would be the first thing. One other thing that I would definitely make sure that you're doing in the interview is don't feel afraid to ask questions of your interviewer as well. You can ask multiple questions. Don't feel like they always have to be asking you things, but things like, what's the environment like? What's the work-life balance like? If they're comfortable sharing it with you, hey, what's one of the big challenges that your team is working on right now? So that you can understand if some of those challenges are similar to some of the challenges that you're dealing with, and that can increase your confidence level, right? You know that, oh, I know how to deal with this type of a thing. There is an element of learning what your worth is in the market, and sometimes that can take a little bit of time. It's very important to apply often and feel comfortable with potential rejection. You're frankly not going to get the interview request at every company that you apply to. You're definitely not going to get the offer from every company that you interview with. And you should go into it understanding that. This is going to be a journey where you're going to be exploring things that you're interested in and things that will hopefully lead you down the path of your next career. I always encourage candidates to celebrate after getting a role. You are probably unaware how much pressure you're putting on yourself during the interview process. Really acknowledging that and taking the time and taking that beat to sit with that for a moment is important before you take that next step. When I got this job, I went out for a crab boil. I remember I came off of the plane and I was getting some good news because I was taking a trip somewhere, and we landed and there was a crab place right there, and we sat down and got some crabs. So loved it. Hi, I'm Chris.
Hi, I'm Kevin.
And congratulations on making it through this course. Now we're going to give you a little bit of a sneak peek on what you can expect for an interview that will cover some of the questions from this course.
We hope this will help you know what to expect in your next interview.
All right, Kevin. So first question for you. What interests you in a career in cloud security?
Chris, my interest in cloud security really comes down to how pervasive cloud security is in our day-to-day lives. Everything from streaming movies and video games pretty much runs on the cloud these days. It's how technology is evolving to become more efficient and accessible and equitable for people around the world. With it becoming more accessible and services running on it, such as banking and family photos and so forth, protecting that information is paramount. So my interest in security for the cloud really comes down to making sure that all that information stays protected and safe.
Well, imagine you would need to explain the main differences between on-premise and cloud computing to a business leader. How would you go about it?
If I was talking to a business leader and trying to describe the differences between on-premise computing and cloud computing, first, I would try to understand how much they understand about cloud computing and on-premise computing. How technical is this business leader? Have they worked in IT, or have they worked, from more of a business perspective where they sort of learned how businesses operate? Or have they actually worked in a server room where they actually built data centers and built servers and deployed computer racks? And depending on where their technical foundation lay, then I would talk to them about how really the biggest differences are with cloud computing. You can save costs and share responsibilities with a cloud provider. So with on-premise computing, they need to hire specialized staff, educate that staff, help them with on-the-job training and possibly cross-training. But with cloud computing, they can rely on a third party that will offload most of those responsibilities for them and help them just run the business.
Imagine a scenario, right, where you're asked to implement infrastructure for a project. What are the benefits of using infrastructure as code in this type of a situation?
When asked to implement infrastructure as a code, really just it's more efficient. It works in ways that can be automated. So there are various vendors and various products that allow you to write what we call playbooks in a human readable fashion. Think of it as a recipe. Think of it as a recipe book, and you can sort of have this recipe book that you can pass on to people who are working in the kitchen, and they will all follow this recipe and do everything exactly as it is. This is really what helps cloud computing become efficient, because if you as a client start with a small business, let's say you have 3 employees, and you'd like to provide them something as simple as email service. What you might do traditionally is maybe deploy that on their individual laptops and go in there and configure them and modify different parameters and do this for each person. And in a small business, that's maybe can be done pretty quickly. But your business starts to grow to 50 employees or 100 employees or 1,000 employees, or big companies like Google, you have 400,000 employees across the world. You can't go to each person's computer and start modifying these settings and parameters. So what you do is you deploy infrastructure as code, and you write these playbooks where you send rules to all these computers, and they automatically build out and deploy everything the same way across the world.
All right. Well, how would using a cloud shell support you in your role as an entry-level cloud security analyst?
Cloud Shell would support my role as a entry-level cloud security analyst by giving me access to generally what we would define as a shell-like or terminal shell-like virtual machine interface that allows me to interact with the cloud environment. This could be something like an integrated development environment, an IDE, where I can run and execute code. And the beauty of an IDE is it'll allow me to have things like color coding of various aspects of the code. Functions will be highlighted one color, various variables will be highlighted different colors. And it really enables sort of this automation and ease of access and modifying of system files and cloud parameters through a shell-like environment.
So what is cloud firewall? What should a cloud cybersecurity analyst consider when defining firewall rules on Google Cloud?
A cloud firewall can be an application or hardware, and it's essentially a resource that allows you to control traffic that comes in and out of a cloud environment. It can allow you to create firewall rules. You can do things like filter out or block port 22 if you don't want SSH access into the cloud environment. It also allows you to sort of create rules that you can distribute to many different computers or many different services running on a cloud platform. Earlier, we alluded to sort of infrastructure as code and the ease by which you can deploy playbooks and rules as opposed to doing them manually at each endpoint. Well, with a cloud firewall, you can automate these tasks. You can make them all in a central resource, and then you can distribute them to remote resources.
Thank you.
Thank you for having me.
In this scenario, Kevin was able to demonstrate how to talk through his answers to show his thinking. By sharing your thought process, you're able to demonstrate what you know and how you solve problems. Problem solving is one of the main things that hiring managers are going to be looking for in an interview. Well, that's it for now. Stay tuned for some more interview tips.
Congratulations on finishing this course. You are well on your way to accomplishing great things in cloud cybersecurity. I love working in an industry where I can protect millions of users every day. We work behind the scenes to improve lives, and soon you will too. Let's take a minute to go over all the things you learned in this course. You began by exploring an introduction to the program and tips for successfully completing the certificate. You also learned about cloud computing and cloud infrastructure, plus how virtualization, containers, and storage function in cloud computing. Next, you deepened your defenses in the cloud using security controls, identity and access management, and networking practices. You also discovered how users and cloud service providers share security responsibilities in different cloud models, like infrastructure, software, and platform as a service. Then you explored automation in the security lifecycle. You learned about teams and workflows, along with automation's role in software pipelines and infrastructure as code. Plus, you learned about the software supply chain and the importance of securing it. Finally, you explored the roles, responsibilities, skills, and tools of a cloud cybersecurity analyst. You experienced Google's Cloud Shell and added some useful solutions to your cloud security toolbox. Congratulations on your progress so far. You're off to a great start.
Hi there. Welcome to the next stage of your learning journey. Congratulations on completing your first course. You learned about the field of cloud security and the roles and responsibilities of a cloud security professional. You also learned about cloud fundamentals and important techniques and tools that you can use in a cloud security role. In this course, you'll learn about risk management strategies that can be used to secure the cloud. You'll also be introduced to critical tools, regulations, and industry standards. You're on your way to knowing more about how to be a cloud security professional. This section's focus is to identify risk management strategies and frameworks and review regulations and security controls. You'll learn how to use these regulations and controls as a cloud security professional to secure cloud environments and meet compliance standards. Let me introduce myself. My name's Preston. I work as a security engineer at Google. This means that I investigate and develop solutions for identifying unauthorized activity in customer environments. I first learned about computer security investigations while working as a software engineer at a former job. At the time, we had unauthorized activity in our enterprise environment, so we hired consultants to perform forensic investigations to identify the who, what, when, and how. This began my broader understanding of offensive and defensive computer security and the necessary components of a cybersecurity investigation. One of the coolest parts of being a cloud cybersecurity professional is that you'll always be learning new things and growing because of it. We'll start with a general overview of security domains, policies, risks, controls, and compliance. You'll explore the relationship between the three areas of compliance: people, process, and technology. You'll even get a chance to practice implementing security controls based on scenarios. Next, you'll explore risk management frameworks, laws, regulations, and industry standards. You'll also compare and contrast data privacy and data protection. Then, you'll get a comprehensive overview of the compliance lifecycle. You'll explore controls and control mapping, assessments and auditing, negative organizational impacts of noncompliance, and policy as code, or PAC, and infrastructure as code, or IAC. Finally, you'll build on your knowledge of risk and vulnerability frameworks to dive deeper into cloud security posture management, or CSPM, for a multi-cloud system. You'll also learn about key cloud tools and their uses for risk and compliance, and about cloud organizational policies. Learning risk management and how to secure your cloud will prepare you for some of the most important day-to-day aspects in your role. Don't forget, I'm here to help you every step of the way. You can work at your own pace, so review videos and resources anytime you need to. You've got this. By the end of this course, you'll know how to confidently use proven risk management to secure cloud assets. Let's get started. Hi, I'm Preston. I'm a security engineer with Google. I split my time between performing forensic investigations of potentially unauthorized activity in customer environments and developing software solutions to improve the investigation workflows for security analysts. My journey to computer security happened by accident. I began my career in software development after graduation. I disliked nearly every aspect of the job and quickly started to panic. I was interested in red teaming and malicious software analysis. As I dug deeper into understanding how malicious software was written and used, I found a new role as a consultant doing incident response for companies who had breaches. I spent several years responding to and mitigating threats for breached companies. Eventually, I moved back into software development role with a better understanding of the process and a better grasp of what capabilities the software project required to serve the frontline defenders. Finding a mentor was a huge help and enabled my continued growth early on. Having someone judgment-free be a resource for what feels like dumb questions can be very helpful. Nobody knows everything. It's a journey that never ends. Lastly, recognize that continuous learning is critical. The field is constantly evolving. Attackers continuously change tactics, which means attempting to always stay ahead is a never-ending endeavor. While daunting, it also provides a new and fresh perspective of the day-to-day work. It's great to have you here. In this section, you'll get an introduction to security domains, risks, controls, and the different areas of compliance. First, you'll learn about security domains and how they relate to compliance. You'll also analyze how compliance differs from security. Then, you'll learn about risks and controls and how they relate to compliance. Next, you'll explore the three aspects of compliance, which include people, process, and technology, and then get an overview of Google Cloud Security Command Center. By the end of this section, you'll learn how to implement cloud security controls. I've got lots to share with you. Let's move on. In your role as a cloud security professional, you'll need to be aware of your organization's cloud security domains. These domains can help you with resource planning, training, and compliance, which are key to securing the business. In this video, we'll discuss domains and how they can help you secure assets in the cloud environment. The International Information Systems Security Certification Consortium, or ISC², is a nonprofit organization specializing in training and certifications for cybersecurity professionals. For ISC², a security domain is a collection of tightly coupled security practices that address a specific security discipline. For example, domains help to ensure that you have the right processes, skills, and tooling in application development so that you can properly and securely write and run code. There are 6 security domains or categories identified by the ISC² Certification for Cloud Security Professionals, or CCSP. Domain 1 focuses on cloud concepts, architecture, and design. Domain 2 consists of cloud data security. Domain 3 addresses cloud platform and infrastructure security. Domain 4 covers cloud application security. Domain 5 investigates cloud security operations. And lastly, Domain 6 explores legal, risk, and compliance. It's important to keep in mind that these domains have no clear boundaries. In other words, tasks completed in one domain can also be relevant in other domains. For example, there are controls in each domain that deal with things like authentication and access control. Security leaders use domains to ensure that there are no gaps or oversights in an area of security. In your role as a cloud security professional, domains can help you choose your discipline and your job skill focus. For example, you might choose to work in the cloud security operations domain. Knowing the skills and work that make up that domain would help you plan a development path to build relevant skills and experiences on your career journey. Let's explore different domains. The Cloud Concepts, Architecture, and Design domain focuses on high-level security that aligns with your organization's objectives. In the same way that an architect plans and designs for a house based on specifications, this domain is responsible for ensuring that the security designs and services will meet the business needs of that organization. Next, the Cloud Data Security domain focuses on security of data within the cloud environment. It includes all procedures used in designing and implementing encryption, access controls, data loss, prevention, and tokenization techniques to ensure the confidentiality and integrity of data. Identifying and classifying data is critical to this domain. Controls are matched according to the value and sensitivity of data, as well as relevant laws and regulations. This domain is like the plumbing of the cloud environment. It determines how communication will happen and how data will move into and out of the systems under control, like water running through pipes into and out of a building. The Cloud Platform and Infrastructure Security domain addresses the virtual and physical security threats to cloud infrastructure, including cloud infrastructure connections, cybersecurity, and the implementation of audit tools. People working in this domain could be compared to builders laying a good foundation for the rest of the structure that will be built. The Cloud Application Security domain focuses on how applications for the cloud environment should be built, released, and maintained. This might include investigating all cloud computing application security challenges, including identity and access management, developing secure software, threat modeling, and validating software security through testing. This domain could be compared to a carpenter that uses raw materials to build sound structures to secure the inside and outside of the house from internal and external threats. The Cloud Security Operations domain covers how to securely operate the designed, built, and deployed environment, including how to respond to events and restore the environment to a secure state. This domain addresses issues that arise from using cloud computing services. It focuses on responding to and resolving any issues that may impact the confidentiality, integrity, or availability of applications running in the cloud. This may include attacks, configuration mistakes, or even cloud provider outages. This domain could be compared to the person that is responsible for installing final safety features like alarm systems and smoke detectors after a building is built. People in this domain focus on safety and alerts once the cloud structure has been built. Finally, the Legal, Risk, and Compliance domain focuses on the legal and regulatory implications of cloud-based applications. It explores how cloud computing influences business risk management and how cloud security controls are audited. This domain is like an inspector that makes sure everything in a building complies with standards and regulations. That was a lot of domains. Understanding each of these domains will help you be a more well-rounded and effective security professional and possibly find the right domain fit for your next role in cloud security. Now that you know about security domains and what they do, you will be able to discuss and analyze the different domains within the cloud environment. Keeping things safe means to pay attention to the details and make sure to operate using sets of rules. As a cloud security professional, security and compliance will be a key aspect of your job. While these two topics are related, it's important for you to understand their differences. In this video, we'll explore how you can use security and compliance together to help keep your systems safe. It's important to call out, our discussion in this course should not be considered legal advice. First, let's discuss security. Security includes systems and controls that protect an organization's assets from threats. Security ensures confidentiality, integrity, and availability of the organization's services. These threats can happen through a breach, leak, or cyber attack. Methods to ensure security include mitigate identified threats with different types of controls, like firewalls, strong password management tools, and a multi-factor authentication. Implement controls designed to prevent threat actors from impacting your organization's business functions. Provide guidelines for responding to a breach in a worst-case scenario. And require a cloud security team to protect a system by threat modeling and risk assessment. While security protects an organization, compliance is the process of adhering to internal and external standards and government regulations. These can include the International Organization for Standardization, or ISO, the National Institute for Standards in Technology known as NIST, or federal law like the Health Insurance Portability and Accountability Act, or HIPAA. To be compliant, an organization must provide evidence that they are following the stated objective, like one of the standards, rules, regulations, or laws that apply to their business. Let's find out how business can address both security and compliance in an example scenario. Imagine that a retail store is required by the head office to install employee fingerprint authentication for things like clocking in, accessing areas of the store, and using the point-of-sale system. Requiring fingerprint authentication is security. It prevents unauthorized access. Providing evidence that the store is using fingerprint authorization correctly to the head office and regulatory bodies is compliance. Compliance standards are not unique to a single organization. The standards measure security protocols at a given point in time or over a specific period of time for any organization. As in the earlier scenario, an organization needs to provide evidence that they meet the required standards, rules, or regulations. There are many positive outcomes of compliance. Proper compliance builds trust within and between organizations. For compliance, there are a set of prescribed controls and practices that help to ensure the required minimum level of security is in place. Compliance shows stakeholders and users that a system meets the required level of security without requiring them to go through the difficult process of verifying for themselves. Compliance also gives a potential business partner or user confidence that an organization will protect their information. But being compliant doesn't mean that all assets are secure or that you have an effective security system. Compliance set a minimum standard for security and establishes a common ground for organizations. Compliance might require a certain type of encryption to meet a security standard. This might influence the controls an organization chooses. For example, the organization might want to use stricter controls than compliance requires because of the specific security threats they have to deal with. Compliance helps an organization be more secure with measures that provide a set of clear frameworks, checklists, and best practices. For example, the NIST Cybersecurity Framework, or CSF, is a set of guidelines and best practices to help organizations build and improve their cybersecurity posture. The NIST CSF is a compliance framework that can easily be adapted across industries to create strong security programs. Security and compliance are complementary processes. A strong security system makes it easier for an organization to meet compliance standards because most of the necessary controls are already in place. As a cloud security professional, you'll not only be able to differentiate between security and compliance, but you'll also use them to strengthen each other. This will better prepare you to manage risk in the cloud.
Cloud's a great democratizer of talent, so anybody can go to work straight away in the cloud, get access to a large array of technology that's a lot easier to use than it used to be. And so a lot more people can have a lot more skills and capability by building on the cloud. Hi, I'm Phil. I'm Chief Information Security Officer at Google Cloud. The role of a Chief Information Security Officer is really to be in charge of many different types of risks, whether it's security, privacy, compliance. It's mostly internal facing, making sure what we build for our customers is secure and compliant, but also a large part of it is working with our customers, helping them build on our platform in secure ways. I started in the 1990s in cybersecurity, and like a lot of people of my generation, we kind of stumbled into doing this. So it was not something I set out to do. I was a software engineer building many different types of systems. Ultimately, started developing secure systems at the beginning of the internet and the beginning of a lot of critical uses of the internet, and I stayed doing that ever since. Probably the main thing about why I kind of find cybersecurity exciting is it's just the ability to just work across everything a company does. And so every single day is different because you're involved in different product launches, you're involved in different geopolitical situations, you're involved in new technologies. And so it's just the breadth and diversity of what we do that's really exciting. When you think about cybersecurity in the context of cloud, it's really an opportunity to get security right. So what we've done in the cloud is we've designed security so that it's built in, not bolted on after the fact. And for many organizations that move to the cloud, it's their first opportunity to get security right because we've architected it in. And I think that's a tremendous moment of transformation for many organizations. The great thing about cloud technology is it permits businesses of all sizes to be able to grow. A small startup business can tap into the cloud and get the scale of capability that was previously only available to major corporations. And that's a tremendous competitive edge for those companies. So cloud's going to keep evolving. Again, every customer that comes onto cloud, every organization that comes onto cloud has new ideas about what they want cloud to be. And a cloud provider, we're constantly taking that feedback, building new technologies, field testing it with customers, and they give us even more feedback. So it's like a great flywheel that's propelling the innovation forward. In cybersecurity, we really look for people who can collaborate in teams, maintain curiosity, and deliver on that mission of protecting our customers. If you want to get started in a career in cybersecurity, I would say the important and perhaps obvious thing is just to take that first step. So any of us that have been in this field a long time, at one point we knew nothing about it, and we took that first step. Watching that first YouTube video, taking that first certificate, taking that first class, downloading that first toolkit and playing around with things. The important thing is to just take the first step and then the next one and the next one, and don't get overwhelmed. Just take those things one step at a time.
It's always better to prepare for a threat than to respond to one. Implementing security controls to reduce risk will be an important part of your role as a cloud security professional. Security controls are also a key part of both security and compliance. In this video, you'll learn how security controls can help you secure your organization's assets so you can meet compliance standards. A security control is a safeguard designed to reduce specific security risks. Security risk is the total of both the likelihood and the impact of threats on assets. As a cloud security professional, reducing the security risks in an organization means that you are trying to either reduce the impact from the threat or reduce the likelihood of that threat. For example, if you encrypt data, you reduce the impact of a breach because the attacker cannot see the data without the key. You might also use two-factor authentication in order to reduce the likelihood of a threat actor accessing a network or system should the threat actor steal a password and try to use it to impersonate a user. Next up, we'll explain how you can also use combinations of controls to reduce risk by addressing impact and likelihood of an attack. Cloud security controls are measures that safeguard cloud environments from threats and minimize the effects of harmful attacks. Security controls are a central element in any cloud computing strategy. CSP-offered cloud security control measures may be part of a shared responsibility or a shared fate agreement with the CSP and the organization using its services. The CSP automatically provides some controls for their customers, such as physical security, secure by design practices in software development, and strong security defaults on services. The CSP also makes some controls available as considerations for businesses' needs. An example of this is customer-managed encryption keys. Other controls the CSP offers can be those measures that are customer-inherited and customer-modifiable. These measures help ensure a consistent protection for data and workloads. To demonstrate compliance as a cloud security professional, you must prove that the required security controls are in place. To achieve compliance, you can make use of some built-in and third-party cloud security tools and run reports on workloads. Now that you know more about implementing security controls to protect assets and meet compliance standards, you can be better prepared for your role in security in the cloud. Imagine you're going rock climbing. Your plan is to have fun, but you also know there are risks involved. To keep yourself safe, you pack all the safety gear you can, like a harness, a helmet, ropes, and hooks. Just as in climbing, risk management also needs proper safety measures. As a cloud security professional, you'll be responsible for protecting vulnerable assets. This means you'll need to understand risk and know how to reduce it to meet your security and compliance standards. In this video, we'll explore risk and how it relates to compliance. First, let's review risk. Risk is the measure of how much a threat impacts the confidentiality, integrity, and availability of an asset. Common examples of risk include data loss, data leakage, and data corruption. Data loss happens when data is deleted without authorization due to either a mistake by an authorized user or an intentional action by a threat actor, resulting in a breach in availability of data. Data leakage happens when sensitive data is handled improperly or when threat actors, entities imposing a threat, get access, resulting in a breach of confidentiality and sharing with other unauthorized users. And data corruption happens when data is either changed because of an unauthorized user or a system malfunction, resulting in a breach of quality or trustworthiness of data. Now that we reviewed risk, let's explore its relationship with threat, vulnerability, likelihood, and impact. Remember, a threat is any situation or circumstance that can negatively impact assets. Vulnerabilities are weaknesses that can be exploited by threat actors. Likelihood is the probability that a vulnerability will be exploited by a threat actor and includes the extent of the impact of the threat. For example, if an organization has a poorly configured access management system, a lot of employees may have access to more sensitive corporate data than they need to do their job. This means there's a likelihood that a threat actor could compromise employees' accounts, which could lead to a major data breach. One method of determining the level of risk is to rank the likelihood of an attack and the severity of the impact or outcome. This can help to determine if the level of risk is low, medium, or high. Analyzing risks, their likelihood, and impact will help you decide the best controls to put in place. As a cloud security professional, you'll be responsible for reducing risk to an acceptable level, called the risk appetite, for your organization's cloud assets. The risk appetite is the amount of risk an organization is willing to take and still meet organizational needs. It could also be described as the maximum amount of residual risk an organization will accept after controls and other measures have been put in place. Determining the level of risk will help you to determine the risk appetite. So how does risk relate to compliance? Compliance certification is proof that you meet established industry regulations and standards to protect your organization from risks. Compliance proves that an organization is following the rules. A lot of compliance certifications are renewed regularly or whenever a new law or regulation version is published, or when security controls of a system have changed significantly. Compliance certifications focus on gathering evidence that security controls are in place at or over a specific time period specified in the audit protocol. Meeting compliance requirements is a risk mitigation activity, but risk management doesn't stop at compliance alone. To more fully handle risk management, a security team needs to also assess security systems for vulnerability often. Security is an ongoing, real-time evaluation of the threat landscape and the state of controls to address those threats. Security also includes vulnerability scanning, control health monitoring, and log reviews. Now that you know more about the relationship between risks, threats, vulnerabilities, likelihood, and impact, you can be better prepared to protect vulnerable assets, just like you would plan to protect yourself if you were to go on a rock climbing trip. Planning for potential risk factors is a valuable skill that will help you be a more effective cloud security professional. Let's start off this video with an on-the-job example you might have as a cloud security professional at a large university. The university just invested in a monitoring tool to protect student records your security team is storing in the cloud. The team needs to define a clear process for using the tool and understanding the reports. This way, the team will make the best use of the new technology, using it correctly and efficiently. You've already learned about how people, processes, and technology play a part in the software supply chain. In this video, we'll explore how having an effective relationship with people, process, and technology can help an organization maintain compliance. The People, Process, Technology, or PPT framework was originally created for businesses in the 1960s to improve the efficiency of their employees and tools. Today, it's used for information technology management. To be compliant, an organization must have strong processes in place to ensure that they're using technology in the most effective way. The PPT framework can help organizations meet their security and compliance goals. In the PPT framework, each piece reinforces the other. Technology is most effective when supported by strong processes and talented people. And with the right processes in place, technology can help people be more effective or efficient when completing specific tasks. Let's explore the three different components of the PPT framework and find out how each fit in with the university example I shared above. People include staff, users, and decision makers that follow processes to use technology safely and effectively. To build a strong culture of compliance, it's important to educate users and provide them with procedures. At the university, the cloud security team can train staff and provide resources that explain protocols. The team can also create processes to ensure protocols are followed. Processes include how people should use new technology and how it should be created or adapted. Examples of effective processes include enforcing two-factor authentication, mandatory software updates, removing access rights from users who no longer need them, and implementing protocols for running scans and analyzing reports. At the university, the cloud security team can create a process to make sure staff know to complete scans, generate reports, and take the correct actions based on the reports. Technology not only helps to ensure compliance, it should also meet the organization's needs. At the university, the security team adopts a monitoring tool to help meet compliance requirements. This technology will also help protect student and faculty records, along with other sensitive information. Balancing and adjusting PPT will be an important part of your job as a cloud security professional. By understanding the relationship between people, process, and technology, you can help your organization more effectively use tools and technology. You can also ensure that your organization meets their security and compliance standards. It would be very difficult for cloud security teams to meet all of their organization compliance and security standards manually. This is where cloud technology can help make so many day-to-day tasks that all need to get done more manageable and effective. And with this technology, a security team's work just got a little lighter. In this video, we'll explore how Google Cloud Security Command Center can provide teams assistance to maintain and manage their security posture and compliance. Let's get started. Security Command Center is Google Cloud's centralized vulnerability and threat reporting service. It evaluates an organization's security and data attack surface, provides asset inventory and discovery, and identifies misconfigurations, vulnerabilities, and threats. Some benefits of Security Command Center include improving security posture, detecting and uncovering threats, and assessing and managing risk. Security Command Center can improve security posture by identifying security misconfigurations and vulnerabilities in your Google Cloud environment and helps resolve them with actionable recommendations. It can detect and uncover threats with specialized detectors built into the Google Cloud infrastructure. And it can assess and manage risk using attack path simulation to discover and shut down possible pathways that threat actors can use to access and compromise cloud resources. The key features of Security Command Center are threat prevention, threat detection, and attack path simulation. First is threat prevention. Threat prevention determines whether an organization's Google Cloud has the expected security posture. Threat prevention can also uncover misconfigurations and find common web application vulnerabilities to quickly resolve issues with best practices. Second is threat detection. Threat detection protects an organization's resources by detecting threats to cloud services like Google Compute Engine, Google Kubernetes Engine, BigQuery, Cloud SQL, and more. Third is attack path simulation. Attack path simulation helps pinpoint where and how an organization's Google Cloud environment could be attacked. This simulation can provide an organization a way to analyze vulnerable paths to valued resources and prioritize the right preventative security controls. Google Security Command Center is just one of several tools you might find in your role on a cloud security team. The right tools for an organization's need will help reduce risk and maintain compliance in the cloud. Cloud computing and security controls will differ for an organization. Since cloud computing is different from an on-premises deployment, cloud security controls will also differ. In this video, we'll review cloud security controls and how to determine which controls should be implemented to reduce risk. Remember, cloud security controls are measures that safeguard cloud environments from threats by reducing the likelihood and impact of harmful attacks. There are three types of cybersecurity controls: technical, administrative, and physical. Technical controls include hardware and software used to protect assets. Administrative controls include policies, procedures, and guidelines put into place to protect assets. Physical controls include any concrete means of preventing or detecting unauthorized access to facilities, systems, or assets, like gates and locks or keycards to enter a building. As a cloud security professional, when you properly implement security controls, you help safeguard cloud environments from vulnerabilities, minimize the effects of harmful attacks, meet and maintain your organization's compliance goals. Security controls are a central element of any cloud computing strategy. So how do you decide which controls to use and when? As you may recall, threat modeling is the process of identifying assets, their vulnerabilities, and how each is exposed to threats. Here's a pro tip. Conduct a threat model to identify the right controls for the threats your organization faces. This will help the cloud security team save time and money. If a threat is related to a low probability or a low impact risk, then the organization can accept the risk, or it can be transferred instead of mitigated by a control. An organization can transfer risk by buying a cyber insurance policy that helps cover this risk, or transferring the risk to the user in the terms of service agreement. For threat modeling, you can use an existing threat model methodology to identify threats across common threat categories. Then, you can select controls to address the threats that you've identified. For example, if you identify an attack risk that threatens proper authentication in your threat model, you might choose a control like second-factor authentication using a key to help prevent the attack. After applying controls based on the threat model and standards and regulations, there may be some remaining risk or residual risk. Residual risk can be accepted or reduced. If the team accepts any residual risk that remains, there is a possibility that the business might fail to meet necessary compliance with the required standard or regulation. If an organization is unable to show they are compliant, they risk fines and civil and criminal penalties. The organization might also be unable to sign contracts with partners or customers that require standards or regulations. By threat modeling and checking that you've met compliance control standards, you can implement the necessary controls to reduce risk to an acceptable level. A critical part of your job as a cloud security professional will be implementing security controls to reduce risk and maintain compliance. There are many choices for controls, so it'll be important for you to think of your organization's needs and potential risks when choosing and implementing them. In this video, we'll give you some steps you can follow to implement security controls and develop an implementation plan so you can be successful in your role. So let's get started with the steps to implement security controls. The first step is to identify controls. It's helpful to start with threat modeling to identify the controls you should implement. That way, you can identify a specific threat and choose the best control to eliminate it or reduce the risk. Imagine that you've identified a potential account spoofing threat, which is where a threat actor disguises their identity. So you decide to implement a second-factor authentication using a physical security key as a control to mitigate the risk of spoofing. The second step to implement security controls is to develop the implementation plan. During this step, consider whether the entire organization needs a physical security key, or if only certain groups like executives, remote workers, or highly privileged accounts need security keys. Since the majority of your organization works remotely and needs to access sensitive data, your team determines that physical keys should be required across the organization, including contractors and third-party vendors. Next, you and your team will need to develop policies and procedures for implementing the control. It's also important that employees and contractors are aware of how to get and use a security key and what is expected of them. So, your team will need to develop policies around implementing this control. Also, be sure that everyone knows how to reach the appropriate people in case of questions, clarifications, or incidents. You'll also need to ensure that you have the budget to buy all the keys. The third step to implement security controls is to accurately test and validate the security controls your team deployed. This step is important to truly determine whether an environment is secure. To test and validate a physical security key, you can use reports to measure and track your users' enrollment in two-step verification with a security key. That way, you can check users' enrollment status, the number of security keys, and enforcement status. Enforcement status refers to how and if the two-step verification is being enforced within an organization. Each user can also verify they can sign in with their own key. After you've implemented and tested each control, continue to the fourth step, monitor and maintain the control's effectiveness. Your team will also make adjustments as necessary. The fifth and final step to implement security controls is to record the process in the team's security plan document. These actions include the security control selection and implementation processes. This document is useful because it will explain the why and the how for implementing security controls. This documentation is also essential for communicating how controls relate to your organizational risk management and compliance goals. Implementing controls is an ongoing process and an exciting part of being a cloud security professional. In your role, you'll continually strategize to mitigate threats and work with people throughout your organization to ensure proper deployment and use of controls. Congratulations on completing this section. Throughout your journey, you learned a lot about frameworks, security domains, and risk and security controls in relation to compliance. You started by learning about security domains and policies and how they relate to compliance. You also analyzed how compliance differs from security. Then you learned more about risk and controls and how they relate to compliance. Next, you explored the 3 aspects of compliance, including people, process, and technology. You also got an overview of Google Cloud Security Command Center. Finally, you learned more about cloud security controls and how to implement them. You've accomplished so much already. Keep up the great work. Welcome. In this section, you'll learn about risk management frameworks, regulations, and industry standards for cloud computing. This section covers lots of tools and topics that will be important in various security roles. You'll learn about laws and regulations for the cloud and the industry standards that must be applied and upheld. You'll also find out about different frameworks developed by respected organizations and how to choose the right framework based on the organizational needs. It's important to call out, our discussion in this course should not be considered legal advice. First, you'll learn risk management frameworks. You'll get an introduction to common frameworks like NIST CSF and ISO 27001. And learn how to analyze the similarities and differences between common frameworks. After that, you'll learn about industry regulations and laws for data privacy and protection. Let's get started.
I was a special agent in the Federal Bureau of Investigation for 22 years. It was during that time in the FBI where I was assigned an investigation that included a cybersecurity element to it, and that's what I would call my pivot moment. That really was the deciding factor for me. I need to invest time, cycles, develop my intelligence on this, take courses, do whatever I need to do in order to get smart on it. My name is M.K. Palmore. I'm a director in the office of the CISO for Google Cloud. My team is responsible for helping customers onboard safely and securely into the cloud. I'm a child of the 80s, and for those of us in Gen X that come from that generation, everything in the 80s was really about the opening of the door to all things computers. Even families that, like mine, that were socially and economically disadvantaged, we even had opportunities to avail ourselves of computers and computing technology. And so this interest in computing and what it might evolve into, I think the seeds were planted. Cybersecurity is important in a cloud-first world because cybersecurity is the number one topic for business enterprise risk. I made a pointed decision on my own to change my career path and begin investing in the opportunity to learn and become educated in cybersecurity. The skill that I think is most important for cybersecurity practitioners is a willingness to understand that you don't know everything. I'm a huge supporter of certificate programs, certifications in the industry, because that is the pathway that I took in order to get educated. I feel that the more training that we can make available to a wider audience to give folks that opportunity to get educated in this field, I just think the better off we're all going to be. Cloud is probably the most exciting industry to be in right now because the possibilities, I think, are endless. The benefits of cloud to business, to individuals, to society overall, I think that trajectory is still on an upward arc. So when you combine cloud with cybersecurity, and you think about it in terms of the availability of jobs in the job market, this is a market that will continue to expand for years to come.
As a cloud security professional, you'll usually have to work with an organization's risk management tools to identify and manage possible threats. These tools are usually summarized in an organization's risk management program, which is often informed by a framework, standard, or regulation. In this video, you'll learn about some of the common frameworks and their importance for an organization's security. It's important to call out, our discussion in this course should not be considered legal advice. A risk management framework is a set of practices, processes, and technologies that enable an organization to identify, assess, analyze, and manage risk within an organization. Frameworks are a tool for risk management. Their goal is to reduce risks to an acceptable level and improve security posture. Frameworks identify common goals around cloud security and provide the structure and common language needed to maintain them. Here are some examples of industry standard frameworks. The National Institute of Standards and Technology, better known as NIST, Cybersecurity Framework, the International Organization for Standardization, or ISO, 27001, and System and Organization Controls 2, referred to as SOC 2. The NIST Cybersecurity Framework, or CSF, is a voluntary framework that outlines a risk-based approach for governing security, privacy, and a cyber supply chain risk management. The NIST CSF helps organizations to better understand, manage, and reduce their cybersecurity risk and protect their networks and data. The CSF provides an outline of best practices to help an organization decide where to focus their time and money for cybersecurity protection. Another framework you might work with is based on ISO 27001, which is an international certification that focuses on information security management systems. ISO 27001 is a combination of standards included in other frameworks, and its goal is to protect three main aspects of information: confidentiality, only authorized persons have the right to access information; integrity, only authorized persons can change the information; and availability, the information must be accessible to authorized persons whenever it is needed. The last risk management framework that's commonly used in cloud security is the SOC 2 framework. The SOC 2 framework was developed by the American Institute of Certified Public Accountants, or AICPA, and leverages the AICPA's trust services criteria to build trust and confidence for clients about a third-party service provider's system. The trust services criteria are used to evaluate controls relevant to security, availability, and processing integrity of the system that a third-party service organization uses to process clients' data and the confidentiality and privacy of the information the system processes. As a cloud security professional, you'll usually have to work with different security frameworks, so learning about the more common ones and their goals is very important. The more you know, the more you can safeguard a business network and data. Now that you're familiar with the most widely used frameworks, you can continue to build your knowledge as you grow your career in cloud security. You probably wouldn't share personal details about yourself with just anyone, especially with threat actors. As a cloud security professional, part of your job is to protect personal information from being accessed by unauthorized users. In this video, we'll discuss data protection and privacy, and how to prevent data from being used in ways that can cause a security incident, like a data breach. It's important to call out, our discussion in this course should not be considered legal advice. Data privacy focuses on an individual's rights to be in control of how and when their data is accessed and used. It includes the rights to be accurately represented by the information, to be informed about its use, to refuse its use for secondary purposes, and to erase or remove information when they choose. Personal information includes things like one's name, location, contact information, or online or real-world behavior. Just like you may exclude people from a private conversation, a lot of online users want to control or prevent certain types of personal data collection and use. For example, imagine that you are using an app to make an appointment on your smartphone. If you did not disable location services on your smartphone, the app might ask for your location to suggest the closest office to schedule your appointment. You can choose to decline the app's access to your exact location. This is an example of data privacy. You can also decline to accept cookies when visiting a website, as another example. When you decline or turn off cookies, you're refusing to share personal information about how you interact with websites. There are laws and regulations that have been put into place to protect the privacy rights of users. Examples of these laws include General Data Protection Regulations, or GDPR in Europe, and the California Consumer Privacy Rights Act, also known as CPRA. GDPR and CPRA put laws in place that grant consumers, as data subjects, certain rights regarding the use of their personal information. An organization must take measures to protect the data that they gather to meet data privacy obligations. This is called data protection. Data protection also covers protection of other data, like intellectual property, or IP. IP might include anything from a musical composition to an architectural design that the creator may copyright, trademark, etc. Data protection helps enforce policies and regulations, prevent unauthorized access, focus on keeping information safe from attackers, ensure that data is protected from unauthorized intervention and access, safeguard collected data, and is closely tied to security controls. An organization can protect data by putting controls in place that prevent unauthorized access and keep data and information safe from attackers. To protect data, an organization could ensure that they have good authorization and access control for the data and the systems that house the data, and then they could use encryption key to conceal data. They would also want to make sure that good key management policies are in place. In this video, you learn that data protection and privacy are important parts of risk management. You also learn that there are laws and regulations that ensure data protection and the right to data privacy. Staying up to date with data privacy and protection standards will help you and your organization to mitigate risk, meet compliance standards, and protect users. Remember, when a user's privacy is safe, they can safely go about their business. In this video, we're going to focus on a specific framework developed by the National Institute of Standards and Technology, or NIST, using a practical workplace scenario. It's important to call out, our discussion in this course should not be considered legal advice. First, it's important to know that the NIST privacy framework was developed to help improve privacy risk management for an organization's data. It is an international framework that strives to create a common language for international cooperation on privacy. The NIST privacy framework has three parts: core, profiles, and implementation tiers. First, the core is a set of privacy protection activities and desired outcomes that allows for communicating prioritized privacy protection activities and outcomes across the organization. Second, when using the framework, an organization has to develop one or more profiles for the privacy outcomes it wants to achieve. Profiles represent the privacy outcomes the organization aims to achieve. To develop a profile, an organization will review the functions, categories, and subcategories of the framework and decide which functions are the most important to focus on. This will help them achieve their desired privacy outcomes based on business needs. And third, implementation tiers provide context on how an organization views privacy risk and indicates if the organization has adequate processes and resources in place to manage that risk. Now that you know the tiers of the framework, let's examine a workplace scenario that demonstrates why the NIST framework is an essential tool. In this scenario, a large retail organization is in the early stages of developing an application for their home appliances. They want to create an application that will allow consumers to register their devices for warranties and updates, access information about their usage history, and enable universal remote control use for multiple products. The organization requires stakeholder approvals before a product can be released to consumers. Plus, the organization must comply with domestic and international privacy laws and regulations. To help keep their information secure, the organization implements the NIST framework to develop their application. Security frameworks are also useful tools that can help organizations meet their privacy obligations with the right selection of security controls and data protection practices. The organization requires stakeholder approvals before a product can be released to consumers. Plus, the organization must comply with domestic and international privacy laws and regulations. To help keep their information secure, the organization implements the NIST framework to develop their application. Security frameworks are also useful tools that can help organizations meet their privacy obligations with the right selection of security controls and data protection practices. Since security frameworks might have different guidelines for what is considered a risk and how to manage it, your organization might use multiple guidelines and frameworks simultaneously to keep all their data secure. For example, there are overlaps in cybersecurity and privacy risks. Cybersecurity risks arise from an unauthorized activity related to the loss of confidentiality, integrity, or availability of a system or information asset. The NIST Cybersecurity Framework is a tool that a cloud security team can use for data protection. On the other hand, privacy risks arise from authorized activity. For example, a food delivery app may be gathering too much data on its users, which can present a privacy issue. A security team can use the NIST Cybersecurity Framework and the Privacy Framework together as a tool to achieve data security. They work together because the Privacy Framework allows the security team to ask questions about the purposes for data collection and the appropriate retention of the data. The Security Framework then helps pick the right controls for the protection of the data that the app collects and retains. Now that you know more about how to apply the NIST framework, you can start learning about different frameworks and practice applying them to different scenarios. Just like a real cloud in the sky, the cloud that stores data is all over the world. With the widespread use of cloud technology in almost every industry and sector, laws and regulations have been developed and updated to help ensure that data in the cloud is safe and that users are protected. In previous videos, we discussed how frameworks are tools that can help you follow the regulations or laws for your industry. In this video, we'll discuss some of these common laws and regulations like FedRAMP, HIPAA, GDPR, and CPRA. It's important to call out, our discussion in this course should not be considered legal advice. The Federal Risk and Authorization Management Program, or FedRAMP, is a government-wide program that provides a consistent approach to security assessment, authorization, and continuous monitoring for cloud products and services in the United States. FedRAMP's purpose is to ensure compliance of third-party cloud services for government users handling sensitive data. All federal government agencies and non-federal government organizations providing services to the federal government in the United States are able to leverage additional security provided by FedRAMP, and some agencies or organizations may be required to use FedRAMP authorized cloud services if they are handling particularly sensitive data, like personal identifiable information, or PII, and protected health information, or PHI. Another important law is the Health Insurance Portability and Accountability Act, or HIPAA, a U.S. federal law for healthcare organizations. HIPAA includes rules that address the use of standardized electronic insurance transactions, privacy, and security. The privacy rule focuses on the use and sharing of all PHI by what are known as covered entities. Covered entities include healthcare providers, healthcare plans, healthcare clearinghouses, and their healthcare business associates. The security rule protects a subset of information covered by the privacy rule. This subset is all identifiable health information a covered entity creates, receives, maintains, or transmits in electronic form only. This information is called Electronic Protected Health Information, or ePHI. The General Data Protection Regulation, or GDPR, includes regulations that protect personal data and privacy of the residents of the European Union, or EU. All member states of the EU and international organizations handling EU resident data are obliged to follow the regulations set out by the GDPR. These regulations consist of a broad set of rules that require businesses to protect the personal data and privacy of EU residents for transactions that occur within EU member states. The GDPR also regulates the exportation of personal data outside the EU. The California Privacy Rights Act, or CPRA, is a consumer privacy law in the state of California intended to protect consumers. It enables consumers to know about, delete, or opt out of personal data that is gathered. There are a lot of laws and regulations to be mindful of, and they might seem ethereal like clouds in the sky, but they're important and useful measures that protect users and businesses. As a cloud security professional, you'll need to stay up to date with the laws and regulations for your industry and your geography's governing bodies. Everybody loves getting things done more efficiently and in less time. As a cloud security professional, you'll need to know how to apply industry-specific standards, rules, and requirements using tools and frameworks. It's important to call out, our discussion in this course should not be considered legal advice. Asking the right questions can help you choose the best risk management framework for your industry's compliance standards. Some important questions your security team should answer are, what standards, rules, and requirements apply to our industry? This is one of the largest factors that drives most regulatory coverage. What kind of data do we plan to work with? Do we work with PHI, PII, or financial and credit data? And which geographies and jurisdictions do we operate? This is very important for sovereignty requirements, data movement, and processing and control responsibilities. In addition to these questions, you could also ask, do we plan to work with governments? If so, which ones? Will these workloads be in the cloud, on-premises, or mixed? Let's explore a workplace scenario to understand the process of applying specific requirements for your industry and organizational needs. Imagine you are part of the cloud security team for a large statewide healthcare provider. The organization handles PHI, takes electronic payments, and works with insurance companies and federal health insurance. In this scenario, if your organization is determined to be a covered entity by HIPAA, your team will be obliged to follow all HIPAA laws for handling PHI. Some states create additional healthcare laws, so the team will also want to follow any statewide laws and regulations based on location. Your team can use a framework to map controls for those laws. Your team will also want to consider how payments are handled, like patient copays at the office. Critical thinking is not always listed as a qualification on a job listing, but it's a highly valuable skill to a lot of employers. When you know the specific regulations and standards associated with your industry, you can get answers to the right questions. These answers will help your team choose the right frameworks and controls. As a cloud security professional, you'll usually have to review assets and verify they meet the standards and frameworks. You'll also need to be able to describe what you notice in terms of your organization's compliance objectives. In this video, we'll explore the standards and frameworks and discuss how they can help you in your career as a cloud security professional. It's important to call out, our discussion in this course should not be considered legal advice. The Payment Card Industry Data Security Standard, or PCI DSS, is a widely accepted set of policies and procedures intended to optimize the security of credit, debit, and cash card transactions. PCI DSS also protects cardholders against misuse of their personal information. The PCI Security Standards Council, also known as PCI SSC, was created in September of 2006 to address the changing security standards in the payment card industry, or PCI. is an independent body created by major payment card brands focused on improving transaction security. The PSI SSC set the standards for payment security. Then, payment card brands may require merchants to follow these standards to maintain compliance. Keep in mind, the payment brands are responsible for enforcing PCI DSS compliance, not the PCI Council. The PCI DSS applies to any organization that accepts, transmits, or stores any cardholder data, regardless of the size of the organization or the number of transactions. All merchants will fall into one of 4 merchant levels based on transaction volume over a 12-month period. Each level determines the security and audit scope required to remain compliant. These levels are set by payment card brands and so may differ from each other. These levels are not set by PCI SSC. Let's dive into each of these levels. Level 1 applies to merchants that process over 6 million card transactions per year by any method, including online, in-store, or by phone. Level 2 applies to merchants that process 1 to 6 million card transactions per year. Level 3 applies to merchants that process 20,000 to 1 million e-commerce transactions per year. E-commerce transactions are transactions related to buying and selling goods online. Finally, Level 4 applies to merchants processing fewer than 20,000 e-commerce transactions per year, and any other merchant processing up to 1 million card transactions per year. There are 3 ongoing steps a cloud security team follows to adhere to the PCI DSS. First, assess means to identify all locations of cardholder data and analyze processes and IT assets for vulnerabilities that could expose cardholder data. Second, repair means to fix the identified vulnerabilities. You can do this by securely removing any unnecessary cardholder data and implementing secure business processes. And third, report means to document assessment and remediation details and submit compliance reports to the bank and card brands you do business with. Along with the PCI DSS, you'll also need to be familiar with the ISO 27001 framework. Remember, the ISO 27001 is an international framework that focuses on information security management systems. The 3 aspects of information security in ISO 27001 are confidentiality, information integrity, and the availability of data. This is also known as the CIA triad. Confidentiality means that only authorized people can access the information held by the organization. An example of confidentiality risk is a threat actor gaining unauthorized access to client logon details and selling them online. Information integrity means that data within an organization is not erased or damaged, but instead reliably stored and not changed without authorization. A risk to information integrity might be a staff member that accidentally deletes some content in a file. Lastly, availability of data means that an organization and its authorized clients can access information whenever they need to. This ensures the organization meets business needs and user expectations. Availability of data could be put at risk if a database goes offline due to server problems and insufficient backup. Knowing about PCI DSS compliance, ISO 27001, and the CIA triad will help you implement these standards and frameworks for workloads within your organization. Congratulations! You made it through another section of this course, and you've learned so much since you started. You're doing an amazing job. In our time together, you learned about common risk management frameworks like NIST CSF and ISO 27001 and their similarities and differences. Then, you learned about data privacy and data protection and how they're different. We covered common laws, regulations, and industry standards for data privacy and protection like HIPAA and GDPR. Next, you defined and analyzed industry regulations and laws for data protection and privacy. You reviewed laws that apply to certain industries like FedRAMP for the U.S. federal government and HIPAA for U.S. healthcare. You also considered local regulations like GDPR for the EU and CPRA for California. Finally, you dove deeper into the industry standards. Remember, it's important to call out, our discussion in this course should not be considered legal advice. I think you've got what it takes to protect and manage an organization's data. You've got this. Welcome. It's great to have you here. In this section, you'll get an overview of the compliance lifecycle and learn why lifecycle is important to risk management. You'll also learn how to use tools and techniques to meet compliance and maintain a strong security posture. You'll begin this section with a comprehensive overview of the compliance lifecycle and control mapping, where you'll learn what control mapping is and how to implement it to meet compliance obligations. Next up is cloud assessments and auditing. You'll get to check out the benefits and challenges of an audit. You'll also learn how to prepare for an audit and how to remediate audit findings for security and compliance. After that, you'll explore inherited controls and how to use policy control hierarchy to secure the cloud and align with regulatory requirements. Finally, you'll analyze the negative organizational impacts of noncompliance and learn how to implement PAC or policy as code. You'll also learn how to write policy as code updates to improve and strengthen organizational policies. I'm excited that you're taking this learning journey with me. Whenever you're ready, move on to the next video.
Right now, a lot of organizations are trying to figure out how they're going to deal with artificial intelligence. I spend a lot of time helping people think through how to think about applying security to these new sets of technologies. What's the same and what's different and new, and how we want to apply security principles and practices to those technologies. My name is Bill, and I am a security advisor in the Office of the Chief Information Security Officer here at Google Cloud. My job is fundamentally about unblocking people from a security challenge or a business challenge for which security is a concern or some sort of risk. It feels pretty awesome. It feels, like I'm actually contributing to the success of a business, to a customer. It's satisfying for me to feel like I'm of service to a person in that, trying to solve a difficult, vexing problem. I got started in the security field in 2003. And yes, that is 20 years ago. And the field's changed quite a bit in that period of time. But I was at that time running a consulting practice that worked with healthcare customers. It was really at that time that we had kind of experienced a whole series of new kinds of security threats. I was working with a colleague of mine, Rob, who looked at me one day and he said, "Hey, what do you do when there's a burning fire?" And he goes, "It's obvious. You run to it and put the fire out." And he said, "This is a security fire. We need to go in and help put out the fire." And so he and I and a number of others pivoted and joined a lot of the security efforts that were going on at the company at that time, and had to get up to speed on security very quickly. Almost all of my work is based on cloud technologies. Every customer that I talk with is working on cloud. Cloud is again, another form of technology, and with it comes a set of security capabilities and sets of security controls that have to be applied. It requires thinking through the security challenges and the kinds of risks that you face and applying kind of a security mindset to whatever it is that you're doing on cloud. Security is a critical capability that we're going to need in cloud. We need people who can help manage security risk. Yes, it's some pretty cool technology we get to play with. There's some really interesting challenges and puzzles, but there's also a larger social good here, I think. We safeguard what people do every day. And we make it be a trusted space for people to do banking and healthcare, to line up babysitters, to do all kinds of different things in their lives. And, what we're doing is fundamental to a trusted world. And I think that we need people who are going to be committed to doing that work. So come join us.
The cloud environment is constantly changing, which can make implementing compliance requirements challenging, but it's extremely important for organizational success. It helps introduce businesses to new clients and markets, raise customer trust and satisfaction, improve security posture, and save money. Who wouldn't want that? It's critical for any organization using the cloud to understand and implement the compliance lifecycle. The compliance lifecycle is the process for ensuring compliance objectives are met and maintained to support the business goals. It's important to call out, our discussion in this course should not be considered legal advice. Let's check out the 4 stages of the compliance lifecycle. According to ISO 27001, the 4 stages of the compliance lifecycle are plan, implement, monitor, and report. The compliance lifecycle is a continuous lifecycle to help organizations comply with frameworks, industry standards, and internal organizational systems. The lifecycle also provides the governance to maintain a continuous compliance posture. NIST defines governance as the policies, procedures, and processes to manage and monitor an organization's regulatory, legal, risk, environmental, and operational requirements that inform the management of cybersecurity risk. Generally, the governance model informs frameworks, standards, and laws for an organization. After you plan, implement, monitor, and report, and finish the lifecycle begins again. The findings in the report will affect the next cycle's plans. Overall, the goal of the compliance lifecycle is to meet compliance requirements or control objectives. Once met, the organization needs to demonstrate and maintain compliance with these requirements and objectives. Let's examine the first stage of the lifecycle more closely. During the planning stage, you'll identify compliance obligations for your organization and assess how you will meet these obligations. The planning process might involve evaluating controls, assets, and processes that are already in place. This stage often involves a gap assessment. A gap assessment identifies the processes and controls that currently meet the organization's obligations and the areas that need to be addressed. The findings of the gap assessment will drive implementation actions. Monitor, the third stage, comes after implementation. It is important to monitor the system to evaluate the effectiveness of the controls that were put into place. The final stage is report. In this stage, your organization must measure compliance by running reports and control checks. These reports are evidence that security measures have been implemented and vulnerabilities have been remediated. Often, the resulting reports are submitted to auditors as proof of compliance. Now that you and your organization have done the hard work of regulatory and industry standard compliance, you must maintain a robust and compliant security posture. This is done by starting the lifecycle once again. Continually moving through the compliance lifecycle will help ensure that your organization maintains its compliance posture. The compliance lifecycle is never finished. It's a continuous effort that's required to keep the organization and its customers protected. As a cloud security professional, you'll work closely with different types of controls in your day-to-day tasks to keep your cloud environment secure. Let's explore common types of cloud security controls, including preventative, detective, and corrective controls. It's important to remember that there are different levels of security controls. Let's explore this more. Security controls used at the service level are applied to storage, computing, and networking. Security controls used at the workload level are applied to a collection of resources or code that delivers business value, like a customer-facing application. In a workload view, there is a set of services and a flow of data through a system to achieve an outcome. Security controls used at the platform level are applied to a common environment for running applications, like operating systems, programming languages, and runtime environments. Security control architecture and selection is driven by business needs. Although there are nearly unlimited cloud security controls, most cloud security controls fall into the following groups or domains: deterrent controls, which serve as a barrier to a potential attacker; preventative controls, which manage, strengthen, and protect assets; corrective controls, which reduce the after effects of an attack; and detective controls, which identify or detect an attack. A deterrent control makes the effort of an attack greater than the reward. For example, a passphrase, which is more complex than a traditional password, is difficult and time-consuming to crack. The added difficulty may deter an attacker. Deterrent controls are like a sign on a building indicating it has an alarm. The sign acts as a deterrent and hopes an intruder will not even attempt to break in. What if an attack comes from inside the company? An example of a deterrent control against an insider attack is a company-wide policy stating the appropriate use of company assets and the consequences of non-adherence. Another control group is preventative controls, which are put into place to help prevent an attack. For example, you write code that disables unnecessary ports to ensure that there are less entry points for attackers, reducing the attack surface. Another way to reduce the attack surface and help prevent attacks is to maintain a strong user authentication system. Corrective controls are put in place to correct a change from the desired security posture. For example, a corrective control could be a piece of code that corrects or repairs damage after unwanted or unauthorized activity and then notifies administrators of this action. Corrective controls are like an alarm that automatically calls the police in the event of an intrusion. The role of detective controls is to continually monitor the environment to identify when an attack or unexpected event is happening. Detective controls are similar to an alarm going off when motion or sound is detected inside a building. Antivirus software and network or service monitoring are examples of detective controls. Even billing reports are detective because they can show unusual computer activity. A compensating control is a control to mitigate a risk that cannot be fully addressed by the organization's existing security controls. Compensating controls are measures that make other controls more effective. For example, a lock on a door handle can be made more effective by adding a deadbolt lock for stronger security. Compensating controls are usually used when the organization is unable to implement a specific control because of technical or business constraints. Compensating controls can also be a part of a defense-in-depth strategy, where additional controls are added to compensate for gaps in other control coverage. The PCI Security Standards Council, or SSC, provides guidelines that are helpful for creating and implementing compensating controls. The criteria that compensating controls must fulfill are: it must meet the intent and rigor of the original requirement, the level of defense must be similar to that of the original required control, it addresses the remaining risk introduced because of non-fulfillment of the original requirement, and the security level should be equal to or higher than the PCI DSS requirements. As a cloud security analyst, you'll need to be knowledgeable about the different types of security controls and how to implement them. Controls will help you to maintain a strong security posture for your organization. After identifying the types of security controls your organization needs, those controls have to be mapped. Mapping controls in the cloud is similar to ensuring the safety features on a product like a car or an appliance work. Then, if any features are missing, the organization fills in the gaps. Mapping controls in the cloud ensures that all the necessary controls meet regulatory obligations and secure the cloud. To complete the control mapping process, an organization must identify controls, map required controls to cloud security benchmarks, standards, requirements, regulations, and rules, identify the controls not mapped within the cloud security benchmark and respective policies, perform an assessment of platform and service, and implement guardrails with policy initiatives with native or third-party tooling. The first step in control mapping is to identify the controls that already exist in an organization's cloud infrastructure. Then, mapping a set of required controls to the current controls in place. Spreadsheets are often used in control mapping. When using a spreadsheet to map controls, choose appropriate control titles, domain categories, and descriptions to identify related controls. Then, conduct an inventory of all assets, including hardware, software, and data, and then group controls by type of asset. Be sure to align the purpose of each control to the framework that you are using. Note any gaps in the spreadsheet. After mapping, identify the controls that aren't mapped and assess which ones need to be implemented. During this step, you can also map additional sets of compliance obligations that apply to your organization. Mapping these obligations allow you to determine if there are controls that can be inherited from the prior control mappings that were carried out by your team. Control mapping is a valuable exercise to ensure control coverage across various compliance obligations. Next, it's time to perform a platform and service level assessment. Once you confirm your controls are fully mapped, gather any needed supporting information. Keep in mind, your organization may have a checklist to complete before the assessment is performed. Once the documents are ready, the IT team or supporting organization will review all provided information in an official platform assessment. This assessment will determine if the set of currently implemented controls meet all security and compliance requirements set by industry regulators. If there are gaps identified, you may need to develop more controls to close gaps and mitigate risk. Finally, implement guardrails using policy initiatives, using built-in or third-party tooling. Security guardrails are broad rules that prevent an insecure or not policy-aligned action, but guardrails are not as narrow and directed as policy rules. For example, developers might be allowed to launch services that cannot be exposed to the public internet. The control that prevents that exposure is the guardrail. Depending on your control objectives, you might need to create custom policy and code to meet regulatory requirements. The control mapping process not only helps familiarize you and your team with the current controls, but also helps you understand how these controls line up with regulatory requirements. By mapping controls, you'll be able to identify any missing controls or gaps and then adjust as needed. This process will mitigate risk and help avoid breaches and non-compliance. To ensure the safety of passengers on a bus, you would check that the tires, brakes, and other safety functions have been properly inspected and that the bus driver has a valid license. Similarly, if you're working with a business, you want to make sure that they're carrying out audits to ensure the proper security cloud controls are in place. An audit tests the cloud environment to ensure controls are in place to protect assets in the cloud. In this video, you'll take a deeper dive into what a cloud audit is and why they are important. A cloud audit is an assessment of the cloud environment that is usually conducted by a third party. It results in a set of findings that describe how well an organization is meeting the audit standards, and it also provides ideas for improvement. Audits generally take place every 6 to 12 months. Before the audit, auditors outline an audit plan. The audit plan includes the controls auditors will be evaluating for in the audit. During the audit, an auditor will gather evidence through inquiry, observation, reperformance, or analytics. The focus of a cloud audit is on the cloud security controls. Remember, security controls are safeguards designed to reduce specific security risks. The auditor will check for which security controls exist, whether these controls are implemented correctly, and whether they are working as required. The auditor will check for alignment with specific requirements based on regulations, industry standards, or security benchmarks. A key benefit of an audit is demonstrating appropriate protection or stewardship to earn and maintain customer trust. Another benefit is contractual compliance and insurability. An audit helps to build trust by establishing accountability for the implementation and operation of a set of intended controls. For example, an audit might require evidence of a third-party risk management process. The auditor will check that the system was designed and operates a program that includes that process. While audits have many advantages, they also come with some challenges. Two of the biggest challenges are time and resources. Audit preparation is time-consuming, so it's important to build processes that overlap with audit standards. Also, the third-party company that conducts the audit needs to be paid. Therefore, an organization needs to budget money for the audit process. When hiring an auditor, an organization must ensure the accreditation of the auditor. Without an accredited auditor, your organization will not be certified or receive an official SOC 2 letter. Additionally, an audit affects staffing, training, and causes an increased workload across the organization. This can cause slowdowns and business disruptions that can also cost the organization. The challenges can vary depending on the scale, scope, and complexity of the audit. Audits are essential parts of compliance. They secure integrity in data and assets and systems. Ultimately, when performed transparently, audits develop a deeper sense of trust between organizations and their customers. An audit is an important part of meeting compliance obligations and maintaining a strong and trustworthy security position. Imagine you're going to take a test. You probably want to know what's going to be covered and how to prepare, right? Being prepared will help you to learn the content and pass the test. The same is true for a cloud audit. Together, let's dive deeper into the specifics of what an audit usually covers, how it differs from an assessment, and audit best practices. To begin, let's identify what's commonly covered in a cloud audit. Cloud security procedures and policies, access control, network segregation, data protection, logging and monitoring, and incident response are all included in a cloud audit. Please note that the audit approaches will vary based on the scale and complexity of the service being audited. Let's explore these steps in detail. The first step in a cloud audit is to inspect cloud security procedures and policies. The auditor will evaluate current cloud security policies. They will check that the organization knows how to assess risks in the cloud and has an effective way to manage those risks. The second step in the audit process is to assess access controls to ensure they are adequately implemented. Auditors will check access controls for strong password standards and policies, multi-factor authentication, privileged access management, and least privilege principle for all cloud assets. Third, auditors will check for proper network segregation. They search for evidence that networks are properly segregated in accordance with their expected standard as outlined in the audit plan. The fourth step is ensuring data protection. Auditors assess relevant security controls. They verify that data is encrypted at rest and in transit using effective cryptographic algorithms. Auditors also ensure that data loss prevention tools are in place. Fifth, auditors check logging and monitoring settings to verify that all required actions are logged. It's important to verify that the logs can't be changed, access to logs is limited, and that critical activities are monitored. Sixth and finally, auditors will verify that the organization is prepared to respond to incidents by reviewing the incident response processes. Auditors assess how an organization evaluates and improves security in response to completed incidents, known as postmortems. These are common steps in an audit, but remember, audit approaches vary based on the scale and complexity of the service being audited. As a security professional, it's important to know the difference between a security audit and a security assessment. A security audit can be internal or external and includes an evaluation of various areas of control. The intent of an internal audit is to provide the board audit committee and stakeholders, like the CFO, evidence that internal controls are appropriately applied. The purpose of an external audit may be to become certified in a standard, like ISO 27001. Another purpose could be to meet contractual or commercial obligations. Security assessments, however, are less complex. They only scan the company's technological systems and identify flaws. Security assessments usually consist of an automated scan to ensure that the controls are in place as intended. A security audit is a more objective and comprehensive evaluation than a security assessment. Now that you know what an auditor will be reviewing for, let's go over best practices to prepare for an audit. First, study the audit requirements and make a plan to pass the audit. Second, identify asset and control inventory, such as control mappings, components, connections, functionality, and the people accountable. Third, assess your cloud architecture. Cloud architecture can be public, private, hybrid, or multi-cloud. Fourth, be sure to identify points of contact to work with auditors and ensure their schedule has availability. Fifth, test run your own internal audit. This is where things get really interesting. The single best practice for audit preparation is to do an internal test audit using the exact testing criteria outlined in the audit plan. This will help you avoid control gaps critical to the audit or certification. Sixth, gather evidence and prepare reports on the existing security controls. The evidence and reports will be used by the auditors as one way to determine if standards have been met. Knowing what to expect during an audit will help you do everything you can to be prepared. Preparing for and taking part in the audit process will be a super important part of your job as a cloud security professional. It's another way you can protect users and organizational assets. Until around 2011, organizations using the cloud generally didn't know the security controls that cloud providers offered. Luckily, much has changed since then. Now, major cloud providers openly publish the controls they already have in place. These are called inherited controls. Because of this, it's important to understand how inherited cloud security controls relate to frameworks and compliance. It's important to call out, our discussion in this course should not be considered legal advice. Control inheritance is the process of using controls or compliance certifications and audits that are already provided by a cloud service provider. An organization can use inherited controls to meet their control requirements when using a cloud environment like Google Cloud. Because the controls are supplied by the cloud provider, they can be inherited or incorporated into the overall controls that an organization uses. The use of existing cloud service provider controls enables an organization to inherit them into their compliance process. Remember, organizations adhere to compliance standards. Compliance standards are typically established by their governing entities, both internal and external. If an organization cannot provide evidence of compliance, they may be held accountable. For example, an internal governing entity might be the board of directors or a company policy. Examples of external entities include regulators and customers that require compliance. Lack of internal compliance may result in a less secure cloud environment. Lack of external compliance may result in a failure to secure or retain a commercial relationship with a business or incur fines and penalties by a regulatory body. Frameworks are consensus agreements that outline the minimum acceptable level of security. They offer guidance and define scope. As a cloud security professional, you can use frameworks to help organize the security effort and help meet compliance objectives. Frameworks help you to evaluate and select appropriate controls, including inherited controls. A framework is a guide. It doesn't tell you what inherited controls a service provider will give you, but it will prompt you to ask your cloud provider the right questions. You can get the most out of your inherited controls by identifying alignment between compliance frameworks and cloud vendor inherited controls. Recognizing and adapting inherited controls to business requirements will enable you to achieve compliance within your organization. For example, if an organization is planning to offer protected health information, or PHI, handling services on the cloud, knowing that the cloud service provider is certified in a HIPAA-compliant framework allows the organization to build on their evidence of controls in the cloud and platform. First, it's important to understand the business risks and legal requirements of your industry and organization. For example, healthcare or government organizations may have specific laws and requirements that you will need to comply with. It's also important to understand the business expectations that customers may place on your organization. Once you understand industry requirements, legal requirements, and commercial expectations, You can choose frameworks and/or compliance certification programs to help guide your cloud security team. By identifying the inherited controls that align with your chosen framework, your team can determine how you'll build or configure tools and services to meet business objectives. For example, imagine an organization plans to control and manage card user data. It would be a good idea for the organization to choose a cloud service provider that meets PCI DSS requirements. The organization will inherit those controls. The organization can use the cloud service provider's audited controls and may then add their own controls on top to achieve the full set of required controls. Using inherited controls and the controls that your team has put into place, you can secure assets and meet compliance obligations. Here's a pro tip before we go. Frameworks are tools to help you meet your security goals. They are not the end goal themselves. Resources in Google Cloud are arranged hierarchically. In the same way, a plant species, like a grape tomato plant, inherits physical traits from other parent tomato species. Policies and controls established at the top level are applied down through the hierarchy. In other words, the grape tomato includes all genetic information its ancestor tomatoes had. And it's important for you to understand that cloud organizational structure hierarchy works the same way as it relates to policy and compliance. A hierarchy is a system that organizes or ranks things, usually by power or importance. In the cloud, hierarchies help engineers figure out how components are organized inside of their cloud account. They also enable the security team to put policies and controls into place within a business. Hierarchies offer more efficient and consistent management of controls. Let's take the hierarchy of Google Cloud as an example. Hierarchies in Google Cloud are arranged in organization, folder, and project levels. The top level in the hierarchy is organization. The next level under organization is folders. And the bottom level under folders is projects. Controls applied at higher levels in this structure cascade down. A business should first determine the organization level's policies. At this level, company-wide controls and policies can be set. These will then cascade down to all folders and all projects under organization. Within the organization, a company may have folders that align with departments like IT, finance, or HR. There might also be folders for other logical segments like global regions that apply to the business. Policies and controls can be set at folder level and apply to everything inside the folder. Also, each Google Cloud folder will have projects that could contain specific resources like an application and storage for that application. For example, there might be different projects assigned for development, testing, staging, and production. Each project can then have different rules, permissions, and controls. For example, there might be stricter rules on code deployment for staging and production projects. There's levels to understanding hierarchy in the cloud. Applying levels will help you create policies and controls at different levels to meet your control objectives. The hierarchy will also enable you to apply controls for different levels and different groups, making security faster and more efficient. Imagine a new driver is taking a road trip to visit a friend. A few miles into the trip, the driver forgot to stop at a stop sign. A police officer pulled the driver over and gave the driver a fine. Luckily, the driver didn't cause an accident, so wasn't sued for any liability. For organizations, fines and lawsuits are two common examples of the serious negative impacts of non-compliance in cloud security. Let's first review compliance. Compliance is the process of adhering to internal and external standards and government regulations. Simply put, compliance is following rules set by laws, regulations, policy, standards, or guidelines. If you set a rule, follow it, and demonstrate that you are following it. Then you're in compliance. But failure to follow standards and regulations results in non-compliance. Non-compliance is the failure to follow standards and regulations that are set by internal standards and policy or external laws and regulations. As a cloud security professional, you'll need to understand the importance of compliance and how to make sure the proper controls are in place to avoid negative impacts of non-compliance. Let's explore the most common organizational impacts of non-compliance. Negative organizational impacts include financial loss, legal risk, reputational loss, and talent loss. Let's first examine the financial risks of non-compliance. The cost of non-compliance can be significant. Regulators can fine or prevent organizations from conducting business. In addition to government fines and penalties, other financial impacts include lost business from failing to meet existing contract terms, not being able to win bids for new contracts, significant costs to remediate compliance audit findings, and delays in product releases, and other business activities. An organization that is not in compliance may be subject to legal risks like imprisonment of its leaders, fines, and shareholder and customer lawsuits. Reputational risk can be equally harmful. Trust is key to business relations and growth. Losing trust from customers, shareholders, partners, and the general public can weaken or destroy a company's brand, and nobody wants that. Lastly, organizations that fail to comply with industry and regulatory standards will have a more difficult time keeping and recruiting new talent. Qualified people will seek out companies that are trustworthy. Without strong talent, the company risks falling behind on innovating and creating products. The risks we just explored affect the organization itself, but there are also negative impacts of noncompliance on customers, partners, and vendors. For example, in a healthcare organization, a compliance failure could cause a leak of protected health information, or PHI, to unauthorized parties. This not only has an impact on the organization, but also on the covered entity with which it has contracted. Covered entities include health plans, healthcare clearinghouses, and healthcare providers. Lastly, noncompliance will affect the patients whose data was compromised. As you progress in your journey to become a cloud security professional, you'll continue to learn about many tools and techniques that will help you comply with regulation and better protect assets in the cloud. Documentation is just as important as implementation. As a security professional, writing and updating policies that protect assets in the cloud will be an important part of your job. In this video, you'll learn how infrastructure and policy as code can help you mitigate risk and meet compliance obligations. In IT, a policy is any type of rule, condition, or instruction that governs operations or processes. A policy could be a rule that defines which conditions must be met for code to pass a security checkpoint and be deployed. It could also be a set of procedures that are executed automatically in response to a security event to limit damage and reestablish controls. Let's first review a related process, infrastructure as code. Infrastructure as code, or IAC, is the practice of automating and managing infrastructure using reusable scripts. There are many benefits to deploying IAC, like consistent configurations, decreased risk, application controls are clearly described in code, faster deployment, increased operational efficiency, and financial savings through less manual effort. When you apply IAC, you'll likely experience stronger security, faster incident recovery, and improved accountability. Let's discuss an important subset of IAC next. Policy as code, or PAC, is the use of code to define, manage, and automate policies, rules, and conditions using a high-level programming language. Using PAC is a straightforward way to automate policies across an organization. With a PAC approach, the compliance checks that you want to apply will be automated. You'll be able to write out policies using a programming language like Python, YAML, Rego, or use tools like Terraform, Chef, Puppet, and Ansible. The specific programming language depends on which PAC management and enforcement tools that you're using. You can then apply this code to different groups in the cloud hierarchy. PAC allows you to write continuous assessment checks against the infrastructure to determine that it's secure and compliant, and remains that way. There are many benefits to using PAC for security and compliance. Efficiency, a security team can share policies and automatically enforce them rather than manually. Speed, security team operations are faster when the team automatically enforces policies. Visibility, it's easier for all stakeholders to understand what's happening in the system. They can check the code rather than asking engineers or making assumptions. Collaboration, PAC provides a clear and uniform way of managing policies and so simplifies collaboration, not only within the same team, but also between different departments or teams. Accuracy, when a security team automatically enforces policies, there's less risk in making a mistake. Version control, if your team keeps track of policy files as they change, PAC makes it easy to revert to an earlier configuration if you run into a problem with a new policy. Testing and validation, with PAC, it's easier for a security team to utilize automated auditing software to check that the code is valid and doesn't have any gaps or errors. Using PAC enables teams to efficiently set policies and controls that protect assets and meet compliance obligations. Understanding how and when to use PAC will improve efficiency, speed, accuracy, and more when it comes to securing assets in the cloud. Congratulations, you're doing great. You've learned a lot about the compliance lifecycle and how to maintain a strong and compliant cloud infrastructure. As you progressed through this section, you learned about the different aspects of the compliance lifecycle. You discovered how things like control mapping, audits, policy hierarchy, and policy as code can help organizations maintain a strong security posture and align with regulatory requirements, industry standards, and frameworks. First, you were provided with a comprehensive overview of the compliance lifecycle. You learned why the compliance lifecycle is so important to risk management and how to implement control mapping to fill gaps and meet compliance obligations using tools and techniques to maintain a strong organizational security posture. Next, you learned about cloud assessments and auditing and examined the benefits and challenges of an audit. You also learned and practiced how to prepare for an audit and how to remediate audit findings for security and compliance. Then, you explored inherited controls and learned how to use policy control hierarchy to secure the cloud and align with regulatory requirements. Lastly, you analyzed the negative organizational impacts of noncompliance and how to implement policy as code or PAC. You then learned how to write a PAC updates to improve and strengthen organizational policies. Great work on your progress so far. Pack your bags. It's time to move on. It's so great to have you here. Are you ready to learn more fascinating security concepts? I know I'm ready to help explain them. Together, we'll explore some tools for managing your organization's security posture in the cloud. As a cloud security professional, you may be responsible for securing thousands or even hundreds of thousands of assets in the cloud or a hybrid environment. In this section, you'll learn about the process of cloud security posture management, which includes taking inventory of cloud assets. You'll also learn how to identify risks and vulnerabilities and what steps to take to fix and prevent security issues. Here's what you'll learn. You'll start by reviewing some of the risk and vulnerability frameworks to explore multi-cloud cloud security posture management. You will also learn about key cloud tools and their uses for risk and compliance, and about cloud organizational policies and controls. Next, you'll explore multi-cloud cloud security posture management, or CSPM tools. These tools help you inventory your cloud assets and give you visibility into misconfigured assets and other vulnerabilities. You'll also learn how to use Google's Cloud Security Posture Management tool, Security Command Center, along with other tools used for multi-cloud and hybrid environments. Then, you'll find out about key cloud tools and their uses for risk and compliance. You'll also learn to evaluate your organization's security posture with Risk Manager and generate reports you can share with insurers to give them an accurate idea of the risk your organization carries. Finally, you'll discover organizational policies and controls to prevent violations before they occur, and learn how to ensure your cloud environment is secure and your organization stays in compliance. Let's get started. I'll meet you in the next video. Knowing what to watch for will make you more effective in the security world. As a cloud security professional, you'll need to stay up to date on vulnerabilities and threats. In this video, you'll learn about the specific types of organizations that work to identify, research, and classify vulnerabilities, and how those organizations share the information with the public. MITRE is a not-for-profit organization that conducts research to support government agencies in several fields, including cybersecurity. MITRE created and maintains a standard naming system for vulnerabilities called the Common Vulnerability Enumeration, or CVE system. MITRE assigns an identifier including the letters CVE, the year, and a unique number to each vulnerability. These identifiers make it easier to share information about vulnerabilities. The National Vulnerability Database, or NVD, is a publicly accessible repository of data about known system and software vulnerabilities created and updated by the National Institute for Standards and Technology, or NIST. The NVD is updated regularly with information from researchers, vendors, and other security organizations. There are many uses for the NVD, including vulnerability management, security management, and compliance. The vulnerabilities in the NVD are categorized based on their unique CVE numbers. The NVD also contains information about vulnerabilities' severity, whether fixes or patches have been created to address them, and how much potential they have to affect systems. The Open Web Application Security Project, or OWASP, is a foundation that creates guidelines and frameworks for securing software. The OWASP Top 10 is a regularly updated report of critical security risks for web applications. OWASP created the Top 10 by researching common risks that make it easier for attackers to target web applications, like misconfigured security settings or insecurely designed applications. Cloud security analysts use Top 10 to guide their security testing efforts, minimize vulnerabilities in cloud environments, and assess risks. A lot of web application firewalls are designed to address Top 10 vulnerabilities. Now that you understand more about how vulnerabilities are classified, you're ready to stay up to date on the latest updates throughout your cloud security career. Stay curious and be open to learning new things. As a cloud security professional, you might work with anywhere from a few to hundreds of thousands of projects, virtual machines, containers, and other assets. That's a wide range of possibilities. With so many possibilities, your organization may choose to use a multi-cloud environment. Multi-cloud is a strategy using more than one cloud service provider. In a multi-cloud environment, it's extra important to have an effective monitoring system to track your organization's security posture and alert you to threats as quickly as possible. Cloud Security Posture Management, or CSPM, is the process of monitoring and configuring cloud assets for security and compliance with best practices, regulations, and organization policy. CSPM tools automatically scan cloud assets and alert security teams if a potential issue is found. Using multiple cloud service providers helps organizations take advantage of different cloud providers' strengths and capabilities and avoid concentrating all their business with one cloud provider. Keeping track of assets spread across multiple clouds and managing access and identities can be difficult. Luckily, there are strategies to mitigate these challenges. Multi-Cloud Security Posture Management, or CSPM, is the process of assessing the security of assets throughout a multi-cloud environment. CSPM provides a centralized place to ensure the right policy actions and controls are in effect and alert you to events within the multi-cloud environment. They also help keep the whole environment secure and in line with compliance standards. For example, CSPM tools can also automate threat response by automatically isolating assets that may have been compromised until the security team has a chance to address them. A wide variety of multi-cloud CSPM tools are available, each with different features, integrations, and underlying technologies. Organizations should consider all these factors to find the best fit for their requirements. Let's explore the following multi-cloud CSPM tools and why an organization might choose each one. Palo Alto Prisma Cloud, CrowdStrike Falcon Cloud, Orca, Checkpoint Cloud Guard, and Netskope Cloud Security Platform. Palo Alto Prisma Cloud is a cloud-native application protection platform, or CNAPP. Prisma Cloud secures cloud-native applications through the stages of the development process. Prisma Cloud works by taking in configuration data, user activity, and network traffic from across an organization's cloud environments. Using this data, Palo Alto Prisma Cloud provides visibility across the hybrid or multi-cloud environment. It also provides security assessments and compliance monitoring. Prisma Cloud can also integrate with external services to help provide remediation. For example, it can automatically check if patches are available for a vulnerability. Finally, Prisma Cloud provides identity and access management, or IAM capabilities, to help your organization maintain least privilege access. Next, CrowdStrike Falcon Cloud is a cloud-native endpoint protection platform. It's designed to protect endpoints, including desktops and laptops, servers, and virtual machines. Falcon Cloud provides multi-cloud or hybrid visibility into an organization's IT architecture. Like other CSPMs, Falcon Cloud uses threat intelligence to detect potential threats in an organization's cloud assets. Falcon Cloud also uses machine learning, or ML, and artificial intelligence, or AI threat detection algorithms to analyze activity and respond to potentially malicious behavior in real time. Other multi-cloud CSPMs include Orca, which uses an agentless approach, meaning it doesn't require installation of additional software on systems. Orca scans cloud workloads and identities and provides visual graphs of potential attack paths. Another agentless CSPM, Checkpoint Cloud Guard, uses rules and queries written in a unique, human-readable syntax called governance specification language. And finally, the Netskope Cloud Security Platform is a CSPM tool that has a unique focus on data security and data loss prevention. That wraps up our discussion of Cloud Security Posture Management. You're one step closer to keeping your organization's multi-cloud infrastructure safe and secure. Imagine you're on a hike and you want to do some bird watching, but then you remember that you forgot your binoculars at home. That might make it hard to observe the birds up close, right? Similarly, in security, tools are an important way to monitor threats. Let's take a moment to review Google Cloud's CSPM, which a cloud security team can use in multi-cloud environments. Security Command Center, or SCC, is Google Cloud's centralized vulnerability and threat reporting service with CSPM features. Security Command Center scans your organization's cloud infrastructure, helping you prevent, detect, investigate, and respond to threats throughout your organization's cloud environment. SCC also helps you maintain your compliance with security standards, like the Center for Information Security, or CIS, Google Cloud Computing Foundation's benchmark, a set of secure configuration guidelines for Google Cloud environments. Let's take a peek at some SCC features that will be useful to you as a cloud security analyst. On its main dashboard, SCC gives you a comprehensive overview of your organization's cloud assets from a security point of view. You can use SCC's Assets feature to carry out an asset inventory review to help you discover and view your resources and policies in near real time. This tool also provides asset tracking so you can identify new, modified, or deleted assets. SCC can also be configured to send the security team real-time notifications when an asset or policy is modified so you can determine whether it was an authorized change. Along with helping you keep track of cloud assets, SCC scans for vulnerabilities using two main built-in services. The first is the Security Health Analytics service, which can identify misconfigured virtual machines, containers, networks, storage buckets, and IAM policies. This service also helps detect vulnerabilities. And second is the Web Security Scanner service, which automatically detects vulnerabilities in App Engine, Google Kubernetes Engine, or GKE, and Compute Engine applications. Web Security Scanner provides two main types of vulnerability scanning: managed scans and custom scans. Managed scans are configured and managed by SCC and manage basic vulnerability detection for projects across the organization. You can configure custom scans to provide more granular information about vulnerabilities in individual projects. Along with identifying vulnerabilities, SCC scans for threats and compliance issues within your cloud environment. The Event Threat Detection Service scans your cloud logging stream for potential threats based on threat intelligence features or information about known or potential threats. The Container Threat Detection Service scans for potential compromises of GKE containers. The Virtual Machine Threat Detection Service scans for potentially malicious applications running in virtual machines or VMs or Compute Engine. If a threat is found, SCC provides information about related events like the event type, the event time the threat occurred, the event data source, and the event severity. Besides monitoring cloud resources for threats and vulnerabilities, SCC can be used to assess your organization's compliance. The Compliance Dashboard checks your cloud environment settings for violations of certain compliance frameworks. It recommends fixes for any violations found. The dashboard also exports compliance reports based on the framework you chose. SCC also integrates with other data sources to provide more details about your cloud security posture. For example, Cloud Armor analyzes traffic to help protect cloud assets from DDoS and common OWASP attacks. Sensitive Data Protection scans storage buckets and databases for sensitive and regulated data and provides recommendations to secure it. Also, SCC partners have solutions available to help you integrate data from SCC into your organization's security portfolio. SCC is available in two tiers: standard or no cost, and premium. The standard tier provides security health analytics, including identifying high-severity threat detection. The premium tier builds on the functionality of the standard tier, including the security health analytics service, with the addition of PCI and CIS benchmark reporting support. The premium tier also includes Web Security Scanner, along with event threat detection, container threat detection, and VM threat detection. Now that you understand more about Google SCC or your cloud data security binoculars, you're ready to secure your organization's cloud environment. Dealing with sensitive information requires a strategic approach. As a cloud security professional, you may be responsible for securing sensitive data using the compliance framework or frameworks that apply to your organization. In this video, we'll explore how you can use cloud tools to help manage risk. It's important to call out, our discussion in this course should not be considered legal advice. There are a few tools included in the Google Security Command Center, or SCC, that you can use to improve your organization's security posture and compliance. For example, Risk Manager is a risk assessment and management service within Google Cloud SCC. Risk Manager integrates with security tools to help you coordinate your security efforts. It also generates risk reports that you can share with insurers as part of the cyber insurance purchase process. Risk Manager reports include information aggregated from SCC, Cloud Asset Inventory, and other sources. These reports align with the Center for Information Security, or CIS, Google Cloud Computing Foundation's benchmark. This benchmark is a set of secure configuration guidelines for Google Cloud environments. You can generate Risk Manager reports as needed or schedule them to automatically generate every day, week, or month. Your organization can also use Risk Manager in the purchase process for cyber insurance, a type of insurance policy that helps cover expenses from cyber attacks or data breaches. Cyber insurance can help your organization recover from a cybersecurity-related disruption to its business operations. When it's time for your organization to purchase cyber insurance, you can send Risk Manager reports directly to cyber insurance carriers that are part of the Risk Protection Program from the Google Cloud Console. Risk Manager reports give the insurer an accurate idea of how much risk your company faces so you don't buy too much or too little coverage. Policy Analyzer is another security tool within SCC. Policy Analyzer reviews your identity and access management policies, or IAM. Policy Analyzer lets you know which users, service accounts, and domains can access which cloud resources and helps you achieve least privilege access. Policy Analyzer provides role-binding reports. Role-binding reports include sets of one or more members and identities, known as principals, who have a permission or role granted by the cloud security team. And role bindings may include conditions which determine whether to grant a request. To use Policy Analyzer, you'll need to create an analysis query. You can then search by one or more role binding characteristics using analysis query fields. These fields include principals, or whose access you want to check, access, including permissions and roles, the resources you want to check access to, and condition context. You'll also need to specify the analysis scope, which includes the organization, project, or folder that you'll analyze. Policy Analyzer will return all the role bindings within the scope that match your search. Policy Analyzer also lets you write analysis query results to BigQuery or cloud storage. Another cloud compliance tool, Assured Workloads, is a tool that manages the security and compliance of Google Cloud workloads. It offers predefined controls and configurations that meet the compliance requirements of regulated industries like healthcare and government. Simply choose the compliance program that applies to your organization, and Assured Workloads will apply the controls you require. Assured Workloads also provides data residency controls at rest or in use. If your compliance obligations require you to store data in certain geographic locations, Assured Workloads automatically restricts data storage to the regions you designate. Assured Workloads personnel data access controls help make sure only authorized Google personnel can access your data. Authorized personnel can include people within the physical area of your compliance program and who satisfy the required background checks. By default, Google Cloud provides encryption of data at rest and in transit using default encryption key management settings. Pro tip, you can use customer-managed encryption keys if you need more control over the keys to encrypt data at rest. You can also use these keys if your compliance requirements don't allow you to take advantage of Google's default encryption of data. Assured Workloads also provides monitoring and alerts to organization policy changes that break compliance. Assured Workloads can also work with multiple compliance programs for multinational organizations or others that fall under more than one compliance framework. Now that you've discovered the security posture tools within SCC, you're well on your way to managing risks in Google Cloud environments. Organizations buy insurance policies as a common practice to protect their buildings and people from unforeseen events. You might not imagine a business can also buy insurance to protect their technology, but they can. In this video, you'll learn about applying for cyber insurance using Google's Risk Protection Program. Cyber insurance is a type of policy that covers businesses against financial losses resulting from cyber incidents. Cyber insurance offers a number of benefits. For example, if an organization is hit with a cyber attack that keeps it from doing business for a few days, cyber insurance helps to cover the lost revenue. The insurance may also help recover any lost data and replace damaged equipment. It also will provide an investigation into how the incident occurred and cover any legal and regulatory fees. Lots of organizations require that their business partners have cyber insurance in place as part of their risk management plan. Though cyber insurance is often required, it comes with its own set of challenges. Buying cyber insurance can be challenging because it's usually seen as difficult to underwrite. Underwriting is an insurer's process of pricing an insurance policy. The first challenge is that cyber insurance can be expensive and difficult to get. Through the underwriting process, the insurance carrier decides on a fair price to charge the customer to cover a potential loss. Another challenge is that cyber insurance underwriting can be complicated, especially in cloud environments. There's not much information out there to help cyber insurance underwriters predict the likelihood of a breach or other incidents. One last challenge is that cyber insurance can also be difficult for organizations to get because of difficulties with loss prevention. Some experts disagree on the impacts of security controls and on the best strategies for preventing cybersecurity losses. This makes it difficult for the insurance companies to decide whether they will insure an organization, how much the policy will cover, and what the cost will be. To help make this process easier, Google developed the Risk Protection Program, a solution that provides insurance carriers with information about an organization's level of risk. The Risk Protection Program sends data from Risk Manager directly to Google's insurance carrier partners to help make underwriting cyber insurance easier and more accurate. Here are the Risk Protection Program steps an organization follows to join the Risk Protection Program. First, the organization must generate a Risk Manager report. A Risk Manager report provides centralized recommendations an organization can use to minimize risk. After an organization's management approves the Risk Manager report, the organization then sends it to the insurance carrier. Next, the insurance carrier sends a specialized security questionnaire to the organization to fill in any details about the organization's security posture. The Risk Manager report and questionnaire lets the insurance company know that the organization has security controls in place to reduce their risk of a security event or lessen the loss if one does happen. The insurance carrier then uses this information to complete the underwriting process. Then, they send a quote back to the organization through a broker based on the amount of risk the organization carries. Cloud Protection Plus is a specialized insurance policy developed by Google in collaboration with insurance carriers and is available through the Risk Protection Plan. Cloud Protection Plus helps cover losses to the insured organization's computer systems or the critical IT systems of third-party IT providers. The policy is based on underwriting that recognizes the security posture and investments of both the insured and Google. Just like a business getting insurance for its building and employees, purchasing cyber insurance is an important part of an organization's risk management strategy. By learning the Risk Protection Program steps, you now know even more about keeping data in the cloud safe. Honeybees are known for their collaboration skills. Their success at ensuring the overall health of the hive relies on each bee doing their specific job. Similarly, as a cloud security professional, you, your teammates, and even external organizations sometimes rely on each other. Your success and their success depends on everyone doing their job. In this video, we'll explore shared fate, a model of how cloud service providers and their customers depend on each other to keep cloud assets secure. With on-premises computing, the responsibility for keeping assets safe is clear. Since the infrastructure is on-site, the organization's security team takes on all the control and responsibility for securing it. Managing responsibility gets more complicated with hybrid and cloud environments, where infrastructure is provided by cloud service providers, or CSPs. To support this, the shared responsibility model was developed to clarify the responsibility for securing cloud resources. It varies slightly between IaaS, SaaS, and PaaS environments, but the idea is similar between cloud models. Suppose you're working on a cloud security team and your organization recently became a CSP customer. Here's how your business relationship might work in a shared responsibility model. The CSP is responsible for the security of the cloud infrastructure and services they provide. This usually includes the security of physical servers and operating systems. The customer is responsible for securing resources in the cloud by configuring resources, managing IAM, and securing applications running in the cloud. The shared responsibility model helps define which tasks belong to customers and which belong to CSPs. But it places a clear boundary between the CSP and customer, which can lead to issues or misunderstandings. Under the shared responsibility model, users and CSPs may be unsure about who is responsible for certain tasks. Now back to your organization's new CSP contract, your team is ready to begin storing sensitive data with the CSP. Under the shared responsibility model, you, as the customer, may assume that no matter how you configure the service's settings, the CSP will keep your organization's data secure. But the CSP may assume that your organization owns the responsibility of configuring the service correctly. This creates the potential for your security team to misconfigure the service, leading to sensitive data exposure. Another issue with the shared responsibility model is that tasks may be assigned to someone who isn't the best fit to complete them. For example, your cloud security team may be unsure whether default settings on cloud products are right for the organization's needs. The shared fate model was designed as a new way of thinking about cloud security and helps determine how CSPs and customers should collaborate to manage risks. The shared fate model emphasizes that CSP's involvement in the customer's entire security journey and offers resources to securely manage their environment at each stage. Both the CSP and the customer share the responsibility of securing cloud infrastructure and resources. This model acknowledges that security issues affect both CSPs and customers and encourages them to work together. In a shared fate model, the CSP plays a more involved role throughout the customer's journey in the cloud. The CSP guides the customer and helps with the response if something goes wrong. The shared fate model also includes secure by default settings. This means that cloud resources come with robust security settings. If a customer wants to lessen security settings to meet their needs, the CSP will let them know how changing those configurations might affect their environment. In a shared fate model, the CSP makes advanced security features available to the customer and guides them through configuring these controls. The CSP regularly tests controls in place on their cloud services to make sure everything's working as it should. So, under the shared fate model, the CSP will accept the risks along with your organization as the customer. The CSP will also work to minimize the risk of their service being misconfigured. CSPs may also provide more secure default settings, give your data security team more guidance, and encrypt the data by default. These measures help keep your organization's data safe, even if your team accidentally misconfigures a setting. When CSPs and users collaborate using the shared fate model, they keep the cloud more secure than ever before. Keep buzzing along and work together to keep the cloud assets secure. As a security professional, you might be tasked with deciding how members of your organization can create and configure cloud resources. That's where cloud organizational policies come in. A cloud organizational policy is a set of restrictions or constraints on a specific cloud service or a list of services. Constraints restrict and control how you can configure cloud services and resources in your organization's environment. There are different policy options available depending on your organization's needs. Identity and Access Management, or IAM, focuses on who is allowed access to a resource. Organizational policy addresses what resource configurations are allowed in an organization or in a specific set of resources. Organizational policies can be set at resource hierarchy nodes, including the organization, folder, or project level. By default, assets in the hierarchy inherit the policies of resources above them. All new resources created under a resource hierarchy node with a constraint set on it conform to that constraint. You can also set organizational policies using tags. Tags let you define groups of resources throughout a hierarchy and assign constraints to all resources in that group. Organizational policies help prevent security violations from happening by restricting actions that pose security risks, similar to guardrails on a highway. The policies enable people in your organization to work more quickly and securely with the confidence that the security team has authorized their access. If a restricted action is attempted, it's recorded in an audit log and sent to the Security Command Center so that administrators can track restricted actions and follow up on any issues. Organizational policies let administrators enforce compliance at a higher level than IAM policies. Even in large-scale cloud environments with thousands of resources created every day, organizational policies can help achieve compliance by restricting resource actions that do not fit within standards. A well-designed organizational policy can also prove to your auditors that your organization is complying with applicable standards. And since organizational policies can prevent unnecessary resources from being created, they can be used to control costs. As I mentioned earlier, cloud organizational policy is a set of restrictions or constraints on a specific cloud service or a list of services. Now, let's dive in a little deeper and discuss two constraint types: list and Boolean. List constraints are rules that allow or disallow a set of values and are useful when you need to specify the characteristics of resources created within your environment. For example, you might choose to enforce a constraint that prevents both public and anonymous access to cloud storage data. This would result in all created cloud storage resources becoming accessible only by a set of trusted accounts from a predefined list of domains. When a user tries to configure a resource to provide access to accounts from domains not on the list, they'll receive an error code specifying which policy was violated, and the account access will not be permitted. Boolean constraints are constraints that are either enforced or not enforced for a resource. They govern a specific behavior and can be set to true or false. This is known as the disable automatic role. The disable automatic role is an example of a Boolean constraint because it grants access to default service accounts. Some cloud services automatically create default service accounts with the editor role. The editor role includes a large number of permissions and can pose a security risk if an account is compromised. Using the constraint disable automatic role grants to default service accounts, you can prevent new service accounts from automatically receiving the editor role when they're created. This lets you choose which permissions to grant to service accounts either manually or by adding additional constraints to your organizational policy. Using organizational policies, you can be confident that your cloud environment will stay secure and in compliance, even at a large scale. The more you know, the more of an asset you can be to your team, your coworkers, and your organization. As a cloud security professional, your knowledge of organizational policies will help your teams configure resources securely. A person famously coined the phrase, "A stitch in time saves 9." The meaning of this phrase is when you deal with the situation right away, it saves you time later. In this video, we'll explore Organization Policy Service, Google Cloud's tool for managing organization policies. As a cloud security professional, Organization Policy Service gives you centralized control over organization policies throughout your resource hierarchy, and it lets you choose resource configurations to allow and enforce in your cloud environment. When organizational policies are well defined, teams can work with confidence knowing they're in compliance with laws, best practices, and the organization's information security policy. Organizational policies apply to newly created organization, project, and folder resource hierarchy nodes. So, resources automatically contribute to your organization's scalability. Whether you create a few dozen or a few thousand new resources, they'll all follow the organizational policies in place. You can get all the permissions needed to set constraints using Organization Policy Service by asking your administrator to grant you the Organization Policy Administrator role. You may also be able to achieve the permissions you need using custom roles. Once you have the required permissions, you'll be able to create, modify, and delete constraints. A constraint is a restriction against a Google Cloud service or a list of services. You can think of a constraint as a blueprint that defines what behaviors are controlled. Once you apply a constraint to an organization, folder, or project, the Google Cloud service mapped to the constraint will enforce the restrictions you've configured. Let's explore some constraints you can configure using Organization Policy Service. The Domain Restricted Sharing constraint limits the set of identities that can be used in Identity and Access Management, or IAM, policies. You can use this constraint to limit resources sharing to a specific Google domain or set of domains. Several constraints can be used to limit the use of IAM service accounts in your cloud environment. You can use the Disable Automatic Role Grants to Default Service Accounts constraint to keep default service accounts from automatically receiving the editor role. Other constraints that can help keep service accounts secure include Disable Service Account or SA Key Creation, Disable SA Key Upload, or limit lifetime of service account keys. Making sure your organization policies surrounding service accounts are configured properly helps your organization follow the principle of least privilege by making sure accounts have only the access they need. You can use the Restrict Resource Locations constraint to set a list of physical locations where you will create new resources. Permitted resource locations can include multi-regions and zones. Multi-region locations examples are the USA and Europe, because they have more than one region, like specific cities or states. Regions contain zones, which are independent failure domains. For example, you may work in an organization that falls under data residency requirements. You can use a list constraint to specify the set of locations where cloud resources can be created and data can be stored. If someone in your organization attempts to create a resource in a location that isn't on the list, they'll get an error. The resource will not be created, and the attempt will be logged. You can use Organization Policy Service to view all enforced policies and to edit policies after creating them. It's a good idea to review and evaluate your organization policies regularly and update them if needed, so they align with your organization's goals and structure. Organization Policy Service helps your organization address potential cloud security problems before they occur. Remember, putting the effort in now can help save you time later and keep your data secure. Who doesn't want that? Congratulations! You've made it to the end of the risk management section. You learned so many new security skills, including what tools and policies you can use to secure your organization's cloud assets and maintain compliance. Let's review. You began by exploring some security and compliance frameworks you can use to guide cybersecurity efforts and ensure cloud resources are compliant with laws and regulations. Then, you learned about Cloud Security Posture Management, or CSPM, tools. You also learned how Google Cloud Security Command Center can give you visibility into your cloud environment and help you to identify and manage risks. You then explored the advantages and capabilities of some common multi-cloud CSPM tools. Next, you reviewed the shared fate model of security and discovered how to use Google's risk protection program as part of your organization's cloud security approach. Finally, you explored using organizational policies and controls to prevent violations before they occur, and learned how to ensure your cloud environment is secure and your organization stays in compliance. Now that you've built a robust foundation in cloud security posture management, you can use it throughout your journey as a cloud security professional.
Hi, I'm Patrick.
And I'm Danielle.
Let's step into an interview that's in progress. In this interview, questions will cover cloud cybersecurity topics related to cloud risk management frameworks.
We hope this will help you as you prepare for your next interview.
Hey Danielle, what interests you in a career in cloud security?
Good question. I've always been someone that likes to go deep in order to understand something. I like to get to the nuts and bolts, the nitty gritty. If this is chemistry, I like to get to the atom. As I was learning about products and solutions, I found that I was diving into security compliance because security is a part of everything. It's a foundational aspect and it's a crucial aspect. It affects an organization, it can affect your personal life, it can make or break a sale. And so I found that in my quest to learn something and dive deep, I dove into security compliance and I love it.
Why is cybersecurity compliance important, and what are some examples of risks that it addresses?
Cybersecurity compliance is important for a number of reasons. And the first thing that comes to mind is to do right by your customers. When I think of privacy laws like GDPR and CCPA, they're protecting the rights of individuals and they require business to be upfront about how they're using customers' data, their personal data, name, social security number, addresses. And so it's in a business' best interest to gain the trust of their customers and lay that foundation. Another reason is penalties. A business can be fined and they can be found legally liable if they're not compliant. And then the last thing I would add is it opens up doors and opportunities to new sales, basically provide growth for your business. So I would say trust of your customers, penalties, and new revenue.
What is the difference between preventative, detective, and corrective controls, and what are some examples of each?
The difference between preventative, detective, and corrective controls is the purpose of each of them. I like to think of this as going to the doctor. So preventative care, going to your annual visit, you get your blood work done, you get your blood pressure, they ask you whether you're taking your vitamins. So preventative is making sure that you have the security controls in place to prevent a cyber attack from ever happening. Some examples of these are firewalls for networking, encryption for your data, and a last example would be identity and access management, which is often forgotten about. And it's making sure the right people have access to the right resources. So that's preventative. Detective is you're going to the doctor because you actually have symptoms. You have a cough, you have a headache, and you're trying to figure out what's going on. So detective is security controls that evaluate a security incident that has already happened or happening right now. And a great example of that are logging and monitoring tools and being alerted when there's suspicious activity. So using a SIM tool, for example. And the last one is corrective. So you've gone to the doctor, you have these symptoms, and they've diagnosed you. So how do we fix it? What medication do we give you? Do you need to have an operation? And so these are the remediation techniques that you can use. So do you have a disaster and recovery plan? Do you have a communication plan in place to go out to outbound customers and internal employees if there's a breach? Are you able to leverage a SOAR tool to have an automatic response? So I would say that is the difference between those three.
You might be asked to use tools to identify and remediate security risks in your role as a security professional. Why is that important, and can you give me some examples?
Yeah, we've been talking a lot about cybersecurity and the domain as a whole, compliance, but a big part of being a professional is being able to implement that knowledge through the use of tools. Tools are going to be what allows you to actually go in and identify the risk, mitigate it, and streamline and automate. One example that comes to mind, specifically within Google Cloud, is called Security Command Center. I like to think of it as a central hub for any security engineer to go in, have a single pane of glass of everything to do security-wise within their environment. Some of the things they can do are DLP, which is data loss prevention. So if there's sensitive data, they can mask it to make sure it doesn't get leaked. Another thing that you can leverage in Security Command Center is scanning for vulnerabilities within your web applications, and so much more.
That's all the questions I have for today. Now it's your turn to ask me any questions you might have.
Yeah, one question I would love to ask is, you're looking to find someone on your team that's a good fit. And I would love to know, when you think about your team for this year and you think about your priorities, what is a top priority for your team?
Well, this year, one of our main goals is that we have a portfolio of products that we are trying to get FedRAMP High compliant. And it's a huge effort.
Yeah, that's something I'd love to be a part of.
In this interview, Danielle demonstrated how to provide examples when answering questions. During the interview, you too can differentiate yourself by providing specific examples that show what you know and how you've used those different skills in different situations. Watch for more interview tips later on in this certificate.
Awesome work. You made it to the end of this course. I hope you've enjoyed learning about risk management strategies and frameworks in the cloud. My favorite part of working in cloud security is learning about the new and novel ways attackers gain unauthorized access to resources and systems. Identifying these threat vectors and creating detections or solutions to mitigate the threat is what gets me out of bed in the morning. My advice: dig into a specific topic, explore it until you reach a stopping point, build a solution to highlight your learning, and then show it off on the internet. Maintaining a portfolio of simple to complex projects is a highly valuable tool in showcasing your individual journey. Let's think back on everything you learned in this course. You started by exploring a general overview of security domains, policies, controls, and compliance. You learned about risk, security, and compliance, and investigated the relationship between 3 areas of compliance: people, process, and technology. You also practiced implementing security controls based on scenarios. Next, you explored risk management frameworks, laws, regulations, and industry standards. You also compared and contrasted data privacy and data protection. Then, you got a comprehensive overview of the compliance lifecycle. You explored controls and control mapping, assessments and auditing, negative organizational impacts of noncompliance, and policy as code, or PAC, and infrastructure as code, IAC. Finally, you build on your knowledge of risk and vulnerability frameworks to explore multi-cloud, cloud security posture management. You also learn about key cloud tools and their uses for risk and compliance, and about cloud organizational policies and controls. Congratulations on finishing this course. I'm excited for your next steps.
Hi there. It's great to have you here. In this course, we'll explore the essential aspects of securing digital assets in the cloud. And by the end of this course, you'll have a well-rounded understanding of the tools and techniques needed to protect your organization's data and infrastructure. Before we dive in, let me introduce myself and tell you a bit about how I got into the interesting world of cloud security. I'm Manny, and I'm a security engineer. Like some of you, I started in a different field before finding my way to cloud security. I started my career in IT. I worked as a help desk technician for a few years, then I moved into systems administration role. I enjoyed working in IT, but I was always fascinated by security. My unexpected journey took me to exploring vulnerabilities and challenges in the cloud space. I looked into Google Cloud projects to understand the various resources I could deploy, like compute instances, and how to configure firewalls for a home network lab. I realized that cloud security was a rapidly growing field, and I wanted to be a part of it. From my experiences and learnings, I'm now an offensive security engineer at Google, where I simulate real-world attacks against Alphabet and keep our data, systems, and users safe. Venturing into cloud security can be an exciting challenge, offering great opportunities. As we journey through this course, you'll gain key knowledge and insights, shining a fresh light on how to defend our digital infrastructure. Now, let's dive into the content and build skills essential for safeguarding digital assets in the cloud. First, you'll explore cloud security fundamentals, including identity management, access controls, trust boundaries, and the differences between zero trust and traditional perimeter security. Next, you'll learn about the cloud-native architecture and data protection, secure configuration, threat and vulnerability management, and data protection techniques like encryption and data masking. Then, you'll learn about cloud-based operations and continuity, including business continuity planning, disaster recovery, and infrastructure as code. Finally, you'll be introduced to automation, continuous integration and continuous delivery, service accounts, and secure management of credentials in cloud-native environments. Now, let's examine each topic in more detail. In the Cloud Security Fundamentals section, you'll learn more about the essential concepts and practices related to securing cloud environments. Your primary area of focus will be identity management principles and effective access controls in cloud environments. This includes how you'll learn to effectively manage user access. Next, you'll examine the concept of trust boundaries in cloud security. This will enable you to better understand and manage the flow of sensitive information within your organization. You'll then compare two widely used security models, zero trust and traditional perimeter security. By comparing these two models, you'll discover the knowledge and insights needed to determine the best security approach for your organization. In the Cloud Native Architecture and Data Protection section of this course, you'll review best practices for secure configuration and the effective management of threats and vulnerabilities in the cloud. This knowledge is essential for assuring the security and integrity of your cloud-based applications and infrastructure. During this section, you'll learn the details of cloud-native architecture and design considerations, focusing on key components like containers, serverless computing, and orchestrators. You'll also examine various data protection and privacy techniques that are crucial for safeguarding sensitive information and upholding privacy standards in the cloud. These techniques include encryption, data masking, the use of certificates, and the implementation of robust governance models. In the Cloud-Based Operations and Continuity section, you'll first focus on business continuity planning within the world of cloud computing. You'll inspect the steps organizations take to develop a robust plan that enables recovery from any potential disruptions that may occur. You'll also explore various key concepts and technologies that are crucial for efficient cloud-based operations. These include infrastructure as code, or IAC, automation and continuous integration and continuous delivery, or CI/CD. Along with these concepts, this section will also cover the usage of service accounts within cloud-native environments and the topic of secure credential handling. Throughout this section, you'll learn the importance of automating processes and securely managing credentials. After completing this material, you'll be on your way to becoming an effective and knowledgeable cloud security expert who is capable of addressing challenges and protecting an organization's cloud assets. Join me as we continue the exciting journey to expand your cloud security skills. Hi, I'm Manny. I'm a security engineer on Google's Red Team. My job is to simulate real-world attacks against Alphabet and keep our users safe. I make it harder to hack Google by hacking Google. I started out as a civil engineer, but I was always fascinated by the idea of protecting people's data and systems from attackers. I learned most of my hacking knowledge through free online resources like YouTube, books, and other helpful hands-on learning material. I also tinkered with virtual machines and looked at foundational security certificates, technical books, and programming to learn more about the field. I did extensive sandbox testing on different platforms. I was able to explore security topics in depth. I connected with friends already working in the field to get a better understanding while researching the various paths into cybersecurity. Additionally, Google's Cybersecurity Professional Certificate gave me a comprehensive foundation into cybersecurity and helped build my security mindset. I started my career as a parking garage attendant in college. I then worked in IT at a help desk, where I learned a lot of my initial computer skills. After graduating, I realized that I enjoyed troubleshooting and tearing computers apart. I pursued IT full-time, and from there, I became eager to learn more about the various disciplines within cybersecurity and how to protect organizations from cyber attacks. I've gained a lot of transferable skills along the way, from communicating effectively with stakeholders, to leading projects, to working with colleagues and friends. And involvement with community service has given me a variety of skills to work with when collaborating with security engineers and tackling some of the hardest challenges each day. I accepted an amazing opportunity with Google's Information Technology Residency Program, where I honed in on my computer, programming, and networking skills. I participated in a security rotation program and realized that I enjoyed the work, from defending devices and networks against malicious activity to analyzing logs and deep diving into issues. I realized that cybersecurity was a great career, and so I followed my passion. I continued to learn independently so that I could transfer into the security org. Eventually, I made it, and I'm still here today. It often helps to think about the big picture. In this course, we'll provide you with a comprehensive overview of the latest cloud security concepts, tools, and best practices. We'll cover 3 main topics that are crucial for understanding the cloud environment. First, we'll discuss identity management and access control in a cloud environment. We'll also review related concepts including single sign-on, or SSO, multi-factor authentication, or MFA, and identity and access management, or IAM, services. Second, we'll explore the different types of access controls employed in a cloud environment, including role-based access control, or RBAC, and attribute-based access control, or ABAC. And third, we'll provide you with an overview of trust boundaries, best practices for configuring and managing defense, and the zero trust security model. By the end of this course, you'll have an understanding of cloud cybersecurity concepts and be able to apply these concepts to scenarios you might really encounter in the workplace. Let's get started. Good security starts by knowing who has access to what. In this video, we'll be discussing the core principles of identity management in a cloud environment and how it aligns with least privilege and separation of duties. We'll also explore how these concepts differ from traditional on-premises environments. Then we'll dive into key topics like role-based access control, single sign-on, multi-factor authentication, and identity and access management services. Let's get started. Identity management is a core component for access control in cloud environments. Combining identity and network control strengthens the defense of cloud environments. One of the key differences between cloud-based and on-premises identity management is the scale and variety of providers and platforms available in the cloud ecosystem. Organizations are no longer limited to the in-house infrastructure and can now choose from a multitude of service providers, technologies, unique tools, and interfaces. This diversity, while offering flexibility and choice, also requires a unified approach to managing user identities and access control. Centralized and consistent identity management is essential for several reasons. Let's discuss 5 of them. Reason 1, use streamlined access control when you have multiple platforms and services in play and centralize the process of granting, modifying, and revoking access to resources, as opposed to managing these resources in a separate environments. Reason 2, you enhance security when you minimize vulnerable systems by consolidating access controls and preventing potential breaches. Reason 3, you improve compliance when you fulfill requirements to meet compliance, rather than when you just focus on implementing controls on data access and user authentication. Reason 4, you simplify administration when you provide a single interface for managing users, groups, and permissions across many systems in your environment. Reason 5, you save operational and resource cost when you centralize multiple identity management systems into a single identity platform. Now, let's go over some key topics in identity management for cloud environments. Role-based access control, or RBAC, is a method for controlling access to resources based on roles assigned to users. This helps ensure users only have permissions and access to the resources necessary for their job. Single sign-on, or SSO, is a technology that combines several different logins into one. It simplifies the authentication process by allowing users to access multiple applications using a single set of credentials. This minimizes the risk of password fatigue, which is when users feel overwhelmed by the number of different login credentials they need to manage. Multi-factor authentication, or MFA, is a security measure that requires a user to verify their identity in 2 or more ways to access a system or network. MFA adds an extra layer of security by requiring users to prove their identity using multiple methods, like a password and a fingerprint scan. Identity and Access Management Services, or IAM, is a collection of processes and technologies that help organizations manage digital identities in their environment. These services enable you to create, manage, and delete users and groups, and assign and enforce access policies. And that's a wrap. Understanding key concepts of identity management in the cloud, like RBAC, SSO, MFA, and IAM services, and how to apply them to cloud-based resources will increase your effectiveness as a cloud security professional. By implementing these principles, you'll be way on your way to securing your cloud environment. In our ever-evolving digital world, security is essential to protect sensitive data and prevent unauthorized access. With the growing threat of cyber attacks, it's essential to have robust security measures in place to safeguard against potential breaches. Fortunately, the AAA framework provides a reliable and effective way to help ensure security in computer systems. So, what are the 3 essential components of AAA? Authentication, authorization, and auditing, or AAA for short, describes a security framework that is used to verify the identity of users or groups in systems and grant them access based on their privileges. Let's examine each component. First is authentication. Authentication is the process of verifying who someone is. A common example is using a password to authenticate a user on a server, but relying solely on passwords is insufficient, leading to the development of multi-factor authentication, or MFA. MFA is a security measure that requires a user to verify their identity in 2 or more ways to access a system or network. Importantly, MFA prohibits the use of identical factors for authentication, adding an extra layer of security that helps protect against unauthorized access. Examples of MFA include combining a password with a fingerprint scan or a one-time code sent to a user's phone. This approach significantly reduces the risk of unauthorized access, as malicious actors would need multiple forms of authentication to breach the system. Next, we have authorization. Authorization is the concept of granting access to specific resources in a system. One form of authorization is role-based access control, or RBAC. RBAC is a method of controlling access to resources based on the roles assigned to users. RBAC streamlines the process for administrators, allowing them to manage permissions collectively rather than individually. Understanding the differences between authentication and authorization, their respective roles in identity management and access control, and their importance in maintaining system security is crucial. By implementing strong authentication and authorization processes, organizations can ensure that only authenticated and authorized users access their systems, and that those users can access only the resources they need to perform their job functions. Finally, there's auditing. Auditing is the process of recording and reviewing system activity to ensure compliance with security policies and identifying potential security breaches. The primary purpose of auditing is to ensure that any deviations from the expected behavior of a resource are identified and addressed. Auditing also helps identify potential security threats and vulnerabilities. There are several types of audits that can be conducted, including compliance audits, security audits, and operational audits. Compliance audits ensure that the organization is complying with the relevant laws and regulations. Security audits assess the security posture of the information system. Operational audits evaluate the effectiveness and efficiency of the system's operations. An audit is only effective when its objectives are clearly defined from the beginning. These objectives should be specific, measurable, achievable, relevant, and time-bound. These are called SMART goals. Audit objectives should align with the organization's overall goals and objectives. By establishing clear audit objectives, auditors can focus on the efforts on areas that are most critical to the organization's security. Simultaneously, auditors need to choose suitable tools and techniques that also align with the audit objectives and scope to help streamline the audit. The AAA framework, authentication, authorization, and auditing, provides a comprehensive and effective approach to ensure the confidentiality, integrity, and availability of cloud resources. By implementing this framework, organizations can safeguard their data and systems against cyber threats and breaches. With this in mind, use SMART goals to audit your organization's compliance, security, and operational systems to identify potential security threats and vulnerabilities. Remember, Prevention is always better than response. You may come across security practices in your everyday life. For example, businesses lock their doors when they close for the day and often keep security cameras on premises. You can compare these business security practices with a cloud security team's security principles to keep their organization's services and accounts safe. In this video, we'll discuss important topics related to security risk and best practices to help keep systems and data secure and protected. Specifically, security principles will include credential management, secrets management, non-interactive access, and security protocols to protect your systems from security risk. As a cloud security professional, credential management is a good place to start. The risks associated with unauthorized access to data are primarily because of inadequate credential management practices. If your organization's users create weak passwords, share their credentials, or fail to change credentials regularly, threat actors can easily gain access to your systems. To avoid such risk, it's important to require strong and unique passwords for all user accounts and require users to regularly change passwords. Users can also use a password manager to securely store and manage their credentials. Another important concept is secret management. Secrets are sensitive information like application programming interface or API, keys, passwords, and certificates that are used to authenticate and authorize access to systems. Your cloud security team will want to manage your organization's secrets to prevent threat actors from compromising sensitive information, which may lead to negative consequences. Best practices for managing secrets include using a centralized secret management tool, strong encryption methods to protect them, and regular rotation of API keys, passwords, and certificates. This way, unauthorized users are unable to use secrets to exploit services or gather data. Non-interactive service accounts are another security risk that your security team needs to address. These accounts are created for automated processes and services and are often overlooked. If not properly managed, they can provide an easy entry point for malicious actors to infiltrate your systems. To mitigate this risk, it's important to regularly review and audit these accounts, rotate keys associated with service accounts regularly, and limit their privileges. Now that we've covered some primary security risk, let's dive into some important security protocols that can help protect your systems. MTLS, OAuth, and OpenID are three common protocols that provide secure communications between different systems and services. Let's explore each of the protocols and understand their role in securing user communication and network access. MTLS, or Mutual Transport Layer Security, is a protocol that provides mutual authentication and encryption between servers. It's a variation of the Transport Layer Security, or TLS, protocol that secures communication between a client and a server. With MTLS, both the client and the server authenticate with each other, ensuring that the communication is secure and private. This helps prevent potential breaches or attacks and ensures that only authorized parties can access the information being exchanged. Open authorization, or OAuth, is a method that allows users to grant applications access to their information on other sites or systems without the need to share their passwords. For example, if you want to allow an application to access your Google Drive account, you can use OAuth to securely authorize the application to access your account without sharing your credentials. This ensures that your credentials will not be compromised and you have control over the access given to the application. Finally, OpenID is a protocol that is used for single sign-on functionality, allowing users to authenticate once and access multiple services. The process involves the user authenticating with an identity provider in exchange for an identifier. This identifier can then be used on another site or service without the user having to authenticate on that site or service for a second time. This simplifies the login process for users and reduces the risk of password fatigue and credential reuse. It's critical to implement best practices for credential management, secrets management, and non-interactive access and security protocols to protect your systems from security risk. By following these practices, you can ensure that your systems and data are secure and protected, allowing the appropriate people to reach the information they need. Imagine you're a receptionist working at a front desk of an apartment complex. It's your responsibility to decide who you let in. The concept of access controls and security works in a similar way. In this video, we'll discuss the different types of access controls and how they can be implemented to keep your cloud resources secure. Let's get started. Access control is a crucial element of cybersecurity because it ensures that only authorized individuals can access your data and resources. There are three main types of access controls: discretionary, mandatory, and role-based access controls. First is discretionary access control, or DAC, a security model where the owner of the data or resource has the discretion to grant or revoke access to other users. For example, in Google Drive, it's possible to share only view access with an individual to one specific file, while simultaneously providing edit access to a different file. Both files can reside within the same directory. These varying levels of access, from partial to full, from the owner of the files are discretionary. In a cloud environment, DAC can be implemented using Access Control List, or ACLs. ACLs specify the permissions for each user or group. Next is Mandatory Access Control, or MAC, which is a strict security model in which access is granted based on predefined security policies. For example, a private company's information is classified into three categories: confidential, internal, and public. The company controls the distribution of crucial information under the confidential classification by granting access on a need-to-know basis. By assigning individual permissions based on the required access levels, the company successfully secures its proprietary information. In a cloud environment, MAC can be implemented using security labels or tags, which are assigned to both data and users. Access is only granted if the user's security label matches the data's label. Now, let's discuss role-based access control, or RBAC. RBAC is a method of controlling access to resources based on the roles assigned to users. In a cloud environment, RBAC can be implemented by assigning users to different roles and managing permissions at the role level. In some cases, it may be necessary to implement role hierarchies to simplify the management of permissions. Role hierarchies allow higher-level roles, such as a user with edit access to a Google Drive directory, to inherit permissions from lower-level roles, such as a user with view access to a Google Drive directory, ensuring that the users with more responsibility have the necessary access to perform their duties. In other words, a user that can edit can also view documents in a directory, though a user with view access will not be able to edit documents in a directory. Finally, attribute-based access control, or ABAC, is a security model where access is granted based on the attributes like user resource and environment. In a cloud environment, ABAC works by creating policies that define the conditions under which access is granted or denied. These policies can be based on a variety of attributes like the user's job title, the sensitivity level of the data, or even the current day and time. Implementing ABAC in a cloud environment typically involves setting up a policy decision point, or PDP, and a policy enforcement point, or PEP. The PDP evaluates policies and makes access decisions, while the PEP enforces those decisions by granting or denying access to the resources. As a cloud security professional, you'll need to apply a multifaceted approach to effectively implement access controls in the cloud and secure your data. One key component to implementing access controls in the cloud is Identity and Access Management, or IAM. Remember, IAM allows you to manage users, groups, roles, and permissions across your cloud environment. Along with IAM, organizations must consider policies and resource hierarchies. These are crucial for structuring and enforcing access controls. Now that you know the different access control types, let's discuss some best practices for implementing access controls in cloud environments. The top 3 best practices include: 1. Apply the principle of least privilege, granting users only the permissions they need to perform their tasks. 2. Separate duties to minimize the risk of unauthorized access or actions. 3. Regularly audit access controls in your cloud environments to ensure access permissions are up to date. Then review and update and add or revoke access when necessary. By implementing these access controls, you can ensure the security of your data in the cloud. Remember, as a receptionist of the cloud, you only want to let approved guests and visitors into the building. Setting boundaries is important. In this video, you'll learn the different types of perimeter protection, explore various types of defenses, and learn about the importance of trust boundaries. Finally, you'll learn best practices for configuring and managing these controls. This is all very exciting stuff. Let's get into it. With the increasing adoption of cloud environments, perimeter protection has been more essential than ever. In a cloud environment, perimeter protection refers to the security measures implemented at the edge of a network or system to defend against unauthorized access and cyber threats. As a cloud security professional, there are several types of perimeter defenses that can be implemented to protect a cloud environment. Let's explore some of them. Identity and context-based access is increasingly becoming the first line of defense because it offers a robust security solution compared to traditional methods. Firewalls typically are only for internal networks and can help prevent lateral movement within the system. Intrusion detection systems, or IDS, monitor network traffic, check for signs of suspicious activity, and alert administrators when detected. Moving along the same lines as the intrusion detection system, IDS, we come across a similar yet distinct system, the intrusion detection and prevention system, IDPS. Intrusion detection and prevention systems, or IDPS, monitor network traffic for signs of malicious activity and either alert the administrator or actively block the threat, or both. Virtual private networks, or VPNs, create a secure, encrypted tunnel for data to travel between the cloud environment and the user, ensuring that data remains confidential and safe from prying eyes. Finally, access control lists, or ACLs, restrict access to resources in the cloud, ensuring that only authorized users have access to specific data or services. Trust boundaries are a crucial aspect of perimeter protection because they define the points in a network where the level of trust changes, like transitioning from a trusted internal network to an untrusted external network. For example, you can use systems like firewalls and routers to separate the public internet from the internal corporate network at both physical and logical levels. This action establishes and maintains a clear boundary between trusted and untrusted environments, providing a vital layer of security for the organization. An office building is like a trusted network, with each floor representing different sectors. Inside this network, doors and walls represent the firewalls. Think of the outer walls of the office building as the shift from a trusted network moving into untrusted territory, like the public internet. Now, imagine some offices in the building. These offices are trusted spaces with an extra security measures like locked doors. These spaces are like a company's private secure zones that contain critical information. Other rooms, like the lobby or an outdoor patio, would be the untrusted spaces. They're more open, like public areas in a company's network, but still have basic security. The key point is that trusted or untrusted isn't about the room itself, but about the level of protection and the sensitivity of the information within. Regular checks like office security inspections help keep both real and digital environments secure. Without clearly defined trust boundaries, your network is at risk of unauthorized access, data breaches, and other security issues. Establishing trust boundaries can help you better manage access to sensitive data and identify potential vulnerabilities. Now that we understand the importance of perimeter protection and trust boundaries, let's discuss some of the best practices for configuring and managing these controls to ensure your cloud environment is secure. These best practices can be categorized into three primary areas: improve cloud network security, monitor and control access, and maintain security policies and training. Here's how you can improve cloud network security. Implement network architecture that always requires user authentication. Segment networks, use microperimeters and apply context-aware access controls, and define trust boundaries between network zones based on risk and required access controls. To monitor and control access, follow these best practices. Regularly review and update firewall rules. Deploy cloud-based IDS, IPS solutions for protection, and implement secure remote access solutions and enforce strong authentication methods. Lastly, you can maintain security policies and trainings in these ways. Audit and update IAM policies for least privileges. Train employees on cloud security best practices and enforce strong password policies and multi-factor authentication, or MFA. By understanding the concepts of perimeter protection, trust boundaries, and implementing cloud security best practices, you can significantly improve the security of your cloud environment. Remember, the best defense is a good defense. Think about what it's like for someone just learning how to play a new game. There are rules or guidelines to follow and strategies to win. Just as in learning a new game, knowing how malicious actors operate allow you as a cloud security professional to stop them more easily. In this video, we'll discuss attack vectors and their significance for network and system security. We'll explore various attack vectors, understanding their impact on security, and discuss common examples, along with effective countermeasures. Let's first explain attack vectors. Attack vectors are pathways attackers use to penetrate security defenses. Now, let's learn the guidelines of using attack vectors. 1. Gain insight into attack vectors that are vital for network and system security. 2. Once you gain insight into attack vectors, pinpoint potential vulnerabilities and effectively defend against these targeted attacks. Next, we'll discuss strategies using countermeasures to help you overcome common attack vectors that impact perimeter and boundary protections. Malicious actors may use social engineering techniques that exploit human mistakes to gain access to sensitive data or valuables. Examples of social engineering are phishing, vishing, smishing, and spear phishing attacks. These types of social engineering attacks involve the use of digital communications to trick people into revealing sensitive data or deploying malicious software. To counter this, you can implement user training and email security measures. Next, password attacks are a widespread threat that usually involve brute force techniques in which attackers use trial and error to reveal private information. To significantly improve security, strengthen your password policies and incorporate multi-factor authentication. Cybercriminals might also exploit vulnerable software by taking advantage of known vulnerabilities. Remember, a vulnerability is a weakness that can be exploited by a threat. To counteract this, it's crucial to regularly patch and update software and use vulnerability scanning tools. Then there's malware, or software designed to harm devices or networks, which infiltrate and compromise systems. To combat malware, use advanced malware protection solutions and regularly update your software. Lastly, distributed denial of service, or DDoS attacks, are a type of denial of service attack that uses multiple devices or servers located in different locations to flood the target network with unwanted traffic. This can cause service outages and potential unauthorized access. To protect your company from these attacks, deploy DDoS mitigation services and monitor network traffic. It's important to know the threat actors you might encounter and how they think. You'll first need to understand guidelines of using common attack vectors. Next, you can utilize strategies to implement robust perimeter and boundary protection measures. Then, you're in a position to keep your network and systems secure. User authentication, or verification, is similar to receiving a phone call, and the phone displays the caller's name and number. Verification allows organizations to help ensure that an individual accessing any asset or piece of data is who they claim to be. In this video, we'll explore the Zero Trust security model and how it differs from traditional models. We'll also discuss its core principles and the network security mechanisms involved. Traditional access control models like role-based access control, or RBAC, and discretionary access control, or DAC, were designed with the assumption that everything within a network perimeter could be trusted. But this assumption can no longer be made because organizations have embraced remote workforces, cloud-based infrastructure, and Internet of Things, or IoT devices. In these new environments, the perimeter is no longer a clearly defined boundary, creating opportunities that can be exploited by malicious actors. In recent years, the adoption of the Zero Trust security model has been one of the most significant shifts, offering a more robust and adaptable approach to security in today's complex distributed IT environments. Zero Trust is based on the principle of never trust, always verify. This means that every user, device, or system must be authenticated and authorized before accessing any resources or data. This approach assumes that any user or device, whether inside or outside the network perimeter, could be compromised. So every access request must be validated and authorized on a case-by-case basis. By shifting the focus from perimeter security to securing individual resources, Zero Trust offers a granular approach to access control. Granular access control allows for more defined control over access, as permissions can be granted or restricted based on specific conditions. Let's discuss the core principles of Zero Trust. The first principle is verify explicitly. This means that every access request must be authenticated and authorized before access is granted to any resource. The second principle is apply least privilege access. This means that users, device, and systems should only be granted the minimum access necessary to perform their task. The third principle is assume breach. Organizations embracing Zero Trust should operate on the assumption that a breach has already happened or will happen and design their security measures accordingly. Now, let's discuss how organizations can implement Zero Trust policies using key access control mechanisms. These mechanisms include identity and access management, or IAM, multi-factor authentication, or MFA, microsegmentation, and network access control, or NAC. We've already defined IAM and MFA. Now, let's focus on microsegmentation and NAC. Microsegmentation is a security technique that divides a network into smaller, isolated segments to limit unauthorized access and reduce the potential attack surface. Note that an attack surface includes all the potential vulnerabilities that a threat actor could exploit. This approach ensures that even if an attacker gains access to one segment, they can't easily move within the network. Network Access Control, or NAC, is a security solution that enforces policy-based access controls to network resources, ensuring that only authorized devices and users can access the network. NAC's core function doesn't just stop at policy enforcement. It extends to identification, monitoring, and control of devices and users on the network. By employing these mechanisms, organizations can strengthen their security posture and minimize the potential attack surface. Another critical aspect of Zero Trust is the use of context-aware access controls. Context-aware access controls are decisions about granting or denying access to resources based on the user's identity and contextual information. Resources can include the user's location, device, and system access patterns. By incorporating this additional data, Zero Trust can make more informed access control decisions, reducing the risk of unauthorized access. As a cloud security professional, it's essential to understand how Cloud Access Security Brokers, or CASBs, and Secure Access Service Edge, or SASE, platforms can assist organizations in implementing Zero Trust policies, or ZTP. CASBs act as intermediaries between cloud service users and cloud service providers enabling organizations to enforce security policies and maintain visibility over cloud-based activities. By incorporating ZTP, CASBs can restrict access to sensitive data based on user identity, device, and context, ensuring that trust is not automatically granted. SASE platforms, on the other hand, combine network and security functions into a single cloud-based service. By integrating ZTP with SASE, organizations can apply adaptive security policies based on real-time context like user identity, device, location, and application. This approach eliminates the traditional trust boundaries and ensures that access is continuously evaluated and granted only when necessary. Both CASBs and SASE platforms play an important role in helping organizations implement ZTP by providing granular access controls, continuous monitoring, and adaptive security policies based on context. To wrap up, the Zero Trust security model represents a shift in the approach to access control, better securing today's complex, distributed IT environments. In a future role as a cloud security professional, you'll be well prepared to help organizations stay ahead of emerging threats and protect critical assets in an increasingly interconnected world. Congratulations, you made it! During this section, you gained essential knowledge and practical abilities to maintain an organization's asset securely within cloud environments. We dove into the intricacies of identity management and access control, gaining insights into vital concepts like single sign-on, or SSO, multi-factor authentication, or MFA, and identity and access management, or IAM services. You also learned about various access control mechanisms, the significance of trust boundaries, and the foundational principles of the Zero Trust security model. You began this course by exploring the core principles of identity management and access control within a cloud environment, focusing on SSO, MFA, and IAM services offered by cloud providers. Second, you explored the different types of access controls employed in a cloud environment, including role-based access control, or RBAC, and attribute-based access control, or ABAC. Finally, you learned about trust boundaries, identified best practices for configuring and managing defense, and how the Zero Trust security model employs mechanisms like IAM, MFA, microsegmentation, network access control, and encryption to strengthen security posture. Great job with the progress you made so far. You're doing awesome. Welcome. I'm so glad you're here. We have a lot of fascinating topics to cover. This section will cover three main topics: effective threat management, asset management and cloud security, and vulnerability remediation and posture management. The first topic you'll start by exploring is the significance of effective threat management in protecting an organization's assets, reputation, and operational efficiency. Then, you'll dive into the elements of a successful threat management strategy, including risk identification, assessment, prevention, detection, and response. Next, you'll uncover how to address challenges in executing threat management programs, like limited resources and evolving threats, by emphasizing continuous employee training, proactive risk management, and collaboration with industry experts to stay informed on trends and best practices. In the second topic, you'll discuss best practices for asset management in cloud security, and dive into the crucial aspects of managing and optimizing your organization's resources. Our focus will be on ensuring you're well-versed in the most effective strategies for tracking, maintaining, and optimizing your assets. You'll also find out about various tools and technologies for streamlining asset management. You'll then learn valuable tips for maintaining accurate and up-to-date records of your assets, and emphasize the significance of data integrity and consistency. This knowledge is crucial for making informed decisions and minimizing the risk of expensive errors. The third and final topic covers vulnerability remediation and posture management. You'll inspect secure configuration and posture management in cloud environments, and give you the knowledge to protect your organization's data and resources from potential threats. You'll also dive into best practices for vulnerability remediation and posture management so that you can effectively and efficiently identify, assess, and tackle potential risks. Finally, You'll review information about emerging trends and technologies in threat management to keep you updated on the latest advancements and innovations so you can enhance your organization's security posture. By the end of this section, you'll have a comprehensive understanding of threat management, asset management, and vulnerability remediation and posture management in a cloud environment. This will have you well on your way to navigating the cloud security environment with ease. As technology continues to advance, cyber threats are becoming more sophisticated and widespread. It's no longer if an organization will be targeted, but when. That's why having an effective threat management strategy is crucial for protecting your organization's digital assets. In this video, we'll discuss the essentials of establishing a strong threat management strategy. A threat management strategy is a comprehensive plan that addresses the various types of cyber threats an organization may face. This strategy should include preventive measures, incident response procedures, and regular audits. The key component of effective threat management strategy are prevention, detection, response, and recovery. Prevention involves implementing security controls to prevent cyber attacks from occurring in the first place. This includes firewalls, endpoint protection software, and access controls. Detection involves monitoring systems and networks for any signs of suspicious activity. This includes intrusion detection systems, log analysis, and security information and event management, or SIEM systems. Response involves quickly identifying and containing any cyber attacks that occur. This could include incident response plans, communication protocols, and emergency response teams. And finally, recovery involves restoring systems and data to their pre-attack state. This could include backups and disaster recovery plans. As a cloud security professional, implementing an effective threat management strategy is not without its challenges. One of the biggest challenges is the constantly evolving nature of cyber threats. As soon as you think you've handled one threat, another one emerges. Another challenge is the lack of resources and expertise in the field of threat management. A lot of organizations struggle to keep up with the latest threats and don't have the staff or resources to effectively manage them. Finally, there's a challenge of balancing security with productivity. Organizations need to ensure that their threat management strategies don't hinder their employees' ability to do their jobs. So, what can organizations do to overcome these challenges and implement an effective threat management strategy? The first step is to stay informed about the latest threats and trends in cloud security. This can include training, attending conferences, and staying up to date on the latest industry news. The second step is to invest in the right tools and technologies to help you manage threats more effectively. This can include next-generation firewalls, NGFWs, intrusion detection systems, and threat intelligence platforms. Ultimately, organizations must encourage and reinforce cybersecurity awareness among their employees, especially because people represent the most susceptible element in security systems. For step 3, organizations can support their employees when they create a culture of awareness through regular training and maintaining clear communication about the importance of security measures. Organizations rely heavily on IT systems to operate efficiently. But without proper maintenance and regular audits, systems can be vulnerable to cyber attacks and downtime. Regular audits can help identify vulnerabilities in your system that may have gone unnoticed. By being proactive, you can address these vulnerabilities before malicious actors can exploit the system. Downtime can be a severe issue for any business. It can lead to lost revenue, decreased productivity, and even damage the business's reputation. Regular audits can help increase system uptime when the system is working by identifying potential issues before they cause downtime when the system isn't working. Audits provide valuable insight into the health of your cloud resources. By understanding your audit results, you can make informed decisions on where to invest resources to ensure your systems are working at peak performance. In summary, regular audits are critical to protect organizations from cyber attacks, increase system uptime, and uncover vulnerabilities that may have gone unnoticed. In this video, you explore the fundamental components of a threat management strategy, uncovered how to address potential challenges and learned the importance of regular audits for enhancing cyber defenses. By taking these insights into account, you'll become better prepared to actively protect your organization from the rising regularity of sophisticated cyber threats.
My name is Ari. I am the lead security engineer for Google's threat analysis group. Basically, we try to protect Google's users as well as Google itself. And we do this by having these 3 different missions, namely tracking financially motivated threat actors, tracking disinformation, as well as tracking various government-backed threat actors. My favorite thing about my job is that we are basically protecting the more vulnerable population of the internet. This includes activists, dissidents, journalists, as well as other political entities. How did I get started? Somewhere between my junior and senior year of undergrad, I ended up joining a cybersecurity competition. I haven't been around other people that were very much interested in security before. So going to the cyber camp, I was like, oh, this is awesome. And I love the vibe, and everyone was so friendly and sharing tips and all that. I was actually enjoying myself. So I was like, yes, this is for me. A lot of companies have information or data in the cloud, and it's very important to protect these assets. Having knowledge of how to secure these assets in the cloud is very important as a skill, especially when you're trying to work in cybersecurity, as everyone is moving all of their data into the cloud. If you're just starting out in your cybersecurity career, my advice would be to go seek out mentors. Aside from trying to learn everything you can, trying to watch videos, trying to take time to read books, I would also reach out to a few people that you admire. A lot of the people in cybersecurity are very helpful. You can go to a lot of conferences, or you can join various different local communities, as well as basically just going through your local cybersecurity meetups. There's a lot of people that have helped me out and pointed me to the correct resources in order for me to further my skills as well as further my career. Working in cybersecurity, I think, is very much like an adventure. Sometimes you don't know what you're gonna get, right? Sometimes it's gonna be awesome and it's gonna be amazing. Sometimes it's a very difficult adventure, but at the end of the day, you actually end up learning something.
Organizing a closet is one of those chores we might put off. The longer you wait and the more you pile into the existing pile, the more work you'll have to do later. When you access a well-organized closet, it'll take you less time to get what you need, and so you'll be more efficient. Maybe you'll even save some money because you want to buy something you couldn't find in a messy closet. Proper asset and resource management, similar to a closet, saves time and increases efficiency and can help cut costs. In this video, you'll learn more about the role of asset management in maintaining a secure and well-organized digital environment. We'll uncover best practices for managing your assets and tools and technologies that can help streamline these processes. You'll also learn tips for maintaining accurate and up-to-date records to ensure a smooth and efficient asset management process. Ready? Let's get started. You may be wondering, what is asset management? Asset management is the process of tracking assets and the risks that affect them. Effective asset management is key for maintaining a secure environment because it helps organizations identify and track critical assets, detect and respond to security incidents more effectively, and mitigate risk associated with unauthorized access, data breaches, and other cyber threats. In the context of cybersecurity, asset management involves identifying all devices, software, and data within the organization, classifying assets based on their sensitivity and criticality, tracking assets throughout their life cycle, from procurement to disposal, and ensuring proper security controls are in place for each asset. Let's examine some best practices for asset management. First, it's important to develop an asset inventory and create a comprehensive, centralized inventory of all digital assets, including devices, software, and data. This inventory should include information like asset type, location, owner, and any associated security controls. Next, categorize assets based on risk. Assess the risk associated with each asset and categorize them accordingly. This will help prioritize security efforts and allocate resources more effectively. It's important to establish ownership and accountability. Assign clear ownership and accountability for each asset to ensure that they are properly managed and protected. Then, you can make sure to implement access controls. Establish access controls to limit who can access specific assets and ensure that only authorized personnel have access to sensitive data. Finally, monitor and audit assets regularly to identify any potential security risk, unauthorized access, or changes to the asset. There are a variety of tools and technologies that can help streamline the asset management process. The first tool we'll discuss is IT Asset Management, or ITAM software, a centralized application designed to manage and track the lifecycle of your organization's IT assets. ITAM software offers a comprehensive inventory of software and hardware within a business environment, including details like purchase dates, prices, license information, and serial numbers. ITAM software also streamlines the process of tracking, monitoring, and managing your IT assets. Next is the Configuration Management Database, or CMDB, a repository designed to store data about your entire IT environment, including its relationships between hardware and software assets. This provides a holistic view of your IT infrastructure, allowing for better understanding and management. Then, there are network scanners and discovery tools, which can help identify and catalog all your devices connected to your network, providing visibility into your organization's assets. Last but not least are vulnerability scanners. Vulnerability scanners can help identify potential security risk and vulnerabilities in your organization's assets, allowing you to prioritize remediation efforts. To ensure a smooth and efficient asset management process, it's essential to maintain accurate and up-to-date records. Here are 4 useful tips to help you achieve this. 1. Establish a centralized asset repository. Create a single, centralized location for storing all asset-related information to make it easier to manage and access. 2. Automate asset discovery and updates. Utilize tools and technologies that can automatically discover and update asset information, reducing the risk of human error and ensuring that your records are always current. 3. Implement a regular review process. Schedule regular reviews and audits of your asset records to identify and correct any discrepancies or outdated information. Finally, train your staff. Provide training and resources to your staff on the importance of asset management and clearly define their role in maintaining accurate records. Effective asset management is an important aspect in a robust cybersecurity strategy. By following best practices, utilizing the right tools and technologies, and maintaining accurate and up-to-date records, you can ensure that your organization's assets are well protected and secure. In this video, we'll discuss how a comprehensive asset management system provides transparency and continuous monitoring for cloud resource usage. You'll also learn the steps for effective asset management, including identifying assets, categorizing them based on risk levels, and maintaining accurate digital records. It's important to call out. Our discussion in this course should not be considered legal advice. As a cloud security professional, the first step in effective asset management is to identify all the assets within your cloud environment. When the cloud security team identifies assets, it helps them understand the scope of their cloud environment and prioritize resources based on their criticality. Assets include servers, like virtual machines, which run your applications and services within your cloud environment. Databases, which holds your organization's data and are important components of your cloud infrastructure. Applications including various software programs and tools, web applications, mobile apps, and application programming interfaces, or APIs. Other resources like load balancers, storage buckets, and network components are also part of your cloud environment. Once you identify assets, you'll continue to the second step in effective asset management, risk tiering. Risk tiering is a process that enables organizations to identify and categorize their assets based on their importance and potential impact. There are 3 tiers. You'll devote a different amount of time, energy, and resources to each tier. For high-risk assets, you'll provide the most attention and protection to assets like sensitive data and mission-critical applications. For medium-risk assets, you'll provide substantial attention and protection to assets like internal documentation and finances. For low-risk assets, you'll provide a small amount of attention and protection to assets like public information and non-copyrighted material. Risk tiering helps organizations allocate resources effectively and focus on the most critical assets. Let's examine an example of risk tiering in a healthcare organization. High-risk assets include electronic health records, or EHR, which contain sensitive patient information, proprietary research data, and mission-critical applications like hospital management systems. These assets require the highest level of protection, like access control and regular security audits. Medium-risk assets include internal communication systems, employee records, and billing information. While not as critical as high-risk assets, medium-risk assets still require a solid level of protection to prevent unauthorized access and data breaches. Low-risk assets include general information about the organization, like marketing materials, public-facing websites, and non-sensitive internal documents. Even though low-risk assets need protection, they can be allocated fewer resources and are a lower priority compared to higher and medium-risk assets. By risk tiering their assets, the healthcare organization can allocate resources more effectively. The organization can then focus on protecting the most critical assets that have the highest potential impact on the organization, should the assets be compromised. After you perform risk tiering, it's time for the third step in effective asset management. Maintain effective oversight. As a cloud security professional, it's a must to have an accurate and up-to-date inventory of all your cloud assets. This inventory should include information like asset type, location, ownership, and risk level. Regularly updating your inventory helps ensure you have a clear understanding of your cloud environment at all times. Implementing a comprehensive asset management system involves monitoring and tracking changes to your assets. This includes monitoring asset configurations, access controls, and vulnerabilities. By continuously monitoring your assets, you can quickly detect and respond to potential security issues. The process you follow to monitor and track assets is called Asset Lifecycle Management, which helps organizations optimize their cloud resource usage and reduce potential security risks. Asset Lifecycle Management encompasses planning, which entails defining procurement requirements and handling capital expenditure, and addressing all aspects of the asset lifecycle, from acquisition and deployment to maintenance and disposal. Planning ensures a seamless process. Let's check out an example of lifecycle management. A software company recently migrated its application and services to a cloud environment. To ensure effective asset management, the company follows these steps. Acquisition. The company selects the appropriate cloud resources like virtual machine, storage, and databases based on their specific requirements. Deployment. The company deploys these resources in a well-organized way to ensure seamless integration with their existing infrastructure. Maintenance. The company regularly monitors the performance of its cloud resources and updates assets as needed to maintain optimal performance. They also ensure that security patches and updates are applied to reduce any potential vulnerabilities. Disposal. When a cloud resource is no longer needed, the company securely disposes of it by following the proper decommissioning process. This includes deleting any sensitive data and ensuring that the resource is no longer accessible, reducing the risk of unauthorized access. By following these steps, the software company can effectively manage the lifecycle of its cloud assets, optimizing resource usage and minimizing security risk. In this video, you learned that implementing a comprehensive asset management system is vital for maintaining transparency and oversight over your cloud resource usage. By identifying and risk tiering assets, maintaining an accurate inventory, monitoring changes, and managing the asset lifecycle, you can ensure the security and efficiency of your cloud environment. The more you can effectively establish the security of a cloud environment, the more confidence you and your organization will have in the security of your assets. As a cloud security professional, sometimes you can correct or even mitigate problems when you take a step back and try to view the whole picture and identify what the end result is supposed to be. In this video, we'll explore vulnerability remediation and posture management in a cloud environment, review secure configuration, and discuss the importance of these concepts in maintaining a secure cloud environment. Let's first examine vulnerability remediation. Vulnerability remediation is the process of identifying, assessing, and resolving security vulnerabilities in your cloud environment. Vulnerability remediation is a process that typically involves 6 steps. 1. Identify vulnerabilities through automated scans, manual testing, or third-party reports. 2. Assess the severity and impact of these vulnerabilities on infrastructure and operations. 3. Prioritize vulnerabilities based on their severity, potential impacts, and ease of exploitation. 4. Implement patches, updates, or configuration changes to address those vulnerabilities. 5. Verify the remediation efforts to ensure that you've effectively resolved the vulnerabilities. And 6. Document the details of the vulnerabilities, your remediation efforts, and any lessons learned for future reference. This comprehensive approach helps ensure a secure and resilient cloud environment for your organization. Now we'll explore posture management, or the continuous process of monitoring, assessing, and maintaining the security stance of an organization's cloud resources. During this process, your cloud security team ensures that the cloud infrastructure is configured and operated securely, adhering to best practices and compliance requirements. Posture management typically follows 6 steps. 1. Monitor the cloud environment. In this step, you'll detect potential security threats, misconfigurations, and compliance violations. 2. Evaluate the security posture. In this step, you'll assess the robustness of the security posture by comparing the current state to established security standards and best practices. 3. Report. In this step, you'll create regular reports and dashboards that highlight areas of concern and improvement. 4. Remediate. In this step, you'll address security issues through vulnerability remediation, configuration changes, and other corrective actions to ensure a secure environment. 5. Implement and enforce security policies. In this step, you'll ensure that cloud resources are consistently configured and operated securely. 6. Regularly review and update security policies, procedures, and controls. In this final step, you'll keep pace with evolving threats, technologies, and business requirements, fostering continuous improvement in cloud security. Now let's review the definition of secure configuration. Secure configuration refers to the practice of setting up your cloud resources with the proper security settings and configurations to minimize potential risks. This includes following best practices, like limiting access to sensitive data and regularly updating software and applications. So why are secure configuration and posture management important in a cloud environment? Well, they help prevent unauthorized access, maintain data integrity, and protect your cloud resources from potential threats. In conclusion, vulnerability remediation and posture management are crucial aspects of maintaining a secure cloud environment. By adopting secure configuration practices, you can effectively prioritize remediation efforts and ensure the safety of your data and applications. Once you know where your organization might be vulnerable, you can take additional steps to properly secure those assets. Identifying weaknesses is just as important as developing security infrastructure. In this video, we'll discuss vulnerability remediation and posture management as they relate to software development. As a cloud security expert, it's important for you to understand and apply those concepts to ensure the safety of your software and systems. Let's start off by reviewing vulnerability remediation and posture management. Recall that vulnerability remediation is the process of identifying, assessing, and resolving security vulnerabilities in your cloud environment. This can include system patching, package rebuilding, or other external mitigations. Now, let's return to posture management, the continuous process of monitoring, assessing, and maintaining the security stance of an organization's cloud resources. This process helps organizations stay ahead of potential threats and minimize risks. In the world of software development, it's important to ensure the security and integrity of applications. One key aspect of this process is vulnerability remediation and management, which helps prevent security breaches and protects data while maintaining the integrity of applications. Imagine a software development team is working on a web application that handles sensitive user data, like personal information and financial transactions. During the development process, the team discovers a vulnerability in the application's authentication system, which could potentially allow unauthorized users to gain access to sensitive data. The software development team will complete the following steps to address vulnerabilities in an application. First, they need to identify the vulnerability. To do this, the team must understand the vulnerability and how potential attackers could exploit it. Tasks may involve reviewing code, consulting documentation, and researching known security issues related to the active technologies the organization uses. The team can conduct an impact analysis on vulnerabilities to complete these tasks. This analysis will help the team address potential consequences and set how they prioritize the urgency of issues. After that, the team needs to develop a remediation plan. Once the vulnerability has been identified, the team needs to develop a plan to address the issue. This may involve updating software libraries, modifying code, or implementing new security measures. Next, they need to implement the remediation. The team must implement the changes outlined in the remediation plan to ensure that the vulnerability is effectively addressed and that the application is no longer susceptible to the identified security risk. Then the team needs to test the solution. After implementing the remediation, the team should thoroughly test the application to ensure that they've resolved the vulnerability and that they didn't introduce any new issues as a result of the changes. And finally, they need to monitor and maintain. The team should continuously monitor the application for any new vulnerabilities and be prepared to address them as they arise to ensure the ongoing security of the application. By effectively addressing vulnerabilities through remediation, the software development team can prevent security breaches, protect user data, and maintain the integrity of their application. This will also ensure they provide a safer and more reliable experience for their users. There are several types of remediations. Let's explore 4 of them. Hotfixes are quick, temporary fixes for critical vulnerabilities that require immediate attention. Hotfixes are unscheduled because of urgent and time-sensitive needs. Also, hotfixes are usually added into patches at a later stage, which helps to make the system stronger over time. Security patches are updates that address specific security vulnerabilities. Unlike hotfixes, they're usually scheduled and systematically planned. A key feature of security patches is their ability to simultaneously fix multiple security issues, enhancing the overall security of the system. Updating dependencies involves updating or replacing third-party libraries and frameworks to more secure versions. Feature patches are updates that not only fix vulnerabilities, but also introduce new features or improvements. Follow these 5 best practices for vulnerability management and a strong security posture. First, implement a vulnerability management program that includes regular scanning, assessment, and remediation processes. Second, prioritize vulnerabilities based on severity, exploitability, and potential impact. Third, quickly apply patches and updates to minimize exposure to threats. Fourth, monitor and analyze logs and alerts for signs of potential security incidents. And fifth, continuously improve your security posture through training awareness and process improvements. Now that you have a better understanding of vulnerability remediation and posture management, you can begin applying these concepts to cloud security-related scenarios. Automation is becoming increasingly common in technology. It can help improve the efficiency of systems and strategies. In this video, we'll explore automation tools for posture management and vulnerability remediation. We'll also discuss best practices for validating security remediations to ensure compatibility and minimize potential disruptions. The features and benefits of IT automation tools include flexibility, efficiency, and consistency. These tools are flexible because they support various platforms and environments. These tools are efficient because they allow for faster deployment of updates and patches. And these tools ensure consistent configurations across systems. IT automation tools streamline the process of resource provisioning and configuration management and improve the detection and remediation of vulnerabilities. These tools play an important role in how you, as a cloud security professional, can manage complex IT infrastructure and ensure security compliance. Let's compare two popular IT automation tools. Ansible, a fast and simple configuration management tool, and Puppet, a more powerful but complex configuration engine. First up are the key features of Ansible. Ansible is an open source IT automation tool that helps organizations manage their infrastructure and applications more efficiently. Ansible has agentless architecture and does not require any additional software to be installed on the managed nodes. It uses yet another markup language, or YAML, for defining automation tasks. YAML makes it easier to create and maintain automation scripts. Ansible's modular design allows for the creation and sharing of reusable components, which can be used to automate tasks across multiple systems. With Ansible, you can also integrate with security tools like vulnerability scanners and intrusion detection systems to automate security tasks and enhance overall security posture. Next, here are the key features of Puppet. Puppet is another popular IT automation tool that helps organizations manage their infrastructure and ensure security compliance. Puppet uses a declarative language to specify the desired infrastructure configuration. This approach allows it to manage the implementation details itself. Puppet is designed for scalability. Puppet is suitable for organizations of all sizes because you can match the software to meet the needs of your organization, from small businesses to large enterprises. Puppet also provides comprehensive reporting and auditing capabilities, enabling organizations to track changes, demonstrate compliance, and identify potential security issues. And created with extensibility in mind, Puppet includes a wide range of modules and plugins. This enables organizations to extend its functionality and tailor it to meet their needs. Along with IT automation tools, businesses also need to have robust update and patch management tools in place. Update and patch management tools are essential for businesses to mitigate security risk. They ensure timely installation of updates and patches and address vulnerabilities, decreasing the possibility of cyber attacks. Organizations are recommended to have proper patch management processes in place to ensure the security of their systems and data. These tools help maintain compliance with various industry regulations and standards. Also, regular updates can improve system performance and stability by fixing errors and optimizing code. Finally, the automation of update and patch deployment can reduce the manual effort required from IT teams, allowing them to focus on other critical tasks. Before deploying security remediations, it's important to validate them to ensure compatibility and minimize potential disruptions. Some best practices for validating security remediations include canary testing, rolling deployments, and blue-green testing. Let's quickly review each best practice. Canary testing involves deploying a security update to a small percentage of the environments first, monitoring its impact, and then rolling it out to the rest of the environment if no issues are detected. This approach helps minimize the risk of widespread disruptions caused by a problematic update. Rolling deployments involve gradually deploying a security update across the environment in stages. This approach allows you to monitor the impact of the update on each stage and address any issues before moving on to the next stage. Blue-green testing involves creating two identical environments, blue and green, and deploying a security update to one of them while the other remains unchanged. Once the update is tested and verified in the updated environment, traffic is gradually shifted from the unchanged environment to the updated one. This approach helps minimize downtime and allows for easy rollback when appropriate. The key to helping an organization maintain a secure and well-managed cloud environment is threefold. First, use IT automation tools like Ansible and Puppet. Second, implement robust update and patch management solutions. And third, follow best practices for validating security remediations. The more you know about these tools and concepts, the more prepared you'll be to navigate modern cloud security environments. Consider the role of a vehicle mechanic responsible for maintaining and enhancing the performance of cars. Just as a car may seem to be operating smoothly, it's vital to conduct regular inspections and make necessary improvements to keep it in top condition. Systems, much like cars, also require periodic checkups and updates to maximize their effectiveness. In this video, we'll explore two key system maintenance methods, patching and rehydration. Let's get started. First up is patching. Patching is the process of installing updates to software to address vulnerabilities, improve stability, or add new features. In the context of system maintenance, patching plays an important role in keeping systems and applications secure and up to date, reducing the risk of cyber attacks. As a cloud security professional, you'll follow these mechanics of patching steps. Step 1. Develop a cloud-based inventory and baseline. The first step is creating a baseline of all the resources in your environment. This baseline is a reference point for tracking any changes. Be sure to maintain and update this list regularly. Step 2. Identify vulnerabilities and available patches for the system. Next, identify possible vulnerabilities on resources in your environment. Tools like vulnerability scanners can help you in this process. After identifying these vulnerabilities, find patches that are compatible with the system. Once you have appropriately identified the vulnerabilities and their corresponding patches, it's crucial to examine how these patches will affect the system. Step 3. Assess the patch's impact on the system. Patches may affect the performance of the system. A system evaluation should consider effects on stability, software compatibility, and performance of the patch. This evaluation should also consider the risk associated with leaving the vulnerability unpatched. Step 4. Download and test the patch in a non-production environment. Download the patch from a trustworthy source. Before deploying it in the production environment, test the patch in a non-production environment that closely resembles the existing system. This ensures the patch operates as intended without causing any additional problems. But we're not done yet. Step 5. Schedule the downtime or plan a service restart. Installing patches may require system downtime. To minimize the impact on operations, schedule this during off-peak hours. Also, make sure to communicate the estimated downtime to stakeholders. Step 6. Backup data and system configurations. Next, back up all the essential data and system configuration files. Doing so will enable you to restore the system to its previous state if the patch causes unexpected issues. With all important data and system configurations securely backed up, you can start to apply the patches. Step 7. Apply the patch to the system. Now you can apply the patch to the system. This step includes the actual installation of the updates. Step 8. Verify the patch's effectiveness and stability. The final step of the patching process is to confirm whether the patch has successfully fixed the intended vulnerabilities and monitor system performance to make sure no new issues have emerged. Now, let's discuss rehydration. Rehydration is a cloud-native process where new servers are created with the latest updates and patches, allowing for the workload to be transferred from old servers and for the outdated servers to be decommissioned or destroyed. Unlike conventional patching, rehydration emphasizes continual replacement with up-to-date instances. Let's review each rehydration step in detail. Step 1. Inventory of all cloud-based resources. In the first step of rehydration, establish a system baseline that includes all of your cloud resources as a point of reference. This will assist you in tracking system or configuration changes. Step 2. Identify vulnerabilities and available upgrades. The second step is to identify any vulnerabilities in your resources from the baseline. This includes known bugs, outdated software, or poorly configured settings. Step 3. Run updated and old instances to compare. Once you've created new resources with updates, run them alongside the existing ones. This helps identify and fix issues or compatibility problems before they replace production resources. Step 4. Slowly redirect traffic from old to new instances. Next, slowly redirect traffic from the old resources to the new patched resources to minimize downtime. Doing this gradually ensures that the new resources can handle the workload and that no data is lost in the transition. Step 5. Decommission or destroy old instances. Finally, after all the traffic has been successfully redirected to the new resources, decommission or destroy the old instances. This final step ensures that only updated systems are in the production environment. In this video, we explore the concepts of patching and rehydration system maintenance methods. You gained a better understanding of the mechanics, benefits, and limitations of both methods. Remember, choosing the right approach depends on your system's architecture, environment, and organization's requirements. Be the vehicle mechanic your security system needs. Stay up to date with the latest security updates, and regularly refine your process to ensure your systems remain secure and perform optimally. Hi there. Let's discuss the differences between the patching and rehydration maintenance methods. We'll also cover when to use each approach and the advantages and disadvantages of both. Let's dive in. Patching is a common method of updating software or systems to fix vulnerabilities, errors, or improve performance. It involves applying a small piece of code called a patch to an existing software or system. Rehydration is a more recent approach to updating systems and applications in the cloud. Rehydration involves creating new servers with the latest updates, patches, and then decommissioning or destroying the outdated servers. This method is different from patching, which introduces minor updates to the current system without needing a complete replacement. Now, let's discuss when you, as a cloud security professional, might use patching and when you might use rehydration. Patching is an effective method for making targeted updates, particularly necessary for old systems or monolithic applications. It is especially useful when downtime is unavoidable, ensuring system performance and integrity. Cloud-native rehydration is a process that minimizes downtime and ensures consistency for serverless and containerized applications. It allows easy system updates and is great for maintaining uniform configurations and security settings, making it efficient for large-scale changes. Both methods help keep operations running smoothly, but they have their own unique advantages and disadvantages. Let's start with patching. There are several advantages of patching. Patching includes targeted updates to specific components and doesn't require the entire system to be rebuilt or reconfigured. Also, patching has compatibility with legacy systems. But there are also some disadvantages. Patching can lead to increased complexity and potential for human error. It can also have incomplete updates, leaving systems vulnerable. Cumulative patches can also lead to performance issues. Now let's shift our focus to rehydration. The main advantages of rehydration are speed, consistency, immutable infrastructure, and simplified management, reduced downtime, and reduced human error. Let's discuss these differences in more detail. First is speed. Rehydration is faster, as it replaces components rather than updating existing systems. Second is consistency. This method ensures that all instances of a cloud resource run the same software version, eliminating issues caused by patching. Third is immutable infrastructure. This approach promotes unmodified components after deployment, reducing risk. Fourth is simplified management. Rehydration can be automated for easy cloud resource management and large-scale updates. Fifth is reduced downtime. Rehydration minimizes downtime as it creates new instances with the latest updates. The last is reduced human error. The automation aspect of rehydration decreases the potential for human error. We've listed the advantages of rehydration. Now, let's review some of its disadvantages. The integration of rehydration with legacy systems managed by the organization's or underlying system may present a compatibility issue. On the other hand, the organization's IT professional or team bears the responsibility of mitigating potential data loss risk by ensuring proper data management practices are in place. Next, what's a good example of how to apply rehydration? Use rehydration with systems running on Google's Kubernetes engines, or GKE. This is a good example of taking advantage of immutability's benefits for containerized applications. By creating new containers with updated dependencies, a stable environment is established. This process minimizes downtime, enabling seamless traffic switching and easy rollbacks. Maintaining an immutable infrastructure using disposable components enhances reliability, ensuring Kubernetes application stability with smooth management. Patching and cloud-native rehydration are two distinct approaches to updating systems and applications. Understanding the advantages and disadvantages of each will help you choose the right approach for your specific use case, ensuring optimal system performance and security. We can't predict the future, but we can prepare for it. In this video, we'll discuss current and future trends in vulnerability and threat management. We'll also explore emerging trends and technologies like machine learning, artificial intelligence, and the Internet of Things. We'll also discuss cloud security posture management and cloud attack surface management solutions. Let's dive in. Machine learning, or ML, and artificial intelligence, or AI, have had a significant impact on cloud security. These technologies have revolutionized the cybersecurity landscape by enabling the analysis of massive datasets, pattern recognition, and proactive threat prediction and prevention. ML, a subset of AI, uses algorithms to learn from data, allowing computers to make decisions and predictions without explicit programming. In cloud security, ML can analyze vast amounts of data, detect anomalies, and automate threat detection and response. AI, a broader concept encompassing ML and other technologies, creates systems capable of learning, reasoning, and problem solving. In cloud security, AI enhances ML capabilities, improves threat intelligence, and enables the development of sophisticated security tools. The synergy of ML and AI actively drives significant advancements in cloud security, including real-time threat detection, advanced analytics, and automation of routine tasks. These advancements enable continuous adaptation to emerging threats, ensuring secure and well-protected cloud environments. Next, let's discuss the Internet of Things, or IoT. IoT refers to the interconnection of everyday objects and devices that enables them to collect, exchange, and analyze data through the internet. IoT devices like smart home systems, wearable devices, and industrial sensors rely on cloud-based computing infrastructure for data storage, processing, and analysis. This seamless integration allows for real-time monitoring, automation, and remote control of various processes, ultimately improving user efficiency and convenience. The rapid growth of IoT devices brings exciting possibilities, but it also presents new cybersecurity challenges. To safeguard user privacy and ensure data integrity, it's crucial to secure both the cloud infrastructure and the connected devices in this ever-evolving digital landscape. Lastly, let's discuss cloud security posture management, or CSPM, and cloud attack surface management, or CASM solutions. These tools help organizations maintain visibility and control over their cloud environments, ensuring adherence to security best practices and threat identification. CSPM tools continuously monitor and assess cloud environments and identify misconfigurations, vulnerabilities, and compliance violations. Key features of a cloud security posture management (CSPM) solution include automated assessment, compliance monitoring, policy enforcement, and real-time alerting and reporting. Chasm solutions focus on identifying, monitoring, and minimizing an organization's cloud attack surface. Key features of a cloud attack surface management Chasm solution includes asset discovery, vulnerability assessment, threat intelligence integration, and risk prioritization. Integrating CSPM and Chasm solutions into an organization's cloud security strategy ensures a comprehensive approach to the security posture and proactive threat management. Some of the most significant trends in cloud security include the following: zero trust architecture, container security, edge computing security, security as code, automated incident response. Each of these trends presents unique challenges and opportunities for organizations. For example, AI and ML can help automate threat detection and response, but may also introduce new attack vectors. Similarly, zero trust architecture can enhance access controls and monitoring, but it requires a significant shift in cloud security and infrastructure management. You'll evaluate technologies and approaches to protect your organization's digital assets and mitigate security challenges. Here are 5 key steps to help solve cloud security challenges. Step 1. Assess the effectiveness of various technologies. Assess the performance and capabilities of security technologies and methods, and choose solutions with a proven track record of success in managing similar challenges. Step 2. Determine suitability for unique cloud environments. Each organization needs to determine if they need a unique cloud environment, potentially requiring customized security solutions. Assess whether a specific technology aligns with your organization's unique needs. Step 3. Consider scalability for growth and changing needs. As your organization expands, so will your cloud security requirements. Ensure that the technologies you select can scale to support future growth and adapt to emerging challenges. Step 4. Evaluate compatibility with existing systems and processes. When choosing a security solution, evaluate its compatibility with your organization's current systems and processes. A solution that integrates with your existing infrastructure will be easier to implement and manage. And step 5. Examine ease of integration for smooth implementation. Examine how easy or how complex it will be to integrate selected technologies into your organization's cloud environment. A straightforward solution will reduce disruption to your operations and expedite your organization's ability to benefit from cloud security. The future of cloud security will be shaped by emerging trends and technologies. By staying up to date on advancements and implementing the appropriate security measures, organizations can protect their cloud environments and ensure the safety of their data. Now that's what I call future-proof. In this video, we'll cover several important threats and vulnerability topics. The significance of regular reporting and assessments, analyzing potential business risk, evaluating the role of reporting and assessments, and some emerging trends and technologies in cloud security. Let's get started. Regular reporting and assessments are important to maintaining a strong security posture. They help organizations identify vulnerabilities, detect security incidents, and monitor the effectiveness of security controls. By conducting these evaluations, organizations can proactively address potential threats and reduce the likelihood of cyber attacks. Also, regular assessments help organizations stay compliant with industry regulations and demonstrate their commitment to security best practices. For example, imagine the ABC Company, a financial services provider, understands the importance of a strong security posture. To achieve an improved security posture, they've implemented a comprehensive security assessment and reporting strategy. First, the ABC Company conducts regular vulnerability scans of their network infrastructure, web applications, and critical systems to identify potential weaknesses. Second, to ensure timely incident detection and response, the ABC Company utilizes advanced security monitoring tools and has a trained incident response team ready to quickly assess and mitigate threats. Third, periodic internal and external security control audits are conducted to assess the effectiveness of security controls and ensure compliance with industry regulations. Fourth, the ABC company also provides ongoing employee security training to keep employees aware of the latest threats and best practices. Finally, the security team regularly generates monthly and quarterly security reports, sharing the results with senior management to drive continuous improvement. By implementing the security assessment and reporting strategy, the ABC company proactively addresses potential threats, maintains compliance, and fosters trust among users and partners. By following this approach, the ABC company has successfully implemented an effective program. An effective program involves the following steps. First, identify assets like devices, applications, and data. Then, assess vulnerabilities and potential threats to these assets. Next, prioritize remediation efforts based on risk and impact. Then, implement fixes, patches, or other security measures. And finally, monitor progress and continuously adjust strategies as needed. By following these steps, organizations can effectively manage and mitigate risk associated with cyber threats. Failing to conduct regular reporting and assessments can lead to severe business risk. These include financial losses because of data breaches, reputational damage as clients lose trust, and legal penalties for non-compliance with industry regulations. Organizations that don't conduct ongoing security evaluations leave themselves vulnerable to cyber attacks and potential breaches. This can result in long-term consequences and hinder a company's growth and success. Emerging trends and technologies in cloud security offer a lot of advantages. Some benefits of these advancements include stronger data encryption, more efficient threat detection, streamlined security management, automation, increased visibility, and improved detection and response capabilities. But there are also potential disadvantages to consider, like increased complexity and reliance on third-party vendors. These trends usually require continuous learning and adaptation to maintain a secure cloud environment and stay ahead of evolving threats. When organizations adopt new technologies, they must ensure that their security teams have the knowledge and expertise to manage these tools effectively. So, it's essential to carefully evaluate these factors when adopting new security solutions. Balancing the advantages and disadvantages of emerging trends and technologies can help organizations make informed decisions and optimize their cloud security strategy. In this video, we explored the importance of regular reporting and assessments, and the potential business risk of not conducting them. We also discussed the role they play in threat and vulnerability management, and the advantages and disadvantages of emerging trends and technologies. By understanding and implementing these concepts, you can strengthen your organization's cloud security posture and protect against cyber threats. Great to see you! Let's recap what you've been learning. So far, you've gained an understanding of threat management, asset management, vulnerability remediation, and posture management in a cloud environment. We started by exploring the importance of threat management in protecting an organization's asset, reputation, and operational efficiency. Then you learned the components of an effective threat management strategy, including risk identification, assessment, prevention, detection, and response. We also explored challenges faced by organizations when implementing threat management programs and gave you some helpful tips for overcoming these challenges. Next, you learned about the aspects of maintaining and optimizing your organization's resources and best practices for asset management. You were also introduced to tools and technologies for asset management and learned some tips for maintaining accurate records of your assets. Then you learned about the aspects of maintaining a secure infrastructure in today's digital landscape. We also explored the importance of secure configuration and posture management in a cloud environment, and discussed best practices for vulnerability remediation and posture management. Finally, we examined emerging trends and technologies in threat management to keep you informed about the latest advancements and innovations. Great job with the progress you made so far. Keep the momentum going. Hi there. I can't wait to join you on your journey through cloud-native concepts. We'll start with an overview of cloud-native design and architecture, including designing for automation. You'll also learn about cloud-native security models. Then we'll explore time to live, or TTL policies. You'll also learn about the benefits of ephemerality and immutability in cloud security. Next, we'll explore automation, specifically infrastructure automation. You'll also learn about infrastructure as code and policy as code. Then you'll learn about Terraform and cloud security automation. Next, you'll learn about containers and their critical elements. You'll also learn the differences between containers and virtual machines. Finally, we'll explore container security. You'll learn about container drift and how to prevent it, and explore orchestration. You'll also learn about serverless functions. As soon as you're ready, meet me in the next video. Let's start your journey into cloud-native design. As a cloud security professional, understanding how cloud resources are deployed is imperative to securing the network. In this video, you'll learn more about what role automation has in deploying cloud-native infrastructure and how understanding cloud-native design contributes to overall network availability. You'll also learn about managed services and examine some powerful defense strategies. Cloud-native design is the method of creating and deploying applications and services that are optimized for cloud environments, ensuring scalability, reliability, and security. This method is key to understanding how to automate resources, and most importantly, how to keep your cloud environment secure. Designing cloud infrastructure with automation is very important, and it comes with some really great benefits. Automation will provision assets with limited manual input. With just a few simple commands, you can choose the number of resources you want to deploy on demand. Imagine you're a cloud security professional working on a cloud site with millions of visitors. You need to deploy enough resources for all of them. Resources cost money, so you want to reduce those resources when you have less traffic. So how do you make sure you're deploying enough resources for the visitors while not overusing resources? Use autoscaling. Autoscaling is a process where automation sets up resources for you and reduces unused resources. Automation provides a consistent platform across all resources, so issues and misconfigurations can be fixed in a centralized location. As a cloud security professional, you'll come across automation often in your career. Sometimes you may need to use services from a third party or managed services. So, what is a managed service? A managed service is a service, application, or ecosystem managed by a third party. Managed services can reduce cost and reduce administrative tasks. Managed services can do things like monitor your network, protect against threats, and maintain compliance so that they can help you with some of your security duties. Now that you know more about automation and managed services, it's time to discuss defense. One of the ways to protect your assets is to apply authentication between each component. You can think about authentication like getting past a guard in a restricted area. Before getting access, proper identification must be shown. Authentication is one part of your protection program. You should also use rate limiting. Rate limiting is a method that prevents an operation's frequency from exceeding a set limit or value. This will help you avoid overusing services or overloading them beyond use. Consider this example of rate limiting. A user is logging into an app on their phone. They enter the wrong password, and the app gives them a warning. Only 2 more attempts. They put another password, but it's also wrong. The app gives them another warning. Only 1 attempt left. The user tries again, but it's the wrong password. Now the app blocks them from accessing their account. This is an example of rate limiting based on the number of attempts. The user was limited to 3 attempts, so the app won't allow them to continue after they exceed those attempts. Here's another example of rate limiting where a user meets a data limit. A user is streaming a video on their mobile device, which uses a lot of high-speed data. The user gets a message from their service provider warning them that they've used up 18 gigabytes of their 20 gigabyte high-speed data allotment. After a short time, the user gets another message. They've used up all of their high-speed data allotment, and their data speed has been downgraded. Along with rate limiting, time to live, or TTL, policies let you remove access from assets that don't need to be accessed anymore. Imagine you have private data that needs to be available externally for a limited time. Once the time to live expires, the data can no longer be accessed. This will help secure your cloud, leaving less data available for possible attacks. When implemented correctly, cloud native design uses automation to provision assets and employ authentication, rate limiting, and time to live to defend data. Cloud environments contend with a unique set of threats. But the good news is there are effective ways to deal with them. In this video, you'll learn how to keep your assets safe in the cloud. With everything in a cloud environment on the internet, instead of an on-premises server, the cloud needs a specific type of security. One of the pillars of cloud security is a shared responsibility model, an agreement between the customer and the cloud service provider, also called the CSP. The shared responsibility model is the implicit and explicit agreement between the customer and the cloud service provider regarding the shared accountability for security controls. The shared responsibility model states that a cloud provider monitors and responds to security threats related to the cloud and its underlying infrastructure. Meanwhile, end users, including individuals and businesses, are responsible for protecting the data and other assets they store in any cloud environment. As a cloud security professional, it's important to consider how to maintain your end of the shared responsibility agreement. You may need to follow regulatory obligations, develop a risk management plan, apply the security standards of your organization and your customers, and follow vendor security requirements. It's important to understand the different responsibilities that you, your organization, and your CSP have in securing cloud assets. The shared security model can help you determine these responsibilities. In a cloud model, servers and hardware are typically housed in a data center outside of your control. So the provider takes care of the physical hardware. As a cloud security professional, you're responsible for setting the security controls for your organization. For example, imagine a construction company builds a brand new gate and fence. The gate is strong and no one can break it down. Sounds pretty secure, right? Well, maybe not. After the gate is built, they put an old rusty lock on it. Because the construction company used an ineffective security measure to secure the gate, a malicious actor who really wants to get in can. This is an example of misconfiguration. Misconfiguration is like using a security control on your cloud assets that can be easily compromised. That's why it's your responsibility to keep up with the changes and always configure your security controls for the latest threats. Now that you know you're responsible for setting security controls, you also need to determine who gets access to what in the cloud system. This is known as multi-level security. One aspect of multi-level security is access control. Access controls are security controls that manage access, authorization, and accountability of information. Other aspects of multi-level security include using data sensitivity and classification, together with IAM. To do this, you need to determine how sensitive your data is and assign access based on its classification. You've taken quite a journey through the security concepts in this video. Now you know how to secure data in cloud-native architecture. Nothing lasts forever, right? In this video, you'll learn about ephemerality and immutability. These are two important concepts in the cloud, especially in cloud security. You'll review ephemerality and immutability and how they keep the cloud secure. You'll also explore the distributable, immutable, and ephemeral triad, also known as the ditriad. So, what is ephemerality? Ephemerality is the concept that things only exist for a short amount of time. For example, an access token is a piece of code that contains important information, like the user's ID, their permissions, and groups they belong to. Temporary access tokens expire shortly after they're created. They give users enough time to provide the information needed to gain access, then they expire. So, when you apply the concept of ephemerality to infrastructure, It refers to resources that are created as the need arises, then made unavailable when no longer needed. Think of it this way. Ephemerality is like having a paper file of confidential data that you read and then lock in a secure vault so no one else can read the file. Similarly, in cloud security, once your task is complete, ephemeral data is locked and is no longer available. Imagine an organization has highly confidential data that will only be needed for a short time. If the organization saves the data permanently, there's still a chance the data can be breached. However, if the data is ephemeral, once it's used and the expiration time is up, the data is made unavailable. Even the most skilled attackers can access data once it becomes unavailable. Immutability is the concept of being unable to change an object after it is created and assigned a value. An object that's immutable can't be changed after it's created. So, if your infrastructure is immutable, you can't modify it. If something needs to be changed, you replace it with a different version. Immutability has benefits in cloud security. One benefit is that immutable assets can't be changed, so they can introduce new vulnerabilities. For example, a web application has code that can't be modified by users. This prevents the introduction of a malicious code in the app. Because cloud servers are in remote data centers managed by cloud service providers, they need to be configured differently. Cloud security professionals need to rely on cloud-specific solutions. The DIE triad can help you do just that. DIE stands for distributed, immutable, and ephemeral. Distributed refers to the system resources that are distributed and not dependent on a single zone. Remember, a zone is the collective number of data centers in an area. Immutable means your infrastructure can be disposed of and replaced rather than modified. This is helpful because you can more easily identify and reverse changes by reverting to a previous version that's been saved in an immutable state. Ephemeral means your resources are finite and can be disposed of when they are no longer being used. Attackers can be persistent, but they can access information that's not available. In this video, you learned how ephemerality can help keep your data protected. You also learned about immutability and how you can use it to protect your resources from being modified by keeping them in an unchangeable state. This knowledge will strengthen your effectiveness as a cloud security professional. As a cloud security professional, you can use automation to streamline tasks and responsibilities. In this video, we'll discuss some of the benefits of automation, how it applies to infrastructure, and how it can help you in your career. Before we dive into the automation of infrastructure, it's helpful to understand the overall concept of automation. Automation is the use of technology to reduce human and manual effort to perform common and repetitive tasks. Automation also reduces the likelihood of human error. Cloud architecture is pretty complex, and there's a lot you need to do to keep it secure. Automation can support you in this process. One common security task is monitoring your system for threats. You could do this yourself, but using automation to monitor the system, you can free up time to focus on other tasks. Once automation is set up, it completes tasks efficiently without deviation. For example, if you set automation to monitor your systems, it'll complete this task within the parameters you've provided. Now that you know the benefits of using automation, let's explore how it works. You can use code and automation tools to program your system to perform repetitive tasks and monitor the system for security. You can even apply and distribute patches when vulnerabilities occur. Now let's explore infrastructure as code, or IAC, which is the practice of automating and managing infrastructure using reusable scripts. To set up IAC, you'll need to use tools like Terraform to provision infrastructure. Terraform is an automation tool. It lets you build, change, and version cloud resources efficiently and safely. With Terraform, if you specify the cloud platform and the resources needed, Terraform will build the assets for you. IAC can provide you with the automation power to do fantastic things like creating cloud resources, reviewing changes, testing changes, and auditing. Now, you'll explore how to use automation to deploy containers. A container can be built in Terraform and is a software package that holds only the components necessary to execute a particular application. There are several platforms available for deploying these containers. One of the most popular is Kubernetes. Kubernetes has the ability to manipulate containers and automate the deployment of resources throughout their lifecycle. Software goes through a lifecycle, or a series of stages and automated steps in a continuous integration, continuous development, or CI/CD pipeline. Since this is a continuous and iterative process, automating this process with Kubernetes allows the system to do the work for you. Automation can also help with configuration, scanning for vulnerabilities, reporting, enforcing policy, patching software, and resolving threats by taking the proper steps to solve them. Automation is a key factor in efficient cloud security operations and a resource you can rely on. Learning how to use it efficiently will improve your competence as a cloud security professional. Infrastructure is the foundation of many services. Working with cloud infrastructure doesn't always mean working with physical hardware. You can use code to build infrastructure and to define and manage policy. Let's explore infrastructure and policy as code. Then explore how DevSecOps keeps security involved in operations throughout the coding process. Infrastructure as a service, or IaaS, and other cloud infrastructure hosting platforms have made infrastructure as code possible. So how does infrastructure as code work? Users create files with infrastructure specifications, meaning they code the infrastructure they want to use. It's like turning code into components. Infrastructure as code is made available by an application programming interface, also known as API. API is a library function or system access point with a well-defined syntax and code that communicates with other applications and third parties. Infrastructure as code is also compatible with many different coding languages. There are two approaches to infrastructure as code. First is the declarative approach, in which you use an infrastructure as code tool to configure the desired state of the system, including necessary resources and any properties those resources should have. This also makes it simpler to manage taking down the infrastructure. The declarative approach focuses on what you need done. Second is the imperative approach, which defines the specific commands you need to achieve the desired configuration. After configuration, these commands need to be executed in the correct order. The imperative approach focuses on how you need something done. As a cloud security professional, you can use tools to help automate and manage your infrastructure components, like networks, cloud-managed services, firewalls, applications, and other components. But automation can be used for so much more. Let's explore another way you can use automation to help with policy management. Policy as code is the use of code to define, manage, and automate policies, rules, and conditions using a high-level programming language. Policy refers to the rules, conditions, or instructions that govern processes or operations in IT. Cloud professionals build policy into infrastructure to help manage policy. So, how does security fit into the coding process? There's a growing movement known as DevSecOps that's working to integrate security into the coding process. Development operations, or DevOps, consist of practices designed to increase the frequency of delivery and reduce lead time. DevOps' goal is to make sure the operations team is collaborating with the development team from the very beginning of a project. When security is incorporated, it's called Development Security Operations, or DevSecOps. An effective DevSecOps model will engage security throughout the operations and development process. With the DevSecOps model, policy as code and other security measures are incorporated throughout the operations and development process. Overall, this process promotes teamwork and collaboration. The increased teamwork helps identify vulnerabilities early, providing faster delivery. DevSecOps employs automation tools to automate several security processes. Some of these processes include continuous integration and continuous deployment, or CI/CD, the version control system, continuous testing, continuous monitoring, containerization, orchestration, and configuration management and deployment. In this video, you learned about infrastructure as code, policy as code. Additionally, with DevSecOps, you learn how to save time and resources by incorporating security into infrastructure, promoting collaboration, and using automation. You'll encounter these concepts in your career as a cloud security professional. Policy is one of the most important factors of security, but maintaining policy is complex, takes time, and people make mistakes. A mistake in enforcing policy can cause major problems. What if you could save time while reducing the potential for human error? Well, you can, using policy as code. Cloud security engineers enforce policies like the creation of virtual machines, limiting access to resources, and more. While these can be done manually, there are benefits to using policy as code. These benefits include implementing updates at a large scale, providing fast feedback about compliance, preventing mistakes, and avoiding violations and penalties. Let's start with implementing updates at a large scale. Updates to policies across many resources can be automated using policy as code. Imagine security cloud engineers are setting policy for an e-commerce retailer. They need to apply the same policy changes to many resources at one time. They use policy as code to automate updates to all of their resources, reducing the manual process, which could take several hours or even days. Another benefit to using policy as code is fast feedback about compliance. Going back to the example, the retailer security team decides to automate policy enforcement for compliance purposes. Doing so provides the team faster feedback about compliance than if employed using a manual approach. Whether policies are automated or updated manually, humans make mistakes. These mistakes can cause big, expensive problems, especially when done on a large scale. Suppose the retailer's security team automates the creation of virtual machines. They accidentally provision hundreds of large-sized machines, which isn't appropriate for their use case. This costly mistake uses up a lot of resources. Thoughtful implementation of policy as code can prevent mistakes. Another benefit to consider when using policy as code is avoiding violations and penalties in order to comply with government and industry standards. Security teams can code the controls from the standards into the policy to ensure compliance. As a cloud security professional, it's important to remember that policy that works right now may not always work. Policies may need to change. Technology changes too, and sometimes policy causes new problems with new technology. It's a good idea to keep track of all the different versions of your policies. That way, you can go back to an earlier version of policy configuration if there are problems. Now you know about the benefits of policy as code. As a cloud security professional, you can use these benefits to your advantage in order to maintain security standards and compliance. In your cloud security career, implementing thoughtful infrastructure design will be critical. You can use infrastructure as code, or IAC tools, to help automate and manage your infrastructure components, like networks, cloud managed services, firewalls, applications, and other components. IAC tools give you a way to define resources using configuration files. Within these configuration files, you can define parameters, options, settings, and preferences for these resources. Terraform is a popular IAC tool that enables users to provision cloud resources by communicating with an application programming interface, or API. Terraform creates and manages resources through that code. Some of the benefits of using Terraform include automation, reproducibility, and consistency. Terraform can automate the process of building and managing your infrastructure, which can save you a lot of time and effort. Terraform can also help you create reproducible infrastructure deployments. In other words, you can easily create the same infrastructure environments on different cloud platforms or on-premises. Additionally, Terraform ensures that your infrastructure is consistent across different environments, improving the overall reliability and security of your infrastructure. Terraform is a declarative tool, which means it defines what the desired state of the system is, including which resources you need and what properties those resources should have. There are 3 steps to the core Terraform workflow. The first step is to write the infrastructure as code. This involves defining your desired infrastructure configuration using Terraform. Consider this scenario. As a cloud security professional, a developer team asks for your help in building and deploying a virtual machine. They provide requirements, and you use Terraform to write instructions to build the virtual machine. In this case, you use a Google Compute F1 micro virtual machine. First, you designate your resource, then name your instance, then put in the machine type. So now you have an IAC that is ready to preview. The second step is to run the Terraform plan command. In this step, you preview your configuration before you apply it. The focus of this step is to ensure that the feedback loop aligns to the design of your infrastructure and is error-free. Please be aware that this step may be iterative. When building infrastructure, the development team should work together with the security team to build in policy as code using Terraform. You can use these policies to ensure the Terraform plan is compliant with past practices and security rules. For example, Terraform uses a tool called Sentinel to enforce policy on Terraform configurations. Sentinel uses a high-level purpose-built programming language to build policies. Benefits of policy as code include sandboxing, codification with comments for quick learning about policies, and version control. The Sentinel step happens between the planning and applying steps in the Terraform workflow. The third step is to run the Terraform apply command to provision the infrastructure. The focus of this step is for Terraform to communicate with the cloud provider to initiate the provisioning process. This involves the creation, modification, or deletion of resources based on the configuration in the IAC. It also determines the relationships between resources. It can use provider plugins to modify, create, and destroy resources on infrastructure providers. You can also use a single workflow to manage your infrastructure, but it will acknowledge the uniqueness of your provider. In this video, you learn that you can save yourself a lot of work by building and automating your infrastructure. So remember, tools like Terraform can help. In this video, you'll learn how virtual machines and containers use virtualization differently. As a cloud security professional, you'll need to be familiar with the security implications and best practices of these technologies. Let's get started. A virtual machine is a full operating system running on a host computer. It can run applications and use its own operating system independent of the host computer. It even includes the hardware layer, just like the hardware you'd find in a physical computer. This layer holds components like the CPU, memory, and disk drives. It also uses a hypervisor. A hypervisor is software used to create and run virtual machines. The hypervisor allows one host computer to share its memory, processing, and other resources to support multiple virtual machines. Containers let you run applications online, making them more efficient and faster. A container is a software package that holds only the components necessary to execute a particular application. When an application goes into a container, it's just like putting something into a box. And after adding an application, you can then add libraries and other dependencies to the container, just like adding more things to the box. Imagine you need to build a container for a specific Linux distribution. Instead of searching for every required component of that distribution, you can use the search term of the distribution you want. When you query a container repository, that repository will find the specific distribution and all dependencies and libraries needed for the Linux distribution to run and place them in the container. Both containers and virtual machines let you use isolated environments for running software services. But it's important to remember that there are differences between them. A virtual machine has its own guest operating system, like Linux, running on top of a host operating system. A benefit of using a virtual machine is that the hypervisor is allowed access to utilize the host hardware. Containers hold only the dependencies they need, but they don't have access to their own hardware. A benefit to containers is that they're lightweight, meaning they use a lot less memory than virtual machines. You can use a deployment platform, like Docker, to deploy your container once the image is created from building the application and all dependencies that were retrieved from the container repository. You can also use Docker to create, deploy, and manage your containers. Docker has its own command line interface and builds the containers based on your needs. You can use this interface to interact with Docker in a terminal. Your commands are sent to a program running in the background called the Docker daemon. The Docker daemon manages the containers and the images those containers are created from. When working in the cloud, you'll frequently have to use virtualization. Remember, virtual machines are complete virtual systems with hardware access. Containers hold only what you need to run your application, but they don't have hardware-level access. Knowing these differences will help you decide which technology to use depending on the situation. As a cloud security professional, it's important to know about containers. Chances are, you'll be working with them often. In this video, you'll learn about how containers can benefit you and what to be aware of when you use them. One critical element of containers is that they share the kernels of their host instead of having their own kernels. The kernel is a component of an operating system that manages processes and memory. For example, when you turn on a computer, the first component that starts is the kernel. Since they're not connected directly to kernels, containers can be moved easily between systems. They're platform independent and can be run on any systems that can support them. Remember, containers share the host's kernel, so if the host is vulnerable to an exploit, an infected container can attack the kernel's vulnerability. This means that the host kernel needs to be up to date, and all the libraries in the container need to be patched. You'll also need to be extra careful when configuring your container permissions. If you give them more privilege than they need, like having them run as root users, you can expose them to attack. Now that we've covered containers and container security, let's discuss container orchestration. Container orchestration allows you to deploy, scale, and manage your applications using automation. Kubernetes is a popular container orchestration platform that you can use in a cloud environment. Imagine Kubernetes as the conductor of a grand orchestra. Kubernetes, like a band or orchestra instructor at a school or university, directs the performance. It issues commands and ensures harmony with the ensemble of containers, just as an instructor guides students. Containers are like the musicians in an orchestra or students in a music class. Each container represents a specific instrument, each with unique roles within the performance. Kubernetes groups containers into pods, which are like the classrooms or music halls within the school where the orchestra practices. They are shared spaces that house multiple containers, similar to classrooms, accommodating students with various roles. These pods enable containers to work closely together, sharing resources like power and the local network, much like students sharing facilities within the same room. Nodes are the physical or virtual machines where the performance takes place, akin to the school buildings hosting multiple classrooms. Just as a school building may have many classrooms, a node can have many pods running within it, providing the stage for the orchestra, containers, to perform. A layered file system is another important element of containers. When you make a new container, there's one new container layer that new commands and files can be written to. So, any new commands, such as run or copy, that you give to the running container are written to the container layer. Each layer of a container is built on another layer to form an image. After the layers are put together, you get a final image. Remember, an image includes all the files and dependencies you need for your containerized app. Container runtime is software that is responsible for running and managing containers. The container runtime provides an interface that interacts with the host operating system to create, start, stop, and manage containers. Thinking back to our orchestra example, it's like a conductor cueing a musician to play their instrument at the right time. Now, let's explore how a container runtime works to put containers together. First, you'll need an image that includes all the software and dependencies you need for your container. When you use the run command, the platform puts together the container and deploys it. Because containers make up an important part of cloud computing, you'll likely use them a lot in your role as a cloud security professional. Now that you know more about the elements that set containers apart from other cloud technologies, you can use them to save time and resources. Containers are convenient and make sharing CPU, storage, memory, and network resources easy and portable. An important part of being a cloud security professional is securing containers. In this video, we'll explore ways to keep containers secure so that you're prepared for a role in cloud security. It's important to know the rules when it comes to securing containers. First, don't put anything in your container that you don't need. This can give attackers a larger surface to breach. If you find tools you don't need, remove them. If you leave them there, attackers might use them. Second, use verified or signed images. Third, scan each image you use to make sure there are no vulnerabilities or misconfigurations. Pro tip, be aware that images that may have been verified as secure originally can have new vulnerabilities later. A container deployment platform lets you build containers and deploy them. They may include command line interfaces or CLIs that allow you to input commands to deploy the containers. A container deployment platform is a software solution that allows you to manage containerized applications. It provides capabilities like automation, orchestration, governance, security, customization, and enterprise support for container architectures. Now, let's explore deployment and security with automation using a container orchestration system. There are a few container orchestration systems available to cloud security professionals. For example, Kubernetes is one of the more popular orchestration systems that you might come across in your career. Kubernetes is a platform for automating deployment, scaling, and managing containers. If a container goes down, Kubernetes will start a new one using automation. This makes the process easier because it's done for you automatically. Kubernetes also includes built-in commands to deploy applications, scale up and down for changing needs, monitor applications, and roll out changes. The Kubernetes platform handles a lot of the work that goes into application management, runs health checks against services, and replaces stalled containers when they're unhealthy. This means that containers are not updated or patched, but replaced by new versions. This allows you to roll the container back to a previous version if vulnerabilities are discovered in new code. Even after completely replacing containers, there are still vulnerabilities you need to be aware of. Let's explore some of them together. Kubernetes is a useful deployment system, but there are some vulnerabilities that can happen at different stages. When containers are being built, all the code needs to be trusted and checked. Code from any untrusted registries might contain backdoors which can allow potential attackers in. When building containers, you want to avoid too much clutter. Remember to search for any unnecessary libraries and dependencies. To keep these artifacts from being compromised, delete them as soon as you find them. There are some considerations you need to be aware of during deployment. First, never grant unnecessary privileges. Only grant what is necessary for the task to shrink the attack surface. Next, avoid problems by using namespaces to group services for your application and to isolate applications in your container clusters. Then, use policies to divide the network into segments. Finally, use role-based access controls, or RBAC, to prevent unauthorized access. Vulnerability scanning is another process that can help you find any vulnerabilities in your container images. You can manually scan your container software images, or you can use automation. When you use automation, it will automatically scan each container you deploy to make sure there are no vulnerabilities. Security threats can also happen in containers. As a cloud security professional, you'll need to be able to detect and respond to these threats. Using container runtime security can help you detect abnormal behavior and stop a threat by isolating a container on a different network. It can pause or restart a container if it finds potential problems. It can also enforce runtime policies. Now that you know more about securing containers, you can keep them safe from attackers. When your container has a container layer, it can write to that layer and make changes. This can be convenient, but it can also introduce dangerous container drift. In this video, we'll examine container drift and how to deal with it. Let's investigate. A container layer is a writable space in a container. But this space poses security risk. The more the container writes to this space, the less it has in common with the original image it was created from. When the container writes to the container layer, the container changes. That's container drift. One way to find vulnerabilities is by scanning for them. If containers can't be changed or updated, scanning images would prevent vulnerabilities from being introduced at runtime. When a container has a writable container layer that can be changed, scanning the image won't help much. So, while having a writable layer can give the container some flexibility, it can also introduce vulnerabilities. Vulnerable images don't pose an active threat by themselves, but they can introduce vulnerabilities to a live environment. Imagine the following scenario. A developer team needs to deploy a resource quickly, so they use an image from an outdated container library. The image had been previously scanned and was free from vulnerabilities and malware, So they dispatch the container with the added image. When they dispatch the image, they discover new vulnerabilities in the image. Now, there's a vulnerability in the live environment. Even a popular, commonly used container library can contain thousands of images with malware. This malware might include cryptocurrency miners, backdoors, website redirectors, and DNS hijackers. These consume resources and increase operational costs. They also give attackers opportunities to gain information and hijack your website. Container images are layered. The container layer is a writable layer that allows changes to be made. As the container writes to this space, it becomes different from the image it originated from. To prevent the problems associated with container drift, you need to prevent the drift itself. Drift prevention stops files from running if they're not part of the original image. You can use drift prevention to keep your container immutable, meaning no new executables can be added. Code needs to be updated to keep up with changes to technology. When these changes happen, you can build a new image and deploy it, but make sure you keep the old image available in case you need to go back, so you can redeploy it. When you're building containers, you should also keep a list of their components. These components include the software built into the container. A software bill of materials, or SBOM, is a machine-readable list of each piece of software and its components involved in the supply chain. An SBOM will provide information on applications and components running in your container and software information for all third-party libraries you're using. An SBOM can also track software and its components. It can track where they came from and what security vulnerabilities they contain. And it enables protectors to stop vulnerabilities from being exploited. SBOMs usually follow the Software Package Data Exchange, or SPDX standard. SBOM documents may contain package information, file information, snippet information, any other licensing information detected, information on the relationships between SPDX elements, annotation information, and review information. Container drift can compromise your container security, but you can prevent it. You can use the knowledge you learned in this video to keep containers secure throughout your cloud security career. There are many tasks cloud security professionals need to perform on a regular basis. That's a big responsibility. So, how do they manage them all? Well, orchestration can help. Orchestration is useful because it manages a full set of automated tasks for you. For example, it manages deployment, scaling, load balancing, networking, provisioning, lifecycle management, and container availability. And orchestration itself can also be automated. To use orchestration, use declarative programming. With declarative programming, you can write a configuration file focused on the desired outcome of an automation instead of detailing the steps needed to complete a task. Then, you can choose a platform or tool to find the appropriate host for your containers. Orchestration tools choose a host based on the requirements or predetermined constraints in the configuration files. These tools also schedule container deployments. Container orchestration tools help automate a variety of operational tasks. For example, these tools scale containers and load balance and allocate resources between containers. Additionally, orchestration tools monitor the health and performance of the application. There are several orchestration platforms available. For example, the Kubernetes engine is a popular platform that enables you to configure infrastructure to run your containerized apps. This infrastructure includes networking, hardware, scaling, and security. It also manages underlying components like nodes, pods, and container clusters for you. Nodes are machines that can be either physical or virtual, and include one or more containerized applications, which are known as pods. A pod uses shared resources and a specification on how to run containers. Pods are grouped by container clusters. Container clusters are dynamic systems that manage and place containers grouped in pods. Container clusters run on nodes, along with all the interconnections and communication channels. Once an image is deployed to the Kubernetes engine, it goes into the cluster through a load balancer and into several nodes containing pods. Clusters can be set up for a single zone or for a region. If the clusters are set up for a region, they're replicated across multiple zones. Setting up a regional cluster can help minimize disruptions, but it can also help use a lot of resources. So it's important to use horizontal autoscaling. You can use horizontal autoscaling to increase or decrease the number of pods based on utilization. And you can use virtual autoscaling to scale your clusters for both pods and nodes. Orchestration can automate policies and keep errors from happening. Imagine a container is about to be deployed, but it has vulnerabilities that violate a policy. If a violation of the policy is found during orchestration, deployment will be stopped. This can help you avoid human error and ensure the container is safely deployed. Role-based access control, or RBAC, is a type of identity and access management, or IAM, that is central to Kubernetes operations. It involves a template or permission set that determines who can execute what and where it can be executed. With RBAC, you can create and grant roles for any object or object type within a cluster. A role defines access to only resources within a single namespace, while a cluster role defines access to the entire cluster's resources. RBAC can help keep your cluster safe, but there are some things to avoid. Because the cluster admin role grants unlimited access, never grant cluster admin access to any users or teams that don't need high-level access. Also, avoid aggregating or combining privileges. Combining them may change the access they grant. It's also important to avoid creating roles that are not used. Orchestration does a lot for you. To be safe, always be sure to carefully assign roles and only give access to those who need it. Now that you know how orchestration can help you with cloud security, you can use it to manage your automated tasks. Orchestration can also help you prevent security risks. Congratulations! You've arrived at the end of this section on cloud security risk. You've learned a lot about cloud-native concepts and security along the way. Well done! On your journey, you learned about cloud-native design considerations. We started you off with an overview of cloud-native design and architecture. Then introduced you to cloud-native security models. Next, you explored time to live, or TTL policies. Then you learned about the concepts and benefits of ephemerality and immutability in cloud security. Next, we discussed infrastructure automation, infrastructure as code, and policy as code. Then you explored Terraform and cloud security automation. After that, we introduced you to containers and their critical elements, and discussed the difference between containers and virtual machines. Finally, we explored container security. You learned a lot about container drift and how to prevent it, and explored orchestration. Congratulations on finishing this section of the course. You're doing an amazing job. Meet you again soon. Hey there. Are you ready to learn about the fascinating world of data protection and privacy? Let's get started. We'll start by exploring the 3 states of data and how to use encryption for each state. Next, you'll learn about data classification, data governance, and sovereignty. Then we'll discuss data discovery, retention policy, and business continuity planning. First, we'll provide you with an introduction to the 3 states of data. You'll also learn about data encryption at rest, in transit, and in use. Then you'll learn about data classification and tagging. Next, you'll learn about data governance, data sovereignty, data discovery, and data retention. Then we'll discuss business continuity planning. You'll learn about the process of creating a business continuity plan that's best for your organization. Plus, we'll go through a possible scenario for using a business continuity plan. There are lots of cool things for you to explore. As soon as you're ready, let's meet in the next video. Companies collect large amounts of highly confidential data, like customer data, financial data, and business data. As a cloud security professional, you'll work to ensure data is secure. In this video, you'll learn about the 3 states of data. Let's get started. The first state of data is data at rest. This is data that is not being accessed or actively moving from device to device or network to network. Data at rest is stored on servers, databases, mobile devices, physical drives, or in the cloud. At-rest data includes intellectual property, employee and customer personal information, financial documents, contracts, and any other types of data, like healthcare data. The next state of data is data in transit. This is data that is moving between 2 places, like between a cloud provider and your site, or between two services. For example, using a mobile device to access a banking app moves data between two places, your mobile device and the host of the banking app. The third state of data is data in use. Data in use is data that's been accessed by one or more users. Data in use includes, but is not limited to, data that is being processed, erased, read, or accessed. For example, after you've accessed the banking app, accessing your transaction history on a banking website or app is an example of data in use. If you then decide to transfer money between accounts, the data then returns to an in-transit state while it moves between your device and the banking app's host. The data returns to being in use as you review additional account details. Now that you know about the 3 states of data protection, you'll be better prepared for your career as a cloud security professional. Data encryption protects your data at rest, in use, and in transit. But how does at-rest encryption work? In this video, we'll explore encryption techniques for the 3 states of data. Remember, data at rest is any data that is not currently being accessed. Data at rest needs to be encrypted to be secure. Data encryption is the process of converting data from a readable format to an encoded format. For example, a readable format might be a plain text email, and an encoded format might be scrambled text and symbols that don't make any logical sense to a reader. The Advanced Encryption Standard, or AES, is the world standard encryption tool that helps protect data at rest. AES is a tool that converts data to unintelligible cybertext and back into its original form with the proper key. This means that AES encrypts information while at rest, and this information can only be unencrypted with a key. Encryption helps keep data protected with data encryption keys, or DEKs. Even if an attacker gets access to the data storage, they won't be able to read any of it without the appropriate keys. Another way to protect data at rest is to break it into chunks for storage. Each of these chunks get their own DEKs. Each time a chunk is updated, it gets a new encryption key. Because there are a variety of keys that can change regularly, the risk of encryption key compromise is reduced or eliminated. It's not just data at rest that needs to be protected. Data in transit also needs to be protected by encryption. You can use Transport Layer Security, or TLS, to encrypt data in transit to keep it secure. TLS is a security protocol that encrypts data transmitted between 2 communicating applications. TLS is often used to encrypt data sent over the internet to ensure that unauthorized users are unable to read what has been transmitted. This is critical when transmitting private and sensitive information, such as passwords, credit card numbers, and personal correspondence. For example, say you're using a mobile banking app. If you transfer money to another account or pay a bill with the banking app, TLS will help to ensure that your sensitive information, like your account number, is transmitted securely over the internet when you make the transfer. Encrypted data is useless to any attackers because they're not able to read it. Lastly, you will need to encrypt data in use. Confidential computing is one way to do this. Confidential computing is the protection of data in use with hardware-based trusted execution environment, or TEE. To encrypt data, a TEE offers a secure and isolated environment that prevents unauthorized access or modification of applications and data while they're in use. A TEE is secured through embedded encryption keys, and only authorized code can utilize these keys. Now that you know how different types of data encryption protect data at rest, in transit, and in use, you'll be able to help secure different states of data as a cloud security professional. The last thing anybody wants to learn is that their personal information has been leaked or stolen. In your cloud security career, you or your team will be responsible for keeping sensitive personal information away from attackers. In this video, you'll learn about data classification, tags, and how categorizing data helps keep assets secure. Data classification is the process of analyzing data to determine its sensitivity and value. Data classification enables organizations to categorize their data, which helps security analysts efficiently find and secure assets. Organizations use sensitivity levels, data type, and value as metrics to organize the data. Let's explore the different sensitivity levels of data: low, medium, and high. Lower sensitivity levels represents less of a risk for organizations. This makes low sensitivity data less valuable. For example, imagine you create an open access public blog that has lots of readers. Publishing a blog for the public to read is an example of sharing public information, and public information is the least sensitive type of data you can have. Medium sensitivity level data is more sensitive and should be inaccessible to the public. Here's an example. At a marketing company, an associate sends an internal memo with little information about the company, along with meeting notes on an advertising plan outline. There's no personal information, like social security numbers or medical documentation, and there are no company secrets. But the information is still sensitive and should not be shared with the public. High sensitivity data includes information like personal financial data, legal documentation, and company secrets. High sensitivity data is very valuable to organizations. For example, a database with all employees' personal and employment data is highly sensitive. If an attacker gets that information, the employees' identities will be in danger. Stolen or leaked sensitive data can lead to major consequences, like fines for violating privacy laws, or damage to the organization's reputation. Cloud security professionals use tags as a consistent way to document and classify data. Tags are custom metadata fields you can attach to a data entry to provide context to people authorized to access the data. Metadata can include information like who's responsible for the data entry and whether it contains highly sensitive data, like personally identifiable information or PII. Keep in mind, tags or labels are essential for data protection. They help your security controls find the data that needs to be protected. So, to protect your data, you need both the tags and the security controls. Let's review an example of a customized PII tag. The information in this tag is presented as a label, followed by two metadata pairs. The first line of code is the next label for the tag, and it has the letters PII. The next line of code is the first metadata pair. It verifies that the value is true. This means there is personally identifiable information in this asset. The last line of code has a second metadata pair, and it identifies the type of PII as a social security number, or SSN. Both of these pairs together create a field in the tag. This PII tag example has a Boolean field, abbreviated bool. That means there can only be two possible results. In this case, true or false. The asset with this tag has highly sensitive information, and the tag indicates what type of data it is. The tag classifies this information as high sensitivity, making it easier for security controls to locate. When you make your tags, you can use tag templates or reusable structures to rapidly create new tags. You can make a template by putting together metadata values in fields. You can then grant or deny access to a template with Identity Access Management roles, or IAM roles. Now that you know about data classification and tagging assets to classify and protect them, you can use them to protect data so you can keep the data from being leaked or stolen. Data governance enables cloud security teams to ensure data is private, accurate, secure, available, and usable. In this video, we'll explore how you can use data governance to maintain data quality and keep data secure. Data governance is a set of processes that ensures that data assets are managed throughout an organization. These processes are everything an organization does to ensure data is private, accurate, secure, available, and usable. The processes people follow, the actions they must take, and the technology supporting them throughout the data lifecycle are all included in data governance. Data stewards are an important part of data governance. Data stewards are subject matter experts who are responsible for collecting and managing data and preserving the quality of the data. Data governance can be used to help maintain data quality. Usually, data quality is judged on 6 dimensions: accuracy, completeness, consistency, timeliness, validity, and uniqueness. Let's examine each of these dimensions. Data is accurate when it can be confirmed with a verifiable source. For example, an accurate email address for a team member ensures they can be reached. Data is complete when there is enough data to deliver meaningful decisions and inferences. For instance, when completing an online form, some fields may be required while others are not. The data is complete when all the required fields have information. Data is consistent when data stored and used at multiple instances match the values across various records. Suppose a business has more than one customer database. If a specific customer's name is spelled differently in each database, the data is not consistent. If the same name is spelled the same way in each database, the data is consistent. Data timeliness means that the data is available when the user needs it. For example, if an auditor is conducting a review, the audit report data must be ready when the auditor needs to access it. Data is valid when value attributes are aligned with specific requirements. For instance, if a person is purchasing a product online, they need to input their credit card number. The number is valid if the correct number of characters of a verified credit card number are in the credit card number field in the payment form. And data is unique when there are minimal overlaps or duplicates. Consider a salon customer who uses an online form to make 2 appointments for the same service at the same time on the same day. If that customer record is duplicated in the system, then the record is not unique. Data quality means your data is complete, accurate, available when you need it, and fits with the organization's requirements. Having formal governance processes in place to maintain the quality of data will help to ensure that your organization's data maintains a high quality. For example, say you're working on a data governance framework. You'll want to make sure to create processes that address the accuracy of data and ensure that your data is available when you need it. Establishing clear policies and procedures for data governance helps to protect and secure data. The policies and procedures in your governance plan or framework should cover data access, use, storage, and disposal, and should align with industry standards and regulatory requirements. For example, policies and procedures should prevent threat actors and other unauthorized users from accessing certain confidential data. There must also be policies and procedures in place so that authorized users are able to gain access to the data. When you collect, keep, and use data in secure and effective ways, you're practicing data governance. Data governance can help you and your organization maintain high-quality, secure data that meets regulatory and policy requirements. Now that you know more about how you can use data governance, you can apply those skills to maintain high-quality standards and keep your data secure. Cloud data can be stored in different physical locations around the world. As a cloud security professional, you'll need to know where the data is stored to ensure that it complies with required regulations and policies. In this video, you'll learn about data sovereignty, data residency, and data localization. You'll also explore some ways that data governance can help to ensure data sovereignty. Physical servers that store cloud data are kept in buildings called data centers. Data centers are located in many different countries. These countries have their own laws and regulations for data storage. This is where data sovereignty applies. Data sovereignty means data stored in a physical location has to follow the regulations of that geographic location. A country enforces its laws on the data systems, controllers, and processors by exercising data sovereignty. Data sovereignty also extends across borders and even has international implications. A country may refuse another country to exert control over its sovereign data. To comply with data sovereignty, data professionals need to know what data they have and where their data resides. Data residency refers to the physical or geographic location of an organization's data or information. Once data is moved, stored, or processed within a particular geographic location, it is subject to laws, customs, and expectations of that specific location. Sometimes there's a need to keep sensitive data within the borders of a particular country to enhance data security. This is called data localization. Data localization is a requirement that all data generated within a country's border remains within those borders. Consider how this impacts the way an organization conducts business. An organization must research and comply with the data sovereignty laws of all geographic locations where they intend to operate. This ensures that the organization is in compliance. This is so important because data localization helps countries safeguard the data of their citizens and organizations in their territory. Data governance helps organizations comply with and reinforces data sovereignty. These work in tandem. Remember, data governance is a set of processes that ensures that data assets are managed throughout an organization. Having data governance processes and procedures that address sovereignty risk, such as data that's subject to the regulations of multiple governments, will help organizations remain compliant with relevant laws and regulations. An organization can take several actions to facilitate data governance. For example, an organization might conduct a data audit as part of their data governance. In the audit, they can identify where the data is stored, processed, and transmitted, and also the relevant data protection laws and regulations for those locations. This will help identify any potential data sovereignty risk and ensure that the organization is in compliance. The organization could also research and select cloud providers with data residency options that align with the organization's data sovereignty requirements. They might also map out the regulations from each country that stores or might store data to find similarities and differences between the sovereignty requirements for each country. The organization could even create an organizational policy to use as a preventative guardrail. As a reminder, guardrails are the policies, procedures, and processes to manage and monitor an organization's regulatory, legal, risk, environmental, and operational requirements. It's often helpful for organizations to check with their cloud provider to figure out if there's a policy the organization can use. For example, the cloud service can help the organization identify a resource's location property and also where it's maintained and deployed. When an organization uses location constraints in their policy, they can limit where the resources are deployed and maintained to make sure that they meet sovereignty requirements. As a cloud security professional, you'll need to work with data sovereignty, data localization, and data residency to keep your organization compliant with data regulations. Having strong data governance will help you to meet your sovereignty requirements. In this video, we'll explore data discovery. We'll consider how data discovery relates to data governance and data sovereignty, and how data discovery works to keep sensitive data from being moved out of protected spaces. Let's get started. Data discovery is the process of searching, identifying, and analyzing large amounts of data within an organization to uncover hidden patterns, relationships, and insights. Data discovery can identify risk and inform better decision-making. For organizations, data discovery supports both data governance and data sovereignty. During data discovery, organizations can flag data that is subject to governmental sovereignty laws and regulations. Then, they can use data governance to ensure they're in compliance with those regulations. Data transparency enables organizations to remain in compliance with data sovereignty laws and regulations. Organizations use data discovery to check for the dimensions of data quality, including the accuracy, completeness, consistency, timeliness, validity, and uniqueness of data. Each of these dimensions factor into how organizations use data for different purposes. But completeness, timeliness, and accuracy especially affect the ways organizations ensure transparency. Transparency is one benefit of data discovery. In data discovery, an organization's data may come from many different data sources and be stored by cloud service providers. The organization needs to keep track of this data and know how the data is collected, where it is collected from, and where it's stored. Data transparency ensures that data is available and searchable. For security, discovery of sensitive data is particularly important. Sensitive data discovery is finding and identifying all confidential and regulated information kept by an organization. This includes any data that's regulated by law, like confidential payment data and PHI. It also includes finding data related to intellectual property. For sensitive data, it's important to know what kind of data it is and where it's located to ensure that it's properly protected. As a cloud security professional, there are tools that you can use to find and protect sensitive data. One tool that we'll explore is a data loss prevention engine. At various stages of the data lifecycle, you can use a data loss prevention engine, also known as a DLP engine, to filter and search for sensitive data. You can use DLP to inspect, mask, or remove sensitive data once it's discovered. Doing so may lower the risk inherent to certain data types. The DLP can also be utilized to complement encryption for data at rest, manage access controls, and other security measures. You can also examine data closely with DLP. After, you might decide to apply security controls based on the data sensitivity or move the data to a less restricted area. If you move data during a cloud migration, for example, you can use data discovery to validate whether the data is being moved into places that are properly secured. Data discovery also checks to make sure that there are no mistakes in data classification and placement. This prevents regulated data from being moved into an environment without proper controls in place. Now that you know about data discovery and how data discovery supports data governance and data sovereignty, you have the info you need to identify and protect sensitive data wherever it is. Everything needs somewhere to go, whether it's forks and spoons in a kitchen drawer or data in the cloud. And to find a spoon, you know which drawer it's stored in. Similarly, security professionals need access to well-organized data, and they need to know where to find it. That's where storage becomes useful. In this video, you'll learn how data is stored and how a data retention policy can help you manage your data and follow regulations. Let's get started. Data retention is the process of storing data, including how long it needs to be stored. In cloud storage, the length of time that data is stored is determined by an organization's needs. The time period for stored data is called a retention period. A data retention period is the length of time an organization keeps information. It's also a key element of an organization's data retention policy. A data retention policy helps determine what data needs to be stored and where the data should be stored. Because it includes an expiration period, a retention policy can also help decide how long the data can be stored. These considerations need to follow compliance regulations, which are often outlined in an organization's compliance policy. And having a data retention policy will help ensure that data is compliant and safe. As a security professional, you may be responsible for working on data retention policies. As part of this process, you'll need to conduct research before you start creating the policy. While conducting research, you'll need to make compliance considerations like industry or regional compliance standards for data and regulations for the location of the data. Take notes while you research. Then, consult the legal staff members on your team for insights on your research findings. While you're preparing for building your data retention policy, consider the following questions. What are your organization's needs for specific data? What are your organization's policies for data retention periods? Do organizational needs change over time? Do different data types need different policies? A data retention policy should be flexible and be based on an organization's needs. Keep your organization's compliance policy in mind as you build your data retention policy. Try to ensure that both policies work together, that they're not contradictory, and that they're clear to members of the organization. For example, if your organization has a compliance policy that states user data is only retained for a short time, make sure your retention policy reflects that. As you create policy, here's a pro tip. Policy creation is also affected by what type of resources you use to store data and the applications you allow to access that data. You're responsible for keeping your applications and hardware secure. Vendors may not provide regular security updates, so it's important to understand the limitations and capabilities of applications and hardware when creating your policies. Organizations also need to consider risk when creating data retention policies. When data is available, there's a potential risk for a data breach. This means attackers can steal your data while it's available, including sensitive data. To defend against this risk, it's useful to delete or replace data over time. Let's review how risk consideration works. Retention policy is defined by time. First, you add a retention policy to a bucket. In cloud storage, a bucket is a virtual container that holds objects. Then, you can define the age of the objects that can be deleted or replaced by specifying the retention period. It's important to know that you can only delete or replace those objects once they reach the age you define. If you try to delete the objects before that time, you'll get an error. You can set your retention policy in units of days. You can also permanently set a retention policy by locking it. This means that the policy is locked in and stays for the life of the bucket. To delete the bucket, You'll need to wait until every object has completed its retention period, since the object's age must be greater than the retention period duration. Understanding how a data retention policy keeps data compliant and safe allows you to create and implement a plan for your organization. Imagine a software company is using cloud resources to host their applications when a large storm strikes a data center, taking the company's resources offline. It's important for the business and its customers to get the cloud environment back up and running quickly. That's where a business continuity plan comes in. A business continuity plan, also called a BCP, is a document that outlines the procedures to sustain business operations during and after a significant disruption. BCPs can minimize damage from disruptions like natural disasters or cyber attacks. A disaster recovery plan, or DRP, is an important part of each business's continuity plan. A DRP is a plan that allows an organization's security team to outline the steps needed to minimize the impact of a security incident. While BCPs focus on keeping a business going during a disruption, DRPs focus on recovering assets and data after the disruption. Let's explore some impacts that business continuity planning can help prevent or mitigate. Business continuity planning can decrease the financial impact of a disruption since it helps an organization get back to normal quickly. It can also mitigate brand impact and reputation loss. The sooner an organization recovers from a disruption, the less it affects their customers. And that keeps customers happy with the organization and likely to keep using its services. Let's explore the steps to develop a business continuity plan. Departments throughout an organization usually collaborate to create a BCP, with each department planning for their own operations. Leadership helps to keep the plan in line with the company's goals. The first step in building a business continuity plan is to determine the most critical apps and data for business function. You can organize these resources into tiers based on importance. For example, let's say you're helping create the BCP for your employer, a financial institution. If your online banking app goes down, your customers won't be able to access their accounts from their phones. This means the banking app is a high priority. By contrast, let's say the financial institution stores archived employee newsletters in a cloud storage bucket. If the storage bucket goes offline, your company can still continue its operations and your customers won't be affected. It's a lower priority. After ranking the most important apps and data, the second step is to identify acceptable amounts of downtime for each one. You can do this by assigning recovery time objectives. A recovery time objective, or RTO, is the target time allowed for the recovery of a service in the event of a disaster. The services most critical to your organization's operations should have the shortest RTOs. You should also assign recovery point objectives to your applications. A recovery point objective, or RPO, is the maximum acceptable length of time during which data might be lost from an application due to a major incident. The longer an application is offline, the more data will be lost, so you should assign the shortest RPOs to the most critical data. The third step in developing a business continuity plan is to conduct a risk assessment to identify what risk could affect your resources. Next up, the fourth step is to document your disaster recovery plan. This plan should include solutions to recover your operations as soon as possible, including steps to restore backup data. It should clearly define each team member's roles in the event of a disruption. You should include contact information for your cloud service provider, backup providers, and key personnel who will be involved in restoring operations. After developing a BCP, the fifth step is to communicate the plan with others on the security team and throughout the organization, so everyone is familiar with how their role fits within the overall strategy. Finally, the sixth step is to regularly test and update both your BCP and your DRP. Testing should include simulation drills of different scenarios with the security team and throughout the organization. You'll want your plan to cover any type of event, from small malfunctions to complete shutdowns. Business continuity planning is an ongoing job. It's important to update business continuity plans regularly to make sure that they keep up with any changes to the business or its IT infrastructure. I hope you had fun learning to create an effective business continuity plan. You're ready to help your organization keep operations going no matter what. Imagine you're attempting to access your organization's cloud data storage. Suddenly, a message appears telling you that sensitive customer data has been encrypted and you need to pay a large sum of money to unlock it. You realize the data storage has been infected with ransomware. This ransomware attack could cause a major disruption for your organization if you don't handle it properly. Fortunately, you have a business continuity plan. Let's explore how business continuity planning can help the company solve this problem. After you alert colleagues to the ransomware attack, your team can begin carrying out the business continuity plan. Your plan identifies the most important data and services to your organization's operations. Your business plan also lists acceptable amounts of downtime for each of those resources. Because the ransomware attack affected sensitive customer data, your plan only allows for 1 hour of downtime. Your risk assessment identified that a ransomware attack could affect your data storage, so you have a disaster recovery plan in place. The disaster recovery plan portion of your BCP contains information about each team member's role. According to your plan, your colleague is responsible for communicating with other departments to make sure everyone knows what's going on. Another colleague is responsible for shutting down cloud resources affected by the ransomware. Meanwhile, you're responsible for getting the data back online. Your disaster recovery plan also includes recovery solutions for restoring apps and data. Because the data affected by the ransomware has a short acceptable downtime, your team has worked with your cloud service provider to back it up to another site. Your plan contains cloud service provider contact information, or CSP contact information. You're able to reach out to your CSP and access the backed up data which hasn't been affected by the ransomware. Since your team has been regularly updating your BCP and training for all types of disruptions, including a ransomware attack, everything goes smoothly and the data is only unavailable for a few minutes. Disruptions happen, and they can require significant effort from you and your team. But with a proper business continuity plan in place, you and your team can minimize disruptions efficiently, effectively, and with confidence. Congratulations! You've completed your journey through data protection and privacy. Well done. You learned about encryption, data classification, and data governance. And you explored the steps to building a business continuity plan. You started with the basics of data protection and privacy. Then, you learned about data encryption at rest, in transit, and in use. Next, you learned the importance of data classification and tagging to data security. You also explored data discovery and how it supports both data governance and data sovereignty. You learned how to keep data storage compliant and secure by creating a retention policy. Then, you learned about business continuity planning, including disaster recovery planning. And finally, you explored how using a business continuity plan can help your organization deal with an emergency. Congratulations on getting here. You're doing a phenomenal job. Keep going. You got this.
Confidence is very important, and something that one of my first managers ever told me is it's not what you know, it's how you say it, and it's something that I continue to tell myself day after day. My name is Lauren, and I'm a cloud sourcing lead. What that means is my team is responsible for reaching out to candidates for our open roles within the cloud organization. The 3 top things that a candidate should do when updating or creating their resume is first, tailor your resume to the job description. You want to make sure you're pulling out keywords and key indicators that match your experience to ensure that the recruiters can see pretty quickly the experience that you have that's relevant to the job description. Secondly, do not exaggerate or do not lie on your resume. That probably goes without saying, but anything on your resume is technically fair game. It can be asked in an interview, so you want to make sure that you're being as accurate as possible. My third tip would be keep it concise, keep it short. We definitely want to make sure that we can get all of your experience, but you can cut things out. That's okay too if it's not relevant to the job. What makes a resume stand out for a recruiter or a hiring manager is an organized resume. You want to make sure you have clear headers, it's in chronological order, and you have short and concise bullet points. Some ways that candidates can demonstrate their technical skills in interviews is to talk out their thought process and the answer to the questions they are asked. The process of how you get there is just as important as getting to the correct answer. Some common interview question types are problem-solving based questions, experience-based questions, and also leadership-based questions.
The best way to answer a hypothetical question is really just talking through your thought process. You're going to get a scenario, something that you may or may not have experienced before, and your interviewer just wants to see your thought process, how you're connecting the dots as you're talking through your answer. The best way to answer a behavioral-based interview question is really leaning on your own personal experience. This could be a personal experience from a previous job, from school, from a class, and talking through that experience and that thought process. It's very important to ask follow-up questions throughout the interview. First and foremost, you want to make sure you're understanding the question that's being asked. You have a very limited amount of time with your interviewer, and you want to make sure that you're spending it as productively as possible. I think some candidates worry that it's bad to ask questions. I love when candidates ask me questions. I want to make sure that my candidate knows what I'm asking so we can get to the best solution. Workplace skills are absolutely important during the interview process. These are skills that can't be taught. Are you kind? Are you empathetic? How are you showing up? Do you have that eagerness to learn or to thrive in ambiguity? We really want to see candidates that have that self-drive and that self-determination. A candidate can best position those workplace skills just on how they're simply answering their questions, especially in those behavioral questions. Like, lean on those examples that show your grit, that show maybe a struggle that you had and how you overcame it. I'm not looking specifically for something that happened perfectly the right way. I'm looking for someone that maybe had to overcome some obstacles to get to the right solution. Candidates hold a lot of power in the interview process. We want you to be successful. We want reasons to say yes. So please show up, be your authentic self, be confident, and show us all the amazing skills that you could bring to the company.
Hi, I'm Patrick.
Hi, I'm Brenda.
Let's step into an interview in progress. In this interview, questions will focus on cloud cybersecurity topics relating to identifying and detecting threats.
We hope this will give you some tips for your next interview.
Hi, Brenda. What interests you about roles in cloud cybersecurity?
I would say what interests me the most about jobs in cloud cybersecurity is the fact that you're continuously learning. As a whole, with security and with cloud specifically, there's always new features, new services that you have to learn. And as security practitioners, you always want to essentially learn and know how to protect them. And so as a whole, I'm attracted to the fact that you're continuously learning.
Let's say you're working on a project to help a new company implement access control processes. What are some cloud access control processes you might recommend?
So some of the cloud access processes that I would recommend in this instance are, for example, perimeter protection and also trust boundaries. And so with perimeter protection, this is essentially your security measures that you want to take into place, or you want to put in place to essentially prevent unauthorized access. And so some of these might be like firewalls, virtual private network, intrusion detection systems, or intrusion prevention systems. With trust boundaries, that's essentially trying to separate your trusted and untrusted environments. And so this can be done with something like firewalls or routers to essentially set that logical and also physical separation.
What are some examples of trust boundaries that you could delineate and kind of isolate based on?
So essentially, a very simple example would be trying to separate the public internet from your corporate intranet. And that can be one instance where, again, you would have more of a physical and also logical separation.
What impact did you have on the project, and what impact did that project have on the company?
The impact that I had on the project was essentially to act as one of the security gates to make sure that there were proper security requirements put in place and practices before we actually went through with full migration. As far as impact for the overall organization and company, this was a big move for us, and the fact that we had to have so many teams coordinate together was essentially all for the goal of getting to a more modern kind of cloud architecture.
Imagine you're asked to explain the key components of a threat and vulnerability management strategy to a business leader with not a lot of technical experience. What components would you choose, and what would you say about each one?
So there are 4 components that I would highlight to explain a effective threat vulnerability management strategy. The first being prevention, the second being detection, the third being response, and the fourth being recovery. So with the first component, this is the part where you essentially want to prevent any kind of unauthorized access to begin with. You want to prevent that cyber attack. And so here you want to make use of endpoint protection, software, virtual private networks, etc. Then we move on to the second component, where this is all about detection. And this is going to be monitoring efforts, where you essentially want to set up things like event management systems, and you want to make sure you have proper log analysis. And so here is where we want to detect the malicious activity and also alert on it. Once we alert on that, then we move on to the third component, which is going to be response. And so with response, this is where we want to not only identify the threat, but also contain it. And so we'll make use of incident response teams and plans, as well as other emergency response teams. Moving on to the fourth and final component, this is going to be recovery. And so here we'll want to make use of any kind of disaster recovery plans or teams and get back to a state before the attack. And that will be not only for your systems, but also potentially for data.
Could you give me an example of the impact that each of those components has?
With the first one, where we essentially want to prevent, the impact as a whole here is to reduce your attack surface. And so as a whole, you want to have security measures so that attackers just have less avenues to actually get into your environments. For the second component, for the overall detection, again, here the goal is to monitor. And so the benefit and the overall impact is that you actually have the proper logging to actually detect whatever malicious activity comes your way to your environment. For the third component, that's going to be, again, the response part. And so you want to make sure you have the proper teams and plans set in place so that the overall company will benefit by having actions readily available. For the fourth and final component of recovery, again, this goes back to what plans do you have already in place, because a company can't really have too much downtime. You need to make sure you have essentially steps in order to get back to the pre-attack state. And again, get your shop up and running.
Thanks, Brenda. Do you have any questions for me?
Yes, I do. So what would you say are some of the toughest challenges that you see in environments relating to access control?
When we think about access control, there's a really big difference between what is mandatory and what is discretionary. And so being able to assert that a control is actually mandatory and that there aren't ways to bypass it or backdoors or ways that, teams, customers, or malicious actors can route around those controls is probably the biggest challenge at scale.
That makes sense. I can see how something like Terraform would help enforce this. Thank you so much.
Thanks for watching. In this scenario, Brenda demonstrated how to explain impact when answering questions. In interviews, be sure to share the beneficial effects of any process, concept, or tool that you discuss. Whether it's deploying a concept to identify a particular threat or deploying a tool to protect against a particular threat. Explaining the potential impact will help you stand out to an interviewer. Keep watching for more interview tips.
Great work on finishing this course. I love being in a field where I can use my skills to protect users, data, and systems daily. I work behind the scenes to identify and mitigate threats, and I'm always learning about the new and novel tools and techniques that attackers use to gain access to information. If you're interested in a career in cybersecurity, I encourage you to pursue it. It's a challenging and rewarding field, and we need more talented people like you to help make the world a safer place. Together, we can make a difference. Let's go through all the things you learned in this course. You started by learning about identity management principles and the implementation of effective access controls in cloud environments. You also examined the concept of trust boundaries in cloud security. Then, you compared two widely used security models, traditional perimeter security and zero trust. Next, you explored best practices for managing threats and vulnerabilities in the cloud, including asset management, vulnerability remediation, and posture management. And you learned about the cloud-native concepts of rehydration and reinstantiation. You also explored the key cloud concepts of ephemerality and immutability. You learned how infrastructure as code, IAC, and policy as code, PAC, let you build security into your cloud environment. You learned all about containers, including container orchestration and security. Then, you learned about data protection and privacy, including data sovereignty and data governance. Finally, you learned how business continuity planning can prepare you to deal with disruptions to your organization's cloud resources. You now know all about the essential aspects of securing digital assets in the cloud. And you have a well-rounded understanding of the tools and techniques needed to protect your organization's data and infrastructure. Great work throughout this course. Congratulations on the milestone.
Hey there! You're well on your way to becoming a cloud security wizard. Ready to explore the magic of cloud security? Me too. First, let me tell you a little bit about myself and how I stumbled into the captivating field of cloud security. I'm Celine, and I'm a security engineer. Just like many of you, I didn't start my career in cloud security. In college, I studied computer science, where I focused on becoming a software engineer. It wasn't until I completed an internship doing penetration testing that my plans changed. I discovered that cybersecurity was the career path I wanted to follow. I continued to grow my skill set by learning on my own, doing trainings and getting certifications, just like you're doing now. Moving forward, after different experiences and learnings, today I proudly wear the hat of a security engineer on Google's Red Team, where our main role is to make hacking Google harder by hacking Google. Through simulating adversaries, we can identify and help fix security issues that attackers could exploit to achieve their goals. These exercises help test Google's detection and response capabilities, improving our resilience against real-world attacks. Cloud cybersecurity is like solving exciting puzzles, but with real-world impact. It's a field where you can truly make a difference. Stick with me, and together we'll explore the fascinating world of cloud cybersecurity. To help prepare you for a role as a cloud security professional, you'll start with discussing the foundations of incident detection. Here, you'll learn about security operations teams and how they use logging, monitoring, and detection tools to manage security incidents and secure cloud environments. Next, you'll explore applied detection, where you'll go in depth about how security teams use detection tools and techniques to promptly detect security attacks in the cloud. Here, you'll explore Lockheed Martin's cyber kill chain monitoring tools, indicators of compromise, and threat hunting. Then, you'll explore incident response, where you'll learn about the various processes and security tools involved in incident response. This includes how to preserve and document evidence, analyze alerts, and utilize automation. Finally, you'll end off by discussing incident recovery, where you'll learn about how security teams recover after a security incident. Here, you'll focus on how organizations create business continuity and disaster recovery plans using considerations like recovery metrics. You'll also learn about the role of stakeholders in disaster recovery. When you're ready to get started, join me in the next video. Hi, I'm Celine. I'm a security engineer on Google's Red Team. My team simulates real-world attacks on Alphabet, Google's parent company, to make the company and its users safe. After earning a bachelor's degree in computer science, I completed multiple cybersecurity-focused internships. I didn't stop learning there. Over time, I sought certifications and took online security courses to continue my educational journey. My first job was as an entry-level security consultant. I was exposed to customers in many different industries, operating in varying system environments. After gaining several years of experience learning both on and off the job, I joined Google's vendor security team. I then transferred to my current role on the Red Team, where I perform threat simulations to help make Alphabet and its users safe. When not at work, I also like to apply my cloud security skills outside of my day-to-day responsibilities. I really enjoy mentoring, tutoring, and volunteering my technical skills through nonprofit organizations. There are so many opportunities to make an impact in the cloud security space, and we need people like you to help make a difference. Are you ready to learn about detection, response, and recovery from cyber attacks? You'll start by discussing logging, then explore detection, response, and monitoring. Next, you'll learn about incident management and how to handle an incident if it happens. Let's review what we'll cover in more detail. First, you'll be introduced to logging fundamentals. Then, you'll discuss the role of logs in maintaining a secure environment. You'll also learn how log retention policies can help you detect and remediate potential cyber breaches. Next, you'll discuss different types of intrusion detection and response, and how they can be used to safeguard your cloud resources. You'll also learn about different monitoring methods and how to set up alerts to help you identify and handle potential security threats. Finally, you'll discuss how to handle security incidents and examine the incident management process. You'll also learn how to report, investigate, and resolve security breaches. That way, you'll be able to act quickly and efficiently to minimize damage if an incident happens and prevent similar breaches in the future. As soon as you're ready, let's meet in the next video. Operations make up the core structure of many different businesses and industries. For example, making sure a zoo runs smoothly requires an effective operations infrastructure. This includes everything from well-trained employees to fences, paths, and restrooms. All of this ensures that visitors have a positive experience. Similarly, cloud security often uses operations to make sure assets are protected. In this video, you'll explore security operations and discuss how professionals leverage different tools to enhance their security operations. Security operations, or SecOps, is the practice of combining people, processes, and technology to effectively protect an organization's data and infrastructure. High-level goals of SecOps includes detecting, preventing, and mitigating threats in real time. In cloud security, SecOps consists of several key components, including logging and monitoring, incident detection, incident response, and incident recovery. Let's review each of these components. Logging and monitoring are essential for maintaining visibility in your cloud environment. A log is a record of events that occur within an organization's systems. By collecting, analyzing, and storing logs, security professionals can identify potential security threats, track changes, and monitor user activities. This information will enable you to detect anomalies and take appropriate action to prevent security breaches. Incident detection is the process of identifying and addressing security threats in the cloud environment. This process includes analyzing log data, correlating events, and prioritizing incidents based on severity and potential impact. By detecting incidents promptly, security professionals can minimize the damage and prevent further escalation. Incident response is the process of identifying, investigating, and mitigating security incidents promptly and effectively. This includes assembling a response team, containing the threat, investigating the root cause, and communicating with stakeholders. A well-executed incident response plan can help mitigate the impact of a security breach and prevent future occurrences. Incident recovery is the process of restoring affected systems and data to their normal state. This is the final component of the SecOps process and may involve patching vulnerabilities, repairing damage, and implementing new security measures to prevent future incidents. Google Cloud offers a range of tools and services that can enhance your SecOps capabilities. Some of these tools include Google Cloud Security Command Center, or SCC, Chronicle SIM, Chronicle SOAR, VirusTotal, and Mandiant Threat Intelligence. Let's first discuss Google Cloud Security Command Center, or SCC. This tool is an on-guard security specialist for all things Google Cloud. It monitors data security risks and potential threats using its dashboard and data analytics. SCC also identifies security findings, keeps an inventory of cloud assets, and even scans web applications for security threats. Next is Chronicle Security Information and Event Management, or SIM. This tool provides actionable security insights in real time. Chronicle's SIM tool takes massive amounts of machine data and translates it into helpful security information. Chronicle also offers security orchestration, automation, and response solution, or SOAR. This tool gives teams the power to fight common threats by using automated response workflows. From managing alerts and cases to deploying incident response playbooks, SOAR ensures security teams are able to shift from detection to response quickly. Now, let's discuss VirusTotal. This service is an online detector used to identify malicious content. Just submit files or URLs to VirusTotal, and it will analyze them using various tools like antivirus engines and website scanners. VirusTotal also uses analysis tools to detect viruses, worms, or Trojans. Last is Mandiant's Threat Intelligence. This service offers more than just security updates. Mandiant's Threat Intelligence helps security professionals understand the tactics, techniques, and procedures used by global threats before they happen. Actively applying this knowledge is beneficial to establishing defensive strategies and maintaining strong SecOps. In this video, we explored the world of SecOps, its key components, and how teams leverage Google Cloud tools to enhance their security operations. By understanding and implementing these concepts, security professionals are on their way to strengthening an organization's cloud infrastructure. Good management is the key to successful operations. In this video, you'll explore security operations management. You'll also learn key concepts like vulnerability management, red team, blue team, penetration testing, and tabletop exercises. Vulnerability management is the process of finding and patching vulnerabilities. Monitoring and managing vulnerabilities can minimize the risk of cyber attacks and protect valuable assets. Here's an example. A software company ensures the security of its cloud infrastructure by using advanced automated tools to regularly scan for vulnerabilities. When discovering high-risk vulnerabilities, the company prioritizes patching to prevent potential attacks, demonstrating its commitment to safeguarding its infrastructure and protecting users' data. In vulnerability management, the red team and blue team play crucial roles. A red team is a group of ethical hackers who mimic potential adversaries in order to examine the security defenses of an organization. As a cloud security professional, the red team can be part of your organization, or they can be part of an outside group hired to test your security. By simulating real-world cyber attacks, the red team helps your organization understand its weaknesses and improve its security posture. The blue team is a group responsible for defending the organization's systems and networks from simulated attacks. They work closely with the red team to identify vulnerabilities and implement security measures to protect your systems. The blue team focuses on monitoring, detection, incident response, and recovery to ensure your organization's security remains robust. Here's an example. A financial institution hires a red team to simulate a cyber attack on their online banking platform. The red team identifies a vulnerability that allows them to access sensitive user data, highlighting the need for improved security measures. In response to the red team's findings, the financial institution's blue team implements additional security controls like multi-factor authentication and encryption to protect user data from potential attacks. Organizations can also use penetration testing to manage vulnerabilities. Penetration testing, or pen testing, is a simulated attack that helps identify vulnerabilities in systems, networks, websites, applications, and processes. Penetration tests can include exploiting weaknesses in various parts of an organization's security, like networks, applications, and even physical security measures. By conducting pen testing, organizations can better understand their risk level and prioritize remediation efforts to strengthen their overall security posture. Imagine this scenario. A healthcare organization initiates a penetration test on their patient portal. The objective is to assess the security of patient data. The penetration test found a vulnerability that allowed unauthorized access to an insecure application programming interface, or API, linked to the patient portal. Despite the organization having detection protocols in place, the unauthorized access to the API went undetected. The organization realizes they've missed an opportunity to identify a security incident. As a result, the organization adds additional security measures, including encryption, adjusted access controls, and more robust authentication. They also initiate a reassessment of their security event log coverage, monitoring for better incident detection and response. Finally, the organization commits to conducting frequent security audits for real-time evaluations. This case highlights the need for a robust SecOps approach to minimize potential vulnerabilities, retain data security, and repair technical loopholes. Finally, let's discuss tabletop exercises. Tabletop exercises are scenario-based exercises that involve an organization's security team and other stakeholders. During tabletop exercises, participants take part in a guided conversation centered around a scenario in a relaxed and informal setting. These exercises aim to replicate emergency security situations and are grounded in the organization's current policies, plans, and procedures. As the exercise unfolds, team members examine their roles and responses to the simulated crisis. They put their incident response plan to the test, assessing the organization's readiness. The main objectives of tabletop exercises include fostering a deeper understanding of concepts, pinpointing strengths and weaknesses, and driving changes in policies and procedures. For example, imagine a retail company conducts a tabletop exercise simulating a ransomware attack on their point of sale, or POS systems. This exercise includes participants from various departments like security, store management, and IT support. The exercise uncovers gaps in the company's incident response plan, including insufficient data backup procedures, unclear roles and responsibilities, and inadequate employee training. It also highlights the need for improved communication between security teams and store management. Based on these insights, the company can proactively address these gaps by updating their incident response plan, conducting regular employee training sessions, and implementing robust data backup solutions. These changes enhance the company's overall security posture. Security operations management is an essential part of maintaining a strong cloud security posture. By understanding the roles of the red and blue teams, conducting penetration testing, and participating in tabletop exercises, organizations can effectively manage vulnerabilities and protect their assets in the cloud. As a cloud security analyst, you're the first line of defense when a system has been compromised. That's a very important role. In this video, we'll explore the significance of incident detection in maintaining a secure cloud environment. Incident detection is the process of identifying and addressing security threats in the cloud environment. By detecting these threats early on, you can take quick action to minimize risks and protect valuable digital assets. Within the Google Cloud ecosystem, there are powerful threat detection tools specifically designed to assist with incident detection. One of these tools is the Google Cloud Security Command Center, or SCC. SCC, which can help you gain visibility into your cloud resources and detect potential security threats. It provides insights, alerts, and recommendations to enhance incident detection and response. Another tool is Google Cloud Logging and Monitoring. This tool enables you to collect, analyze, and visualize logs and metrics from your cloud infrastructure, allowing you to identify suspicious activities and potential security incidents. Last are the tools included in the Google Chronicle Security Operations Suite. Chronicle SIEM, SOAR, and Threat Intelligence provide security professionals with the ability to detect, respond, and analyze incidents from several different sources. Now that we've discussed threat detection tools, let's explore incident detection. The focus of incident detection is to spot anything out of the ordinary, like strange patterns or abnormal events. For example, this could include a user login from a new physical location. The faster you can detect these types of occurrences, the more effectively you can respond to any issues and keep your cloud systems secure. To be successful in incident detection, cloud security professionals should consider the following common questions. What are the indicators of compromise associated with this incident? What is the potential impact? What critical systems or resources are affected? Has the incident spread to other systems? Are there any indicators that an attack is still in progress? And what evidence should be collected to help my team? By asking these questions, you'll be able to quickly assess and triage a security incident. And your answers to these questions can strengthen your team's ability to respond effectively to these types of incidents. So whether you're starting your career in security operations or looking to specialize, mastering incident detection will improve your ability to identify, evaluate, and respond to unforeseen security events. In cloud security operations, incident management plays an important role in ensuring swift response to potential threats. How can you, as a cloud security professional, handle these incidents when they arise? Well, with a plan. In this video, you'll learn about the phases of the NIST incident response lifecycle, which provide a structured approach to managing security incidents in a cloud environment. The manner in which cloud security professionals manage incidents is an important part of cloud security operations. Effective incident management helps minimize the impact of security incidents, enables you to quickly identify and repair vulnerabilities, and also ensures that your organization remains compliant with regulations and industry standards. Now let's discuss the NIST Incident Response Lifecycle. This framework was developed by the National Institute of Standards and Technology. It provides guidelines and best practices for a structured approach to handling security incidents. You can use this framework to guide your response to security incidents. It consists of 4 phases: preparation, detection and analysis, containment, eradication and recovery, and finally, post-incident activity. Now, you'll learn about how to apply the NIST Incident Response Lifecycle to incident management. You can also follow along with a practical example within Google Cloud. The first phase of incident management is preparation. This includes everything an organization needs to do before a security incident occurs. During this initial phase, an organization develops an incident response plan, defines policies, assigns roles and responsibilities, and identifies critical assets. The second phase is detection and analysis. The goal of this phase is to identify security incidents early on by collecting and analyzing data using monitoring and logging. Detection can happen in many ways. For example, a user might report an issue,
or a security monitoring solution might generate an alert. In Google Cloud, you can use tools like Security Command Center, Cloud Logging, Cloud Monitoring, Chronicle SIM, Error Reporting, and Stackdriver Trace to detect anomalies, trigger alerts, and analyze logs. With detection tools, you can configure alerting policies to notify you when a specific event happens, like an admin login from an unusual location. With analysis tools, you can also examine and analyze incidents. An important part of this detection process is examining events surrounding the alert. For example, examining any logins before the alert and monitoring any changes, like role assignments or unusual configuration changes after the alert. During the investigation, it's also helpful to ask questions that can triage the incident. Some types of questions include how the alert was initially detected, the timing of detection, what logs are accessible, and if there are signs of ongoing unauthorized access. The third phase is containment, eradication, and recovery. After the incident has been correctly identified, any compromised systems need to be contained to limit impact. The attacker's system's access must be removed, and any damage they caused must be completely eradicated from the system. Recovery actions are then performed to return operations to normal, ensuring that all systems are functioning as expected. This gives the organization the opportunity to implement more precautionary measures moving forward. There are several cloud tools that you can use to enable containment, eradication, and recovery actions. This includes preventing the spread of malicious activity and minimizing data loss. By leveraging Google Cloud's capabilities, you can isolate the resources that have been affected using Virtual Private Cloud, or VPC firewalls, with the Cloud Security Scanner. Also, Identity and Access Management, or IAM, plays a key role in the containment and removal of an attacker in cloud environments. By leveraging IAM features, you can address the security concerns identified during the detection and analysis phase. This includes actions like disabling compromised accounts, revoking suspicious OAuth tokens, and blocking untrustworthy IP addresses. In Google Cloud, many services work collectively to safeguard data, automate infrastructure, and ensure consistent deployments for reliable operation. These services can be used as tools to assist you in your containment, eradication, and recovery efforts. Google Cloud SQL's automated backups consistently preserve important data, and its point-in-time recovery feature allows restoration of the database to an earlier state in case of accidental modifications. Alongside this, Deployment Manager automates the process of deploying and managing your services and resources for consistent handling of configurations, enabling automatic scaling and balancing of applications. Google Cloud Backup and DR Service is a complete disaster recovery solution safeguarding data, applications, and digital assets. It ensures system restoration post-disaster, verifies backups for readiness, and offers configurable on-demand and scheduled backups. It also includes testing and planning for quick recovery in case of system failure. It's important to remove an attacker and isolate and restore any critical services after an attack. You also need to be careful while restoring systems to avoid accidental reintroduction of malicious elements like backdoors, compromised accounts, or command and control or C2 elements. These can potentially offer the attacker a chance to reestablish a presence in your system, especially if you restore the vulnerabilities that were present in the system before the initial attack. The final phase in the incident management process is post-incident activity. This phase is where you learn from the incident and identify areas of improvement. Once the threat has been successfully contained, you can perform post-incident activities, such as conducting a post-mortem analysis, documenting the incident, and implementing changes to prevent similar incidents in the future. Cloud tools can be used to facilitate post-incident activity. Google Cloud's Cloud Audit Logs and Cloud Security Command Center's continuous monitoring and recommendations are valuable resources in understanding the actions leading to the incident and identifying improvements.
Google Cloud's Cloud Audit Logs can help you understand the actions that led to the incident and identify areas for improvement. You can also use Cloud Security Command Center's continuous monitoring and recommendations to proactively improve your security posture and prevent future incidents. It's also recommended that your organization adds more security measures, like implementing IAM organizational policies to enforce settings and restrictions, and strengthening network security with VPC firewall rules. By following these phases to guide your incident response, you can effectively detect, analyze, and resolve security incidents. This minimizes their impact on your organization's infrastructure and data. With Google Cloud's comprehensive suite of security tools, you'll be well equipped to handle any security incident that comes your way. Knowing how to respond to an incident can boost your confidence and make you a valuable asset to your security team. If you've ever planned a dinner party, you know there are a lot of steps involved. You have to invite guests, shop for ingredients, clean your home, prepare food in a timely manner, and create a welcoming environment. Having a plan in place reduces the likelihood that something can go wrong. Incident management works similarly in cloud security. In this video, we'll discuss the importance of incident management. We'll also dive into ways to build an effective incident management plan. Let's get started. Incident management is an important part of cloud security. It helps organizations identify, analyze, and respond to security incidents in a timely and efficient way. By having an incident management plan in place, you can minimize the impact of security breaches and maintain the continuity of operations. Let's briefly re-examine the NIST incident response lifecycle. The key phases of the lifecycle are preparation, detection and analysis, containment, eradication, and recovery, and post-incident activity. When forming an incident management plan, it's important to be thoughtful while applying each step. You should also be aware of the typical responsibilities associated with incident management. This will help ensure a comprehensive and effective approach. The first phase of an incident management plan is preparation. One way to begin preparation is to assign roles and responsibilities associated with incident management to all relevant stakeholders. Roles may include incident reporters, who are responsible for identifying and reporting incidents to the appropriate teams, incident responders, who are responsible for analyzing and prioritizing incidents, coordinating response efforts, and implementing containment, eradication, and recovery measures. Stakeholder communication executives, who are focused on ensuring transparent communication about the incident status and associated actions to all relevant parties. Incident review and improvement analysts, who concentrate on conducting post-mortem analyses, pinpointing areas of improvement, and refining the incident response plan post-resolution. Clear, designated roles and responsibilities ensure that there's open communication channels, improving communication between relevant points of contact. The second phase of an incident management plan is detection and analysis. A comprehensive and effective system for incident detection and analysis should include a combination of several components aimed at identifying, detecting, and managing potential security threats. Through the use of monitoring and alerting tools, security professionals detect threats to a system. They also use security tool integration to respond to threats and report their findings. Let's examine these components more closely. First, monitoring and alerting tools like Google Cloud Monitoring and Grafana can help identify potential threats in real time. Next, advanced detection measures work alongside monitoring tools to recognize and validate threats. You can use this component to differentiate between normal operations and possible security threats or breaches. Next, security tool integration can help facilitate efficient, real-time threat detection and response. For example, an organization's SIEM platform can be integrated with tools like Elastic Stack or Alien Vault OSIM. Finally, it's important to establish well-structured incident reporting and escalation protocols. Tools like Sentry or Google Issue Tracker can be used to help ensure that incidents are reported and escalated to the corresponding personnel or teams. Some examples include the Security Operations Center, or SOC, and the Incident Response Team. When combined, these components help create a robust and comprehensive system, ensuring optimal incident detection and reporting. Once an incident has been detected and reported, it must be analyzed. The Incident Response Team should gather all relevant information and determine the severity, scope, and potential impact of the incident during this step. The analysis process can be broken down into steps. First, review logs and data sources to grasp the incident's nature. Then, analyze network traffic to find patterns and vulnerabilities. Next, examine affected systems to assess damage and pinpoint exploited weaknesses. Then, collaborate with the IT and security teams to gather more information and insights. After that, be sure to preserve evidence properly. It's crucial when involving law enforcement. Finally, consider engaging professional incident responders who have expertise in chain of custody and evidence collection. The third phase of an incident management plan is containment, eradication, and recovery. After an incident has been analyzed, security professionals need to contain the attack, eradicate any malicious elements, and recover the affected systems. Containment involves stopping the attack from causing further damage, while eradication focuses on removing any malicious elements from the affected systems. During the containment and eradication portion of this phase, security professionals will implement network segmentation or isolation to prevent the attack from spreading. Remove and rehydrate any affected system where there is no concern for data loss. And eradicate malware from systems that contain critical, useful, or important data. Once the issue is contained and eradicated, the recovery process starts. During the recovery process, security professionals will patch vulnerabilities and update software to prevent future exploitation, restore data and applications from backups, ensuring that they're free from any malicious elements, and monitor the environment to ensure the incident has been fully resolved and that no additional threats are present. Security professionals should also consider managing identity and access management, or IAM, which includes disabling and expiring tokens, resetting passwords, and deprivileging accounts. Also, it's important that they revoke access or disable service accounts to minimize potential risks and maintain security. After a security professional has remediated an incident, they'll move on to the fourth phase of an incident management plan, the post-incident activity. In this phase, the security professional and their team will examine how the problem was handled to identify ways to improve their response in the future. This may involve enabling additional tools for monitoring blind spots discovered through lessons learned, conducting a post-mortem analysis to determine the root cause of the incident, and identifying any gaps in the incident response plan, updating policies, procedures, and technical controls to prevent similar incidents in the future, and providing training and awareness programs to educate employees on the latest threats and best practices for maintaining security in the cloud environment. Following our continuous learning approach, we also focus on regularly reviewing and updating the incident response plan to ensure it remains effective and aligned with the organization's needs and objectives, completing regular incident response exercises for preparedness against potential threats, and testing offline backups and restoring processes to ensure data integrity. In this video, we covered the essential steps in building an effective incident response plan. By following the steps in the phases of the NIST incident response lifecycle and continuously improving your plan, you'll be better equipped to detect, respond to, and recover from security incidents in your cloud environment. Planning ahead and preparing effectively will make you better equipped to respond to a multitude of security situations. Hi there! In this video, we'll focus on the fundamentals of intrusion detection systems. We'll also discuss their relevance to Google Cloud and explain how these systems can strengthen your cloud infrastructure's defense against digital threats. When working as a cloud security professional, your system may not display flashing red lights or exclaim "intruder alert," but using intrusion detection systems, you can detect when unauthorized access is taking place. Intrusion detection system, or IDS, platforms are crucial because they actively monitor and analyze your networks for any malicious activities or policy violations. An IDS works much like a security camera system in a bank. The security cameras monitor the physical environment for any suspicious activity. In the same way, an IDS monitors a cloud environment for any malicious activity. Without an IDS, your organization could be left vulnerable to attacks, potentially damaging your data integrity and compromising your cloud security. Cloud IDS actively uses IDS principles to enhance security by detecting network threats, managing in the cloud, having thorough security, keeping full traffic visibility, meeting customer compliance, focusing on main threats, finding disguised apps, and providing efficient performance. Let's briefly review each one. Cloud IDS actively provides a strong defensive mechanism against a variety of exploit attempts, protecting the network from threats. By detecting network threats, Cloud IDS identifies intrusive and obstructive behavior throughout both network and application layers. Additionally, Cloud IDS identifies concealed malware hidden in various file formats and web content. By managing in the cloud, Cloud IDS allows you to manage your systems in a way that best suits your needs. For example, the user interface, or UI, offers a user-friendly and intuitive visual dashboard, enabling those with minimal technical skills the ability to manage systems easily. For those who have expertise in command line operations, the command line interface, or CLI, is an efficient option. CLI allows the user more control and precision. Application programming interfaces, or APIs, are another way to manage Cloud IDS. These are ideal for users who need their systems to interact with other software or need to perform operations at scale. These different management options, including UIs, CLIs, and APIs, offer flexibility to users, from those who prefer simplicity to those who want more complex, integrated operations. Having thorough security can be achieved by maintaining threat detection capabilities. Cloud IDS integrates with Palo Alto Network's threat detection capabilities to provide a broad security range. The built-in catalog of attack signatures updates continuously, allowing systems to keep up to date with emerging threats. Next, keeping full traffic visibility is vital for detecting intrusions. Cloud IDS, equipped with Google Cloud's packet mirroring, actively expands its reach beyond standard internet traffic. It includes communication within and between virtual private clouds, or VPCs. This enhancement allows for efficient detection of suspicious lateral movements that could suggest the presence of potential intruders, significantly strengthening cloud security. Meeting compliance standards is a critical goal for many organizations. Cloud IDS actively helps customers meet compliance standards by providing strong network threat detection. Using advanced algorithms, it identifies risks in real time and supports businesses in adhering to required standards. With customizable options, Cloud IDS adjusts to unique risk levels and ensures constant network security, maximizing threat detection while minimizing false alerts. Focusing on main threats is important for security teams because they need a way to properly classify threats. With Cloud IDS, the system actively goes beyond identifying threats. It also categorizes them into distinct severity levels. This intelligent classification enables you to prioritize your security responses and focus on the most critical issues first. By streamlining your security measures, you can effectively protect your infrastructure and respond to potential risks more efficiently. Cloud IDS closely integrates with Palo Alto Network's App ID technology to support finding disguised apps impersonating legitimate ones. It helps deliver an effective barrier against potentially harmful incursions. This combined capability also strengthens cloud security and contributes to improved safeguarding of digital resources. Providing efficient performance is at the core of Cloud IDS capabilities. Depending on your organization's unique requirements, it can efficiently scale up or down to examine all incoming and outgoing traffic. This flexibility ensures that there are no compromises in performance levels. By adapting to various traffic volumes, Cloud IDS consistently delivers reliable security measures while maintaining optimal network efficiency for your organization. The foundational IDS principles are critical tools in your cybersecurity toolbox. When implemented within Google Cloud, these techniques can strengthen your defenses. Having a full toolbox means you can respond to a variety of problems with ease. Now, let's explore signatures. A signature is a pattern that can be associated with malicious activity. A signature actively checks packet patterns for any malicious activity using factors like IP addresses, used ports, types of protocol, and payload details. In network security, a signature database should be regularly maintained and updated. The signatures in this database are designed to identify specific patterns in network traffic that may indicate malicious activity or potential threats. Just like a security camera can be set up to monitor specific objects or activities. When network traffic is analyzed, it's compared to these signatures. If there's a match, it could indicate a potential threat. As new threats and attack techniques emerge, the signature database must be updated regularly to remain effective. Here's an example of a signature. This Python dictionary is evaluating network traffic from a specific source IP address, utilizing the TCP protocol to make requests at the destination port 80, and carrying a payload labeled as exploit_payload. Now, let's discuss anomaly-based detection. Anomaly-based detection is an alternative to signature-based detection that involves creating a normal baseline for network activity. This baseline is then used as a standard for comparison to identify activities that aren't part of normal network operations. This security system is like a tireless guard. It keeps a constant watch on all the network traffic, comparing it against a baseline of regular or average network activity. Now, if there's any traffic that significantly changes or moves away from the baseline, the system sends an alert. These differences can often signal an unwelcome intrusion or an irregularity in progress. So while you're busy with other tasks, your system remains watchful, prepared to notify you of any harmful intrusions. Here's an example of how you can detect anomalies with SQL Query. SQL Query is designed to model the regular behavior of a network by retrieving historical data on network traffic over a specific time period. It also groups activities based on source IP, destination port, and protocol. This query has several effects. It provides insights into the network's normal behavior, establishes a baseline for comparison, and enables the comparison of current traffic to the established norm. Running this query provides a comprehensive understanding of which source IP addresses, destination ports, and protocols are commonly used within the network, allowing better detection of any deviations or anomalies. Anomaly-based detection is an effective strategy when dealing with new or unidentified threats that may not have an identifiable signature. They say that knowledge is power. In this video, you'll learn about logs in Google Cloud. You'll understand the different types of logs available and find out why log retention is important. You'll also discover how logs can be used for analysis and monitoring, and how to manage retention policies using these logs effectively. Let's get started. To get started with logs, you need to know the 4 foundational terms associated with logging. First, a log is a record of events that occur within an organization's systems. Second, log analysis is the process of examining logs to identify events of interest. Third, logging is the recording of events occurring on computer systems and networks. And fourth, log management is the process of collecting, storing, analyzing, and disposing of log data. There are several ways logs can be used. For example, log analysis analyzes logs for patterns and trends to identify potential security issues. Setting up monitoring alerts based on specific log events notifies security teams of potential incidents. It's also important for teams to regularly test the monitoring to ensure its effectiveness. Maintaining retention policies ensures logs are retained for the required duration to meet compliance and security needs. And threat detection proactively detects and mitigates security threats based on log data and analytics. Logging contributes to security monitoring and incident detection by providing valuable information about activities within systems. By analyzing logs, security teams can identify suspicious patterns, detect potential security breaches, and investigate incidents. In Google Cloud, a variety of log types are generated, each serving a unique purpose. Types of logs include admin activity audit logs, data access audit logs, system event audit logs, and policy denied audit logs. Let's explore each of these log types in detail to help you better understand their functions and use cases. Admin activity audit logs provide a view into the activities of administrators and other authorized individuals. These logs track who did what, when, and where. Actions like creating databases, deleting instances, or changing permissions would be found here. Here's an example of an admin activity log. Admin@example.com created a new table in Google Cloud Bigtable. The log entry shows the user performed a create table operation in Bigtable service. Now let's explore data access audit logs. Data access audit logs record API calls that create, modify, or read user-provided data. In other words, these logs tell when data is created, modified, and read, and by whom. Examples of these activities include Google Cloud Storage object accesses and data store database reads and writes. Here's an example of a data access audit log, which records a specific event. The code is a JSON representation of a data access audit log entry from Google Cloud. In this case, the event is a read rows operation in Google Cloud Bigtable. Next are system event audit logs. System event audit logs report changes to your system's configurations and settings. Some examples of changes to a system include alterations to the settings of a cloud service. These logs provide invaluable information that can be used to detect anomaly behaviors in systems. Here's an example of a system event audit log. This is a JSON snippet from a Google Cloud audit log, which records system events for Google Cloud resources. Simply put, this log shows that a migration of a compute engine instance took place because of host maintenance. And finally, there are policy-denied audit logs. Policy-denied audit logs capture instances where requests were denied because of existing IAM policies. Unauthorized access attempts and modification requests by users without the required permissions can be found here. These logs provide a strong audit trail of any failed access requests. Here's an example of a policy-denied audit log in Google Cloud. This log documents a denied attempt to start a compute instance using the im.serviceaccounts.actAs permission on my project. It effectively tracks unauthorized actions for security and compliance purposes. Understanding the 4 crucial types of logs in Google Cloud can help manage systems and improve cloud cybersecurity. Now, let's dive into the log lifecycle and retention. Logs follow a lifecycle that includes generation, storage, analysis, and eventual expiration. Log retention is an important part of the log lifecycle, as it's used to preserve logs for a specific period to meet regulatory requirements and facilitate historical research. Retained logs can be used to investigate past incidents, identify trends, and improve security posture. With Google Cloud, users can decide how long to store their logs. Based on the needs of their organization, users can balance the cost of storage and the need for past data. Users also might choose to save their logs to cold storage or store them offline. With these options, if a security breach lasts longer than an organization's usual log storage period, it won't lose access to vital log information. So where are logs located in Google Cloud? Logs in Google Cloud can be found in various locations. These locations include the logging section of the Google Cloud Console, Cloud Operations, and BigQuery. Security information and event management, or SIM systems, like Chronicle, can aggregate logs from different sources, providing a centralized platform for log analysis and security monitoring. In this video, you learned about logging and log retention, the different types of logs in Google Cloud, and how logs can be used for analysis, monitoring, and maintaining retention policies. With this knowledge, you can effectively manage and secure your cloud environment. There's often a lot of discussion about technical skills, but what about human skills? Businesses are as interested in skills that allow a person to fulfill their responsibilities effectively as they are interested in technical knowledge. And chances are, you already have a lot of awesome human skills that you've learned throughout your life. In this video, you'll learn about some essential workplace skills that will improve your effectiveness as a cloud security professional. By closely examining each of these skills, you'll better understand how they can help you maintain a secure cloud environment. Some core workplace skills include high attention to detail, critical thinking skills, effective time management skills, solid communication skills, and adaptability and curiosity. These skills can be applied to many different aspects of cloud security. Let's examine how these skills apply to logs and log management in particular. First, you'll need to be able to focus on a specific task with high attention to detail. Log management requires the ability to examine log files closely and identify potential issues or anomalies. This includes recognizing patterns and trends, identifying errors and security threats, and ensuring data accuracy and integrity. Strengthening your focus on details will help you effectively analyze and interpret log data, leading to better decision-making and problem-solving. Next, you'll need critical thinking skills. This involves analyzing information objectively, evaluating the relevance and importance of data, and identifying potential solutions and mitigations. By applying your critical thinking skills to log management, you can identify the root cause of issues, prioritize tasks, and make well-informed decisions to enhance the security of your cloud environment. The process of log management can often be complex and time-consuming, requiring a significant investment of time and energy. Active and successful time management is a skill that allows you to stay organized, maintain focus, and operate efficiently. Key aspects of this skill involve prioritizing tasks based on urgency and importance, allocating appropriate time for analysis and problem solving, and balancing multiple tasks and responsibilities. Log management can be very time-consuming. Having effective time management allows you to stay organized, focused, and efficient so that you can prioritize your log management tasks. In the ever-evolving world of logs and log management, it is crucial to develop and maintain exceptional communication skills. This skill empowers professionals to contribute to a more secure and efficient work environment. Communication skills include clearly articulating findings and insights, collaborating with team members and stakeholders, and writing comprehensive reports and documentation. Strong communication skills enable you to share valuable information with others, ensuring that everyone stays informed about potential risks and security measures. Log management is an evolving field, with new technologies and threats emerging regularly. That's why adaptability and curiosity are essential for log management success. This involves staying up to date on new tools, technologies, and best practices, embracing change and adapting to new challenges, and continuously learning and seeking ways to improve. Can you think of a time when you used any of these skills, either in a work environment or in your everyday life? Chances are you use them more often than you think. But did you know that tools can also help you improve these skills? Chronicle, SIM, and SOAR are two tools that can enhance your essential skills. These tools collect and correlate data, organizing it in a way that makes it easier to decipher. This frees up your attention, allowing you to focus on the details and improving your ability to conduct effective analysis. The data collected by SIM and SOAR can also contribute to your ability to think critically. Functions like intelligent threat detection, customizable alerts, and visualization give you new insights into security operations. And, As a result, new solutions can emerge. SIM and SOAR support effective time management using automation, prioritization of incidents, and centralized monitoring. There are several features within SIM and SOAR that support communication. These include collaboration features, incident tracking, and comprehensive reporting tools. Using these can improve the efficiency and effectiveness of your security operations. Now, let's explore an example scenario demonstrating the importance of the workplace skills we discussed for log management success. Imagine you're a cloud security analyst responsible for monitoring log files from various cloud services. One day, you notice a pattern of failed login attempts from an unfamiliar IP address. This situation requires the application of the skills we discussed earlier. Your attention to detail enables you to spot an unusual pattern of failed login attempts among a vast amount of log data. This observation raises concern, prompting further investigation. Using your critical thinking skills, you analyze the log data and determine that the failed login attempts could indicate a potential brute force attack. You decide to monitor the situation closely and take action if necessary. As you continue to monitor the log files, you must also manage your other responsibilities. Your effective time management skills allow you to prioritize tasks and allocate enough time to address this potential security threat without neglecting other essential duties. You communicate your findings to your team, explaining the potential brute force attack and its implications. Your clear and concise communication ensures that everyone understands the situation and can work together to address the issue. As the situation unfolds, you research the latest brute force attack prevention techniques and apply them to your organization's cloud security measures. Your adaptability and curiosity help you to stay up to date with new developments and continuously improve your log management skills. In this video, you learned how a combination of attention to detail, critical thinking, time management, communication, adaptability, and curiosity makes it easier to address potential security threats. By mastering these workplace skills, you can become proficient not only in log management, but cloud security as a whole, and contribute to the success of your organization's cloud security efforts. Have you ever written a note on a piece of paper to remind yourself of an upcoming responsibility? Cloud security professionals do something similar by setting alerts and notifications within their cloud environments. In this video, we'll go through an overview of alerts and notifications. You'll also learn about false positives and effective management strategies to efficiently handle alert systems. With these insights and strategies, you'll be prepared to start implementing alert management systems in your security operations, or SecOps. Let's get started. In cloud security, protection is the primary defense method. Alerts play an important supporting role in this process. Reliable alerts actively warn of potential issues or threats, helping security professionals identify and address problems quickly. Keep in mind that while some alerts come from security detections, others might not. But focusing on the actual detection is more crucial than the alert itself, because it directly impacts safety. There are some common alert types to consider for a cloud environment. Let's examine 3 types. First is unusual network traffic. Cloud security professionals set alerts to monitor for unexpected spikes in traffic or unauthorized access. Second is suspicious login activity. It's helpful for cloud security professionals to configure alerts for failed login attempts or logins from unfamiliar locations. Third is policy violations. Cloud security professionals create alerts to detect when users attempt actions prohibited by their organization's security policies. It's important to note that not every alert signals an actual threat. Some alerts are just false positives. A false positive is an alert that incorrectly detects the presence of a threat. False positives flag normal activity as potentially harmful or suspicious. False positives increase the workload of the SecOps team, which can lead to lower performance and productivity. The team may experience alert fatigue while handling an overwhelming volume of these alerts, potentially causing genuine threats to slip through unnoticed. Managing false positives effectively involves a methodical and focused approach. Here are the essential steps for managing false positives more efficiently. First,
Refine alert parameters by adjusting them to align with your organization's specific risk tolerance and security posture. This will enhance the overall accuracy of the system. Next, audit regularly. The task of managing false positives is an ongoing one. Regularly auditing alerts ensures system accuracy. It's also important to collaborate across teams, including all teams in refining, reviewing, and providing feedback. That way, each team can contribute uniquely to more effective identification and management of false positives. Also, apply feedback and utilize it as a powerful tool for continuous improvement. When used effectively, it can improve alert systems' precision and prevent alert fatigue. Next, use automation like AI and machine learning to spot false positives. This will free up your team for more challenging work. Also, make sure you prioritize training and education. Train your staff to manage false positives effectively and keep learning so you can be aware of new threats. It's also important to customize strategies. Given the quick evolution of threats, a fixed strategy is not enough. So it's crucial to tailor false positive management strategies based on shifting needs and situations. And finally, to improve your organization's overall security operations, it's essential to integrate a strategic process for mitigating false positives. By strategically thinking, integrating, and adapting this approach not only reduces alert fatigue, but also strengthens the organization's security posture and risk resilience. Google Cloud offers a comprehensive set of tools designed to assist in creating meaningful alerts. These tools allow users to define alert conditions and parameters, assign appropriate alert policies, and specify preferred notification methods. It's important to adapt this process to your system's unique needs and vulnerabilities, ensuring optimal protection and monitoring. As you manage your alert system, keep the following best practices in mind. Prioritize alerts based on risk level and potential impact. Make use of machine learning to identify patterns and reduce false positives. And regularly audit your alert system to ensure it remains effective. By understanding the role of alerts and notifications in cloud cybersecurity, mitigating false positives, and using Google Cloud tools to set up effective alerts, you'll be better prepared to protect your organization's cloud environment. Cloud security professionals use alerts to manage their cloud environments. In this video, you'll explore how effectively querying alerts can handle cybersecurity threats. Ready? Let's dive into the world of alert search techniques. Querying alerts is the act of scanning through numerous security alerts from your cloud infrastructure to identify possible threats. As a cloud security professional, these alerts provide essential information on potential weaknesses and incidents that need attention. Effective querying, or the use of precise data requests, has become a crucial part of how security issues are handled. This powerful tool reduces risk, forming a strong base for several aspects of active security management. Effective querying allows you to identify important alerts in real time, prioritize high-impact issues, streamline response to incidents, and enhance proactive security posture. Alert filters are instrumental in refining your search results. Chronicle Security Information and Event Management, or SIEM tool, improves search efficiency and threat analysis by enhancing alert filters. These filters focus on specific details, like event categories, severity levels, or timeframes, to narrow down search results. By using Chronicle SIEM, you can streamline your security operations. Chronicle SIEM also offers refined features, like customized filtering criteria, adaptable event correlation, and machine learning-based insights to simplify data management. These functions help manage the flood of data, removing unnecessary information and highlighting the most important alerts. Chronicle SIEM provides better alert filter performance and stronger threat detection and analysis. Let's examine some of the most common filters that can be used in Chronicle to query alerts. The most common filters include alert title, source, destination, severity, and time. They can be combined in different ways to create highly targeted queries.
When creating queries, it's important to be specific and thorough. But being too specific may cause some results to be overlooked if they don't match your criteria. So, let's go over some tips for querying alerts. Here are some best practices for querying alerts. Make searches specific to lessen distractions. Save your frequently used searches for future use. Familiarize yourself with the frequency and timing of alerts. And always reassess and change filters as needed. Now, let's review each of these practices. It's important to make your searches specific to lessen distractions. By focusing on key details that directly relate to the issue you're trying to identify, you can find relevant information and insights faster. This targeted approach removes unnecessary data, increases the relevance of your search results, saves time, and reduces frustration. To achieve a more efficient workflow and maintain the same standards in data analysis, make sure to save your frequently used searches for future use. This will not only give you faster access to information, but also significantly reduce the amount of time it takes to accomplish search-related tasks. Familiarizing yourself with the frequency and timing of alerts helps you effectively use your time and resources. By understanding past patterns and changes in the amount of alerts, you can better prioritize your responsibilities. Proper prioritization helps you manage time more effectively and identify alerts that are no longer relevant. Focusing on the most significant alerts makes your work process more efficient and increases your overall productivity. And remember to always reassess and change your filters as needed. It's important to consistently update your filters to stay aware of new risks and technological updates. Paying close attention to alerts can also help you quickly handle any unexpected issues, ensuring potential dangers are handled swiftly and successfully. So remember, implementing strong alert search techniques can speed up a cloud security team's response time, accelerate incident resolution, and improve resilience against cyber threats. Congratulations! You've arrived at the end of this section on detection foundations. On your journey, you explored lots of important topics related to maintaining security and effective incident response of cloud systems. You started by learning the basics of logging and the role of logs in maintaining a secure environment. You also learned about log retention policies. Next, you explored intrusion detection and response, and learned how they can be efficiently utilized to safeguard your cloud resources. You also learned about monitoring methods and setting up alerts. Finally, you learned about the incident management process and how to accurately report, investigate, and resolve security breaches. You also gained strong foundational knowledge of how to act swiftly and efficiently when an incident occurs. You're doing great. Keep up the excellent work. It's great to have you here. I'm so excited to share my cloud security knowledge with you. Coming up, we'll focus on how cloud security professionals can use detection tools and techniques to detect and respond to potential threats. Then, we'll analyze the stages of an attack and discuss false positives. You'll use Lockheed Martin's cyber kill chain to learn about the anatomy of an attack so that you can better defend against one. You'll also learn about the impact false positive alerts can have and how to manage them. Next, you'll learn how cloud security professionals can gain visibility into a cloud environment through security monitoring. And finally, you'll explore indicators of compromise and threat hunting. Are you ready to develop your detection skills? Let's get started. Sometimes, examining things from a different perspective can give you insights into things you might not have noticed otherwise. In this video, we'll examine Lockheed Martin's cyber kill chain framework. This framework will help you understand the anatomy of an attack so that you can better defend against it. Ready to get started? Lockheed Martin's cyber kill chain framework defines the steps of a successful cybersecurity attack. Each attack provides an opportunity for defenders to understand an attacker's mindset, strategy, and goals. Before we discuss the cyber kill chain, it's important that you're aware of Advanced Persistent Threats, or APT. An advanced persistent threat is an adversary that possesses sophisticated levels of expertise, significant resources, and achieves its objectives through multiple attack vectors. APTs are a serious threat to cloud environments. The good news is, the cyber kill chain can be used to identify APT activity and mitigate it. There are 7 steps in Lockheed Martin's cyber kill chain that need to be completed in order for an attacker to successfully complete an attack. As a defender, if you're able to stop an attacker during any step of the chain, you can break it and stop attackers in their tracks. The 7 steps of the cyber kill chain are reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. Let's explore each step in detail. In step 1, reconnaissance, the attacker focuses on gathering information. Before attackers can attack, they need to identify their targets. To do this, they collect as much information about the target as possible. Malicious actors aren't that different from criminals operating in the physical world. Each step of Lockheed Martin's cyber kill chain can be compared to a scenario involving a zoo heist. In this example, the members of the zoo heist team have to take certain steps in order to successfully take rare animals from the zoo. Similarly to how a heist team member would identify the best zoo to target, malicious actors plan their attack by performing reconnaissance. This includes gathering information like employee names and job titles, email addresses, and information about the target's infrastructure, like the services or operating systems being used. After successfully performing reconnaissance, the attacker moves to step 2, weaponization. Similarly, in the zoo heist example, after the heist team members pick their target zoo, they must prepare for the heist by gathering the tools they need, like gloves and bolt cutters. After an attacker successfully creates their exploits, their next step is delivery. In this step, the attacker officially launches their attack. This might be done by sending a malicious email to the target or by performing social engineering. For a heist team member, this step is like arriving at the zoo with their tools in hand, ready to break into the zoo's locked doors. After the attacker has delivered their malicious payload, they move on to the next step, exploitation. The goal of this step is for the attacker to gain access to the target. They can do this by exploiting a software vulnerability. For members of the heist group, this step includes successfully breaking the locks of the zoo to gain access. After the attacker has successfully gained access into the target system, the next step is installation. The goal of this step is for the attacker to maintain access to the target system without the target knowing. They can do this by installing backdoors into the system. Backdoors allow an attacker to bypass security measures and conceal their access. For the heist team, this step includes creating a secret underground tunnel entrance connecting to the zoo, so they can continue to have access to the zoo and easily transport the stolen animals. After an attacker has successfully ensured persistent access to the target system, they begin the command and control step. The goal of this step is for the attacker to be able to remotely control the target system. Common command and control channels an attacker might use include web, DNS, or email protocols. The final step is actions on objectives. This is when attackers achieve their end goal. During this step, they can collect and exfiltrate data, destroy systems, or worse. In the final step of the zoo heist operation, the heist members successfully steal animals from the zoo. In both scenarios, the attacker and the heist team are able to get what they want using the cyber kill chain framework. Now you can use Lockheed Martin's cyber kill chain to anticipate an attack and defend against it. Staying ready means taking as many precautions and steps to prepare as possible. It's not negative, it's false positive. In this video, you'll learn about false positives and false positive analysis. You'll examine their impact, some common causes, and some best practices for managing them. A false positive is an alert that incorrectly detects the presence of a threat. There are many systems and tools designed to notify you of potential dangers. These types of alerting devices appear in our everyday lives and may include fire alarms or heart rate monitors. Consider this example. You're a cloud security professional. You've configured your intrusion detection system to create an alert if it identifies a threat. One day, the alert goes off. After investigating the alert, you determine that it was generated by normal behavior, so there was no harmful impact. That's a false positive. As a cloud security professional, it's important to recognize false positives because they have a big impact on security operations. Specifically, incident management and attack mitigation. False positives can also negatively impact a team's confidence, effectiveness, speed, and resources. It's important that security professionals are confident when dealing with an incident, so they can quickly respond to it while also applying the appropriate resources. Security professionals can't do their job effectively if their efforts are spent on a harmless event. False positives also impact security professionals by creating a phenomenon called alert fatigue. Alert fatigue is the result of all noise and no signal in security environments. Alert fatigue happens when there are so many alerts that need to be addressed, it overwhelms a security team. Over time, too many alerts can lead a team to lower the importance of alerts in day-to-day operations, leading to actual threats being ignored or overlooked. False positive alerts can have significant consequences like wasted time, loss of resources, and increased stress levels. They can also increase exposure to attacks because real threats are being misjudged. These misjudged threats are called false negatives. Let's explore some of the common causes of false positives in regular security operations. False positives can be created from a range of situations, like misconfigurations in tools and systems, over-engineered detection strategies, or even unaccounted changes within the cloud environment. So, what can be done to reduce false positives? False positive reduction strategies include continuously testing and fine-tuning security systems, consistently monitoring logs and alerts, communicating any configuration changes, and contributing to a culture of continuous learning and improvement. By reducing false positives, you can increase the chances that your team can quickly and confidently identify genuine threats. As you dig deeper into cloud security operations, remember that effectively managing false positives is one of the keys to maintaining a strong security posture. Security professionals are at the forefront of securing cloud operations for their organizations. In this video, we'll explore security monitoring to support you in your role in the cloud cybersecurity field. Let's start with an overview of security monitoring. Security monitoring is a systematic process of surveilling systems to detect and handle potential security breaches or incidents. For example, security monitoring is useful for online services that people depend on and use every single day, like banking apps. A single security breach on a banking app could lead to a serious security incident, like customer data theft. And a breach doesn't just leave customer data at risk. It can also cause the organization to suffer financial losses and reputational damage. Security monitoring can help mitigate security incidents. By proactively monitoring all the systems in an environment, cloud security professionals can quickly address threats before they turn into serious issues. To do this, they rely on security tools, resources from the cybersecurity community, and knowledge from the professionals on their team. Making the effort analyze, learn, and adapt is important because security monitoring is a never-ending task, which demands constant attention. New vulnerabilities and attack strategies are being identified every day, making the continuous monitoring of security systems a necessity. Alert systems and tools serve as early warning systems by delivering timely notifications about suspicious activities. This can lead to faster security response times. These notifications can also help cloud security professionals gain insight into security events so they can act and respond efficiently. So what tools do professionals use for security monitoring? Let's explore some of the Google Cloud tools that can help with this. To start, Google Cloud Security Command Center provides a centralized view of all the assets in your Google Cloud environment, helping you identify and address potential security issues. Google Cloud's Cloud Logging is a fully managed service that allows security professionals to store, search, analyze, monitor, and alert on logging data and events. They can leverage cloud logging to track activities and uncover evidence of potential issues. Cloud monitoring is a service that collects metrics, events, and other data from Google Cloud and other applications and systems. As a security monitoring tool, it creates insights about the environment so that cloud security professionals can detect security threats early on. Chronicle is a tool that's designed to retain, analyze, and search data. Chronicle combines the features of security information and event management, or SIEM, and security orchestration, automation, and response, or SOAR. This makes it a powerful security monitoring tool that can be used to quickly detect and investigate security threats. As a SIEM tool, Chronicle collects and analyzes data to detect security threats like malware. As a SOAR tool, Chronicle can be used to automate incident response actions using playbooks. And finally, VirusTotal is a service that analyzes suspicious files, domains, URLs, and IP addresses for malicious content. VirusTotal integrates with Chronicle to support security professionals in their investigations by providing threat context and reputation data relating to suspicious artifacts. These security monitoring tools can provide cloud security professionals with a robust framework to monitor their security systems, set up alerts, and streamline their incident response processes. Cloud security professionals make important contributions to the security monitoring and operation processes. By learning more about these processes, you can support your organization's development of a more secure digital environment.
Hi, my name is Tim. I work on the detection and response team at Google. Our responsibility here is to defend Alphabet from being hacked. Google is a target for literally every attacker out there, from the most sophisticated nation-state attackers to criminals that would look to steal money and steal information and other resources, and also kind of your run-of-the-mill vandals and run-of-the-mill folks that would just look to cause chaos and do harm. The job is very hard, but it's also very rewarding. I mean, being able to protect the information and protect all of the data that users entrust with us, billions of users entrust with us, is at the end of the day extremely rewarding. I studied political science and history in college, but during that time, I did work at the IT department at my university. And the reason I was able to do that was because I tinkered with computers throughout my childhood, right? So, getting my first kind of XT computer, breaking it a bunch of times, having to learn to fix it, learning MS-DOS, etc. Unbeknownst to me, set me up to be able to work in the IT department as a help desk operator, and then growing from there into this field now. Cloud is the present and cloud is the future. If you look in the next 10, even 15 years, everything is moving to the cloud. And I'm not just talking about infrastructure as service, but I'm talking about the pillars that run the cloud and understanding the identity pillar, understanding virtualization, understanding software-defined networking. All of those pillars, those are not going away. They're only increasing in stature, increasing in complexity, and increasing in importance. Cloud is a field that I would highly encourage not just people to join, but people to learn that come from a quote-unquote traditional technical background. I think for people with a non-traditional background, when you build on your communication, when you build on your analytical thinking, those will serve you in any field that you apply yourself to. Everybody who has, had to figure out how to run a schedule in their own life, or who's had to figure out, how to juggle school and work and two jobs and whatnot, those are all skills that, once you kind of zone in and name them, you've had them your whole life. All of this is achievable. For example, I'm a college dropout. I never finished college. It's not about the amount of education that you have. It's not about what you've been through in your past. It's really about the ability to learn new skills and putting yourself out there and applying yourself into this world. The world of technology is so vast and it's growing so fast. It may seem overwhelming, but really, zoom in on the one or two skills you want to build at a time, make one step forward after the next step forward, and you know, anybody can do this.
Cloud security tools can help identify and address threats. In this video, you'll explore how to use Google Cloud's monitoring tools to proactively monitor your security. Let's start our investigation by examining cloud logging. Cloud logging is a powerful tool that you, as a cloud security professional, can use to store, search, analyze, monitor, and alert on log data and events. Cloud logging is a key component for lots of cloud security activities. You can use cloud logging to search for log entries while investigating potential threats. For example, imagine you're investigating a potential breach where an unauthorized individual has accessed a cloud application. You want to identify whether there are any log entries that indicate that the individual accessed any sensitive data. In this scenario, you could use cloud logging to query for log entries from the cloud application that the individual accessed. Along with cloud logging, you can use Security Command Center, or SCC, for proactive security monitoring. Let's explore these in more detail. SCC is a security solution that helps organizations improve their security posture by detecting threats and managing risk. Cloud provides instant scalability and elasticity, which allows you to quickly expand cloud infrastructure. But this makes keeping track of each cloud asset very challenging. From a security perspective, you can't protect what you don't know. So keeping track of your cloud assets is essential to managing risk, maintaining your cloud security posture, and most importantly, detecting and responding to threats. SCC provides a centralized view of all your cloud assets. They're displayed in a full inventory, providing comprehensive visibility into your environment. This overview also provides you with a way to evaluate each asset for vulnerabilities, misconfigurations, or errors so that you can address them. One of the most common cloud security issues is caused by misconfigurations. SCC can detect whether cloud assets are misconfigured and vulnerable to attack, helping you mitigate security issues. For example, imagine a media organization provides cloud-based streaming services to its users. But the organization accidentally adds a new critical server to their cloud environment that contains unreleased video content. SCC immediately alerts the security team that there's a misconfiguration in the newly created server. The alert indicates that the server has an open firewall, allowing traffic from the internet to reach the server, which can unnecessarily expose resources to attacks from unintended sources. The organization's security team quickly remediates the issue by adding firewall rules to the server and disabling all traffic coming from the internet. Next, let's examine a component of the Security Command Center, Event Threat Detection. Event Threat Detection is a built-in service for the Security Command Center platform. It provides continuous monitoring of a cloud environment to identify and alert you to any potential threats. Event Threat Detection works by analyzing logs from the cloud logging platform. It analyzes log entries using built-in detection rules. These detection rules then provide security systems with instructions on identifying malicious activity. You can choose which type of detection rules you want to use based on your organization's security needs. An example of a built-in detection rule is a rule that's used to identify and block suspicious account logins. To wrap up, monitoring tools provide cloud security professionals with actionable insights about their cloud environments. So, with these tools, organizations can proactively identify and mitigate threats. How do you know if something in your system has been compromised? Turns out, there are methods to identify potential incidents. In this video, we'll explore a fundamental component of every incident: indicators of compromise. Indicators of compromise, or IOCs, are observable evidence that suggests signs of a potential security incident. IOCs appear as events or signs that suggest a potential security breach has occurred in a network or system. IOCs are a lot like smoke. Smoke warns you that there might be a fire, and fire can mean danger. A potential security breach in a network or system could be a serious issue. So, early detection of IOCs is critical in mitigating threats and keeping cloud environments secure. IOCs link specific data to known malicious activities, processes, or tools. Artifacts like hash values, IP addresses, domain names, or tools can be associated with malicious activity. This is similar to how fingerprints are used to link a known criminal to criminal activity. Here's an example of an IOC. A security analyst receives an alert that a new file was created on a system. The file's hash matches a file hash of known malware. The source IP address also matches a known malicious IP address. In this example, both the file hash and the source IP address are examples of indicators of compromise. It's important to know that IOCs can appear in multiple ways and don't always guarantee the presence of a potential threat. As a cloud security professional, you'll likely engage with IOCs, so it's important you know the best practices for managing them. Let's discuss the 5 general best practices on how to manage indicators of compromise. Proactive monitoring, thorough investigations, risk assessment, timely response, and documentation. Let's start with proactive monitoring. Consistent system and network monitoring helps with the early detection of IOCs. This could include configuring and fine-tuning detection rules to identify anomalies and actively monitor the activity in a cloud environment. Next is thorough investigation. As a cloud security professional, you'll likely investigate IOCs. During an investigation, it's important that you gather all related information to an IOC. That way, you can apply context to its surrounding events to determine if it's benign or malicious. Make sure to be thorough, methodical, and avoid reaching quick conclusions during your investigation. Next is risk assessment. With risk assessment, it's important to identify the systems and data that could be affected by the detected IOC. Make sure you understand the potential impact on your organization and prioritize your response efforts accordingly. Next is timely response. Once you've assessed the potential threat, respond quickly. Your response might include anything from patching a vulnerability to initiating an incident response process. Last is documentation. Make sure to document what IOCs you discover, along with their risk, impact, and anything else that will help you and your team. Clear documentation helps security teams share and access knowledge. It's also a crucial practice that can help improve both future investigations and the overall incident response processes. Now that you know about best practices, let's discuss some helpful tools you can use to manage IOCs. Google Cloud's Chronicle SIEM and VirusTotal are 2 solutions that can be combined to help identify and respond to IOCs. Here's how they work. Chronicle SIEM collects and analyzes event data from sources that can be used to identify IOCs. Chronicle's integration with VirusTotal then lets you investigate IOCs in more detail by providing threat context, reputation data, and information about the relationship between files, URLs, and domains. Along with Chronicle and VirusTotal, Security Command Center offers key features like security services and integrated partner tools that can help you identify and manage threats. It also provides data on potential attack vectors and vulnerabilities, allowing you to respond quickly to potential IOCs. There are a wide variety of tools in Google Cloud, as well as services from multiple providers that are designed to enhance your ability to identify, investigate, and respond to IOCs. Now that you know more about indicators of compromise, you can be prepared to identify and respond to them. This enhances your ability to protect your cloud environment from potential threats. It's often better to take action before an incident occurs rather than responding to one after it happens. In this video, we'll explore the critical role of threat hunting in security operations. We'll also discuss the benefits of threat hunting and the tools that support it, with emphasis on the cloud. Let's get started. Threat hunting is a proactive method of identifying previously unknown threats within a network. Malicious actors often find entryways and pivot points in a cloud environment so they can remain undetected. Threat hunting can help you, as a cloud security professional, actively search for these types of threats in your environment. It's like being a detective in the cyber world, searching for clues and hints to identify a potential breach or attack. While there are lots of benefits of threat hunting, we'll focus on 3 specific benefits. First, threat hunting helps mitigate security threats. Second, threat hunting helps teams respond faster to potential threats. And third, threat hunting helps inform business objectives. Let's explore each of these benefits in more detail. Threat hunting helps mitigate security threats by identifying issues in your organization's systems and networks so that you can take action to prevent them from causing more damage. Threat hunting helps security teams respond faster to potential threats and make better assessments by actively analyzing network traffic for malicious content and gathering data to investigate incidents and improve defenses. Lastly, threat hunting helps inform business objectives. This not only helps intercept possible threats, it also provides insights into the current state of an organization's security. Organizations can utilize this knowledge to align with their business objectives, priorities, and requirements. Next, let's examine one of the most widely used threat hunting frameworks, MITRE ATT&CK. MITRE ATT&CK is a framework used to understand and approach threats. It provides security professionals with a common language to outline and understand attacks. This is done through its knowledge base of attackers' tactics, techniques, and procedures, also known as TTPs. TTPs are based on actual observed security incidents from known threat actor groups. This makes MITRE ATT&CK a very valuable security tool that can be leveraged in threat hunting. Now, let's explore each aspect of TTPs in more detail. Tactics describe a malicious actor's reason for performing an action or technique. In threat hunting, tactics can be used to identify the different phases of an attack. For example, initial access is a tactic that malicious actors often use. The goal of initial access is gaining access into a system or network. This is similar to a heist operation, where the heist team's goal is to find a way into their target. In this example, they do this by discovering an underground access tunnel with a padlocked door they can use to access the zoo. Techniques build on top of tactics by describing the specific actions a malicious actor used to accomplish their goal. For example, malicious actors can exploit unknown weaknesses in public-facing applications to gain initial access into a cloud environment. Weaknesses could be anything that is overlooked or undetected in an organization, like a zero-day vulnerability or a misconfiguration. This is like a heist team planning to use the underground tunnel to access the zoo, and finding a tool that provides initial access through the padlocked door. Finally, procedures are the specific implementation of a technique. For example, a procedure can be the specific system or application vulnerability an attacker uses to gain access to a network, like a SQL injection. This is like a heist team using a bolt cutter to open the lock in the underground access tunnel, which allows them access to the zoo. Understanding the different TTPs that malicious actors use in their attacks can help you map a threat hunting campaign. One approach to threat hunting is to take the perspective of an adversary. You can do this by identifying potential attack paths and focusing on specific indicators of compromise associated with the attack path. MITRE ATT&CK is one of the many tools that can be used in threat hunting. Threat hunting can use a combination of different tools to search for threats in an organization. Let's explore some other tools you can use. Tools like Chronicle SIM can be used to hunt for threats and automatically add more context to alerts so that you can better understand and respond to them. For example, MITRE ATT&CK is one of the frameworks you can apply to threat hunting along with Chronicle. Chronicle's MITRE ATT&CK mapping capability helps you understand prioritize, and improve defensive capabilities. This can be achieved by mapping your organization's security controls against MITRE attack tactics and techniques to uncover potential gaps in your defenses. There are many threat hunting tools available for security teams to use. Threat hunting tools offer benefits in many ways, such as through automated detection, which leverages machine learning and artificial intelligence to detect malicious activities, reducing the time and effort spent on manual investigation. Threat hunting tools also use alert prioritization to prioritize alerts based on severity, enabling you to deal with critical threats quickly. Pattern recognition is used to analyze patterns in data that may indicate a cyber attack, even if that pattern is subtle or complex. With historical analysis, threat hunting tools analyze past activity, which can reveal threats that have been latent or overlooked. That's a wrap on the basics of threat hunting. Remember, in cybersecurity, staying proactive is key, and threat hunting is an important part of that proactive approach. To stay ahead of potential threats and quickly respond to security incidents, organizations need a way to collect vast amounts of data from their infrastructure. In this video, you'll learn about the power of aggregation and correlation. These concepts can help organizations monitor activities, identify patterns, and detect potential threats. Let's dive in. An organization can have many data points in their cloud environments, leading to lots of log data generated by user activities, authentication attempts, firewalls, and intrusion detection and prevention systems. All of this data is important to analyze when detecting and managing incidents. So, the data needs to be properly gathered and consolidated. That's where aggregation comes in. Aggregation is the process of collecting and consolidating diverse forms of data. Aggregation is kind of like farming vegetables. Farmers go through several stages to produce their crops, including plowing land, planting seeds, and watering crops. Farmers plant many different types of vegetables, like tomatoes, corn, or lettuce, on different sections of their land. Once the vegetables are full grown, it's time to harvest them. During a harvest, all of the different vegetables are gathered or aggregated to a central location. Then, they're sent to a processing facility to be sorted. During processing, any damaged or rotten vegetables are removed. After they've been sorted, the vegetables are thoroughly washed to remove soil or bugs. The harvested vegetables are then distributed to grocery stores and purchased by consumers. Just like farmers harvest and process different types of vegetables, in cybersecurity, organizations aggregate data from multiple sources in an environment. By aggregating data like logs and alerts, cloud security professionals can access relevant security data, identify patterns, and gain a comprehensive view of an environment. You might remember that a security event and information management, or SIM tool, collects and analyzes log data to monitor critical activities in an organization. Google Cloud's Chronicle is an example of a SIM tool that aggregates data from a variety of sources, like logs from firewalls and data loss prevention tools. Aggregation collects massive volumes of data. So, how do organizations make sense of it all? This can be done through correlation. Correlation is the relationship between two or more security events. It involves comparing security events, adding context, and making connections between the events. Normalization involves the processing of raw data for consistent formatting. Normalized events improve the performance of correlation. Remember the farming example? Imagine the farmer has plowed the land, planted the fields, and watered the crops. But when it comes time to harvest, the land is very dry, and the farmer finds that the harvest has produced significantly less vegetables compared to previous years. The farmer makes the connection that an extreme drought must have affected the crops, resulting in fewer vegetables. Just like the farmer correlated low harvest yields with drought, in cybersecurity, correlation is used to draw connections between security events. Correlation can be used to address suspicious login attempts. For example, imagine a user logs into an account using a new device, triggering a security alert. The alert then flags the login as suspicious because the user has never logged into their account on this device before. Correlation can be used to cross-reference other relevant data points related to the alert, like the user's commonly used IP address, the date and time of the login, and the user's past login behavior. If the IP address used to log into the device matches the user's IP address, the login was made during regular business hours, and is consistent with the user's login behavior, then the login can be categorized as legitimate instead of a possible breach. Now that you know how to use aggregation and correlation to access data and identify patterns in security events, you can detect and respond to threats more effectively. Being able to sort through large amounts of information is a highly useful skill in cybersecurity. In this video, you'll learn how to sift through aggregated data to find important information. That way, you can support data analysis during the investigation of a potential security threat. Let's begin by learning how to query effectively. When working with logging systems in a cloud environment, you'll likely encounter large amounts of log data from multiple sources. Knowing how to effectively query log data can help you filter, sort, and manipulate log data to find specific information. There are lots of powerful query tools that can be used to do this. One common method is regular expression, or regex, which is a sequence of characters that forms a pattern. Regular expressions use these characters to search text and match specific patterns. Patterns define the parameters of a search. If a piece of text matches a given pattern, regex retrieves it for you. When analyzing logs in cloud environments, you can use regex to search through log data and extract any relevant information you need. For example, imagine you're given an authentication log with thousands of lines of events and need to find out if there's any failed SSH login attempts. You can use regex to specifically search for entries containing the SSH protocol and port number, along with any failed login attempts. Let's check out an example from a Google Cloud Logs Explorer search. Here's a regular expression query that matches SSH log entries. Let's examine each element. The first field, log name, identifies the log file the log entry belongs to. The equal sign and tilde is an operator that tells the application to query using regular expressions. For this example, it's Logs Explorer. Here's where the regex begins. The quotations are used in regex syntax to match a specific string. In this example, the quotations enclose the string SSH. The caret symbol is used in regex to match the beginning of a string. This means it will only find log entries that start with the string SSH. There are lots of different implementations of regex available in programming languages, applications, and tools. For example, with Google Cloud's Logs Explorer, you can use regular expressions to build queries to search through log entries. Searching with regular expressions has lots of advantages, like increased search performance compared to a regular text query. Because of its wide usage across different applications and programming languages, regex syntax can vary depending on the implementation. But what's important to know is the core set of features used to match patterns in text. Let's examine some regex fundamentals. Square brackets are used to match a range of characters. For example, the brackets here enclose the characters A, B, C. This means regex will match any of the characters defined in the brackets. Similar to a wildcard, periods are used to match any single character. In this example, D period G will substitute the period for any other character. It will return match results for texts like dig, dog, and Doug. \S matches any whitespace character like a space or tab. In this example, \S is between small and coffee. This means regex will only match for text that has a space or tab between the words small and coffee. \D matches any digit from 0 to 9. This example begins with a caret symbol, then \D. This will match a string that starts with a digit. The curly brackets contain the number of digits you want to match, which in this case is 5 digits. As you learn more about regular expressions, you'll be able to use these fundamentals in more complex ways to help you find the information you need. The first field rule provides the rule name, different city login. The meta section provides additional information about the rule. Under the meta section, there's events, which specify the UDM events that the rule needs to match on. In this case, the rule is looking for 3 things: user logins, users, and cities. The next section, match, specifies what must be met for the rule to match. In this case, it's user over 5M, which means the rule tries to identify a user who has been logged in within a 5-minute period and ignores all login events that exceed 5 minutes. Finally, the condition specifies the conditions that must be met for the rule to generate an alert. In this case, the rule is looking for UDM events that match what's defined in the match section and that have more than 1 city value. So, this rule will match if a user logs in from more than 1 city in a 5-minute period. If all conditions defined in this YARA-L rule are met, an alert will be generated. In the YARA-L rule you just examined, you might remember the use of UDM event types. Chronicle formats aggregated data using Unified Data Model, or UDM. UDM is a data model used to process and store data. UDM is kind of like a filing cabinet that's used to organize files, or in this case, aggregated log data. Just like a filing cabinet uses clear labeling to identify the contents of a file, UDM organizes data and attaches UDM fields to it to represent important data points. This makes data easier to search through and helps security professionals identify potential threats. With Chronicle, you can perform a UDM search. Through a UDM search, Chronicle searches security data that's been ingested and formatted in UDM. With time and practice, you can learn how to effectively use these querying tools throughout your career. And as an added bonus, you'll be able to save lots of time in log analysis by crafting effective queries. Fantastic work! You've completed your journey through detecting, responding, and recovering from cybersecurity attacks. Let's review what you learned. First, we explored the stages of an attack and discussed false positives. We explored Lockheed Martin's cyber kill chain and navigated each stage of an attack to better understand how advanced persistent threats work. We also reviewed false positives, including their causes and impact on security operations, and how to manage them. Then, we examined how cloud security professionals use security monitoring to monitor their environments. We also covered monitoring tools that are used to configure alerts and detect and respond to potential threats. Finally, we explored common examples of indicators of compromise found in cloud environments. We also discussed how threat hunting is used to uncover threats that evade detection tools. You're doing incredible work. When you're ready, join me in the next video. Hello, and welcome back. You're doing a great job so far. Remember, each new concept, process, and tool you learn helps you become a skilled cloud security professional and a contributor to your team. Previously, you learned about the details of incident detection. Now, let's shift our focus to incident response. In this section, we'll dive into the details of incident response process. We'll discuss the importance of preserving and handling evidence, documenting information, and how automation plays a crucial role in cloud security. And here's a few key topics we'll discuss. You'll go through the steps of the incident response process, including best practices with evidence handling. Then, you'll revisit incident management, where you'll learn more about the response process, including incident identification and team coordination. You'll also have the opportunity to explore how to use a cloud platform when responding to incidents. Then, you'll focus on documentation. You'll learn about alert response, including how to identify actionable alerts. Finally, you'll explore the power of automation including how security platforms leverage automation in incident response processes. I'm here to help you along the way, and remember, you set the pace. Feel free to watch the videos as many times as you like, and review topics that are new to you. Let's begin our journey exploring how to respond to security incidents. I'll meet you in the next video. In this video, you'll learn the importance of preserving evidence in cybersecurity investigations. You'll also learn about evidence preservation, the types of digital evidence you may encounter, the chain of custody, best practices, and how Google Cloud tools can support you. You can think of yourself a bit like a detective on an investigation. Let's explore these exciting concepts together. Imagine the frustration of finding critical evidence of threat actor activity that is unusable due to improper handling or corruption. Evidence preservation is crucial. It allows cybersecurity professionals to ensure that impacted systems have integrity and that evidence is available for a follow-up investigation or to analyze how the incident occurred. That's why it's so important to preserve critical evidence in your work as a cybersecurity professional. You may encounter several types of digital evidence in cybersecurity incidents. Some examples include IP addresses, malware, logs, file hashes, and bad behavior. This type of evidence is also known as an indicator of compromise, or IOC for short. As the term suggests, this type of information indicates or provides clues that a system has been compromised. Each evidence type can provide valuable insights into the incident. As a cybersecurity professional, this digital evidence helps you understand what happened, how it happened, and who might be responsible. It's like piecing together a digital puzzle. Now that you know more about evidence, start to think about what to do with it. How do teams keep their systems from being compromised further while maintaining integrity of the evidence along the way? How do teams work to preserve evidence during an incident investigation lifecycle? As an incident investigation progresses and more people get involved in the process, it's important that everyone maintains the same level of care and integrity so the team can preserve the evidence. During an incident, it's important that everyone follows the same rules in the chain of custody. The chain of custody refers to the process of documenting and preserving evidence in a way that maintains its integrity and establishes a clear timeline for handling. An accurate chain of custody ensures your evidence is reliable and useful in any current or future investigation. To maintain the chain of custody, you should carefully and intentionally document each step of evidence handling, from collection to storage. And you should keep all documentation and evidence in a secure location. What should you think about when preserving evidence? There are 3 important things to consider. You need to capture and store data securely, aim to analyze evidence without altering it, and collaborate to maintain best practices. And the good news is that there are tools that can help. Google Cloud offers several tools and services to support your evidence preservation efforts. Some of these tools include cloud storage, which you can use for secure and resilient data storage, Google Backup and Disaster Recovery, which is helpful for storage and recovery, and Google Workspace, which supports documentation, collaboration, and secure file sharing. These tools can help you maintain the integrity of your digital evidence and streamline your investigation process. As a cybersecurity professional, incident investigations are a key part of the job. Preserving the integrity of evidence for cybersecurity incident investigations is a critical area of focus for you, your team, and your organization. You can use Google Cloud tools to support this process and help you successfully undertake your cybersecurity investigations. An IP address here, authentication attempts there, packets everywhere. It's all evidence in an incident investigation, and all that evidence needs to be preserved. In this video, you'll learn how to preserve evidence and what to consider during the process. Security teams must preserve evidence for accurate investigations and legal compliance. Preserved evidence must be undamaged, unaltered, and documented. Preserving evidence is a team effort. For it to be successful, all team members must recognize the value of evidence preservation and follow the chain of custody. The chain of custody is the process of keeping track of evidence as it progresses through an investigation. As part of the chain of custody, there are mandatory rules and processes. These rules and processes address issues such as unauthorized access and evidence tampering. When following the chain of custody, records and documentation are essential. Clear, accurate, and complete records of an incident investigation helps maintain the integrity of the evidence, ensuring that evidence is admissible and reliable. Organizations can then use that evidence to meet legal, insurance, or regulatory requirements. Proper documentation and collection of evidence helps organizations limit damage, prevent further losses, and comply with regulations. Now that you understand the importance of evidence preservation and how the chain of custody supports it, let's discuss some of the legal and ethical aspects to consider when handling evidence. As a cybersecurity professional, there are 4 key legal and ethical best practices. First, be aware of legal and ethical requirements. Second, balance the need for evidence with privacy rights. Third, collect only what's necessary. And fourth, destroy evidence when no longer needed. So far, we've covered 2 topics that are important throughout the incident investigation lifecycle: evidence preservation and legal and ethical considerations. Now, let's discuss the incident lifecycle and how evidence preservation fits in. Investigating incidents involves 3 phases: identification, incident control, and iterate improvement. In each of these phases, preserving evidence is one of the most important principles to focus on. The first phase, identification, is the phase that new cybersecurity professionals interact with the most. The goal of identification is to provide a foundation of evidence that the team can build from and not have to go back and repair. When identifying and defining the incident in the identification phase, you'll address questions like, what logs, alerts, or events have I observed that make up this incident? What detection rules were triggered? And how can I be sure this is a true incident and not a false positive? Now, let's discuss the unique challenges for evidence preservation when working in the cloud. Cloud resources like virtual machines or containers can be short-lived and automatically scaled. Because of this, you need to collect evidence promptly and create snapshots before any changes occur. Examples of this evidence include virtual machine logs or container operating system logs. When preserving evidence, it's crucial to enforce strict access control management and encryption policies for data at rest and in transit. Logs from any system or device in the cloud are critical. Logs help you preserve integrity and restrict access to collected evidence. Finally, let's discuss a couple tools and services in Google Cloud that you can use for evidence preservation. Cloud logging and cloud monitoring are often used for evidence collection and analysis. These tools help collect, store, and analyze log data from a wide range of sources, allowing you to identify and investigate security incidents. Cloud storage also supports evidence preservation. In cloud storage, identity access management provides appropriate access controls to secure evidence storage. Once evidence is stored, cloud cybersecurity professionals can use features like object versioning and storage bucket policies to ensure data integrity and secure access. Google Backup and Disaster Recovery are designed to create regular, incremental, and secure backups for everything you need in an investigation. The opportunity for evidence preservation is built right into the design of the tool. In this video, you learn the steps involved in preserving and documenting evidence and the legal and ethical considerations to be aware of. You also learned about the incident investigation lifecycle and the tools you can use along the way. Now you know how to handle evidence like a pro. How you respond to an incident will depend significantly on your preparedness. And along with good preparation, using security tools
helps you respond to incidents quickly and effectively. In this video, we'll explore how to apply an incident response process. We'll also discuss incident cases and their lifecycle using Google Cloud for context. We'll focus on SOAR and SIM tools to streamline the incident response workflow. Let's start with some definitions. Security Orchestration Automation and Response, or SOAR, is a collection of applications, tools, and workflows that use automation to respond to security events. Security Information and Event Management, or SIM, is an application that collects and analyzes log data to monitor critical activities in an organization. Now that you know what the SOAR and SIM tools are, let's discuss how they're used and what a typical incident response process looks like. The incident response process has 3 phases. The first phase is identification. In this phase, you start an incident report because potential vulnerabilities and incidents have been identified. The SIM and SOAR tools are very helpful in this phase. They provide valuable information about alerts and events that have already happened, highlighting indicators that the asset may have been compromised. For example, SIM tools collect information from sources in your network. Then, the tools use a set of rules to detect and understand the information so it can be presented to security analysts. Now that the incident has been identified, it's time to move on to the second phase, incident control. There's a lot that happens in the second phase. The main idea is to control the incident's impact. First, you should coordinate with your team and then resolve the issue. While the incident is being controlled, you coordinate and communicate with the rest of the security operations team. You want to make sure that everyone understands what's been discovered and its impact. Next, you work to resolve the incident, limit ongoing damage, fix the underlying issues, and restore normal operations. Additionally, in the identification and incident control phases, the SOAR tools are useful for other aspects of incident response. SOAR programs coordinate communication between team members, assigns tasks, and tracks progress as teams communicate and work to resolve the incident. Now that the incident has been identified and controlled, it's time to iterate improvement. This is the phase in which you improve your security practices by learning from what caused this incident to occur. This enables your organization to improve processes, make plans for continuous improvement, and prevent a similar incident in the future. These steps are critical for security operations teams to evolve and adapt to the changing security landscape. Let's discuss some specific examples to learn more about the incident response process. It's not uncommon for an organization to receive numerous security alerts every day. If cloud cybersecurity teams were to investigate these alerts manually, it would take a lot of time and effort to connect information and determine if the team should act or not. When using a SOAR program like Google's Chronicle SOAR, workflows are automated and alerts are automatically analyzed, so there can be an appropriate response. For example, a SOAR program notifies your team about events connected to a phishing campaign. Your team now has the opportunity to get insight into the attack, learn from it, and mitigate similar attacks in the future. A second example is a distributed denial of service, or DDoS, attack. In a DDoS attack, your team uses SOAR to collaborate in real time to share information about impacted systems, attack patterns, and mitigation strategies. You use that information to coordinate with your team, assign tasks, and enable the team to quickly contain and mitigate the DDoS attack. In this video, you learned the processes and tools involved in responding to incidents. You also learned how a SOAR solution can be used during the response process. With these processes and tools at the ready, you'll be able to respond to events and help your team manage incident response. Imagine there's a security breach at your organization, and you're working on the incident response process. It's your responsibility to help your team better understand the severity, impact, and scope of the breach. How do you accomplish that task? In this video, we'll dive into incident identification, a critical part of any incident response process. You'll learn how to triage and prioritize alerts, collect information, assess potential impact,
and learn the difference between true incidents and false positives. To start, let's consider incident identification. Incident identification involves recognizing potential security threats based on alerts, log data, and other indicators. The key to successful incident identification is to efficiently triage, prioritize, and assess alerts. That way, you can make sure you're addressing the most important incidents first. The initial steps in incident identification are to triage and prioritize alerts. Triaging alerts means categorizing and filtering the alerts based on specific criteria. Prioritizing alerts means you address the most critical issues first, ensuring a timely response to potential threats. When you prioritize alerts, you need to consider questions that help you focus on severity, potential impact, and urgency. For example, a question to help you consider severity might be, how serious is the potential security threat? Next, to consider potential impact, you might ask, what are potential consequences of the incident? And finally, to consider urgency, you might ask, how quickly does the incident need to be addressed? Once you've triaged and prioritized alerts, you get ready to assess the alert by gathering information and evidence related to the potential incident. This might include reviewing logs, analyzing network traffic, or examining user activity. Once you collect this information, you can assess the potential impact and scope of the incident. The assess step in incident identification will help you determine the right course of action for addressing the incident. It's important to keep in mind that not all alerts indicate a real security issue. Sometimes, harmless events like network disruptions or misconfigurations can trigger false alarms. You need to be aware of the difference between true incidents and false positives. To differentiate true incidents from false positives, you need to examine the data and confirm the type of event. Let's discuss how to tell the difference. When distinguishing between the two, you can address the information available with analysis and verification. First is analysis. During analysis, you'll examine the available evidence and context, review for patterns and relationships between data points, and assess whether the alert represents a real security threat. If you discover multiple related alerts and indicators of compromise, your analysis most likely indicates a true incident. Second is verification. During verification, you'll double-check the affected systems for signs of compromise, like unauthorized access or changes to files. If you find evidence of intrusion, the verification likely indicates a true incident. If you don't find evidence of intrusion, the alert might be a false positive. Here's a pro tip about analysis and verification in relation to false positives. Sometimes an incident might be flagged as a false positive and discarded based on the team's current understanding, only to be revealed as a true positive once more information is available. You and your team will always be learning, even in an active investigation. Now you can go into an investigation with confidence. You know how to identify and prioritize alerts to help define the impact and scope of the incident. You also know how to differentiate between a true incident and a false positive to help guide your team down the right path. Ready to explore some key concepts that will help you in your journey as a cloud security professional? In this video, you'll learn more about effective coordination and communication in incident response, and how these practices will help you keep cloud data safe. What exactly is an incident response process? It's a series of events in cloud security operations in which everyone knows their role and responsibilities and does their part to make the response process a success. An effective incident response process is essential because it helps organizations reduce potential harm and keep their operations running smoothly. In incident response, you prepare for potential incidents, detect and analyze them when they occur, and take appropriate actions to minimize the damage. During an incident response process, effective coordination often determines if the response is successful or not. When you've got effective coordination, you and your team work towards the following goals. You manage resources so that all systems and people are communicating effectively. You streamline communication so that everyone knows where they are in the incident response process and what they are responsible for. And you ensure a timely response to security incidents so that everyone knows what's happening now and what to do next. Effective coordination is all about bringing everyone together to work in harmony. That means everyone knows what to do and how to do it. So, what are the must-have tasks for incident coordination? First, you need to set clear goals and objectives. Next, you need to define roles and responsibilities, ensuring everyone knows what to do. After that, you establish communication channels, ensuring everyone can stay connected and share information when needed. Then, you track progress to ensure the team is moving forward. And last but not least, it's important to keep stakeholders informed. This is vital for maintaining trust and transparency throughout the process. When all these tasks come together, you'll have a high-performance team that's working together and ready to tackle security incidents. To effectively address security incidents, you also need the right team members on your security operations teams. Let's discuss some of those roles. The incident manager oversees the entire process. The lead investigator implements response measures and analyzes incident documentation and evidence to determine what caused the incident. The communication lead clearly communicates the progress and resolution of security incidents externally and internally. And finally, the technical specialists are experts in network security, malware analysis, or cloud infrastructure. These team members make sure the incident is understood and resolved. All of these roles on the security operations team work together to protect your organization's data and ensure that security incidents are handled effectively and efficiently. And to get that done, communication is key. Clear, effective, and concise communication is essential to incident coordination. High-quality communication ensures everyone understands their roles and responsibilities and keeps stakeholders informed. In incident coordination, high-quality communication uses standardized terminology, provides regular updates, and leverages secure communication channels. These practices help avoid misunderstandings, keep everyone focused on the incident, and lead to more successful incident responses. You successfully explored coordination and communication in cloud security incident identification. By implementing an effective incident response process and focusing on strong coordination and communication, you can help keep your organization's data on Google Cloud safe and secure. So go out there and use the power of coordination and communication to solve the security incidents that come your way. Documentation is critical to the quality of cloud security for any organization. In a security context, key documentation includes precise and accurate incident reports, evidence logs, and action plans. These documents are foundational to the cybersecurity integrity of organizations across all industries. In this video, you'll learn the fundamentals of documentation so you can be prepared for your role as a security professional. Documentation provides insight into what has happened in the past, direction on what to do now, and what should be done in the future. Well-documented incidents serve as teaching tools for future events that enable you and your team to improve processes, playbooks, and security posture to adapt to increasing threats. There are a few types of security documentation you'll learn more about shortly. These include incident reports, evidence logs, action plans, playbooks, and logbooks. Security operations teams commonly record evidence in these documents. As a security professional, you'll find common types of information in the documents you encounter. Similar types of information might include system events, timestamps, conversations, and changes observed during the incident investigation. And in high-quality documentation, the information is accurate, clear, consistent, and timely. Documentation is also essential for preserving evidence for the purposes of legal investigation. Information like file access and integrity, chain of custody, and actions taken are all critical to maintaining the integrity of the evidence. In the example of digital forensics, files are very easy to change. To maintain the integrity of files so they can be used in legal proceedings, evidence handlers must carefully document the details of the file, including how it was created, how it was secured, when it was transferred to law enforcement, and more. Preservation of evidence is also critical when incident documentation includes sensitive information like system vulnerabilities, recent security breaches, and users with elevated privileges. All of your documented evidence needs to be preserved. The quality and integrity of your documentation will determine whether or not it can be used in the incident investigation. As a security professional, Google Cloud is a useful tool for preserving evidence. Google Cloud provides secure evidence storage solutions that depend on proper authorization and access privileges. BigQuery and Chronicle SIM use secure identity and access management to ensure evidence preservation. Whether they're large datasets that need to be analyzed or logs that need to be aggregated and correlated, that evidence is preserved within those platforms. In addition to preserving documentation, teams use documentation to help guide their operations. A playbook is a manual that provides details about any operational action. By using secured services and tools that work alongside the well-defined procedures and processes in playbooks, security teams improve the likelihood for success when responding to incidents. Now, let's explore those tools in an example. Imagine you're investigating unauthorized access to a Google Cloud storage bucket. First, you create an incident report with the initial events, their timestamps, and all impacted systems. Next, you document the evidence, including logs from cloud logging, and store them securely. Finally, you put a plan into action to mitigate the incident's impact, ensuring that your team has access to your findings. Throughout the investigation, you communicate with your team along the way. By applying this best practice, you ensure that everyone is aware of what's happening and can act quickly. By understanding and applying the fundamentals of documentation in an incident investigation, and using tools to help secure and preserve your documentation, you will set your team up for success. In cloud security, recording your findings is just as important as actually responding to an issue or incident. When you document and communicate your findings, you help others understand the security situation. In this video, you'll learn more about documentation fundamentals, the important elements of documents, and useful information to include. You'll also consider a few tips to help you write clear and impactful documents. Impactful documentation plays a huge role in incident management and investigation. Documentation helps to improve communication with your team, encourages accurate decision-making, and supports the continuous improvement of your organization. To have impact, documentation must be accurate, clear, consistent, and timely. Documentation with these qualities is foundational to the incident management process. Although documentation can take many forms, there are specific elements that help security operation teams to respond to incidents. Those elements are incident summaries, timelines, technical findings, actions taken, lessons learned, and recommendations for improvement. Not every document has all of these elements, but security operations teams do consider all of these elements during the incident response and management process. Now, let's review each element and uncover why they're a part of the incident response process. The incident summary is where you include a quick overview of the incident, including information about how the incident occurred, its severity, and any other relevant context. The incident summary exists so a security operations professional can quickly learn the highlights of an incident and focus on what's important. After the summary in a document, there's typically a section with details about the evidence that prompted the incident response process. This detailed information provides context and understanding of why the incident occurred. This information includes a timeline of events and any technical findings. Examples of technical findings include information such as misconfigurations of cloud settings, evidence of impact, like security logs, system logs, or artifacts, and evidence of a security breach, also known as indicators of compromise. After the timeline and technical findings have been presented, the next documentation element typically describes the team's actions. This is an opportunity for the team to document what they did to mitigate the damage caused by the incident and provide lessons learned for the future. When describing the team's actions, predefined processes or automated responses, also known as playbooks, are included in the document. Incident documentation typically ends with lessons learned from the security incident and what should be done so it doesn't happen again. To document lessons learned, the team would have reviewed the incident to understand and record what went well and what caused the incident. Then, based on their review, the team suggests actions to take that will lead to future improvements. Now that you understand documentation elements, here are some tips to keep in mind when you work on incident response documentation. You should provide actionable information. To do that, use clear, concise, and objective language. By writing objectively and using unbiased information, you can ensure the documentation is an accurate resource for the team. Another tip is to maintain a consistent format and structure across all documents. This ensures the documents are easier for all team members to understand. When working through an incident, it's important to encourage collaboration and communication with your team. You should use consistent language, set clear expectations, and communicate in secure collaboration spaces. And finally, you need to store information in a secure location. This ensures the integrity of your documentation. With these documentation elements and best practices, you'll be well on your way to creating comprehensive and impactful documentation for your security operations incident investigations. How do you know when you need to respond to a potential security incident? In this video, we'll explore how cloud security professionals identify actionable alerts. The incident response process has 3 steps. Actionable alerts start this process in the identification step. In this step, you begin to understand what event has occurred. Keep in mind that events happen whenever there's an observed change in normal operations. Alerts are notifications of the change. Actionable alerts can turn into incidents based on what happens in the event. As a refresher, an incident is a violation or imminent threat of violation of computer security policies, acceptable use policies, or standard security practices. As a cybersecurity professional, it's important to be aware that an incident is something that negatively impacts an organization's normal operations and requires a response. Consider this scenario. Failed login events in cloud identity software happen frequently and are a normal occurrence, so they may not trigger alerts. There are also abnormal failed login events that do trigger alerts because someone tries logging in multiple times. For example, this may happen after returning from a vacation. This is an alert that you note, but it requires no action. One day, you're alerted that a user has a large number of failed login attempts in a short amount of time during their workday from an unfamiliar IP address. This has become an actionable alert that requires you to respond by initiating the incident response process. To help with incident response, security tools provide quick insight into actionable alerts. These tools scan for vulnerabilities and emerging threats and alert accordingly. For example, say you're alerted when there's a high volume of traffic on the network. It becomes an actionable alert or incident when the traffic is coming from protected data storage from an unauthorized user. You know this is an incident because there is a trigger for the protected data storage and another trigger for unauthorized users. Metrics offer great insight into the happenings of a cloud environment. They can be used to measure the what and how of an event related to an alert, enabling you to quickly identify the issue. For example, Say you need to know if there is a high CPU usage outside of regular business hours. You can use metrics to identify the what of the alert, which is the CPU usage, and the how of the alert, which is high activity outside of business hours. Let's introduce 3 Google Cloud tools and services to help with managing events, threat detection, and alerts. First, the Security Command Center. The Security Command Center is a security posture and risk management platform that gives insight into configuration vulnerabilities and incoming threats. Second, Cloud Logging. Cloud Logging is a Google Cloud managed platform that allows you to store, search, analyze, monitor, and alert on logging data and events. Alerts can be ingested from many cloud platform vendors and also from on-premises resources. Third, Chronicle SIEM. Chronicle SIEM is a part of the bigger Chronicle security operations. Chronicle SIEM collects security data and helps you identify the highest priority threats. While security tools, including Google Cloud tools, are essential to any successful security operation, incident response is still a process that's initiated by security professionals. When starting an incident response process, it's important to first capture the event or alert. This requires you to think about the information, its impact, where it came from, and how it affects normal operations. You must document and investigate events early, even if you're not sure they're actionable. This will help you communicate clearly with your team and start an incident response process if needed. This video covered events and alerts, their place in incident response, and how security professionals assess and document findings. To be a thoughtful, action-oriented professional, you need to understand the tools and the information they provide, and how to interpret events and alerts. And by considering each alert's origin, purpose, and impact, you'll have the information you need to decide what actions to take. Addressing security incidents can be complex and challenging in cloud environments. In addition, attacks can happen quickly, while incident investigation takes time. This is where security orchestration, automation, response platforms, and playbooks can help. Let's dive into these concepts. For example, say you're working with a group of expert musicians, and you want to create a beautiful symphony. You need to coordinate the musicians playing each instrument to ensure everyone is playing in harmony. Security orchestration is similar because your security team members are like musicians. And instead of creating a symphony, you're managing an incident response. Orchestration helps you to streamline incident response efforts by coordinating specialized security tools, tasks, and processes. This coordination helps you save time, improve efficiency, and reduce the chances of human error. To help with orchestration, you can use Chronicle's SOAR, or SOAR for short. Chronicle SOAR is Google Cloud's security orchestration, automation, and response platform. Similar to other SOAR platforms, Chronicle SOAR is a collection of applications, tools, and workflows that use automation to respond to security events. To harness the power of these tools, SOAR platforms work with a playbook, which is a manual that provides details about any operational action. Think of playbooks like a musical score that everyone follows to play in harmony. In incident response, playbooks provide predefined procedures that guide security teams through investigating and resolving incidents. Playbooks have defined triggers, which cause security teams to take specific actions and make decisions. This enables fast incident response, helping free up time for security teams. So why should you use playbooks as a security professional? Playbooks have several benefits. They help you automate repetitive tasks to save time and improve efficiency, and ensure consistency by requiring that teams consistently take all necessary steps. Playbooks also help to improve collaboration between security teams. They provide a common framework for communication and action. Playbooks also help security teams reduce risk by automating tasks prone to human error. Finally, playbooks improve compliance by ensuring that security teams follow all necessary procedures. Even better, you can build playbooks into your SOAR tool. In Chronicle SOAR, playbooks can be created, customized,
and deployed to automate incident response workflows. Implementing a playbook helps security professionals effectively manage incidents. Chronicled playbooks begin with a trigger. The trigger is what initializes the playbook. It can be based on an alert from a security solution like an endpoint detection and response platform. Then there's the action. The action conducts an operation. For example, for a phishing incident, you might want to define an action like blocking the suspicious IP address that sent the phishing email. Lastly, there's the flow. The flow determines the progress of the playbook. It defines decision-making substeps in the form of conditional statements. For example, imagine your organization receives an alert about a possible phishing email. You can use a playbook in Chronicle SOAR that automates each manual step involved in the incident response process of a phishing alert. This response process includes identifying and blocking malicious IP addresses, alerting the affected users, and resetting compromised passwords. Instead of having to toggle between different security platforms to perform an action, you simply let the playbook do its work. Here is an example of a phishing playbook in Chronicle's Playbook Designer. It's a simple flowchart with steps. Each step defines the triggers, actions, and the flow of the playbook. All these components work together to integrate and orchestrate tools used by the security operations teams. Platforms like Chronicle SOAR and their playbooks can help you automate and coordinate systems during an incident response process, improving efficiency, aligning goals, and reducing the likelihood of human error. Keep in mind that SOAR playbooks for incident response are not 100% automated. Security analysts still need to customize and monitor playbooks to ensure they follow the correct process and that they're effective in incident response. In addition, security analysts may need to take manual actions that are not automated, such as investigating alerts or communicating with stakeholders. When making a SOAR playbook, keep in mind a few best practices. First, make a plan. Prioritize tasks and processes in playbooks that are prone to human error, take a long time to accomplish, and have high impact. Second, build with strategy. Make sure playbooks follow processes that align with your organization's goals and industry best standards. And third, iterate. Learn from past incidents and continuously refine and adapt playbooks to ensure that they stay effective. As a security analyst, you can use automation and playbooks to simplify tasks and improve workflows to help you and your team. Platforms like Chronicle SOAR are a big help in incident response, so consider SOAR when you need to improve response efficiency and avoid errors.
My name is Fatima, and I'm a tech lead manager on Google's detection and response team. My role at Google requires me to stay up to date with the cybersecurity threat landscape and make decisions about what we need to build so we're in a good position to detect any cyber attacks against Google or Alphabet. It took me a while actually to get to cybersecurity and to understand that was the place I wanted to go. When I was in high school, I got the opportunity to work in a law firm, really making copies. Like my job was, I was called a copy kid because I was a kid who made copies. And at one point, I just started working with their IT systems and just trying to fix things here and there when things would break. We would have people who would lose important work documents or really cherish family photos. So I was exposed to that part of cybersecurity, the very human part, right? That it's not just a nuisance that somebody experiences on their computer, but it can really affect them in a different way. At that point in my life, I decided that cybersecurity was something that I wanted to pursue professionally. I wanted to fight the bad guys on the internet. Cybersecurity is like a performance. It's something that you prepare for a long time. And then one day it's time to put on the show. You have to be ready. You have to be ready to perform, and you have to be ready to perform at your best. For somebody who's just starting a career in cybersecurity, I would say learn how to code. Coding is extremely important. And learn the basics. Learn about networks. Learn about operating systems. Learn about web vulnerabilities. So learn all the fundamentals really well. and then after that, decide really what you want to focus on. What I've learned in my career is that nobody has a magic recipe for success. Everybody's just trying their best, and they're trying to figure it out in the moment. You might think that this other person just knows better and they have some magical skill that makes them more fit to do this type of work. I'm going to tell you that doesn't exist. The only thing that exists is really hard work and learning and developing your skill sets, and eventually you get better and you kind of move on to that next phase of your career or your life. But nobody has that kind of magical recipe and knows all the answers. Everybody's really just trying their best.
Congratulations! You've completed this section. You now have the foundation you need to successfully respond to a security incident. You'll also be able to share your newfound understanding with future employers and other security operations professionals. You've learned a lot. Let's do a quick review. First, you learned about the incident response process and about preserving and handling evidence like a pro. Next, you learned about the Chronicle SOAR and Chronicle SIM platforms that security teams use during incident response process and how they provide oversight and access to multiple tools and information at the same time. Next, you learned about attributes of high-quality documentation, what great documentation should look like, and how to address documentation during an incident. After all, an incident investigation is only as good as its documentation. Finally, you learned about the tools of the trade and how to leverage automation to work smarter, not harder. You also learned about playbooks and how they enable you to focus on the important aspects of incident response process. Continue moving forward on your learning journey and keep building your foundational understanding of the incident response process. Great work! Hi, and welcome back. Coming up, you'll learn all about the importance of recovery after a security incident. Then, you'll be introduced to critical aspects of business continuity and disaster recovery, or BCDR, including cloud BCDR tools used to maintain business continuity. Next, you'll learn how to measure recovery plans for success using key recovery metrics. Finally, you'll examine the relationship between disaster recovery and business continuity, best practices to apply, responsibilities of security professionals working on recovery, and stakeholders involved in recovery efforts. As a security professional, learning the fundamentals of recovering from a security disaster will help you effectively communicate with other professionals and support your team. So, are you ready to get started? Meet you in the next video. How do you ensure that business operations continue to run when disaster happens? In this video, we'll explore a critical skill for any cloud security professional, executing a recovery plan. We'll also provide you with practical examples, so you know what to expect when a plan is implemented. Let's get started. A recovery plan is like a roadmap. It's a detailed guide that steers you on the path to restore operations in case of a disaster. This roadmap isn't just about returning to where you were before the disaster. It's about leveraging the experience to learn, grow, and improve. A recovery plan isn't a static document. Instead, it evolves over time as you learn from past incidents and adapt to new threats. As a security professional, you'll contribute to this growth and help your organization become more resilient with each challenge. As a security professional, you'll likely be involved in recovery efforts. But it won't just be you. Every person in an organization plays a role in the recovery process. Responsibilities during the execution of a recovery plan include assessing the situation, supporting the decision-making processes, communicating with stakeholders, and running specific recovery procedures. Now, let's apply these concepts to some scenarios. Imagine ransomware gains access to your network. Operations come to a standstill, and critical data is lost. This is a difficult situation, but with a well-executed recovery plan, you and your team have options on how to respond. The recovery plan becomes your roadmap. It guides you to quarantine parts of the system that have been infected, eliminate the ransomware, restore the data for backups, get the system back online, and prevent significant downtime while resolving the issue that allowed it to happen. And remember, the recovery process isn't over when the system is back up. You need to learn from what happened. Take the opportunity to analyze what went wrong, why it went wrong, and how you can prevent it in the future. In the event of an active cyber attack, the recovery plan can be your defense playbook. The recovery plan, serving as a playbook, can help you isolate affected systems, remove the threat, and then restore the systems to their previous state. In this video, we explored the crucial role of recovery plans and their impact on systems, teams, and organizations. Every plan, when put into action, is a chance to respond to an incident, learn from what happened, and help prevent a disaster. Not everything goes according to plan, but that's okay. With each challenge, there are opportunities to learn and improve. In this video, we'll discuss a critical area that affects all of us working in Google Cloud environments, the recovery process. To keep systems running smoothly, you need to be prepared for the unexpected. Whether it's a cyber attack, natural disaster, or internal error, you'll need to be able to recover quickly and efficiently. How well security operations teams can recover from a security incident can mean the difference between a minor inconvenience and a major catastrophe. So, how do you restore systems to their normal operations? If you need to get your systems back up and running on Google Cloud, there are a range of helpful tools available. With services like Google Cloud Backup and Google Cloud Disaster Recovery, you can quickly restore your data and applications. Plus, Google Cloud Storage and persistent disk keep your data safe and secure, so you won't have to worry about losing any of your data. After restoring your system, it's important to ensure that all components are functioning properly. Platforms like Google Cloud Operations Suite can help. The suite allows you to keep track of system performance, set up alerts, and prevent future issues. It's an excellent tool for maintaining your system's functionality and for confirming functionality after restoring your system. As a security professional, knowing how to manage recovery effectively in Google Cloud will help you in your professional development. As you develop skills in disaster recovery, you can help build trust with your team and the broader organization by ensuring business continuity in the face of disruption. Business continuity, or BC, is an organization's ability to maintain their everyday productivity by establishing a risk disaster recovery plan. When you support business continuity in the context of cloud security, keep in mind that the cloud environment is dynamic and continuously evolving. So over time, you'll find new tools and services to help enhance your recovery processes. Your knowledge of the latest tools and desire to continuously learn is a big advantage in the recovery process for your organization. So stay curious. As a cloud security professional, you need to understand the importance of the recovery process, the tools you can use, and how to best support your organization when restoring systems. Yet, in the fast-paced world of cloud operations, your duties may extend beyond just restoring services. You also need to guarantee data integrity, preserve users' trust, and face any obstacles with confidence. By consistently exploring, learning, and retaining knowledge, you can become more valuable in this ever-changing field. And your company and coworkers will certainly appreciate your contributions. Knowing how to respond in a crisis is a valuable skill in cloud security. In this video, we'll explore an area that is critically important for any cloud-based operation, business continuity and disaster recovery, or BCDR tools. Let's get started. So, what's BCDR all about? Simply put, business continuity and disaster recovery are like a safety net. They're critical in security operations because they ensure that when disaster strikes, business operations are active and data remains safe and accessible. There's a variety of BCDR tools available to security operations teams, each with its unique purpose. These tools can range from BCDR plan builders and backup and restore utilities to sophisticated software that handles data center failovers. And all these BCDR tools all share a common goal: to protect your business from the negative effects of a disaster. These tools can also help you make and execute a plan to restore your systems and get data back online. They ensure you can continue normal operations and continue serving your users without any interruption. So, no matter the size or scope of the problem, there's a BCDR tool available to help. Now, let's explore BCDR in Google Cloud. Google Cloud offers BCDR tools designed specifically for its cloud environment to assist with regular backup and recovery operations. As a security professional, Google Cloud BCDR tools help with key aspects of business continuity and disaster recovery. For example, you can test and establish backup and recovery processes, test data management, and verify a documented backup plan. Here's an example. Imagine your team can't mitigate a ransomware attack in time. Multiple systems are affected, so you need to utilize backup and disaster recovery tools to restore normal operations. Before you begin the process of restoring the affected systems, you need to prioritize the restoration of critical business systems. First, you isolate the affected system, like a server or virtual machine, and terminate the ransomware task. Then, you restore the system to the most recent recovery point from the last unaffected backup. By using cloud-based BCDR tools, your security operations team can be confident that completely different infrastructure is in use, rather than a compromised network. Once the new system is running, the security team connects the recovered system to the network so that end users can return to work and operations can continue. So remember, these BCDR tools are not just pieces of software. They're what you can use to ensure your business continues to run smoothly and efficiently during disaster recovery. Hello, and welcome to the next step in your cloud security journey. In this video, we'll explore the critical world of business continuity and disaster recovery, or BCDR for short, within Google Cloud. BCDR ensures your operations continue despite unexpected disasters or threats. Google Cloud provides lots of tools that integrate seamlessly with BCDR planning and execution, making protecting your organization's data easier. That way, you can keep your services running after a disaster. Let's examine a BCDR tool in Google Cloud. Google Cloud Backup and DR is a backup and disaster recovery solution that enables organizations to quickly recover data so that they can continue running critical business operations. To get started with Google Cloud Backup and DR, you'll need to first create a backup plan. You can use the backup plan to define the parameters of your backup. For example, how often to back up your data, how long to retain the backups, and where and how to replicate the backups. Once you've created your backup plan, you can restore your data whenever you need to with just a couple clicks. For example, if your organization is targeted by ransomware, employees might not be able to access files encrypted by the ransomware. Business operations will be negatively affected, and employees won't be able to do work until they can access the data. After the security team successfully contains the ransomware, you use the backup plan to quickly find and deploy a backup that has not been infected with ransomware. This allows you to quickly recover your data and get operations back to normal. We've reviewed backup plans, but what about disaster recovery plans? Let's examine what you should consider when creating a disaster recovery plan, or DRP, within Google Cloud. For example, it's important to consider how backups will be set up through replication, what your measures of success during a recovery are, and what happens if there's a failover. You'll also need to test the plan and have maintenance strategies. And lastly, you should consider the cost implications of a disaster. This includes the cost of downtime if your organization is unable to operate, and the cost of restoring data. Let's discuss these considerations in more detail. First is replication, or the process of continuously creating copies of data to multiple locations to support availability. Replication is vital to any disaster recovery plan because it helps ensure that data can be quickly restored. While working in the cloud, it's important to consider replication options that utilize storage in different regions of the world. For example, OnVault can be used to safely store backup data from virtual machines. Another option is StreamSnap, which is used for data mirroring. Data mirroring creates exact copies of data in remote locations. This provides opportunities for replication across multiple regions to improve data availability during a disaster. Now that you've learned how data is backed up, let's discuss measures of success. These include how often data backups happen and how quickly you'll need to get business operations back to normal when carrying out a disaster recovery plan. In a disaster recovery plan, you need to decide how much data can be lost
and how long systems can be down. Both are critical measurements of success for a disaster recovery plan. Google Cloud's compute, storage, networking, and software services can support your team in making these objectives possible. Next, let's examine failover, which helps protect systems from failure. For failover scenarios, deploying Compute Engine and managed instance groups can provide automatic failover in the event of an instance or zone failure. For example, imagine your organization uses Google Cloud to run a critical application on Compute Engine. The application is deployed in a single zone. Keep in mind that a failure in one zone affects all the resources in that zone. So, if the organization wants to improve the critical application's availability, they need to add failover. The organization can achieve improved application availability by creating a managed instance group with 2 instances located in different zones. The application can then be configured to run on both instances. If one instance fails, the other instance will continue to run the application. As always, testing your disaster recovery plan is crucial. In the previous example, the organization can also set up regular disaster recovery testing to verify if the failover works as intended. As a security professional, you can test your plan periodically and conduct tests to simulate a computer instance failure. If the testing fails, you are alerted and can investigate and address the issue. Conducting regular disaster recovery testing will ensure your plan is effective and can help you identify improvement areas. Finally, here's a pro tip. Maintaining your disaster recovery plan is key. Your company's cloud presence will change over time, and your disaster plan needs to change accordingly. Your plan needs regular maintenance to stay current. Now that you know more about setting up and maintaining a backup and disaster recovery plan in the cloud, you're well prepared to help your organization navigate security disasters with confidence. In this video, we'll explore one of the most critical aspects of a security professional's role, disaster recovery. Recovery is more than just a backup plan. It works alongside prevention efforts. But when prevention doesn't work, and disaster occurs, a speedy and efficient recovery is essential to keep business operations running smoothly. Recovery is a team effort. All members of a security team must know how they contribute to recovery processes. They also must maintain awareness of business continuity standards and timelines. Business continuity ensures that your company's operations are uninterrupted at all times. And when a disaster strikes, recovery is a corrective measure that can get your company back on track. There are several recovery options to use in the event of a disaster, but the recovery option you choose will depend on the type of security disaster you encounter. To help you make the right call, let's review the different types of recovery options. Backup restoration is a common practice and recovery option security professionals use to recreate a system from its most recent stable backup. Another recovery option is redundancy, which is the practice of having multiple copies of data in different locations to avoid a single point of failure. Copying data across multiple zones has a lot of benefits. It improves the availability of cloud resources and prevents potential disruptions in the event of a failure or disaster. For example, if System A fails, a redundancy mechanism can automatically start, allowing System A1 to take over to minimize downtime and maintain availability. Cloud providers like Google Cloud provide backup and restore recovery options and replication for databases, giving security professionals a quick way to recover lost data. To support backup and restore efforts, cloud providers offer failover and redundancy services. These services manage heavy traffic loads using load balancers. Load balancers improve the performance of services or applications by distributing network traffic across resources. In the context of recovery, if a server fails or suddenly becomes unavailable, load balancers identify this change in server performance. Then, load balancers work to provide availability by evenly distributing traffic across the other servers. Another recovery option is warm standby. With this strategy, a duplicate system is always running in the cloud, but on a much smaller scale. The duplication is fully configured and operational, so in case of a disaster, security professionals can scale up the system to run quickly. Now that you're familiar with a few recovery options, let's discuss how security professionals use these recovery options on the job. Disaster recovery strategies are included in a disaster recovery plan, or DRP for short. A DRP is like a to-do list that includes the details you need when a security disaster occurs. A DRP also includes measures of success. The success of a recovery effort is not only when a business returns to normal operations, but how quickly the recovery happens, and what data is lost when the system is down. These measures of success are known as Recovery Point Objectives, or RPOs, and Recovery Time Objectives, or RTOs. A Recovery Point Objective, RPO, is the maximum acceptable length of time during which data might be lost from an application due to a major incident. A Recovery Point Objective defines how much data you can afford to lose if a system goes down. As a security professional, an RPO informs how often you back up your systems and how you use redundancy. RPO also typically involves a data backup policy. For example, during the event of a failure, a financial organization like a bank needs a low RPO. In this context, a low RPO ensures that the bank can restore its data as close as possible to the point of failure. Not only does this minimize potential data loss, it provides the bank's customers with access to their information. However, a small local bookstore that uses manual data entry might not need a low RPO, because losing a few hours of their data during a failure might not significantly affect their business operations. Recovery Time Objective, RTO, is the target time allowed for the recovery of a service in the event of a disaster. An organization's RTO is how long they can afford to wait until data is restored from a backup, or how long a system can be down before it's back up and running after a failure. For example, if an organization specifies their RTO as 1 to 2 business days, this means they can accept 1 to 2 business days of downtime in the event of a disaster. In this video, we explored recovery and discussed how recovery strategies like backups and redundancy can be applied and measured using RPO and RTO. Keep in mind that when prevention isn't enough, recovery steps can help you get your organization up and running, even after a security disaster. Organizations often create disaster preparedness plans. By planning in advance, organizations can better navigate challenges and unexpected events. Security professionals also plan for unexpected events. In this video, we'll explore disaster recovery planning, also known as DRP. When all else fails, a well-constructed DRP ensures that business operations can continue. It's the survival kit that keeps an organization going during unexpected disruptions. Let's unpack the kit and explore each of the 4 key components of a disaster recovery plan. The first component of a DRP is roles and responsibilities. Having an established list of roles and responsibilities ensures your team knows how to communicate and collaborate with other employees, vendors, and customers. The second component of a disaster recovery plan is critical systems, applications, data, and resources. The DRP should include documentation of which systems, applications, data, and other resources are most critical for business continuity, and how to bring them back online when they're down. The third DRP component is to make plans for testing and optimization. It's important that your team continues to test and update its strategy to address ever-evolving threats and business needs. The fourth DRP component is a risk assessment. A risk assessment considers strategies for potential hazards and the necessary resources to resume business operations. The assessment should include clearly defined recovery point objectives and recovery time objectives. Remember, a recovery point objective, or RPO, is the point in time to which data must be recovered after a disruption occurs. For example, imagine you're working on a crucial project that depends on a constant stream of live data. Suddenly, without warning, your system crashes. The clock is ticking, and each passing second means more data is lost. How much data can be lost before it starts to impact the company? 30 seconds worth of data, 30 minutes, or 3 hours? These are questions RPOs are meant to answer.
A recovery time objective, or RTO, is the maximum acceptable amount of time allowed for the recovery of a service in the event of a disaster. When setting an RTO, security professionals need to know the maximum amount of time a system can be offline. To figure out the answer, they'll ask questions like, how long can business operations dependent on a specific system be down? And how quickly does the system need to be operational before the impact becomes severe? For example, imagine you work for a global financial technology company that provides financial services through a cloud-based app. Their services are accessible to millions of customers around the world at any time of day. One day, the company is targeted for a distributed denial of service attack. The attack overwhelms the company's servers and systems, causing the app to go offline. The outage causes severe service disruptions, impacting customers all over the world in an instant. Unfortunately, your team's efforts to mitigate and resolve the attack are not successful. Your defenses are overwhelmed, the system stays down, and the app remains unreachable. Your last line of defense is the disaster recovery plan. So the team activates the cloud-hosted DRP, which outlines the steps the team needs to follow to recover critical cloud resources. Your team's designated personnel, including security engineers and stakeholders, access the DRP. Now, everyone on the team knows their roles and responsibilities and collaborates effectively to get servers and systems back online. By leveraging the scalability and distribution of the cloud, your team is able to redirect and recreate network traffic, computing, and data from failovers and backups. All of the redirection and restoration efforts are then guided by predefined RTOs and RPOs, ensuring that downtime and data loss are within acceptable limits. Critical systems then come back online, and the bank's customers are able to access the app once again. As you might imagine, this recovery process is not an everyday action. It's the safety net when everything else fails. Now that you've explored the components of a disaster recovery plan and worked through a security scenario, you understand the process to support recovery when the unexpected happens. Ready to learn more about a vital part of cloud security? In this video, we'll discuss the differences between business continuity and disaster recovery, also known as BCDR. We'll also discuss how to build BCDR plans and examine how they're used in Google Cloud. Business continuity, or BC, is an organization's ability to maintain their everyday productivity by establishing a risk disaster recovery plan. Disaster recovery, or DR, is a strategic and systematic approach to recovering essential infrastructure and systems when a disaster happens. Business continuity and disaster recovery work towards the same goal: ensuring your organization is impacted as little as possible during a disaster or event. Security professionals often refer to these two concepts together as BCDR. Let's explore disaster recovery and business continuity plans in more detail. When building either of these plans, there are 3 considerations to keep in mind. First, both plans start with a risk assessment. A risk assessment helps you and your team identify threats and evaluate their impact. This can also help you thoroughly document and set up a priority list. Next, a business impact analysis is necessary for you and your team to identify which critical operations need to be prioritized when a disaster happens. And finally, organizations use strategic planning to outline various disaster scenarios so they can focus their efforts on minimizing disruption, recovering lost information, and restoring regular business operations as soon as possible. All 3 of these considerations are necessary for teams to create business continuity and disaster recovery plans that help ensure successful outcomes. Both plans consider what systems need to be prioritized and how to address prioritized systems during a disaster. But each plan considers these factors differently. Every organization is unique, so each organization's goals and plans for disaster recovery and business continuity must be tailored to their needs. Let's explore some of the tools and features in Google Cloud that a security team can use to implement both BC and DR plans. An important part of Google Cloud's BC and DR strategy is using the BCDR recovery tool.
This tool is a powerful asset that provides additional assurance that your systems can get back up and running quickly after a disaster. Also, Google Cloud's automation features allow for automatic backups and failover systems. This key feature ensures that your data remains intact and your operations continue functioning even when disaster strikes. Business continuity and disaster recovery plans are important for any security team, and they should be tested continuously. Now that you know more about BC and DR plans, you can build effective plans to manage disasters and support your organization. As a security professional responsible for disaster recovery, it's important to consider who is impacted by a situation as you respond to it. In this video, you'll learn about the important role stakeholders play in disaster recovery planning. Because they're usually the decision makers, stakeholders should be prepared to participate when security disasters happen. There are 3 main groups of stakeholders that work in and around a disaster recovery plan. The first group includes executive stakeholders. These stakeholders are the decision makers. They establish the budget and outline the strategic course of action for recovery. A Chief Information Officer, or CIO, is an executive stakeholder. The CIO is responsible for setting the stage for the recovery process. They consider business requirements and technological capabilities, so they're ultimately accountable for a successful recovery. Next are operational stakeholders. Operational stakeholders work with executive stakeholders to ensure that recovery plans meet the organization's requirements. They're also responsible for implementing the plans. For example, managers of a security operations team are operational stakeholders. Managers implement the CIO's plan. Finally, technical stakeholders form the first line of defense in the event of a disaster. They work with operational stakeholders to make sure their organization's systems are safe and can get back up and running. During a disaster, technical stakeholders are responsible for the initial fallout. They document and mitigate risks and address any issues that arise. They also coordinate responses, implement emergency procedures, and help in the recovery process to restore operations with minimal downtime. They may have different roles, but these stakeholders don't work alone. Instead, they work together and communicate effectively to help an organization fully recover. Effective and timely communication keeps information moving so that everyone understands their responsibilities and can perform their duties when the time comes. What happens when existing communication channels become compromised or unavailable? It's important for teams to consider the possibility of limited communication and implement solutions in advance. This is where out-of-band communications come into play. Out-of-band communications are alternative methods of communicating that can be used when normal channels become compromised or unavailable. These methods are especially important to ensure stakeholders and team members can communicate during an event or disaster. In large organizations, it's common for teams to perform disaster recovery processes in isolation from other teams. Disasters can have wide-ranging impacts on an organization, so members from different departments, like legal or compliance, need to be aware of disaster recovery efforts. So, it's important to maintain communications across teams during disaster recovery to keep everyone up to date. While stakeholders have different roles, there are a few key things they should all be able to do during a disaster. First, stakeholders need to understand their role and what responsibility they have in their organization. Next, they should be able to implement clear and timely communication. And finally, stakeholders should value their role and the contributions they make during recovery, because they're an essential piece of the recovery effort. A successful disaster recovery plan depends on the coordination and communication of its dedicated stakeholders. The people who come together in a collaborative effort to recover from a disaster need to communicate effectively, share an understanding of recovery efforts, and acknowledge each stakeholder's role in the process. Nice work on completing another section. You've learned a lot. Let's take a moment to quickly revisit what you've learned. First, you learned about the critical aspects of recovery. Then, you learned about business continuity and disaster recovery, including tools and best practices. You learned about key recovery metrics that organizations consider when recovering information, like determining how long systems can remain down and how much data can be lost during a disaster.
Finally, you learned all about responsibilities and stakeholders involved in recovery efforts and the relationship between business continuity and disaster recovery. Business continuity and disaster recovery is a critical part of an organization's security posture and response efforts. As a cloud security professional, you'll utilize BCDR tools to efficiently respond to security incidents and maintain operations.
Hi, I'm Patrick.
Hi, I'm Pedro.
It's time for another chance to join an interview that's in progress. In this interview, topics will cover cloud cybersecurity questions related to detecting, responding, and recovering from attacks.
We hope this will help you prepare for your next interview.
Hey Pedro, what interests you in a career in cloud cybersecurity, and what are you looking for in a new role?
Well, my background is in computer science, and I'm really interested in dealing with problems that have to do with scale. And all cloud does is centralize your infrastructure for your customer, for your project in one place. And it lets you focus on problems that are actually interesting instead of physical, for instance, like where is the data? Who's protecting the data center? And what I want out of a career in cloud cybersecurity is to grow. I want to learn, I want to find new problems and solve interesting challenges.
Tell me about a time you faced a challenge and how you responded.
When I started in sophomore year and I asked my professor whether or not I wanted to do research, he asked me, do you even know what that entails? And I said, absolutely not. And he was like, well, pick a topic, go figure out what a problem is that you think you can solve and would be interesting, and go solve it. It turns out that solving that is way more involved than you think. And it involves having and developing a variety of skills that you might never even have thought were relevant.
How long did it take you to find the topic?
About 6 months. We were dealing with IoT devices and cryptography, and I was trying to find some way of mixing those together. And we ended up measuring basically the performance efficiency of a yes on hardware in IoT. And just digging into that whole space, I realized that my interests lie in performance efficiency and cryptography, and those kind of mix the two together.
Pedro, could you give me an example of an incident that a cloud-based organization might have on their infrastructure? How could a cloud cybersecurity analyst detect such an incident?
So in the case of Log4j, there's a few ways that you might go about it. Number one, you might go for what's called static analysis. You might use Google Cloud's managed infrastructure to determine which packages are running the vulnerable versions of Log4j. Another way is you might look for indicators of compromise, IOCs, in the logs themselves, and you might use something like Google Logging and the Chronicle SIM to go and identify the places where the vulnerability was carried out successfully. And finally, you probably want to spin up a generic incident response team that handles any edge cases that you haven't thought of in advance, because the chaos always happens.
So from the Log4j example that you gave, what is a positive takeaway that you got from detecting such an incident?
One thing the world learned about as a result of the Log4j thing is to be scared of strings. I think the entire world is much more familiar with the concepts of string interpolation and the implications that might have. And as a result, it brings kind of these high, complexity, hard computer science topics, like what is string interpolation? And it makes you realize, maybe I should learn about that.
Let's suppose you're going to use cloud data security controls to detect data storage related incidents. What are some examples of tools they would use, and what do they detect?
So the very first thing I would do for my own managed infrastructure on cloud is look at the severity of the data. Are we talking PII, private information, or are we talking machine-to-machine transactions? And for this, I would rely heavily on cloud logging. I need to know exactly what information was being stored and who accessed it and at what time, and start correlating some of the activity around the access of the data to see exactly what happened.
Okay, so let's say you start doing that and you start seeing some of the logs and such, but you're not really sure what's going on. What would you do if you had concerns about the people that access the logs? Like who accessed the logs and why did they access it?
Yeah, no, this is a big problem, and it's actually solved, at least in part, by cloud, but this concept called audit logging. So you might have process logging that tells you what's happening on a system, which port is talking to which port, that kind of thing. But access logging is more like who touched the data, with what justification, was that a valid access, did someone else authenticate them on their behalf saying that they could perform such an action. And so we definitely, in addition to the analysis around what happened for the incident, would want to go and look at any data accesses, both during the incident and afterwards, right? We have to make sure that our responders are also following the rules.
So imagine a scenario where you're responsible for writing an incident report. What are some critical pieces of information that must be included in the report?
The report is super important, and it's very multifaceted too. So there's a part about the incident itself, right? How severe was it? What were the affected assets? What are the indicators of compromise? And ideally, you share those out broadly and contribute back to the community. So there's that kind of the incident itself and the outcomes and the learnings. But then there's also the organizational side, right? Where did we succeed? what were some misses? What are some opportunities for improvement? And it's always really important to include those two sections because you have to focus in on the fact that you are doing a good job and you are improving on catching these incidents.
Pedro, thank you. That's the end of the interview. And now it's your turn to ask me any questions you might have.
From your perspective, what keeps you up at night about information security?
The one that I feel like I'm thinking about a lot that I don't hear very often is that the ever-increasing layers of abstraction that we put onto all of the world's infrastructure have made it impossible for a person to actually reason about the risks of that infrastructure. And therefore, it's really hard to secure it or solve it.
Yeah, and that problem is not going to get easier to solve over time, especially as the cloud infrastructure scales.
Thanks for watching. In this scenario, Pedro demonstrated how to end responses with positive takeaways when answering questions. During an interview, you can demonstrate your ability to learn from your experiences and recover from difficult situations by sharing positive takeaways when relevant.
You made it to the end of the course. Congratulations, you did it. Personally, I love working in cybersecurity because it's ever evolving, challenging, yet so fun and rewarding. You get to help make the digital landscape, from everyday systems to emerging technologies, a safer place for everyone. You're well on your way to helping protect people and assets in the cloud. We've covered quite a bit. Let's take a moment to review what you've learned. First, we began with the foundations of incident detection. You learned about the role of security operations in detecting and mitigating threats. You explored these phases involved in incident management. And you considered the fundamentals of logging and the importance of monitoring and detection tools in providing alerts and notifications. Then, we focused on applied detection, where you learned about how cloud tools and techniques are used to identify threats. You learned about the anatomy of an attack using Lockheed Martin's cyber kill chain and the importance of managing false positives and alerts. You also explored cloud monitoring tools, indicators of compromise, and proactive detection through threat hunting. Next, you learned all about the various processes involved in incident response, such as importance of evidence preservation, effective documentation, and optimizing response through automation. Finally, we ended with incident recovery, where you learned about how security teams recover from a security incident using business continuity and disaster recovery planning. You learned a lot about incident response in the cloud. Great job! As a cloud security analyst, you'll find yourself dealing with challenges related to incidents. You'll use what you learned in this course to better manage the incidents you encounter. Coming up, you'll apply all you've learned in the final course with a capstone project. Good luck!
Welcome to the Career Preparation course. You're so close to being ready to apply for cloud security jobs. In this course, you'll put everything you've learned together to prepare for success in your job search. First, you'll learn ways to update your resume and portfolio to showcase the cloud security principles you've learned from prior courses. Next, we'll explore the interview process, including how to prepare for some common interview questions. Then, you'll apply your new skills and knowledge to create a capstone project that brings together all of your skills and knowledge from this course. Let me introduce myself. My name's Louis. I work as a cloud security architect at Google. This means that I blend security expertise, sales knowledge, and consultative skills to help companies establish and demonstrate cloud security. In my job, I help when a customer has a security objective to fulfill, but doesn't exactly know how to do so in the cloud. For example, they need to log activities and configure alerts so they're notified of suspicious actions. In this case, I guide them step by step to ensure they're logging the correct activities, configuring their alerts correctly, and ensuring that Google Cloud security recommendations are applied. You're almost ready to showcase your new skills and begin applying for cloud security jobs. To get you started, we'll explore the cloud cybersecurity hiring process, including how to search for jobs. Then, we'll give you tips on how to update your resume and portfolio to reflect your skills and expertise so you can be successful in the interview preparation process. Next, you'll create a capstone project that brings together the main concepts you've learned. You can add your capstone project to your portfolio as well. Finally, you'll review what you've learned to complete the final tasks to earn your cloud cybersecurity badge. The job search skills you learn in this course will serve you throughout your career while you continue to gain new skills and take on more complex projects. You're so close to earning your certificate badge. Remember, you set the pace for this course. Feel free to rewatch videos and review new information as often as you need. Once you complete this course, you'll be ready to apply for a cloud security job. Let's get started. Hi, I'm Louis. I'm a security architect here at Google Cloud. A core part of my job is engaging both executive and technical stakeholders to help customers build the most secure deployments possible. This means I help customers protect their data and maintain adherence to regulatory and compliance obligations. I'm a New York native where I studied information science in college. Growing up, I was the most tech-savvy person I knew because I spent all of my time on the computer. But this also meant that when something broke, more accurately when I introduced malware, I had to figure out how to fix it. So it always felt natural to me to study technology, although I initially assumed that computer science was the only way to do so. After learning that I didn't enjoy programming as much, I decided to focus on information science since it had a mix of programming and other courses I found interesting, like data analysis, computer networking, and cybersecurity. I began my career in cybersecurity working on an internal audit team within a finance company. While I learned a tremendous amount about auditing, my biggest lesson was that a career in auditing was not for me. I made a slight pivot and worked in security for a cloud service provider where I was audited against common information security standards instead of being the auditor myself. I then discovered roles that would let me work with organizations to make the most of cloud technology and keep resources secure. I was drawn by the ability to be technical while also helping customers, and the title sounded pretty cool too. That's when I decided that I wanted to pursue a career as a solutions architect. After switching into this role and gaining experience as a solutions architect, I had an opportunity to work for Google in a similar role. Google was especially interested in my background in audit and compliance. I've been at Google and on the same team ever since. It's exciting thinking about all the career paths you can take, but how do you get to the one you want? Let's begin by outlining how you can prepare yourself for success when starting your career in cloud security. First, we'll start with an overview of the hiring process, including how to find and apply for jobs, what to expect from each interview stage, and how to highlight your skills, interests, and goals in a way that sets you apart from other candidates. Next, we'll discuss how to update your resume or how to create one if you don't have one already. You'll also learn how to describe your skills and prior experience and tailor your resume to the job you want. Then, you'll incorporate the projects from this course into a professional portfolio that highlights your expertise, professionalism, and passion for the field. Finally, you'll learn how to prepare for an interview and plan your responses to some common interview questions. You'll also learn how to navigate interviews that include a project. You're one step closer to having a rewarding job search experience. Keep up the great work. The cloud security field is growing fast, and new job openings are added every day. The job search can be challenging, but the skills you've learned in this certificate, along with your prior experience, have prepared you for success. When exploring cloud security jobs, you should include titles like Cloud Cybersecurity Analyst, Cloud Cybersecurity Engineer, or Cybersecurity Specialist in your search. Many job descriptions require 1 to 3 years of experience, but don't let this stop you from applying for a job you want. An organization may be flexible on experience if the candidate is a good fit. To find entry-level jobs, you can include terms like entry-level, associate, or junior in your search. Before we explore the hiring process, let's review some of the common job duties for Cloud Cybersecurity Analysts. First, Cloud Cybersecurity Analysts are expected to plan, configure, document, and monitor cloud security solutions. Second, Cloud Security Analysts use dedicated tools to check for vulnerabilities and respond to threats as needed. And finally, Cloud Security Analysts are expected to stay up to date on security and technology developments and cyber threats to promote a culture of security throughout the organization. Job titles and duties usually vary between organizations, so be sure to read the full job description to determine whether a position is a good fit. You can use a few different strategies to help you find the cloud security job that's right for you. Networking, including attending security events and joining communities or forums, is a great way to learn about job opportunities, sometimes even before they've been posted publicly. LinkedIn is a professional networking site that includes job postings. LinkedIn is also a great way to learn about daily life at an organization. Other job boards like Indeed and Glassdoor allow you to search for jobs by keyword, job title, and location. On each of these job sites, you'll be able to submit an application along with your resume and portfolio. If a recruiter or hiring manager thinks you might be a good fit, they'll usually contact you to set up a brief screening call. On this call, a recruiter will share more details about the position and ask you about your skills and interests. Be sure to ask questions about the role and the interview process. You can also ask the recruiter for tips to help you prepare. If your screening call goes well, the recruiter will follow up to schedule an interview. Once you have an interview scheduled, the next step is researching the company and role. It's a good idea to learn more about the company's mission, vision, values, and culture. This information is usually available on the company's website or on social media. It's also important to map your skills to the job description and think about examples of time you've used each skill. An interview may be held over the phone, on a video call, or in person. The interviewer will likely ask about your background and experience and give you a chance to ask questions. An interview is your opportunity to understand more about the role so you can decide if the organization is a good fit for you. Some organizations may contact you for multiple rounds of interviews. If so, your recruiter will let you know what to expect for each round. Once you complete your final interview, you should follow up with a message thanking the interviewers for their time. You can also ask about when to expect a response regarding next steps. After that, it's time to wait for a response. You can use this time to improve your skills, work on your portfolio, or apply for other jobs. If the employer doesn't contact you during the time frame they gave, you can reach out to the hiring manager to check your application status. Now that you know what to expect from the hiring process, you're ready to prepare your resume and portfolio and start practicing your interview skills. If you've completed your Google Cybersecurity Certificate or other cybersecurity projects, you may have already created an online portfolio. As a reminder, a portfolio is a collection of materials that can be shared with potential employers. A portfolio is a great way to share the skills and knowledge you have with potential employers. Having a portfolio also gives you a chance to share your passion for your work and commitment to personal growth. Hiring managers use your portfolio to evaluate your technical skills, like your experience in securing cloud environments and addressing threats, and skills like problem solving and analysis. Your portfolio is also a place to detail your communication and documentation skills, especially your ability to communicate technical concepts to non-technical audiences. You can make your portfolio accessible from your own custom website or use an existing platform. For example, you can use Git repositories or GitHub or GitLab to organize and customize your project portfolio. You can also use a cloud-hosted application like Dropbox or Google Drive to organize and share project documentation. Or you can use a website building platform like Google Sites, which includes resources to guide you through setting up your site and customizing its layout and appearance. Wherever you choose to host your portfolio, make sure it's well organized, visually appealing, and easy to navigate. This highlights your attention to detail and helps hiring managers understand how your projects relate to one another. If you need ideas, you can ask others in your network or search for example portfolios online. Once you've chosen a platform to host your portfolio, decide what you want to include. It's a good idea to start your portfolio with a short biography and cover statement. Describing your professional goals and experience can provide context for your portfolio projects and help you stand out from other applicants. Then, include documentation samples like risk management policies, control maps, implementation plans, incident reports, and audit or assessment documentation. These can be samples that you've created in an educational environment or on your own. For any projects you can't directly share resources for, like projects completed for an employer, include project descriptions that explain your role. You can also include code samples like IAC scripts. A quick note on including code in your portfolio. If the platform you're using allows you to embed code, you're all set. If not, you may want to provide a link to code hosted elsewhere or include screenshots and descriptions of coding projects. Make sure to include a brief explanation of each asset in your portfolio, including the tools you used, the framework or standards you followed, and any areas for improvement. You may be asked to present your portfolio in an interview. This is a great opportunity to share your accomplishments. Be sure to highlight the skills you used or learned in each project. Show excitement about your favorite projects. Hiring managers want to know that you're passionate about the field. Finally, be sure to ask the hiring managers if they have any questions once you're done presenting your work. As you move forward in your career, it's important to update your portfolio with projects you complete through educational experiences or on your own. Projects you work on for an employer may deal with confidential information or fall under copyright, so make sure that you follow all applicable rules and regulations. If needed, you can summarize your role on a project using general terms to document your accomplishments without violating your employer's policies. Now it's time to create or update your portfolio. Take your time to create something you're happy with, since you'll continue adding to it as you take on more advanced projects and gain new skills. This is an exciting process. It allows you to communicate who you are and what you've accomplished. That's something to be proud of. Before you apply for a job, it's important to update your resume with your latest skills and experience and tailor it to the position you're applying for. A good resume can make a great first impression on a hiring manager and give you a better chance at becoming a candidate for a position. You might be familiar with some resume basics already. If not, here's a quick review of suggested resume sections. You'll want to include your name and contact information at the top of your resume. In some countries, your resume should include a photo. It's a good idea to research whether this is the case in the country you're applying in. You'll also want to include a brief professional summary statement of your experience and goals. It's a good idea to include a bulleted list of your skills, your work experience, and any volunteer experience relevant to the position you're applying for. Your resume should also list your education. Finally, you'll want to add a link to your portfolio so employers can review your work. However you choose to format your resume, it's important to customize it to the job you're applying for. Updating your resume to highlight your relevant skills lets a hiring manager know that you've put an effort to understand the role and are a good fit for the open position. You've learned lots of new skills you can apply in a cloud cybersecurity role, including configuring, improving, and monitoring cloud infrastructure, incident response, and communication and documentation of security concepts. It's a good idea to keep a running list of your cybersecurity skills. This makes it easier to customize your resume before applying for a job. You might find job descriptions listing programming languages, softwares, and skills you're less familiar with. If this happens, consider which tools and skills you have on your existing resume that may be transferable to the position you're applying for. Even if you haven't worked in a cloud cybersecurity job before, you most likely have transferable skills from other jobs you've had before, or from your personal life. For example, you could have great attention to detail from working in data entry, strong teamwork skills from a service industry job, or effective time management and prioritization skills from running a small business. These are just a few examples. Reflect on your experiences and try to think of any similar skills you may have. In the education section of your resume, you can include this certificate along with any other professional certifications you've completed. This is also where you can list your degree if you have one. You may choose to list relevant coursework here if applicable. For example, if you majored in an unrelated field but took a computer science class as an elective. Your resume and portfolio should complement each other. The qualifications included on your resume will help you get noticed by potential employers, while the projects in your portfolio will provide deeper evidence of your skills and accomplishments. Now you're ready to create a resume that shows off your skills and make employers want to learn more about you. If your portfolio and resume get a hiring manager's attention, they'll contact you to set up an interview. Interviews can be intimidating, but practicing interview skills and conducting research can help you feel confident. Before an interview, it's important to research the organization and role, practice responding to common interview questions, and update your portfolio and resume. It's also a good idea to do some research about the organization you're interviewing with. Understanding the organization's mission, core values, and culture can help you decide whether you and the organization are a good fit. You can usually find this information on the company's social media or website or in the job description. If the company makes products, you should also research the products, the customers who use them, and read news articles about the company to better understand their business. If you still have questions, you can ask the hiring manager. After you learn more about the company, it's a good idea to examine the job description again. If some skills listed in the description don't exactly match with your own, identify transferable skills you can emphasize in the interview. The cloud security hiring process usually involves a few stages of interviews. First, an introductory or screening interview with the hiring manager or a recruiter. Then, a one-on-one interview with the hiring manager. And finally, a panel interview with a few members of the team you'd be working with to get a sense of how well you'll fit in with the team's culture. Most recruiters or hiring managers will let you know how the interview process is structured ahead of time so you can prepare. In a cloud security interview, the hiring manager will ask a variety of questions to assess your skills, experience, and attitude. For example, the hiring manager may ask you behavioral questions, like what you did or would do in a specific situation, or how you'd handle a challenge at work. They might also ask you technical questions about the specifics of the technical tools you've used. An interviewer may also give you a technical problem and ask you to describe the steps you take to solve it. These questions are a chance for you to share your knowledge and your communication skills. You can structure your responses to behavioral questions using the STARO method. First, describe the situation, including any context the interviewer needs to know to understand the story. Then, identify the task or the problem or challenge you took on. Next, describe the action or actions you took to address the task. Then, explain the positive results of your actions. And finally, share what you learned. Before answering technical questions, it's important to make sure you understand what the interviewer is asking. Don't be afraid to ask clarifying questions. This lets the interviewer know that you're committed to answering accurately. When answering a technical question with multiple steps, it's a good idea to share your thought process with the interviewer as you answer. If you don't know the answer to a question, don't worry. Explain that you haven't learned that skill yet, but you're committed to learning what you need to know to be successful in the role. The interviewers will expect you to ask questions as well. Remember, you're interviewing each other. Asking questions is your chance to be curious and gather any information you need to decide if the role is a good fit for you. If interviewers ask you about the work in your portfolio, you can give them more information about your goals, the tools you used, and what you learned while working on each project. You should also connect the work in your portfolio to the skills and knowledge that would help you on the job. After an interview, be sure to send a quick email to each interviewer thanking them for their time and confirming your interest in a role. With a little bit of practice and preparation, you'll be interviewing with confidence.
Within my industry, I'm essentially the firewall at Google. I'm protecting user data, ensuring that the controls are in place and that they're applied within each application and service that we have. My name is Joel, and I'm a security engineer. I got started like a lot of people in technology as a power user, where you may be hired as desk job or intern, and then a new printer comes into place, and then you got to add the printer, and they look to you as a new person on the block to do those things. And eventually, I kind of liked doing that over and over, and I kind of transitioned into IT. Within IT, I moved into cloud, and eventually into security engineering. I think what made me decide to pursue security was that within IT, you kind of touch all types of technology, and security was always something that I enjoyed going down the rabbit hole with. Like, someone doesn't have access, why don't they have access? Someone accessed something that they weren't supposed to, how did they get access to that? Or the fun things like, why was there a movie torrent downloaded onto our server? Like, who was able to do that? How did they do that? And when did they do that? So those kind of questions were always something that interested me. And that's kind of how I got within this career path. What I love most about working in this field is working with the unknown. I love the fact that I can come in any day and get a new problem, a new situation, a new scenario, and work to solve that. To be ready for a career in this industry, I researched YouTube videos, cloud certificates, different programs online, any course I could find, I attempted. Practicing coding on my own, doing personal problems, because it all benefits, right? Even if you do a personal project where you're doing a script that rearranges your music in your files, that's something that's valuable, even if it's something that's not for work. Some job application tips and resume tips I would provide is your personal projects are valued on your resumes. I built a bot that looked at stock prices and kind of analyzed it. That's something I would add to my resume to bolster it. It shows that you have a personal interest. It shows that you took an effort other than just applying. You're actually working on those skills. Don't be afraid of coding. I think coding is a daunting task for a lot of folks, especially if you did it within school or college. You may have run into languages like Java or Cobalt or Rust, but the grass is greener on the other side. There's a language for everyone. You could always start with Python, SQL, just to get started. And the fundamentals are all the same across the board. So don't be afraid of coding. Really embrace it and try to make it a part of your tool belt.
Great work. You've come to the end of the career preparation section. You started off by learning what you need to successfully search and interview for your first cloud security analyst job. Then, you explored the cloud cybersecurity hiring process, from locating job openings to researching organizations and submitting applications. Next, you updated your resume with your new skills and prepared to tailor it to specific job descriptions as needed. We also cover how to identify skills from non-security jobs that will help you succeed in a cloud security analyst position. Then, you learn how to create a professional portfolio to share your dedication, passion for the field, and commitment to growth with hiring managers. Finally, you learn how to prepare to impress hiring managers and other interviewers during the interview process. We covered categories of interviews, question types and how to answer them, and how to present your portfolio in an interview. You now have job search and interview skills that will be useful throughout your entire career. Congratulations. Now let's move on to the next step of your learning journey. You're just steps away from completing your capstone project and receiving your certificate. This is a huge accomplishment. Coming up, we'll discuss your capstone project. You'll learn what to expect, tips to help you complete it, and how to make the most of your capstone project in your future cloud security career. First, we'll discuss what to expect and give you some tips to help you complete the project successfully. Then, we'll cover how you can use the capstone project in the job search and interview process. After that, you'll have all the necessary instructions and tools to start, finish, and assess your project. Finally, we'll wrap up your project and discuss some tips for success in your career. When you're ready, meet me in the next video. In this video, we'll discuss the various benefits of completing your capstone project. Your capstone project is an exciting opportunity for you to apply everything you've learned in the program. To complete the project, you'll create and configure it in the cloud. This will give you the chance to practice the tools and frameworks you've learned throughout the program. Let's discuss the benefits of completing the project. First, by completing your capstone project, you'll demonstrate your experience with cloud security concepts and tools. Because the project is similar to actual workplace tasks, completing it will give you a preview into what a cloud security job might be like. Plus, it will show future employers that you have what it takes to succeed in a cloud security role. Completing the project will also give you the opportunity to practice your problem-solving skills. As a cloud security professional, no 2 days will be the same. You'll likely deal with challenges on short notice, and as a new employee, you'll be presented with problems that you may have never seen before. Your capstone project will allow you to showcase your problem-solving skills, and your deliverables will let your employers know that you can successfully handle a challenge. The capstone project is an opportunity to let future employers know that you can identify and balance stakeholder needs and wants. By completing the project, you'll demonstrate that you can carry out delegated tasks and apply your knowledge to configure cloud resources based on stakeholder goals. And by completing your capstone project, you can add a significant achievement to your portfolio. Since it brings together everything you've learned, the capstone project is a great thing to showcase in your portfolio. And when presenting your portfolio to potential employers, you can use your capstone project to emphasize what you learned during this program. Are you ready to showcase your skills? Complete the capstone project to continue your cloud security journey. Hey there, future security professional. In this video, we'll discuss what to expect from your capstone project. I'll also provide you with more details about the project structure and give you some tips to help you along the way. Let's get started. During the capstone project, you'll have access to all the instructions and materials you need to complete it. And before you get started, you'll be able to review a completed example project. That way, you'll have a clear understanding of the expectations for your completed project. Once you've reviewed the instructions and the example project, you'll start your capstone project. The structure of the capstone project is similar to the labs and interactive activities you've worked on throughout this program. While the labs and activities focused on practicing specific concepts and skills, the capstone project is more comprehensive. To complete the project, you'll need to use all the skills you've developed along with the knowledge you've gained from completing the program. If you get stuck along the way, remember, you can always review the previous course materials, labs, and activities. To successfully complete the capstone project, you'll need to use what you've learned about configuring cloud resources, using tools to assess security posture, and documenting your processes. If you'd like, you can review these concepts before you get started. To get started, you'll create a project in Google Cloud. Remember to make sure your project has all the needed security controls in place before you begin. Completing the capstone project to the best of your ability will give you a high-quality work sample that you can share with potential employers. Good luck! Congratulations, you've completed the capstone project. You've done incredible work to get yourself here. Take a moment to congratulate yourself for your effort. By completing this project, you successfully used all the skills you learned throughout the certificate to complete a complex task similar to what you'll complete as a cloud security professional. The capstone project gave you practical experience configuring the security of cloud workloads. Now you can share this experience with future employers to showcase your skills. To share your capstone project, add it to your portfolio, include it on your resume, and present it during interviews. This course has been an exciting journey through cloud security, and finishing it is just the beginning. There are so many more opportunities to learn and grow ahead. To continue learning about cloud security, consider finding a mentor, joining online or in-person professional groups, and attending conferences to learn more from others. You can also continue building your portfolio by completing online practice projects. Before you do any of that, though, take another moment to congratulate yourself on all of your hard work. Congratulations, you've reached the end of the course. You're almost ready to claim your certificate. Throughout your learning journey, you've built on your cybersecurity knowledge and gained the skills you need for success in a cloud security career. I'm honored to congratulate you on all you've accomplished, but there are others who are waiting to join me.
Congratulations on completing this program. Well done. This is the first step of many more.
Congratulations on completing the program. What an achievement.
Incredible work.
Congratulations on completing the program. You did it.
Kudos on your success. Hope you take this moment to celebrate your hard work and perseverance.
Congratulations on completing this program. What an achievement.
Awesome job. I'm proud of all your effort.
Congratulations on finishing your certificate. There's more work to be done.
Congratulations! You did it!
Congratulations, you made it.
Nice going. You've learned so much throughout this program. I'm excited for you to use what you've learned on the job.
Congratulations on earning your certificate. Best of luck in your future endeavors, and I know you're going to do great.
Wow, great job. You finished the whole certificate. Congrats.
For now, you can celebrate. You have a solid foundation in cloud security that you'll build on throughout your career. Congratulations once again, and goodbye for now. You're off on an exciting new adventure, and I'll be cheering for you the whole way. You've just completed a Google Career Certificate. Great work. Let's check out some professional opportunities your new skills can unlock. With this certificate, you can share your accomplishments on any job search platform, like LinkedIn, Indeed, and Glassdoor. You can also add the certificate to your resume. Throughout these courses, you learned how to apply security concepts to cloud environments. You also gained the skills and knowledge you need to get off to a great start in the cloud cybersecurity field. Let's review what you learned in this program. You started by learning the basics of cloud computing. You discovered the security lifecycle and explored a cloud security analyst role in an organization. Next, you learned about security and risk management in cloud environments. You also learned about security and compliance frameworks, explored the compliance lifecycle, and worked with tools for risk management and compliance. Then, you learned to identify and protect against threats. You also learned to implement the principle of least privilege using access control and identity management. Next, you explored threat and vulnerability management. You also learned about the cloud-native concepts of ephemerality, immutability, and handling secrets, and the essentials of data protection and privacy. You also learned how to detect, respond to, and recover from cloud cybersecurity attacks. Finally, you learned about the cloud security hiring process and created a capstone project to add to your portfolio. You've accomplished so much and developed skills you can take with you throughout your future career. As you continue your cloud security journey, be sure to stay engaged in the cybersecurity community and up to date on the latest trends. As a cloud security professional, you'll always be learning. Some resources you can use to stay engaged in the community include social media, where you can follow organizations and individuals within the industry, virtual or in-person conferences and events where you can learn more about the field and meet other professionals, and professional associations. Congratulations again! I'm confident that you're well prepared for a successful cloud cybersecurity career. I wish you the best of luck.